Yeah, okay. So good morning, everyone. Welcome to this 137th edition of the Zak World of Façades Conference Series. My name is Ahmed. I'm part of the organizing team here. This is our 9th United Kingdom edition and the 6th one in London. I'll quickly take you through introducing the event. So we've been organizing this event since 2012. For those who are attending first time around, I thought I'll just take a couple of minutes to explain. So we started this as a small networking event back in 2012. Events grown across the globe. We're currently doing 32 events a year. Finished around 136 editions in 37 countries, and then hope to touch 40 countries by end of this year. So it's been a great learning experience for us, talking about facades, getting people to share their experiences and stories about designing, engineering, installing facades. And yeah, we're going on and on until we stop. So it's been a great experience for us. This was the calendar of event of the lineup for 2023. Almost done. We've got few events left for the year, but we've had a fabulous year this year. And of course, one common theme across most of the events across the globe has been sustainability, which is also one of the key topics of discussion again today. These events wouldn't be possible without the partnering companies we partner with. I'd like to acknowledge all of them first. I'll take a couple of minutes to acknowledge all of them, starting with our presenting partner, Schüco. So Schüco needs no introduction. They are the world leaders in aluminum door, window, curtain wall systems. They've been a strong supporter of this event globally, and also in the UK and other parts of the world. So a fabulous relationship with Schüco since 2012. And are powered by partner this year. So Obex is a British manufacturer into membranes and a lot of other stuff. They've got a very interesting pavilion over there with augmented reality and other stuff. They've also got free-flowing coffee throughout the day. So they have a nice coffee bar, barista. We are not serving barista, but they are. So if you want a barista, you can visit their lounge. Associate partners starting with AGC Glass, again leading coated glass manufacturer. Axalta, they're into liquid and powder coating solutions. Boston Valley Terracotta, American manufacturer of terracotta products. They pronounce terracotta with terra space cotta over there. So it's Boston Valley Terracotta. Cosentino, the inventors of the Decton product, which is a ceramic quartz-based product used for rain screen cladding. Cupaclad, slate cladding, Spanish company working with us for the first time. Ductal, UHPC, ultra high performance concrete, popular here in this region. FSS, again, into membranes, growing fastly here from Portugal. EOT, German company into fixing systems, rain screen cladding systems, and a lot many more accessories. Euromax, Belgian company, they have coil coating for building envelopes. iRise is part of the Merck group. They have a liquid crystal dynamic glass solution. Phils, they've got some expanded mesh and other interesting mesh solutions, Italian organization from part of the Longhi group. Formi Design, with us first time here in London, they've got an interesting aluminium batten cladding solution for interiors and exteriors. FSI, now part of Promat, they've got a perimeter fire stop protection and other pacifier protection solutions. Future architectural glass and glazing from the UAE, value-added glass processor, fire-rated glazing integrator, and many more stuff. Hilti, again, a lot of products from Liechtenstein, pacifier protection, anchor, ventilated claddings, and more. Ipstock Future, they've got GRC, brick cladding, and a lot of other stuff. They've been on a buying spree, buying a lot of companies in the UK. They've got a good portfolio of facade products. Curare is the mother company of the laminated glass interlayer brands Trocifol and Sentry Glass. Laswit do special art facades. They've got some nice stuff. The bar down Reverie, if you see the interiors, that's all done with Laswit products. Of course, can be used on the external facade also. NBK Terracotta, architectural terracotta from Germany, part of the Hunter Douglas group. PowderTech Corby with us first time here, a leading powder coating applicator based in the United Kingdom. A Proctor Group, another British company into membranes. Proteus, rain screen cladding systems, British manufacturer. Q-Railing, German company into modular railing solutions. I've got a fire-rated solution also now. Qualicoat is the leading authority for your coating standards. So basically, your coating has different classes, and Qualicoat is the standard which people use for specifying coating. So Qualicoat, I hear directly, they're headquartered from Zurich, but this is Qualicoat UK participating with us. Quarella, Italian manufacturer, they've got some interesting stone cladding solutions. Rockwool, again, pacifier protection solution, stone wool, and lot many more things. Saflex is the interlayer brand from Eastman. Saint-Gobain glass, again, needs no introduction, one of the leaders in coated glass. Serge Ferrari Stamisol, the membrane division of Serge Ferrari, which is a fabrics company. So this is their membrane division here with us for the 5th time in the UK region. Sherwin-Williams Synthia Pulwin is the powder coating division of Sherwin-Williams. Sherwin-Williams has liquid coating also. Siderice, again, one of the leading pacifier protection providers for ventilated cladding and curtain walling. Slojun, Danish company, specialist in bending aluminum and steel profiles. Sotec, again, leading local British manufacturer of rain screen cladding solutions. Tenmat, again, British company, pacifier protection solutions for rain screen ventilated cladding. Turkish Glass is the association of all the Turkish glass manufacturers and processors. Turkish Glass is being exported all around the globe, and they are here to talk about Turkish glass and glazing companies. UL, again, leading certification and testing company, Underwriter Laboratories. UCS, our Italian manufacturer, they've got actuators for smoke and natural ventilation. Vitro Architectural Glass, formerly PPG, one of the world leaders in high-performance coated glass solutions. Zini Glass, again from China, high-performance coated glass and processing solutions. And of course, post the event, we've got the networking reception. It's courtesy signage from Switzerland, which is a BIPV solution provider, and OBEX. So what's going to happen is those who are attending for the first time, we're going to end by 5:45. 5:45 to 7 p.m., we're going to be having the networking reception at the Harvest Ballroom. At 7 o'clock, everyone who has attended today's event will be asked to leave the hall, and then those who are registered for the awards dinner by the Society of Facade Engineering and SIPSI tonight will have to collect your badge for the dinner event. So the dinner event is a separate event, has nothing to do with this event, so the passes for that event is separate. It's organized by SIPSI and the Society of Facade Engineering. So I'm repeating again, at the end of the event, we will have a 1-hour post-event networking at the Harvest Ballroom, after which the hall will be handed over to them and everyone is requested to leave the ballroom, and SIPSI will take over, and those who are registered for the night gala dinner and awards will be issued new badges to have access inside the hall. Our refreshments partner is Cephar. So Cephar have an interesting mesh which you can laminate with glass and get some features. So these are our partners, all our associate partners presenting, powered by all of them have booths outside. I request all of you to please visit them during the networking breaks and whenever you're outside. We are able to do all these kind of events thanks to our event partners and their patronage to this event in the UK and globally. So it's nice to acknowledge all of them, to go have a chat with them. Our next event is next week in Frankfurt. We're doing this along with Schüco. And then we've got a country number 38, which is Norway. So we're doing Oslo for the first time, again with Schüco. We're trying something different in Dubai next year. So it's a 2-day event at the Coca-Cola Arena. So we're trying, instead of a 5-star ballroom or something, we're trying something different. We want to call it the avant-garde edition. Still don't know what exactly we want to do with it, but we still have a structure in mind and something very different from what we've done in the last 12, 13 years. And of course, I think thanks to all your support, we've overgrown this venue. So next year, we move to the old Billingsgate in London. It's a fabulous venue overlooking the London skyline and Thames, and it's it's a cleaner layout. It's on one floor. It's massive. There's a lot of space for people to network. I think what we could do with this venue, we have done to the maximum. But I think it's time to grow, and we move to Old Billingsgate, a suggestion by Stephen Tanno. So yes, that's it from me. But just before I go, a couple of things. Yes, we've recorded today's event, so we'll share a YouTube link with all of you. A week from now, of all the presentations, we've got permission to share with those who have the red color badge, delegate badge, with the so those who have the lanyard with the red color delegate badge, which delegate written, there's a USB stick. The USB stick has the brochures of all our sponsoring partners of this event, and you can feel free to use the pen drive for your personal use. Also, there's another layer in that. So one layer is locked with the brochures, and the other one you can use it for your personal use. That's it from me. I'd like to call upon Stephen Tanno from Schüco International, who's going to be co-hosting today's event, and I would like him to take over from me. Thank you.
Thank you. I hope you can hear me okay. Good morning, everybody, and welcome. For those who don't know me, I'm Stephen Tanno. I'm from Schüco, and it's an absolute pleasure for me to host you again this year. It's the 6th event for Zak in London. And as you just heard from Ahmed, we hope the event will go on from strength to strength in future years. So we're meeting again in time of war. The Ukraine war is a little bit off the news at the moment. It's been replaced by another war. Both really ugly wars. There doesn't seem to be any winner in any of these wars. Now, war in the Middle East may not be something new. There's always a war going on, it seems. But sorry, these slides have moved on a bit too fast. But it will affect us here, you can be sure. It's affecting our economy, it's affecting how we work, and eventually the whole world pays the price for these wars. But we've also had quite a dramatic year with a lot of severe catastrophic weather events. We started with these floods in Libya, which wiped out more than 10,000 people. We had the earthquake in Morocco, which again took out about 2,000 plus people. We had the earthquake in Syria and Turkey. Again, several thousand were killed in that. We've had massive floods in China that brought misery to tens of thousands of people. And all over North America, there's been floods, fires, hurricanes, tornadoes, and of course, that affected the island of Hawaii as well earlier this year. We've all seen that on the news. So all these natural disasters and floods seem to have a much more frequent occurrence. There are many others, too many to mention, including floods we had here in the United Kingdom. These events seem to be becoming more frequent. The link between these events and global warming is definitely not coincidental. This graph shows us that 2023 was the hottest average temperatures recorded since 1940. And I think the effects of the climate change are being felt by all of us. Yet, despite the wars and these climate changes, we have seen that the world this year will hit more than 8 billion people, and the world economy will hit more than $100 trillion. And I think we can't deny there's a link also between human activity and climate change, that we can't continue to sustain an ever-increasing population where everybody wants to have a certain standard of living. What we're seeing also is that the, if you like, the greed is good culture is not really dead, it's still alive. The pay gap between the rich and the poor is getting bigger. And when you see statistics like this, you sort of start to wonder, is there any social justice to get a fair wage for a fair effort? So we've been quite lucky in our part of the world, we've had quite stable, if you like, inflation statistics for more than 10 years. And we saw it dramatically increase in 2022, more or less coinciding with the start of the war in Ukraine. The cost of living crisis is effectively a daily nightmare for a large swathe of people who are in energy poverty, in food poverty. And although the inflation has started to stabilize at roughly 6.8% of where we stand today, that doesn't mean that prices are getting lower. It just means the prices that went up rapidly over the last 18 months are staying where they are, just slowing down the rate of increase. And I think with all the wars that are ongoing, we're going to see probably this trend reverse back. And we're feeling that in construction. I think I've been working in construction for well over 30 years. And in all my working life, I've not seen the gap between cost plan and tender price as big as it is now. It's the biggest I've ever seen it, where prices come in and clients say simply can't afford to do the project. The situation is not improving, prices are not dropping, and the economic climate has put the brakes on our industry. We're all feeling that. People are unable to afford mortgages for new homes. Therefore, that puts the brakes on new projects and new developments. A lot of young people are simply in a position where they can't see a future that they can afford to buy a home. So a lot of them are stuck in the savage private rental market, a bit like a hamster on a wheel that can't get off the wheel. Now, this graph is familiar to most of us. The slight recovery we started to see after COVID has all been reversed since the start of the war in Ukraine. And sadly, 2024 looks to be another year with near zero or negative growth. But this slowdown hasn't necessarily been all bad. It has focused the effort on delivering better quality, maybe at lower volume. At least from my perspective, we have seen a bigger focus on sustainability and more attention to detail to deliver better quality. Some of our projects have been exemplar in their approach. Our client here for the biggest hospital in Iceland was very aware of the value of early design engagement. Together with their consultant, Bureau Happold, they put real value on supplier and contractor know-how, allowing them to deliver a super robust, earthquake-proof facade in quick time with no surprises. And the facade is currently being delivered on site by Staticus, and I'm delighted that the CEO of Staticus, Osro Vankivichuta, will be on the panel discussion at the end of the day today. So I would encourage you all to stay for the panel discussion at the end, because it's going to cover a whole myriad of things, such as the new Building Safety Act, thermal performance, and how to strive towards passive house standard for high-rise buildings. So please stay with us for the afternoon panel discussion. Now, as most of you know, this is our 6th event, and it has really been a joy for me to present and to host this event for the last 6 years. I'm really honored and delighted this year to be sharing hosting duties with an old mentor that I worked with more than 30 years ago. The man really is a legend in the world of facades. I don't use the term godfather of the facade business very lightly, but I think if any man deserves it, it certainly is John. John's an engineer by training and has a career of 40 years. He has worked as an architect, an engineer, a consultant, a contractor, client advisor, and now he's an in-house guru at an architect's office. So if I could ask you to please warmly welcome Mr. John Perry. Great to have you, John.
Well, thank you, Steve. It's been a while since I've been referred to as a godfather, but I promise I don't have any of the attributes of a true godfather.
First of all, how are you, and how are you enjoying London?
4 weeks in Greece with blue skies, and I'm here in London and looking forward, I have to say, to being back in Sydney with the same blue skies. But London is, as ever, an exciting place to be. So much going on. We look from Australia to what is going on in your industry. And in fact, without it, I think we would be the poorer for it. So, loving London. Coffee could do with a bit of work.
So, John actually brought me into the facade business more than 30 years ago, back in Australia. And you became a contractor for a period of time, John. How did you find life as a contractor compared to being a consultant?
Oh, yes. I was a specialist subcontractor, and I think there's a hierarchy where subcontractors are almost at the bottom.
Yeah.
The buck stops there, and in fact, you're the person that brings the entire design together with all the warts that go with it, the inconsistencies, the things that don't quite work, under time and cost pressure. So I have an immense respect for the people that deliver for us. They're a critical part of our industry. And it's made me a lot more collaborative in the latter part of my career. I sort of wish I'd done it 20 years before. I would have been a better consultant for it.
Well said. I couldn't agree more with that. I think when you realize what responsibility the subcontractors, who are really at the bottom of the chain, have to shoulder, it's important that we all have an appreciation of that. And a time as a contractor for all of us is good. I did 12 years as a contractor, and I know I've got 70 knives in my back. So we've talked a little bit earlier about climate change. Are you feeling that? Are you seeing the effects of it in your part of the world, in Southeast Asia, in Australia?
Look, definitely. I think it's... Australia has been through 13 years of climate change denial with its previous government. So we're a long way behind in a whole series of things. The uptake of electric vehicles, the uptake of solar power, which has fundamentally been driven by private industry rather than led by government. And yet it's all around us. We've had the worst fires on record, the worst droughts on record, the worst floods on record in the last decade, in the last 5 years. So much so that finally our winter code is recognising that cyclones no longer cross the coast north of Rockhampton. Rockhampton's 1,000 kilometres north of Brisbane, which is 1,000 kilometres north of Sydney. They now cross the coast at Brisbane. That's going to start to make a big change to how we design, but more importantly, I think it's going to make a huge change to how we look at safety of our existing built products. So that's just one aspect. The other one is rainfall. And unlike curtain walls and the non-porous materials, the frequency of rain events is going to become a key issue. Because in some parts of the world, you simply cannot build with water-sensitive materials. You can't do stucco in northwest US. You certainly can't do it in parts of New Zealand. You will not be able to do that in parts of Australia shortly. And we do not even have the data that talks about time between rain events, the drying periods, and those sorts of things. So I think climate change is going to come in, it is affecting us, and it's going to come in right across the board in areas that we're not prepared for yet, let alone the sustainability debate.
You're slightly anticipating that these events are coming and starting to think about codes of practice and rain data.
I'm starting to think about it. I'm at the end of my career, I have to say. It doesn't feel like it. It feels like there's so much still to do. And I feel a sense of disappointment that I've spent 30 years learning and talking about waterproofing, and yet still today in Australia we fail to make waterproof buildings in the most simplest of ways. The traditional forms of construction and how you integrate systems together, big issue, a really big issue. And I fear for the future because I do not believe that we're collecting the data and that we're really training people and educating people in how to do these, what are, in my mind, basic principles of waterproofing and incorporating them in design. So whilst I think some preparations are being made, it's not uniform. I actually don't think we've truly recognise the extent to which it's going to hit us. And when it does, it's going to come quickly. And I don't think we in Australia are going to be prepared. I hope you are. And I certainly see, and I admire the speed with which the UK has responded to embodied carbon and the literature that's put out. We look to UK's research and its dissemination of information because we simply don't have that level of input. So look, I'm actually afraid, Steve, I really am. Reaching the end of my career, I'm almost pleased to be finishing in the next decade. It's not imminent, just because I think it's going to get harder.
Thank you, John, and I'm really looking forward to having you on the stage later as well.
Thank you.
Before I introduce our first speaker, I just want to say, as I always do, a huge thank you to everybody that is a speaker, a panelist, a contributor in any way, because this event wouldn't be what it is without their contribution. They come and stand here and they lead us into the discussion and they present new ideas that we all value. So thank you everybody who's contributed in any way today. I think our first speaker, like the two of us, John, he's done time at Arup.
Indeed. Indeed.
How many years did you do at Arup?
19.
19 years.
19 years out.
I'm a mere junior with only 5 years.
Okay.
But our next speaker trumps both of us. He's done 36 years at Arup. Of course, it is Russell Cole. He's the director of facades at Arup in the UK, and he will talk to us about saving buildings and materials and hopefully helping to save the earth. Over to you, Russell.
Thank you, Steve. Thank you, John. Thank you. Good morning, everybody. Hopefully a presentation. Oh, I need to do the next slide. Okay. So yes, slightly ambitious title to my presentation, but after the comments by Steve and John, I think we do have to all come together today and really think about what can we all do to save the earth, to promote sustainability. I think facades are hugely influential. They have a big impact on our environment, and therefore what we do and what we design and what we build will have a big impact on saving the earth from climate change, etc. I want to focus on existing buildings today. There's a lot of drivers pushing us towards doing more with the existing building fabric. We've got some really good stories to already of achievements already realised, but we need to learn from them. So I'm going to run through some examples, but also I'm going to try and explore some of the barriers to doing more. And of course then suggest that we need to make some changes and have a bit of an evolution. There's huge virtues in being sustainable. It's essential. We've just talked about the climate crisis, but reducing the impact of redevelopment is really, really important. At the last COP, in the COP in 2021, Arup committed to actually measuring the embodied carbon, the whole operational carbon of our projects. So we actually surveyed nearly 1,000 projects from around the world. Here's the distribution. And this gave us a lot of insights into our designs and our work, but also how we can improve on things. But one thing I wanted to share with all of you today is the difference between our carbon footprint, i.e. the amount of carbon emissions associated with Arup as a business, versus the handprint, i.e. what we design, what we generate as in our business. 350 times bigger. So I think we can all do a little bit to, reduce carbon by taking the train, etc. But the biggest impact we can have is to improve our designs and what we build. That will reduce, that'd be our biggest contribution to sustainability. Here's Facades UK in Arup. This group of people keep me focused on sustainability. The motivation of our team, and particularly the younger members of our team, is such a driver that it keeps us on the path of taking on projects that are sustainable in nature and through which we can achieve real change. Arup is committed to saving the world, and there's a lot we can all do around meeting climate targets, minimizing ecological damage, making the world a better place, and also supporting human development. And we look to things like this hierarchy, where we really think about the decisions we make around projects and what we do on those projects. Building a bit less, building clever, being efficient. So that directs us towards working with existing buildings. As mentioned, people feel that working on existing buildings is inevitably more sustainable than creating a new building. We create positive stories. These are attractive to businesses. There is a quicker redevelopment cycle. The time between when the last tenant leaves and the next tenant occupies the building is reduced because you've cut out the reconstruction of foundations and structure. It's potentially less expensive, and there's a lot of government policies and planning requirements driving in that direction. And I want to talk about that a bit in the London market. So I want to talk about these three things which I think are driving us towards working more with existing buildings. There's the EPC-B challenge, there's LETI, and the circular economy statements. So let's go through those quickly. I'll refer you to this great article in Building Magazine back in March, and the material I'm about to show is taken from that article and these four authors. But what is the EPC-B challenge? Essentially, the government is saying that in 2030, to lease a building, it needs to achieve at least EPC-B. And as you can see here, there's been an increase in projects which have achieved that rating, the grey bar, but you can also see that there's a large amount of building stock which is not achieving that rate. And looking at the pipeline, there is still a lot of concern about not enough new developments or retrofit buildings coming online that will achieve EPC-B. So owners across the UK are very focused on this, and they're looking at what they call the EPC-B challenge. On one side, they can do tune up the building, they can engage with their tenants to use a bit less energy, upgrade services. But more increasingly, they're looking at bigger things that can be done around changing their building services, but also upgrading the building fabric. And that, of course, is where we come in and we can help with that. We also have the London Energy Transformation Initiative, LETI. It was an advisory document back in 2017, but because it's been brought in by the City of London and other boroughs and councils around the country, this is driving the use of, making us focus on embodied carbon and the whole life carbon content. It's a good read. If you haven't read it, please take the time to have a look at it. It gives guidance on the carbon footprint of buildings, and these have now become targets at a very early stage in our projects. And many of you will be familiar with this challenge about how to build a facade that's less than 100 kilograms of CO2 per square metre of GIA, which of course are different than our facade area. So many of us, and you'll hear plenty of stories I'm sure today, about people looking at whole life carbon assessments and making decisions around this. And of course, we've all learned how to do embodied carbon calculations, and the wonderful work by the CWCT and the consultants that have helped them have given us a guide to how to do that. But again, when you start to think about that, if you can retain the existing building fabric, you can avoid generating a lot more embodied carbon. So it drives decisions on what to do with the structure and the facade. The circular economy is a major focus of ours. The Ellen MacArthur Foundation. This work has been taken on board again by the Mayor of London and created this guidance on circular economy statements. Again, another interesting read. But in the core of that is this flowchart, which the City of London has adopted as a requirement for buildings to complete a circular economy statement for every development. So you will see here that owners and their teams are required to look at the existing buildings on the site and see whether things can be retained and refurbished, or whether the fabric can be recycled. All of that needs to be looked at before you can move to the development of a new building on that site. So it's driving that the players in the market towards a use of existing buildings. So to summarise those three, you've got the EPC-B, which is making people look at their buildings. You've got the circular economy statements, making them think about what's on that site, and then you've got LETI driving people towards reducing carbon. So that's all good. But I believe there's a lot of barriers and challenges. You know, we come to a project with lots of ambitions, but maybe we can't achieve all of those ambitions. So what are the barriers? So I think people have a real anxiety about working with old stuff. It's fear of the unknown. They don't know what's there. They don't know what it does. They don't know much about it, and they're unsure of its condition. If we were going to retain something on the site, on the building, how much remaining life has it got? What does it perform as? Can this be measured? Can we rely on it? How long will it maintain that performance? So many think it's easier to avoid existing building fabric. It's too challenging, too complex, too difficult. And of course, many developers are sort of reflecting the final tenant requirements about warranties. So that, again, you can't get a warranty for an existing building. Well, it's a problem, so let's think about it. It creates a lot of concern. But the reality is a building that's 25 years old doesn't have a warranty. So you haven't got something. Yes, you're going to redevelop it, but what warranties can you get? We need to engage clients and other decision makers around the issue of risk management, because really they're trying to guard against the risk of something going wrong with their building later. I think there's a lot of education needed, but we also need them to engage and think about, well, there's a lot of gains to sustainability gains, carbon gains for retaining existing fabric, and they have to understand that some of the consequences might be there's a little bit more risk. Information is key, and I'll talk in examples I give about how the information gap has been filled. So people need to investigate buildings, they need to do tests, they need to do studies, and that might bring people to the point that they can manage the risk and they have professional opinions backing up the predicted performance of that building. On the screen here I have 25 North Colonnade. Blackstone actually elected, it was a well-built building from the 80s, permasilisa facade in really good condition. So the body of that building, the main office floors, they chose to retain that facade. And we did some investigations to give them confidence that that facade was going to perform well for a good few years for the next tenant. Associated with this is design responsibility. So when you come to an existing building and you're going to retain a lot of things, who's responsible for those decisions? What are the bases of those? What are the basis are they working on? So there's gaps in knowledge that need to be filled. And I would say to any developers, clients, project managers, etc., please let consultants do investigations on existing buildings. If you do, we can do more we know a lot more about it, we can be a bit more confident about what's going to happen. there's always a decision about what's the handoff between the contractor and the consultant. You know, the One's Finsbury Avenue here, we, grade 2 listed building. The facade is a major part of that listing. We wanted to do some alterations to it, but where did the contractor take design responsibility, and where did Arup fill in the gaps where confidence was needed about retaining a bit of the existing facade? And I'd say that when you're working on a listed building, definitely I think consultants have to step in and take responsibility for what the condition and performance of that retained facade is. Going back to the circular economy, right? I hope you all understand the benefits of trying to not go back to raw materials, to maintain things, reuse them, refurbish them, or recycle them, with the virtue being to do the smaller cycle rather than the larger cycle. And I think we have to think a lot about those existing buildings on the sites and what we do with them. I believe that demolition doesn't necessarily lead to good recycling. When we demolish a building, it's chaotic. The materials all get jumbled up, things get, the value gets destroyed very quickly, and the ability to recycle them is damaged. There's many people advocating the concept that existing buildings are a materials bank. We need to think of the building we're coming to work with as an amount of materials, and how can we extract the value of those materials? How can we recycle them or reuse them? And there's concepts such as material passports. Again, bringing information to the existing building fabric and making it valuable again and useful. So I think we need to think about demolition leading to chaos and waste. Dismantling a building rather than demolishing gives you materials that can be used for recycling and potentially components that could be reused. But to actually get to that reuse, you need testing and research plus dismantling. So a very considered approach to the end of life of a building. Back to the barriers. Using existing fabric is hard. It's more complex. People need to spend time looking at it. So the need for investigations and information about whether that retained material can be reliable. Investigations, though, need to be reliable and independent, and they need to be comprehensive. So how much do you test? And I think the other thing is that you'll be dealing with different contractors, people that are prepared to take used products and find a use for them. So to conclude, I want to quickly rattle through three stories of our work in this space. Grosvenor Square, Burwell Collection, and 1 Triton Square. So Grosvenor Square was the old Canadian Embassy, converted to a high-rise residential, and the planners had a good way of putting it. They wanted the redevelopment of this building to be as if someone had been on holiday and they came back and they saw the same building. Or is it the same building? In reality, this building was going to be taken down and new basements added and rebuilt. So rebuilding with existing fabric is not a new concept. Here are 2 other examples from Arup's back catalogue, River Plate House and Eagle Place. I think the significant thing about these 2 buildings is that they're stone buildings. But on Grosvenor Square, I think that holiday, that appearance of the new building is very much like the old building. And of course, to do that, we had to reuse a lot of materials, and that was what could we keep, what could we use, and what modifications could we make to that fabric so that it could meet the latest energy standards. So, as I mentioned, we did a lot of work on this project with Pay, and the stonework was extracted, carefully extracted, stored, and then re-erected on the building. It had to be modified slightly. But also, we looked at the bricks. And apologies, Pay, I forgot to credit you with these images. At the concept of the building, concept of the project, we did testing to see how we could extract as many bricks as possible from that building so that they could go back onto the facades. And the calculation was that the recovered bricks should be able to cover about 2/3 of the facade. And this is where, you go to site and difficult to spot it, but the brick dismantling on the right-hand image, you can see how the guys are chiseling out the bricks and storing them behind them against the hoarding there. So we should get a lot of bricks. But when you look at maybe this image, and sorry, the apologies, look at the bottom right of the corner, you can see how it's much more challenging. So I think the stored, the materials were covered, were stored, and as you can see, once it gets to this condition, a lot more value has been added to those bricks. They're now a commodity again. We know about them, we know what strength they have, etc., etc. We've done the tests. But there was a problem that we didn't actually get as many bricks as we thought. That target of 2/3 was a long way short. So we started to look back at the rejected bricks, and I can see Lex over there. Hi, Lex. So he went down and he assessed these bricks, and he also looked very carefully at the bond pattern and noticed there's a large number of headers in the pattern that had to be rebuilt, and so he was able to work with Pay to identify a lot more bricks from those from that discarded pile that could be used again. So the lessons from that project are that you can whatever dismantling you have to incentivize people to be careful. It's difficult, but if you can incentivize them, you get something valuable as a result. It's easier to manage the masonry than it was the bricks. And once you had those bricks, you had to keep them secure and avoid any further damage. I'm assured this didn't happen, but it also occurred to me that, those pallets of bricks look quite attractive. They've got a value. They might not stay where they're put. I'm pretty sure that didn't happen. But we can be smart and we can reuse even the discarded materials. So moving on to the Burwell collection. This is in Glasgow. The museum was being refurbished, and we managed to achieve some really amazing savings in carbon, both embodied carbon and operational. As a result, this project has gained many awards, including the SFE award last year. Lots of savings around there, and a very happy client, because he's very happy he's got now a building with a steady conditions. But in the process, we also did a lot of work about the recycling of glass, and I'm sure we'll be hearing about that later. But what I wanted to focus on today was the story around the glazing bars. This is the building when it was originally constructed. It had a very simple paint and glazing system. But we decided that, let's see if this could be retained and reused. And so we had to go and look at it, study it, test it. Was it? What strength was it? What properties did it have? And we could see that quite simply we could add a thermal break into it, and to take the larger double glazed insulated glass units that were being installed. But the challenge on this building was to realise that saving in carbon from not using new aluminium, it was extremely difficult to convince the subcontractor for them, it was far easier to take these little bits of aluminium, send them off for scrap, and put some nice, new, reliable stuff in there. So there was a lot of effort needed by my team to actually keep the contractor on the path of saving these bits of aluminium. And I think that's an important thing, is that you need the alignment of the team. You have to be passionate about it. Because these are small gains, but they're actually very important. So as a consequence, this building has achieved huge savings in operational and embodied carbon. And I think for me, again, information, There was no information available about the original construction, so you had to use site investigations. It was a simple concept, but it was a real challenge to keep people than doing the easier thing of just building something new. So small component, big story. And the last example, Triton Square. I've talked about this project before, but again, I think it really fits into this narrative. It was, the original building was completed in 1998, so when we were looking at this, what would it be, about 7 years ago, it was still a relatively young building. So there was this sense that, well, we can't just scrap it. We do have to work with that existing fabric, and fortunately the client and the design team were very much on that journey. And so you can see the building on the right, which, as it was finally realised, where a lot of the facade has been retained and reused. You have, in the main curtain wall, you have two main components. You have an outer screen, and you have the inner wall. And the very fortunate thing about this project, there were two main benefits. One, it was of an age where the people that originally worked on the facade were still in the industry, and Permasteel Lisa still had all of their, Schelderbau had their drawings and records, and we could access that. So there was a high amount of information available, but of course you go and test it and check it as well. But the facade could be categorized about what you were going to take, reuse, and reinstall, what were you going to remove, and what were you going to keep in place or put new in. And so you can see here that the strategy was that the screen was taken off. It was actually put on 1 story higher. The floor, the section of the facade around the floor was retained, but new glass was put in with a little bit of new glazing systems. So this all actually happened. So over 3,000 square meters of unitized panel was refurbished. It saved over 1,000 tons of CO2, and it actually created a cost saving because that new facade didn't have to be bought. And the project as a whole saved 50%, over 50% of the carbon of building a new building in that space. Key things are, understand materials, work with the supply chain. You've got the accessibility to the components. You've got to look at them. You've got to be able to assess them, and you've got to have data available, whether you come from the records or you do your checking. So that information is vital. I think the interesting one about this project is what happened on the warranties. So warranties were given by Gartner on the new components and the workmanship on the retained components. And the client accepted that the retained frames didn't have a warranty, but they knew a lot about them. And that was an acceptable level of risk for that client. So to conclude, working with existing buildings is absolutely essential to address the climate crisis. We're going to be living with these buildings for a long time to come. There's a lot of barriers. We need to work how to overcome them, but there's a lot we can also learn from what's already been done. People will need to take different responsibilities. We'll need different players in the market, and therefore I believe new industries. So just before I say goodbye to you all, and I would like to use this venue to ask people to consider joining the Society of Facade Engineering. There's a lot happening. Those who come to the awards tonight will hear a lot more as well. But we have increasing number of international hubs. There's a route to chartership with SIBSI, and it's a great place for the facade industry to come together. So with that, thank you very much.
Thank you, Russell, for setting the scene very nicely on a big part of what the industry is going to be facing over the next 5-10 years, and that is to work with existing building stock. Yeah. Because the statistics indicate that all the existing buildings will be also our future buildings, and we just have to adapt and reuse them. I know John has scribbled a lot of notes while you were speaking, so he has, I'm sure, a couple of questions to ask you.
I do indeed. Thank Thank you, Russell. That was very informative. We're a long way behind in the retention of existing buildings again. Two things I love. This idea of waste material is just good material without information associated with it. That's the first thing. And the second one was your statement, and I'd like you to expand on it. Little things. 100 tons of carbon saved doesn't sound like much, and it took an enormous amount of effort. But I think that is the key to the future. The idea, if you can't do great things, do little things in great ways. I'd like you to expand a bit more on how you think that.
Well, I think that's, as I showed the picture of my team, and these people care a lot about sustainability, like we all should. And in the day-to-day, they think of these ideas, and it's that passion to convince other people in the project that you need to do these small things, because it gives good stories and it makes people feel good about those little wins and makes their work more purposeful. So that's
Just want to add to that. You mentioned, I don't know, in one of your slides about what you call the materials virtual warehouse. And this is about catching the stock, even though you might not have immediate use for it on your immediate refurbishment, but another project being refurbished in 6 months might have use for those materials. How do we capture that material? You talked about demolition being a cleaner process, almost a de-installation rather than demolition.
So increasingly, you're finding on projects now, pre-demolition audits are being created, being commissioned, and these are where companies like Arup and others can come in and they can assess what's there and what the potential reuses are, etc. The challenge, though, is to find that next person to take that material, make sure they've got the information, and it becomes a product that's then available to others.
But that
there are those
logistical process of recovering the material and storing it for maybe a period of time, that has to have value on it.
And there are businesses
if you
in that
don't make
space.
value on it, nobody will do it.
That if you search, you will find businesses in that space that are looking at that reuse of materials. I think the scale is small, but increasingly you're seeing it. And I walked, I had a holiday the other week in Isle of Wight, and I walked past, and I forgot to put the picture of the front of this merchant who was selling existing building components. And
the other aspect that I see is getting architects to design using existing components, and they need this information, this virtual materials warehouse that tells them what's in the warehouse that they can use. How big are the pieces of glass? How big are the pieces of steel or whatever? So that, again, information management is needed.
And that's also when that picture was taken at our away day at the start of the year, we came away from that committed to trapping the information about what we're designing now. So for those future use in 20, 30 years' time when the building goes around the cycle. So you've got to know about the properties, you've got to do that testing to give value back to that material.
Yep.
I have one more thing to add to that, a question more. British Land accepted no warranties. I think that's got to be one of the key ways where progress will be made, is in getting people to really understand the risks they're taking on board, or the additional risks they're not taking on board. Was it a difficult task?
I think because it went all the way through from the concept, from the early stages of the project, British Land knew they were going to be retaining the existing facade, that they were prepared for that story. I think they've got the challenge of then explaining that to the next tenant who might have a repairing lease or whatever, that you've got your building fabric here. It was examined and checked over, a few years ago, but it's essentially 30 years old.
But it's a good example of how responsibility sharing could be in the future. That the responsibility sits partially with the people that investigate and consult, the people that modify, and the owner of the building who ultimately is saving cost and carbon and the environment.
Yep, that's right. Everyone's got to become a stakeholder in that.
Yep. Thank you, Russell.
Thank you.
Absolutely brilliant. Thank you.
Indeed, very much.
It's quite quite appropriate that our next speaker is an architect, and maybe she will tell us whether there is a future of using a virtual warehouse of or real materials. I'm really happy that Yasmin El-Ani Spence, who's a director at Wilkinson Air, is here, and she's ready to talk to us about the importance of facade design. Thank you.
Hello and good morning. I have to say, I don't think I've ever given a talk quite that early in the morning. I thought I'd be the only one with a few keen people, but I'm not. So amazing, and thank you all for coming, and thank you for Zak for having me. Yes, I'm an architect. I'm a director at Wilkinson Air Architects, and I would like to sort of show you a bit of our work, but with the emphasis on, obviously, facades, the impact on facades, especially on reused buildings, and how we can build on the stock that we have. But obviously, we all know that, not one idea fits all. So with an open mind, this is us, and as I always say, no man is an island. We work together. There's all sorts of expertise that we have that come together and that we encourage. These are the people, as I always say, that build and design the buildings for people. Every building that we are in and that we use is designed for us and for our use, for our products, for our produce. We are, as such, the end user of everything. And we have the power, and more today, to have a positive influence on what we create. Starting off in London, I just wanted to run through this. This is 8 Bishopsgate. It's in the heart of London, for those obviously who know. It's in the city of London. It is just completed this year. It's opened up, and it's the brighter, tall tower of about 51 stories. The blocks are moved around. Obviously, as many of you know, we have St. Paul's that we have to keep the view open to avoid the blocking of the view, and it grounds itself in a more solid element to hit the groundscape. The change of these blocks and facades, again, they are there to put us in an urban setting. They also allow for a reduction of structure. The reduction of the blocks also allows for different floor plates, which in return allows for smaller practices or smaller companies to be part of this. The tower per se is actually a cluster and a gathering of different spaces, and it's a multi-let with the idea of different sizes. It creates its own community. We have viewing platforms higher up. We have amenities. We have retail that, again, doesn't just give the bigger companies the location and the option of having a building like this, but also smaller entities that can profit from what this vertical community has to offer. These are the early renders. Again, the view to St. Paul's clear and over the Thames. This is a public viewing gallery. Again, it is very much part also of the City of London, that a building is not on its own. It is part of the cityscape and to be used by the local communities as well as, of course, for those who work in it. This is obviously the evening and the day. It is that tight cluster that really is now very much part of the focal point of the City of London, very close together, but a strong entity together as well. Typical floor plate, obviously, with amazing views. But we all talk about carbon, we all talk about use and reuse. This building saved a lot of its embodied carbon over the construction and design phase. We managed to reduce it considerably, which is a win. It is very efficient with its cavity glazing, with the solar shading embedded within it, but yet flexible for future changes. There's on-floor plant, which again allows more of an optimized temperature and control for smaller entities within the building as well. But yet, It is 100,000 approximately tons of carbon, which what you can see here equates to many things. The key thing is we can't always reuse, and that's something we have to be cognizant of. Not every building stock is great, and we've done projects where we now, within the City of London, really have to prove very hard that we can remove certain buildings. Not everything was built well enough and within the current regulations to be a building of the future. We have to accept that too. But what that should spur us on to do is that the buildings that we build now will hopefully be much better for the future and of longer life. So we need to learn from what we can't use anymore. Why can we not use it? And what can we do different in the circular economy of the future? To not give our buildings a lifespan of 25 years because of warranties. How ridiculous is that actually if you think about it, when pyramids or whatever were built for hundreds and thousands of years, and we as a society build for the lifespan of 25 to 30 odd years. It is absolutely ridiculous, and that is something we all as an industry need to move away from. And again here, on a sunny day, for the first gentleman who said it wasn't sunny enough, on the odd day, we have it, and it's not photoshopped. But now we come to reuse. You might want to look at the picture. I introduced it a bit earlier. This time it's the elephants, the city headquarters. Many of you know it. It's the Pelly building in the heart of Canary Wharf, one of the first buildings that went up, finished in 1999. This image was taken in 1965. It was the circus, I can't remember, it was Cooper Circus or whatever, that would come to London via Canary Wharf and then pretty much walk through London to get to the circus. What I'm trying to show with this image, and there will be more elephants, is we have changed. Our mindset has changed. Nobody lands an elephant in this fashion anymore and walks it through the City of London to get somewhere. Can you imagine the complaints? So, and this is what I'm trying to say, it's the elephant in the room, but it is also reflects the fact that we have changed our mindsets and we need to keep doing that. What was correct once, which was fun and great, does not need to be the future. So this is Canary Wharf, as it started, obviously a wharf to London, the outer wharf, that fed London mainly with, A, got people exiting London, and B, got a lot of the produce in from around the world. In the the mid-90s, huge developments happened, and of course you can see, do I have a pointer? Oh, look at that's so exciting. We've got Citibank right here. Like I said, one of the first buildings, it was built in 1999. Again, just as a bit of an example, we say that this building is at the end of its life. My son was born in 1999. He's 24. Fingers crossed, he's at the beginning of his life. So why is there such a discrepancy? So we were tasked, it was a competition by Citibank itself, who had a great sort of task force to lead this on. It's a tricky thing to reimagine a vertical structure with no surround. And not only that, to completely gut it, give it a new and very sustainable energy consumption and air and what have you not, everything that wasn't thought of in 1999 but now is. But more than that is to make it into a healthy and a new ways of working environment. So you're taking a very prescriptive thing, you shake it up, and then you try and put it back together. And many of us, I sort of head the workplace as well in the office, is you take Citibank or you take the city, you make it into a town which is more tangible, and then you make it into a village. And the village in any space is your identity, it's your desk, it's your friends, it's your colleagues, it's the living room of your home. How does that work? I'm going to go over the crazy thing again. It is all about to get people together, open up spaces, and to support the flow through the building, connectivity, and reduce the silos that we have spent many years in the 80s and the 90s producing and that we're breaking up. With that in mind, the key feature and the winning feature of this was, it's no rocket science at all, it was that of villages. We had 42 stories that we had to deal with, and we did some major interventions. At this point here, Citibank was still thinking they might have some tenanted space, but actually that is all gone and it's all Citibank now. What we did do is, you can see every now and then, or everywhere, every 3 floors or 5 floors has a village. It has a stair in the middle, it has its identity, they're not repeated, they're in different locations. So if you travel through the building, you're not going, oh, but I've seen this before. It's always something new. And I always call it, it's a vertical town as opposed to a horizontal one. What we also did, which was quite key and quite different at the time, is that we moved all the amenity floors to the center of the tower at level 17, 18, and 19. And that was twofold. One, you've got views, which is always good. B, we had a plant room that we could use below the kitchen. And C, it again undermined a segregation of floors, so that if you sit on the top floor, you're as equal to it as you are on the bottom floor. It is allowing to give this tower a heart in the middle. And then comes the next thing, as Russell was saying before, is that it's an existing building. We have to work with what we've got. We can't come up with new things. They are what they are. We've managed to design this now for a much higher occupancy than the Pelly had allowed for, because, different times. We have kept all the lift shafts. We did not add a single new lift shaft, and we're dealing with that with a lifting strategy of double-deckers and so forth, never more than 1 change, maximum 2. So again, actually putting amenities in the top of the building allows a much better movement with a lot less time than if we had put everything at the base. And again, it's also about well-being. Why would you be at the base of the building when you could be at the top? So what you see on the left is what you get on the right. These are the sort of villages that we spoke about. They're always 3 deep, with a heart in the middle, with a coffee bar, views through, so that you have interconnectivity. And again, these stairs also aid the fact that less people will take the lift, because if I can move up between 2 floors, A, I'm moving around a bit, which is a win, and B, I'm not going to the lift. And C, I might get to see people that I normally don't. So this is the ambition on the left, and we are actually now on site, and again, working in an existing building that has no space around it is a challenge. Your whole building site is internal, which is a very strange thing. It's a huge learning curve for us and Overbury as well, who are the contractors and the team, is that you have to behave very differently on site if it's all within the boundary of 4 walls. So then coming back to reuse, as I said, core, basements, everything is retained in this building. And to 70% the glazing as well. We wanted to make some differentiation that gives a nod to the future. So at 3 points, at the top, which we call the beacon, in the center, which we call the high street, and at the base, which is the plaza, the facade is renewed. Bigger glass panes, more permeability. And what we've also done is, to top that up, is in the middle here, we have created a fresh air winter garden for people to go out. So these are the key nods to the future and give people a sense of a new intervention. We had a lot of, obviously, as we were saying before, if you deal with an original building, a lot of surveys done, and actually the survey of the existing facade was that it was in very good shape. So why not keep it? And that is what we've done. So going to the top, again, there's the intervention. It is more of an executive and event space. We come to the middle, where we see the louvers for the winter garden. where people, again, if you're going to get people to have lunch and stay in the building, at least give them fresh air and the option to go out. So we've got these triple height spaces with completely fresh air as part of the amenity floors. So this is, in the beginning, we're starting now at level 17, 18, 19. I mean, just to put the scaffolding out to support the new glazing going in is a feat by itself. We're working with Scheldabau, who luckily still has the original mock-up, good job they didn't get rid of it, of the original glazing. So it's a nice story as well of actually working with the similar people, using the expertise that you had back then and to be able to use it for the change of the building in the future. So that's been a really positive part of the story. Again, here we have some of those more detailed images. At the front as well, we just gave it a bit more of a contemporary touch, opened the glazing up a bit. We also removed, there was a big loading bay, opened the loading bay up so that everybody, and this is one of the first buildings in Canary Wharf at this scale that allows the public to go through. Considering this is a World Bank, this is quite a new step. It was quite a big step for Citibank that actually the public can use and go between Canada Water and Jubilee to walk through. And this new permeability, and that was something that Citibank was really interested in. It was a very much a huge discussion with security, but we got there at the end. So this is where we are at the moment, with the cladding coming down and the new one coming in later this year towards the new year. And this is what we are hoping to achieve. Now, this is interesting in that we are saving 100,000 tons of embodied carbon, which is what the other project cost in carbon, and yet that was quite low. So this is just a saving we've done on the building, which is amazing, right? The other thing that we're doing, we talked a lot about material passports and what have you not, is a lot of the interior materials. This was built in the late 90s. They loved marble. We have more marble than we ever would need or love. But what we have done is we're taking the marble, we are rehoning it, reshaping it, and we are reusing it. And that history and that always that nod back to the past to bring something to the future, I find it something very, very exciting and quite a nice story that we move away from this throwaway culture that we have. We're done with it. I don't want it, but instead think maybe a bit harder, what can we do with it? And in that regard also, I think we need to re-educate the workforce. We talked about this careful demolition or deconstruction, is to do this, that demolition will become something different and has to be done with care. So 100,000 tons of emission gives you 2,000 new built homes, and that's also the emissions of a lot of wine, which I was quite keen to know. So I'm doing all right, I can keep on. But talking about a war, we've got a lot of wars going on at the moment, which is an insane cost of life, and I don't care for what side we're talking about. No life should ever be lost in a war. War alone, 1 year of the Ukraine war cost 120 million tons of emissions. So if people might have a thought about war and who is right and who is wrong, maybe we see it from a different angle, that this affects all of us from a very pragmatic angle. And when we talk about major, minor to major, we have to understand where we sit within all of that and what the world is also doing. We are a part of this, and as somebody said earlier, wherever we can contribute in doing less, then that is a good thing. And less war, in my mind, is always a good thing. More elephants. This is in Halavington and Malmesbury. Yep, they went everywhere. It's the same circus. This is just a project actually completed a few years ago before everybody talked so much about reuse. It's amazing how quickly we change topics. A few years ago we talked about workspace because we had COVID. Now we talk about this. And I think we need to keep talking about this. So this was a site somewhere in Halavington. We went, this is for Dyson's headquarters, and he wanted a new building on that site. We discovered 2 hangars, 86 and 85, that were in pretty good nick. Built in 1942 as part of the aircraft. And we said, why don't you keep the buildings? He said, well, why? And we said, well, why not? Eventually, we persuaded him to do so. So I don't have the statistics on this, but the building is retained exactly as it was. And even the doors were refurbished. So what you see here is the refurbished doors. All we did was open them up. All the insulation, everything happens on the inside, or the plant on the inside. And the win was not only we kept the building, we then did the other one as a prototype for the cars, that we used 2 buildings which were not built for research and development whatsoever. And they're now doing that job immensely well. So think a bit harder. These are only envelopes. We can do things with them, and that's the example. So this was it before. They used to hang the parachutes to dry. These were the dryers for the parachutes. And this is it now. Completely state-of-the-art research center. Same space, even the windows were just replaced as crittle, and all the work of the plant room happened on this elevations only, so you don't perceive it inside. And back then, because of the war and the loss and the money that was short, the structure was really interesting. We worked with Biro Happels on it. You can't really see it, but it goes from thin to thick and thick to thin, and we thought, what's the rhythm? Well, where they didn't need to put that much concrete, they simply didn't. And that wasn't because of sustainability, that wasn't in economical sustainability, but this is exactly what we need to return to. And there it's just looking pretty. Battersea Power Station, it's still the same zoo. These are still the same elephants. 1965 this was taken, still the same elephants, now obviously with nicer outfits, being walked to Battersea Park to do what they need to do to get their money. Battersea Power Station, an icon, reuse project, amazing, completed. I've always liked Battersea Power Station. It was one of the first projects I did as a student. It came in 2 halves. Maybe people don't know that. One was completed in 35, B was completed in 50, or 34, 35, 40, 55, and worked till about 1983. So actually, a fairly short period of time, if you think about it. Stood vacant, well, for many years, many different developers, but in the end, we got there. Reuse, you talked about bricks before. This is the brick reuse on steroids. Carefully, beautifully done. Those that could not be replaced were reconstructed. And what is interesting on this image, and we are here for facades, is that actually 80% of the windows, the fenestrations that you see in the brickwork are actually new, which you wouldn't guess because it fits in. We managed to make it work with the existing fabric. And obviously what you see on top is the new residential units. It's a multi-use space of leisure, retail, offices, and residential. Even the offices area is so huge, it's about 80,000, is nearly the same size of Bishopsgate. So the scale of this building is amazing. Again, it's a prime example of reuse, keeping history as well, and creating communities. And I think this is always something that's very close to my heart and the way I work, is again what I said in the beginning, buildings are for us to enjoy, to work for us, not the other way around. And I think it's an educational tool as well, so that people and young people that come through there will question why the building is like that and will give a sense of interest as to why was this there, Mum, Dad, tell me. Again, obviously, reuse was at the forefront, Many of the original steelwork was done, reused even as furniture. We really emptied the building and took out what we can to reuse. The juxtapositioning, I have to say that word every now and then, it's quite fun, sits well. There's new, there's old, there's a respect to both. We're using the old dials and where the building came from and what it did as part of the language where we're going with it in the future. Obviously, it's got the greening on the top, and I'm not even going to go into PVs and the green aspect of all of that. But it's really the glory of the space that I want to emphasize here. And like I said, this continuous reminder of what the building did. And then, of course, there's that bit of fun where you can go up for quite a lot of money and can look over London. But, you know. So this is my last elephant. You'll be delighted. And he is actually an AI elephant. I told AI, could I please have a glass elephant? Gave me quite a few. I think AI and we need to keep working together for a bit longer. But I think the reason that I wanted to put that in is we now have technology, we have more intelligence than we've ever had before. We can do more surveys than we ever could before. We can test things better than ever before, and we need to use that, whether it's AI or whether it's something else. This, for me, stands for the future. As part of what we do in the office, and I just wanted to tap on that very briefly, is something called positive architecture. We did a sort of a COP back then, recap and quiz about what happened there, and we sparked conversations about, does sustainable architecture always have to have that certain look? I'm not going to say boring, but it's a look. You know, can we do something different? Can it be more thought-provoking as well? Can it be beautiful? What can we do, and how? So we took that as a bit of a challenge, and as we said earlier, we all have a lot of young people in the office that are they're driven by this, and they're keen to contribute. So we've come up with this positive architecture where we're also working with AKT2 to come up with a language and a practical assessment, not only driven by sustainability, but a holistic assessment of what do we need, how much do we need, and how can our buildings work. Recently, I was overhearing some students, PhD students in Bristol, and they were talking about embodied carbon. And one girl said, well, it's like the slushy. And I thought, what's she talking about? And then anyway, what she said, you go to a cinema, you buy a slushy and a plastic cup. The embodied carbon in that is already terrible. But then you put a paper straw in it. And that makes it okay, because you know, you're responsible. You've taken the paper straw. The first step is, why do we need a slushy? Why does it have to be in a plastic cup? And that is actually the same thing that we should apply to everything. Yeah, we can make things better, but do we need them? And that's a key element. And like I said, the elephant is here, standing loud and proud. We are in a climate crisis. We cannot deny it. It's there. We spoke about earthquakes, we spoke about floodings, we spoke about everything. I think we all know, but we all also have to do something about it. Construction has a huge impact on our emissions throughout, globally. We need to be aware of that. We have that impact. We need construction. I'm not saying stop, but we need to be cognizant. So this is where we're trying to come from. And if anybody's interested in supporting us with maybe glazing ideas and wants to join this group, more than welcome, is to come up with this architecture that we can do even subtractive architecture and design of, do we take things out of the building that are simply not needed? Can we reuse materials so we can reuse beams and columns? They might not be that beautiful, but they don't always have to be. And how can we, with that, come up with a really beautiful architectural expression as well? So this is what we're working on in general. This is an ongoing thing, and we will release things that will come out of it. And we've done various competitions in regards to also facades of the future, very much looking at what we did for Citibank. This was one in New York. We're just cladding it to a new external, taking all the aspects, again, holistically, coming up with a new skin that allows the building to open up more, allows greenery, allows fresh air, is a very positive move. So we're doing more and more, and again, it's also with our younger staff to really encourage them to put their thought process into all of this as well. So again, using a building of age and enhancing it through the embodied carbon. The embodied carbon of adding this on pays itself off after 4 years. And it's like a lattice work of greening, openings, and so forth. And yeah, we hope that more and more of these studies will happen and that more and more of this work will happen. And it is happening. We've got Citibank, we're doing something else, for example, in Germany at the moment with reuse. And it's a very exciting thing. It's exciting to learn from the past. It's exciting to understand. But we also have to understand it doesn't always work. So I think I've said everything I wanted to say. I might have forgotten a few things, but thank you very much.
Stay for a minute. Thank you so much, Yasmin. That was an absolute tour de force of architecture, of renewal, of history. I loved a lot of the quotes you made. Absolutely loved them. Do we need things? Mm-hmm. My bugbear is, do we need cup holders in cars? I don't think we do, but they've stuffed them full of cup holders and people are busy drinking coffee instead of driving.
What about the car? Just a thought.
That's the slushy, you see?
Yeah,
That's the slushy.
exactly.
He's talking about the straw.
Yeah. John, please.
I was inspired listening to you, and I think that's what architects are meant to do. But the knowledge base that goes with this is beyond anybody. I think at the end of the world, the architect can really only bring together the combined intellect and skill base of the team. So my question is about your teams. Mm-hmm. Are you getting the support you need to deliver the dreams that you have for the future? Is there more that we can get? Where would you like to get more support? Because these things are inspirations. We don't have them now.
I think we spoke a bit about, how do we prepare for reuse? And I think one thing that still people and clients and developers are a bit slow in understanding, because everybody has a program and everybody wants to be in the building. Time, because there's so much unexpected. You have to expect the unexpected in those buildings. So I think more than anything else, I would like developers and clients to understand very clearly that there will be problems. So please allow for time. That time will pay you back in dividends later. I think time is the biggest thing. And again, we have more and more the ability of surveys. Please, we've got other projects where you say, they're coming. Do it early. Don't let us wait. Everything that's there is that this understanding you need to work ahead on these projects a lot more than you would with a new build. You have to, it's not just, the emptying the building, everything, but to get the team really knowledgeable and to be able to deal with the project, the information needs to be there as soon as possible to do it justice.
Yeah, and I think you're describing a process where we're now in a kind of, we're predicting the market slow down and so on, and people are being more considered in what they do. Yeah. It's not just about building volume. We went through a phase where a lot of buildings went up. They're all condemned, they all have defects, nobody can get a mortgage on them.
Yep.
But if you actually spend the time to develop things and deliver something of quality at the end of it, that maybe less is more in the end.
Yeah, I think time is a factor, and it's something that the industry doesn't give us.
Yeah.
I don't think it's associated purely with design. I think all the subcontractors in the world would say the same.
No, I'm talking holistically about the whole
process.
team, the whole process, not just us.
Yeah.
And do you see some magic breakthrough that's coming? I was fascinated by the idea of facades. A colleague of mine has been looking for the zero energy transfer facade, where it just stores the energy and gives it back at a useful time.
Yeah.
Things of the future?
I think there's a lot of things. I think we can either you can call it a messy stage, you can call it the exciting stage. There's a lot of, when we talked about sustainability a few years ago, you can't touch steel, don't touch concrete. Now we're realizing actually if you put more columns in, actually that's not a bad thing because you save somewhere else. We are really learning, and we're learning fast. And I think in the next few years, all these things will show up. What was the real answer? Where do we need to go? So I think in a weird way, we should allow ourselves a little bit to enjoy this phase of a lot of innovation. And some of it will happen, and some of
Some it won't.
It won't.
Yep. Great.
Great. Thank you so much.
So much indeed.
Welcome.
Thank you.
Yeah.
A big thank you. The next presentation is covering condensation and airtightness in facades, and it's from James Brackenreed-Johnston. James, are you there? Yep.
Good morning, everyone. Thank you very much for joining me this morning. My name is James Brackenreed-Johnston. I work for the A. Proctor Group, who is a construction manufacturer and developer based up in Scotland and about an hour north of Edinburgh in a town called Blairgowrie. So today what we're going to be looking at is condensation air tightness solutions in facade systems. Obviously, we've heard a lot about facade systems today, but hopefully this will go more into a technical background into the design of those facade systems, especially in regards to the overwhelming issues we have with interstitial and surface condensation within those facade systems, in regards to the air tightness levels that we also want in these buildings, but are either worried, scared about ABIS, about ADT, and about achieving those. So when we first get involved in the design process, we need to understand the occupants of that property. So whether it's a residential property, if it's a commercial property, if it's mixed use, if it's educational, because all that human interaction with that building creates different issues internally which we need to deal with and need to learn about. Once we've sorted out the occupancy levels, we can then look at the external weather conditions in regards to driven rain, in regards to thermal variances. Obviously, as we've heard today a lot of, is the fact that the climates are changing. So we need to understand how that climate is changing. What buildings are around your buildings which can create shadowing, if there's any cliff or any areas that are going to create any shadowing on that property. Then finally what we look at is the building itself. So what we can see, obviously easiest from a design perspective, is to understand how that concrete structure, how that timber structure is being created. So if you're looking at a concrete frame, you've got initial high load of moisture within that concrete, yeah? And then that moisture from that concrete needs to leave that product. And if it's not dealt with properly from a vapor permeability point of view, that concrete has to dry out internally. If you have a VCL sealing that concrete internally, then where does that moisture go? So it's about making sure that you can dry out that concrete adequately. If you don't do it, you entrap that moisture within that system. Once that concrete, if it's allowed to, does dry out, that concrete can act as a decent thermal mass within that building. Therefore, it can aid and abet in regards to heating the internal space of that building over the lifetime of it. Juxtaposing with CLT. If you look at utilizing CLT, you've got a very low moisture content in that CLT from the beginning of the project. Yeah? Doesn't need the moisture to remove from it. However, the thermal mass of that product is very, very low, so therefore it won't aid and abet in regards to heating that construction during its lifetime. So as mentioned before, there is no one-way fits all for any construction. Every single construction will be built in a different place and needs to be treated on a bespoke basis. So once we've got the outer ring of these conditions sorted out, what we can move on to is Again, our core principles are HAM principles, which is heat, air, and moisture movement. The understanding of how that building is going to perform, how that envelope of the property is going to perform in regards to heat, air, and moisture movement. Okay, from a historic point of view with solid walls, there was a lot of vapor-permeable materials that were utilized, which never inhibited that vapor drive, whether it be egress or ingress through that system. Nowadays, we utilize a lot of foil-faced insulation products. We update those walling systems. Yeah? We've changed all the internal usage of materials. We've changed the plumbing. We've changed electrics. We've got more and more washing going on inside properties. We've got more and more people living inside properties. We're changing the dynamic simulation of those solid wall systems. But is it for the good or is it for the bad? So you need to treat them as they go. So, understanding the heating mechanisms within these properties, if we take it back up to high rise again rather than low rise, understanding the heating systems in combination with the air tightness line. So when you're looking at HVAC systems, if you're looking at passive ventilation systems, just because you're designing a passive house tower doesn't mean you necessarily have to stick to a mechanical ventilation. You can look at passive systems in combination with. But ultimately, it comes down to, as with all these things, the installation of the mechanisms, of the materials. So going through the vapor drive, obviously in the UK and generically the Northern Hemisphere, you're looking at warmer internal climate to a cooler external climate. So understanding the placement of the materials, making sure the materials are placed in exactly the correct place so that you don't create an interstitial condensation risk or surface condensation within that buildup. So traditionally wise, if you take an AVCL, which is what it's commonly called now, previously called an air barrier. The name air barrier was replaced purely due to the fact that barrier stipulates an absolute, that is going to be an absolute barrier to moisture, to air through that system. We all well know that when it gets to site, that material, obviously as a solid roll going to site, has that capability. But once installed, it gets penetrated, it gets torn. Does it get repaired properly? Are you solely reliant on that AVCL for your air tightness line, for your vapor control line? More so of a problem is obviously once it's installed by the installer installing the VCL, you've then got a plasterboard or 2 layers of plasterboard going over the top of it. You then have follow-on trades, plumbers, electricians coming in, cutting through that plasterboard, cutting through the VCL that you're requiring to achieve your air tightness line. Are they repairing that? Do they have the ability to repair it? Do they even know it's there? So it's understanding what's going to happen to the products once they're installed in the system and making sure you've got enough defense against what's potentially going to happen. So from an AVCL point of view, airtight, vapor tight, limits moisture ingress, limits air leakage. They are reinforced and durable, most of them in this day and age, but are all those parameters being met once the product is installed? And even from then, once the project is being inhabited by the occupants, are they putting holes through that? Are they affecting the air tightness? So what we can then look at is a vapor permeable membrane, or VPM. They can be airtight or air open, depending upon where you're using it in the build. From this purpose, what we'll look at is we're looking at an airtight membrane. From a high-rise perspective, this membrane will go on the face of the sheathing board, so the cold side of the sheathing board. Vapor permeability, in accordance with BS 5250, they are moisture neutral. Okay, so they allow the egress and ingress of moisture through the membrane. Doesn't mean water. These are watertight products. Don't ever let somebody tell you it's waterproof, because it's not. It's watertight. 2W1, which is a standard for walling. For roofing. The standard for roofing is W2. The standard for walling is W2. It can limit air leakage, obviously dependent upon the installation, and it is a very much simplified installation, especially with, I can say it because it's on the wall, with our product here, which is a self-adhered, vapor-permeable, airtight membrane, watertight to W1, which self-adheres to the sheathing board, so there's no additional tapes or mechanical fixings required. All Part L documents will lend you to look at, listen to, read BS 5250. It's recently been updated, as you can see there. It's not necessarily now in regards to condensation. It's a lot more focus on moisture issues within the facade envelope, and indeed building as a general rule of thumb. So it's been around for probably about 45 years now. Started off as a 10-page document. You're now up to about 190 pages. It now includes CAD details as well, so you can use it as a quick reference guide in regards to what membranes to look at within the facade system. So as I mentioned, condensation was obviously the precursor. You're now looking at a lot more damp proofing issues that the BS 5250 is dealing with. For assessment of a facade, whether it be low-rise, high-rise, mid-rise, modular, whatever you're looking at, it will relate you to BSEN 13788 and BSEN 15026. And now, both of those will now recommend that you look at dynamic numerical simulation as opposed to the standard, which we've all done since the 1950s. Not that I was alive in the 1950s, but ever since the 1950s, we've used the Glaser method, which is still a viable option for a quick assessment of what's going on within that in order to assess a U value and also to assess a condensation risk within a build-up, but a very much more simplified one, which you'll see shortly. So this is a dynamic numerical simulation, which we utilize on a general basis in order to stipulate where that condensation risk may or may not be. And what we can see here is the external temperature. Sorry, I'll just get used to this. External temperature through to internal temperature, internal relative humidity to external water content. Here you can see obviously the build-up of what the products are involved in the build-up itself and the thicknesses of, and then you have the actual moisture content within the build-up. Okay, so that's showing the moisture content. With the hydrothermal assessment, it's a much more in-depth analysis, as I mentioned, in relation to the Glaser method. But what it gives you is actual moisture content from production of the materials. Okay? Even from the case of if you're doing a retrofit project, it will tell you how much, and the age of that project, it will tell you how much moisture generically will be in those materials since they've been built. The differential with the Glaser method is it assumes that complete build-up is dry. Even from a new build perspective, it assumes that complete build-up is dry. You know as well as I do that insulation on the outside of a facade on a high-rise will sit out there for a couple of days, couple of weeks, maybe even longer, and it will be saturated. With the hydrothermal, you can increase that percentage of moisture in that facade system. Whether it's the insulation, whether it's a sheathing board, whatever element you wish to increase that moisture on, we can do that for you in order to give you a more realistic process. Again, time frame wise, with the Glaser, you get 1 year, you get 12 months. With this, we can go 1 year, we can go 3, we can go 5, we can go 10, we can go 15, we can go as long as you want. It takes a little bit longer to do the process, but ultimately, it gives you more validity in what you're doing. Especially in regards to retrofit, what we've seen is people putting on thermal laminates, 2 years, 3 years, 4 years, 5 years down the line, start seeing damp spots on the inside. They start seeing little bits of mold growth. This is because there is an interstitial condensation risk, but it manifests and manifests in that system before it comes out through there. This will highlight this. A standard Glaser method will not, because it only takes that 12 months, sorry. So for that 12 months, absolutely fine, no worries at all. But as the months progress, as the weather changes, it will increase. Again, with the Glaser method, it doesn't take into consideration actual temperature variance. It doesn't take into consideration driven rain or wind speed, whereas this new system does. And again, this is part of the process that you'll receive in the report, which is not a 1-page or 2-page document. It's a decent size, sort of 20, 25-page document. And indeed can be animated, as you can see from behind there. So just to put a bit of proof in the pudding, this was a project that we worked on, which is the first passive house leisure centre, which is down in Exeter. called St Sidwell's Point. So integrated into the design stage, so we knew all the different build-ups, and believe you me, there were 6 different wall types within this building in order to make sure that we were dealing with each of those individual build-ups absolutely to make sure that they were being designed properly and that there was no issues with condensation and the air tightness was there. Obviously, high humidity, so we're utilizing the hydrothermal assessment, and obviously with the chlorinated water, we utilized the VCL that would obviously defend against any chlorine attack from that point of view. Carrying out the woofy analysis. From our perspective, its control's a bit strong. It's about guidance. It's about making sure that the guys on site, the main contractor, the subcontractor, they know what the material's doing. They know what it's there for. They know to advise follow-on trades what it's doing to this building. Okay? Everybody knows that the air tightness level on a passive house is very, very onerous. So if people mistreat the membrane in the fact that they're just punching holes saying, oh, my rail's not in the right place, I'll move it, put it somewhere else, without letting anybody know or without repairing that, that's where buildings start to fail. So it's about communication, it's about understanding, it's about pride and power within your workspace and talking to people. Who's before you, who's after you, making sure you're happy with your work so somebody can overlay your system. Because believe you me, once that insulation's on 150 mil thick, nobody's going to see your stuff underneath ever again. Until the air tightness test fails and you've got to take it all off and do it again. It's fairly standard, don't worry. Again, attention to detail, where junctions in boards, penetrations through boards, fixings through boards. It's a very simple, easy process to overlay these during construction. But you imagine trying to do this once the insulation is on, once facade system's on, and the air tightness test fails. Reducing down penetrations through there, so utilizing innovative stick pins instead of utilizing mechanical fixings through the system to hold your insulation on. Just different detailing, making sure that everything is catered for during the process. What we're looking at now more than often than not, especially in regards to passive house, is having that secondary air barrier on the face of the insulation in the cavity behind the rain screen system or brick slip system, whichever one you're looking at. What that does is negate thermal bypass and wind washing on that facade insulation. I will speed up now. So whether it's low-rise, high-rise, commercial, educational, whatever you need us for, whatever we're looking at, we're more than happy to assist. Brick slip, rain screen panels, spandrel panels, modular, off-site, no problem at all. We have delivery partners over in Australia, Northern America, and in Europe, so we have no issue at all in dealing with projects wherever you're designing for, and we can go from there. Just a nod as well from the fact that last 5 years, the government have been very, very pro in regards to system approvals. We are now starting to do system approvals. Obviously, it's a very expensive and long-term procedure that we need to go through, but this is a BS 1364 test, which is a 3 meter by 3 meter rig carried out with Kingspan, at Warrington Fire in Milton Keynes. Achieved a 90-minute and 10%. So this is a double line of 12.5 plasterboard, ProCheck A2 VCL, Kingspan SFS with their K-Rock framing board between the stud, cement particle sheathing board, wrap tight, K-Rock rain screen slab, mechanically fixed, put against a rig, and it achieved the 90 minutes. So this is the way that we're going. What this will enable you to do is specify happily that 1, you've got air tightness, 2, you've got the fire responsibility, and 3, you've got the moisture control. So whether it's an infill panel from a new build perspective between column, slab, and soffit, or whether this be from a retrofit in the same process, you know that you've got that and you've got a lot of boxes ticked before you even start. thank you very much. There's a lot of other products we've got. If you'd like to talk to us, we're outside today, so please come and have a conversation with us. We run CPDs, they're all REBA approved, so please let us know if you'd like to have a conversation. Thank you kindly.
James, the first bell was for John, so he sat down. The second bell was for me, so I'm going to be really quick.
Okay.
Thank you so much. And it's good to see the sophistication of the tools you have on offer for all this work. And the sort of concept of built-up walls is with us, and we have to know how to work with them and get the workmanship and the trades to respect what they do.
Yep.
So thank you for highlighting all that. Okay, we're going to have our final presentation before the break, and it's on low-carbon glass. It's great to see the glass people taking the topic really seriously. We have Moujehed Neffoussi. Have I said that correct? Yep. Okay. He's going to talk to us about low-carbon glass.
Thanks, Stephen. Oh, sorry about that. So, hello everyone. Glad to be here. Today we will have a look at where we stand with our low-carbon glass and the steps we are taking beyond. Sorry for that. Just a quick background on AGC. AGC Glass Europe is a world leader in float glass production, specialized in two main segments, automotive glass and architectural glass. And I'm sure you've seen the product of AGC Interpane in many iconic buildings in London, such as the Arbor at Bankside Yards, the Paddington Cube, 8 Bishopsgate, and 40 Leadenhall, just to name a few which has been recently supplied. Our commitments, as you can see on this slide, remain the same. And a major key part of this journey was the launch of our low-carbon glass last year with 40% less embodied carbon. So, and this, of course, require a holistic approach, as you can see on the 6 pillars. Most interesting ones are innovations such as electro-boosting of our furnaces, allowing a greater use of green electricity, of course, increased use of cullet, and even the use of fully electric trucks for glass transportations. We now produce the low-carbon glass on 3 lines across Europe and continuing to roll this out. So we have a number of projects across Europe where low-carbon glass is already helping stakeholders to achieve their green building goals. And I'm pleased to share that we have just been awarded our first major project with low-carbon glass in London. So congratulations to everyone involved. So I think most of the people here are familiar with environmental product declarations, or EPDs, which provides values for the building life cycle assessment calculations. And the good news for sustainability engineers here, AGC is releasing a product-specific EPD configurator. That means very soon you will be able, using our online glass configurator, to generate your complete, downloadable, full EPD report, which will be third-party certified as from early next year. That's a market first, by the way. And since our sustainability targets are quite ambitious, low-carbon glass is not the only part of this journey. We launched a new program called Recycled Glass, as you can see on the logo. We no longer consider cullet as a waste, but rather as a valuable and strategic source of raw material. And this program consists of 2 main parts. One is to increase the pre-consumer cullets, collection of it, and that's rapidly improving. But the most important part, and which is completely new, is the collection of the post-consumer cullets. That means end-of-life glass from existing building will come back to our float furnaces. How does it work? AGC, as a first contact, will coordinate all different steps with partners, from project diagnostic to proper dismantling, recycling, to finally remelt the glass into our float furnaces. And today we have already 4 ongoing projects, and I'm pleased to share with you a short video of one of them called Oxy in Brussels, which combines both recycled glass program and low carbon glass. Oh no, sorry about that.
For the Oxy project, which is being developed by Immobel and our partner Whitewood, we have set from the beginning a very high goal to achieve the taxonomy standards that the EU prescribes to achieve a carbon neutral building in 2025. So it's our ADN, it's our DNA that we really want to achieve the highest possible goal. And in order to achieve this, we wanted to dismantle and reuse the building as much as possible. So that means that we analyze the building from A to Z, and we analyze also the facade in the search of how we can optimize and reuse or recycle the facade as much as possible. And together with AGC, we really found out that the existing glazing had a high quality, and we could recycle the existing glazing from the building from the 70s in a future-proof building that will be delivered in 2026. If we talk about embodied carbon and a CO2 neutral building, we really have to search that all materials that come on site have the lowest possible carbon footprint. In order to have an A-grade building, so a building that is on a CO2 level, level A, we really source and we really need to find materials that achieve that goal. And the low carbon glazing that comes out from the recycle of the old facade really has a positive impact on achieving the carbon neutrality of the future building. It is in fact true that by creating grade A buildings which have a very low carbon footprint, that this is a driver for a higher rent, a higher sales price, but also a demand from investors and occupiers that really look to optimize their ESG and their carbon footprint as well. So from a financial point of view, yes, it is important that we create future-proof buildings, but also from a society point of view, it is important for us that the buildings that we create have as low as possible impact on the future generations from a social and an ecological point of view.
So, in summary, our new digital tool for EPD will make life cycle assessment calculation of the building faster and more accurate. Both recycled glass and low carbon glass are a triple win approach. A win for partners and investors, a win for AGC, and above all, a win for our planet. So we need you all in this decarbonization mission. Thank you all for your attention.
Thank you so much. That was
Thank you.
very succinct and to the point. And it's great to see this is now beginning to pick up momentum and people are accepting it. Developers like you showed are accepting it, so that's fantastic. Thank you. Finally, we are at the coffee break, so please enjoy your coffee and we will restart in about 20 or 25 minutes. So if I can have your attention, please, we will restart. Our next speaker is Phil Sedge from Mace. Phil leads the way on innovation, industry trends, and aspects such as quality, carbon, and innovation. So Phil will talk us through the carbon journey of Mace. Phil.
Thank you very much. It's like I wrote that myself, Stephen. Thank you. I'm going to take you through our journey in the Mace Facade team and what we've been doing around carbon for the last 4 years, since 2019 and now up to the present day. But my key message is really, if you don't get on this journey, you're going to get left behind. So that's just a key message to go throughout. A little bit about Mace. Mace are a construction and consultancy business, 2.2 billion, predominantly working in London. So a lot of our work is in London. I have a brilliant facade team of 40 people. I haven't got a glossy image like Arup and a few other people put up. Apologies, my team, a few people here. But there's 40 people in the team and they've done a lot of work to provide this data for me as well. So good to see you all, and hopefully you'll find this interesting. When the slider works. Okay, so 2019, there was this low carbon aluminium launch that a lot of us went to, and we thought, this is good, this is interesting. But actually, it didn't really get to, make us interesting where we took it on board and really started to use that product. So 2020 for us was the first time we really started to look at carbon solutions. And I'm going to start with that as our first platform, really, 2020. So 2020, we started to see in our tenders that carbon was one of the key features of information that the clients wanted back from us. And we didn't really know a lot about carbon, so we started on that journey. The ICE, the BISRA guide, was one of the first lot of documents that we started to read and get base level of information from. And we started to understand what EPDs meant, environmental product declarations. Now everybody knows what that means, but GWP as well, global warming potential. That's the first thing I look for really now when I look at an EPD, is trying to understand what the GWP is. But years ago, we didn't even know what that was. And as Mace, we partnered with One Click LCA, which was a great platform for us to get a bigger avenue of a catalogue of EPDs. There was information on there on timber, there was information there on aluminium windows, stick curtain walling, glass. There were so many variables. We started to get a good platform of data, and we started a catalogue, live data, but streamed from the catalogue from the ICE and from the One-Click LCA guide. So that was great. So we said, let's start with a base level of data. How do we get that level of data that gives us a platform of understanding how do we get better? But without understanding the data, how do we even know that? So we started our first carbon survey in 2020. Obviously, a lot was happening in that time with Grenfell and a lot of other things, but that meant I had a little bit more time on my hands, or just working longer hours, the same as everybody else. So we started this survey. So you can see 17,315 tonnes of carbon. That was what we found of embodied carbon across our projects, but that catered for A1 to A4. So that just wasn't A1 to A3 or all the way through to A1 to A5. This was A1 to A4. 41% was glass. Pretty much a lot of people know that's the sort of factor that's out there. 11% was aluminium, and I think it's 28% was travel, which was a big indicator for us. And we actually see a big downturn in that because of Grenfell. We started to use realware and other products like that meant we didn't do so much travel. So that really did kick the level down again. But that's where we got to in 2020, was understanding what we were talking about, understanding that more and more our clients and architects were asking for this sort of information. And then we got to our level of our first survey in the facade team. 2021, so where did we get to in 21? So we're on this roadmap, this journey that we got together. We couldn't do it on our own, so we started talking industry with different people, and we met with Daniel Grusser and Steve Moody from Alinea, or now TT Alinea, I must say it right, because I'm sure they're here somewhere. And Steve Moody did some lovely sketches and said, why don't we work out separately what was the carbon content of these sort of different scenarios, and we've played them back to each other and see if our calculators work. So that's what we did together. We started to work on a bit of a journey. This was our first carbon calculator. This is A1 to A3, working, as I said, with TT Alinea. And we started to factor in simple scenarios of what a unitised panel would look like. This gave us a base understanding of our embodied carbon, but also gave us a base understanding of all alternatives that were there. So we had standard average aluminium, as you can see there, average Europe aluminium, globally what that would look like, but then using some products like Hydro Redux or at the time Hydro Circal as well. So we started to really get to see that actually you were cutting down 2/3 of your embodied carbon by using some of these lower carbon alternatives that are out there. And again, our calculations were near enough meeting the same as a linear, so it got to prove that our calculator was really working. We didn't just stop there with aluminium, we started to look at precast. We were seeing that, especially in the residential market, that precast facades and the solid element of facades were being driven a lot more because of their U-value content. So we knew embodied carbon was a big factor there. So we started to look at standard precast values, other good contractors like Techcrete that were cutting the edge and really looking at lower carbon content of precast concrete. But then we also looked at UHPC. And we started to factor in what that would give as a value back to our clients and our design team. As you can see, we're on this journey, we're getting there, we're collecting more and more data, and we're showing our clients more and more alternatives that we can do. This was a key one. We worked with Schauderbau on one project. I won't name the project, unless it's on there. And AKT2 Facades as well, working with Stephen McDowell and his team. We looked at the specification of the glass, we looked at the fitness of the glass through the tender stage, and we worked with Schauderbau to say, what if we just change 5 or 6 of these thicknesses of glass? Would it work technically? Would it still perform in the right way? But also, could we save on carbon? And this was just on this particular project, we saved 60 tonnes of carbon by changing the glass. Just these little tweaks that we can do collectively together. During the year, we volunteered to work with Arup, with Ed Forward, who's a fantastic guy, but now left Arup, what a shame, on circularity as a working group for CWCT. Hello, Ed. It was a great journey for us all to go on, actually. There was a collective team of 12 people, something like that, and we met every Friday, I think it was, every Thursday night or Friday night, and we went through how we could try and look at circularities in industry. What were the obstacles? How do we identify the materials? How do we identify designing for circularity or disassembly? All this sort of different scenarios. And we also worked with Hugh McGilvery with EOC on the refurbishment guide because we saw a big trend there. And actually there was a big link between both those working groups, which was quite educational for all of us. During the year as well, CWCT did this fantastic guide on calculation of embodied carbon in facades. We'd done our little journey of calculator. And a few other people, Lend-Lease, have done their same as well. And I know John Downs did a lot of work developing this with a few others in the CWTT and a few people in industry. We were asked to look at this and provide some comments which were taken on board as well. So great journey for us in 2021. Okay, I know it's a Schüco sponsored event, but I'm going to mention this as well. But we entered into a hydro partnership in 2021. This was for us the first journey into companies that really invested in post-consumer scrap. And I really mean that. So this was the product at the time in November 21. So we issued in the industry a statement saying our supply chain should use a low carbon product like Circal 75 unless you have an alternative that could provide the same post-consumer scrap values and a similar carbon value. Because we weren't being predictive, we were just saying this is what we would like you to do, please come up with this or your own alternatives. It didn't go down too well in 2021, but we worked on a journey together, we worked with different supply chain, and we started to progress this quite considerably. So you can see from 2019 to 2021, we've developed a calculator, we now know what we're doing, and now we've entered into a partnership. So 2022 was another big step for us. So we said, let's do our survey again. Let's do that, but in a new technology. Let's use Power BI. Let's try and understand the key data that we've got across our projects. You can see it identifies how many projects we reviewed as a survey. We know how many tonnes of carbon, 13,000 tonnes of carbon. We knew the average square metre rate across our projects of facades. But what was really good, we started to understand some of the key drivers. Was it a precast facade? Was it a key contractor that maybe didn't take on board low carbon? And we also looked at the different solutions of unitised curtain walling, precast, etc., etc. So we started to have that bigger platform with information. We transformed our first project, working with Skonto and Palmerston Court and Henriksen Studios, passive house solution. This was presented, I think, last year at the Zak, but just by switching from standard aluminium to Circal 75, we saved 800 tonnes of carbon. So a fantastic message for us to communicate back to the industry. Okay, we know there's other alternatives there now, but this was just the platform that we had at that point in time. And at the end of the year, working with Hydro, we collated the savings that we had, invoice value of carbon at that particular time. So we know in 2022, we saved 1,271 tonnes of carbon as MACE, as the facade team. That was massive for us, that was great. But also, you know, we started on a journey with other people. So that in 2023, we know we're probably going to double, even treble that saving. But we've also got our first project now working with Schüco and our ultra low carbon solution, or ULC, but working with the Creole project component there, which on our Timber Square project working with Cipro is probably going to save, again, around 800 tonnes carbon saving. So now we've got a partnership, we've now got products, we've now got competitive products in the industry which are giving us some good viable alternatives to really challenge us all to get to low carbon solutions. So what a fantastic journey we had in 2022 and 2021. Now we start to up the gear, we're now racing around the corners, we're coming to the final straight, or a period of the final straight in 2023. We wanted to update our carbon journey, our carbon survey. 2022 was great, the Power BI was brilliant, but it just needed tweaking, it needed a little bit more data to get from us. So this is now our latest version, and again, 2024, we will update this further. Again, it tells you our average per hour projects, it tells you the collation of the projects, but it also gives you an average value, and please take this on, this is a project by project averaged out value on the top left-hand side of top right-hand side of what you're looking at as a chart for precast, stick curtain walling, unitised, handset stone, etc., etc. It then went into facade contractor, broke it all the way back down again into average square metre rates, and it gave us so many different alternatives. And I'll just flick onto the next slide. I've picked on Focky just a little bit here, but this just gives you an avenue of, if you click on the contractor, it tells you what projects they're working on, what products they've got, what is the average square metre rate. This is A1 to A3. Sorry, I forgot to mention that again. A1 to A3. Why have I not done A4 to A5? It gets a little bit more complicated to get those rates. Well, A1 to A3 is just the embodied carbon factor that I was just looking at this point in time. And maybe the next survey will generate A4 and A5 as well. But this really gives us some good value now of understanding of what we're doing across our projects and what ones are really hitting the values high. We can then replay that back to our clients, and we can really start to look at where we can add value back on the next lot of tenders or next lot of projects that we're awarded on. We reinvented our carbon calculator. What I found was me and a couple of other individuals, the only ones who knew how to use it. That wasn't good for me, it meant I had to work a lot harder. But what it meant as well, you had to understand the key weights of profiles to be able to input them into the data to give you the value out. That's all good, and because it does go to that minutiae level of detail, it's fantastic. But what we actually realised, if you took a mean of average across the system suppliers, there was only 1 or 2 kilos of profile change. So actually making it a more simplified version like we've done here, gave you near enough the same value back out again. And bearing in mind, our supply chain should be probably doing this calculation. This is just a USP that we're showing and an advantage for Mace, really, showing the alternatives. This is the precast one. I just show some differences because I've shown a lot of aluminium. You now only have to enter in your dimensions and it'll kick out a standard value in industry, it'll kick out some good options in the industry and also some low carbon options that are in the industry as well. It'll give you a good explanation. We can replay this back to our clients and we can say this is the value you could have by just tweaking your design maybe a little bit. So 2023, we entered in June our partnership with Saint-Gobain for low carbon glass, a rye glass. This was more about making a change in industry again, say we've done a fantastic job with low carbon aluminium, but now we maybe need to look at some other materials. At the time, a rye had just been launched, so we thought a great product, it's been launched, it's been surveyed, it's got an EPD, it's got everything we need, and it saves 42% of carbon. Okay, there's a lot of aspects to this product as well of understanding it and getting our supply chain to use it, but this is what we announced. Now, we do know, of course, that AGC, Guardian and Pilkington have just launched their own low carbon brands. Again, that's healthy competition. That's all about driving our supply chain to provide better options for our clients and for our projects going forward, because it is all about saving carbon, but another good avenue for us to get onto. I was getting asked a lot about C2P. This is our construction to production, or our DFMA, or modern method to construction. This is what Mace called it, C2P. And does carbon get saved by using the prefabricated method? So I said, well, let's do a survey. So we used some stick curtain walling, provided a couple of bays, looked at A1 to A5, and tried to predict where we were coming out with carbon. And on my initial survey, this is what I'm saying. I think you're going to save around 20% of carbon on a standard system by going on a prefabricated route. I think that is reducing waste and reducing the install waste that you have on sites. So I think that's probably where the saving was coming from when I was generating the A1 to A5 saving, but around 20% sort of saving there. 2023, we started to see on our projects now material passports get requested by clients and on the projects. that was a big journey for us. We didn't even know what a material passport was. So we had to investigate what that meant, how we started to provide that with our supply chain, who again have not heard of that system before. But now we've got this running on one project all the way through. So that's from design stage, unique IDs, in through the BIM model, all the way through to product manufacture. And that gives you your dimensions, that gives you the product weights, it gives you your carbon content, all the way through to the finished product. And when we walk away from the product, the O&Ms and the product is stamped through with a full material passport. This sort of pushes into that circularity ambition, which everybody's got. And this is just a simple slide that I think this is everybody's aspiration, isn't it, really? To look at the interiors and how we can recycle those. And I think Yasmin mentioned earlier about the great work they've done at Citibank and looking at some of that sort of product. And this is something that we're going to be doing. On one of our projects now, we've got steel. We've probably, I can't remember how much tonnage it was, but a load of steel that the client had left over from another project that we're now using on one of our projects. So again, it's just about recycling and reusing rather than sending to waste. All the way through to low carbon concrete, raised flooring, but glass recycled content, and I'll touch on that again in a minute, and of course low carbon products in the facade. I think Russell must have nicked a few of my slides earlier because this was exactly his message in his slide, and exactly the same words: retain, reclaim, reduce, refine and recover. But I think they're key messages. I think when we look at a design coming through the books now, if it's stage 1 or stage 2, this is the first point of call to look at circularity of hierarchy. And whether we can do any of those bits will give us a journey of the next path. We've started on that journey. I think KPF John Bushell presented this at last year's Zak, which is 81 Newgate Street, or Panorama, as it's called now. I was involved early on working with FMDC, trying to look at how much stone could we recycle off this project. And at first it was around 60%, 67% I think was the actual figure of recycled stone that we could get. Working with Grants of Shoreditch, Grants did a fantastic job, and they actually saved 95% of the stone on the project. So a fantastic message in the industry of recycling that level of reuse of material back into a precast form, and that's now going on our project. So by St Paul's, you can walk around the outside and you can see all this project going up there. It's a fantastic message. We're also doing a similar project called Wallgate. We're actually doing a full refurb of the project where we're just changing the glass, bringing it up to new standards, new gasket, new beads, and then a straight new facade, just respraying it. So similar sort of message with circularity and refurbishment. We went up to see Morley Glass. Bearing in mind we were talking about recycled glass and carbon mining. I'm quite jealous of Claire Tribe from McLaren because she's beat me to it. And she's doing it with Chalcott's, I hope I've got that right, Claire, Chalcott's estate project, where she's actually recycled all the glass from the project and given it back to Saint-Gobain. We've put that back into the cullet mix. So, great journey. This is something that we're looking at in 2024. Watch this space, Claire. I'm going to make sure I catch you up. The next journey of the facade team and what we started to look at with in 2023 was B6. So working with Schüco, looking at active cavity facades and maybe looking at alternatives to closed cavity facades and different twin wall systems. I think providing that B6 operational energy alternatives for our clients gives them an understanding of what energy they could save across their buildings. I think we've got to do that. Talking to my sustainability team, they think greener energy is coming, so embodied energy is probably the biggest focus. But I actually think it's all good, and I think we should be focusing on all of that. So that's just one alternative. You then come on to other projects, and I'm not an advertisement bureau, I'm just saying there's other products as well. A bit like this Finio, which is vacuum sealed glass, which gives you such a low U value for such a thin glass, and down to 0.4 and 0.5. So a great alternative for glass systems there. And CUIN, I think that's been presented at Zak a few times. Again, a triple glaze unit without actually using the mass of triple glazed. It uses a plastic film in between. Great product, it's been tested, it's been used on projects now. If you don't know of this, you should know. And this gets you down to a 0.4, 0.5 U value and really reduces the G value as well. It's a great product. A great trend that we're seeing in the industry now is timber. Timber curtain walling, timber windows, composite windows, timber unitised products, and we're doing that on Belgrove with Schindler at the moment. Great project, great company to work with, great quality product, and that's really going to change our carbon content as well. So it's massive on our Belgrove life science product. We see a massive trend in this, and we're predicting this is saving around 25% of carbon, less than aluminium. So another journey to go on. I think I've presented a few times in the industry, but photovoltaics are a big thing for me. We have masses of glass, masses of opportunity. We're using building integrated photovoltaics, and we're not using it yet. I think that's a bit of fear around cost, around technical competence, but I think we just need to get on that journey and start using the product. There's good products like Quantum Dot from Guardian out there, and there's some others from AGC and other products that are out there. But for me, this is the product that we should be using in the moment. This is Clearview, a new product that's been issued in the market recently, been launched in the market recently. For me, this is exactly what it says on the tin. This gives you a roughly 40 watts peak of energy per metre squared. So it gives you good output. And it's totally clear. So you can see there, this is at the build centre, looking out now through the product, through the external glass as well. If we could just put that on 25,000 square metres of curtain walling on the next skyscraper, can you imagine the energy we'd get back and the journey that people would get on? But again, I think if you're not using these products, if you don't know about these products, come and see me after, and I'll point you in the right direction. But this Clearview product is definitely one for the future. So that sort of takes me on my journey from 2019 to 2023. I think my key message is understand your base level of data. If you don't know that, you don't know how to improve upon, or you don't know the aspects of where you need to improve upon. Get some partnerships. Link up with some people in the industry that could provide you the data and the EPDs and the journey that you need to go upon. And actually get on the journey. Get on this road and start looking at carbon and really fasten your seatbelts and get on board. Thank you very much.
Yeah, stay there. Thank you, Phil.
You said you weren't going to ask me any questions.
I thought you had some questions for Phil.
See?
Thank you, Phil. The journey is obviously full of new ideas, new products, and I think by pushing, as you mentioned a few names there who've pushed to bring everybody to create alternatives, to create new products, to create new possibilities. So it's only by doing that pushing from the client end, from the general contractor end, that we're getting there. And thank you for your presentation.
Very welcome. Thank you,
Thank
Stephen.
you, Phil.
Thank you all.
Our next presentation is also related to sustainability and carbon, and it's going to talk about carbon control. Looking at it sort of in the round, not just necessarily from an embodied carbon angle, but from a holistic view. And I'm delighted that I have two of my colleagues to present. Stefan Dewald, who's the head of facade engineering at Schüco in Germany, and Thomas Schlenker, who's senior vice president at Schüco, responsible for all digitalization, innovation, and also sustainability at Schüco. Over to you, gentlemen.
Thank you very much, Stephen.
Thank you very much. Pleasure to having us. That works. So yeah, we will write you a little bit in a short version through our carbon control journey at Schüco, where we want to show you some of the corner pillars of how we think carbon control should be, how carbon control offerings should be brought to you. We won't do everything, but hope to do it soon.
Just a sec.
Exactly.
It works.
It works now? Perfect.
Phil pulled it out.
Yeah, perfect. Perfect, thank you. I will split a bit the presentation, and Thomas, it's you to start.
Right, so this infinity symbol, that kind of it represents where we want to walk you through, and the most important thing up here is the design phase. If you don't consider anything else, which is the build to decarb, the operate to decarb, the recycle to decarb in that design phase, you will not make it afterwards. That one, and we talked about that a lot, is bringing down the carbon footprint of the material itself, is for our products one of the biggest impact and the largest pie chart. Of course, that is the one the whole community, the whole facade industry has worked on for decades. And finally, that one, when we talk about refurbishment, but when we also talk about getting back the material in order to have enough low carbon material on that side, so that goes hand in hand. Let's start with the material, because it's one major aspect in here. And first of all, let's look at the contributors of the embodied carbon emission. First of all, it's the material. We looked at it very closely. We looked at our facade of our window systems, stick systems. The main contributor is the material itself. Second is design, which has to do with the form factor, which has to do choosing the right system, choosing the right width, choosing the right size. Fabrication is also part of it, but it's less involved. We are focusing more on the upper two transportations. Also, when we talk about Europe, even when we talk about shipment to London, it's a smaller part. Installation, construction, compared to the others, is also smaller. Who is responsible for it? In the early phase, influence of the shape of the building, it's the architect investor. Then it's the architect, facade consultant, Schüco to support with data what it means choosing that system, choosing that width, together with our partner, which is the glazing company. And this is completely our homework, bringing down the carbon footprint of the material itself. Let's look at that one in the next slide. A window of a size 1.2 to 1.4 meters. And this is how this pie chart looks like. So this is similar to what Phil has shown for the complete building. This is what it means for this component of the window itself. And as you can see, aluminum glass and the thermal break, these are the dominating parts, and this is where we're looking at mainly. And we have actually expanded our portfolio for the aluminum. That's what we have just done this year. In the past, we have worked with this average value. We had one aluminum grade, which we have now split into what we call the conventionally produced aluminum, with 7.1 kilogram CO2 per kilogram aluminum for the extruded profile. This is important to note. We're always talking about the extruded profile. That's the one which ends up finally in the building, in the window, in the facade. We have the middle one, which is the Schüco low carbon aluminum that is produced with green energy, bringing the value down to 4.5, and the one with a minimum post-consumer recycled content of 75%, now with a value of 2.3 kilograms CO2 per kilogram aluminum. We'll see that one going down within the next 12 months to 1 point something, so that is currently derived. We always have to look back for 12 months in order to be able to get the new value certified. All of these different aluminum grades are stamped, certified, and we have an EPD for it, and it's within our configurator, which we'll talk about in the next couple of minutes.
Perfect, thank you. And once we have checked that we have the right materials, we need to look, as a matter of fact, as the next level that we can influence in how to design most properly to get the most decarbonized construction. And we do that, and we offer that, and that's only one proposal, which is the latest thing we have been working on, and we call it kind of smart engineering. I guess most of you do smart engineering on a daily basis. But yeah, what we try to do is we try to optimize our system. And that is, by the way, changing the systems from the standard depth system that we have of a standard unitized facade into what we just saw here. So we reduce the material used dramatically through an innovative design. And the innovative design is actually nothing new. I think it's everybody knows how that works if we leverage the non-activated potential of what we actually have in the facades. So let's take a holistic view on the system, and I think that will be, at the end, the only solution, looking holistically at things, to get down to the goals and the targets of decarbonization that we will have anyway. So we need to really look and leverage the contribution of each individual contributor into one. And this is when we, for instance, you know that if we consider not only the aluminum profiles, but also the stiffness of the glass and have a combined stiffness of a structurally glazed glass facade, this is how it looks like. We have a much stiffer construction. Deflection changes dramatically to the positive, and thus, why not using that? That looks and ends up in a standard unitized facade that we have, depending on sizes for sure, 25 to 40% material savings at 100% same performance, because that is for sure what we need to deliver. We do not want to compromise any on the performances. And what does that mean? If we have up to 40% reduced amount of material in there, that brings us at a frame system only, and this is for the time being where we look at still, depending on using the different grades of material, up to 77% per square meter CO2 reduction looking at the components that we supply. But we know that it's not the only thing. If we leverage the glass, we also need to count in for it. And it's still, with the actual 42% reduced, CO2 reduced low carbon glasses, brings us up to 44% per square meter facade, less carbon in a standard unitized facade. And sure, it's not everything is 100% glazed, but if we look at the 50% glazing, it still brings us 42%, because even there we can leverage the stiffness of the whole structure by using rolled profiles instead of the structurally bond glass profiles. This is how it would look like. It's something that we have been working on now. It's actually nothing new, but just nobody actually did it so far. And it's an interesting mind shift, Thomas, because it's us staying here and trying to sell you a value proposition that at the end ends up with much less material. But this is how we want to participate in the carbon control journey at the end to reach jointly your goals. On the system level, we looked at that. How can we reduce the material that we use in the systems, but also we need to look on a daily basis in how to optimize our profiles. So we use the latest technology, finite prism and finite element methodology with the University of Columbia. And so what we found, and we have like 2,500 profiles on stock regularly, that we can reduce, in average, 4% of much at 100%, keeping the structural behavior of the profiles. That brings us, at the end, and I think we refer to those figures today quite often, per 10,000 tons sold aluminium of the low carbon grade that you just mentioned, is at 1,800 tons, just saving by running it through the processes, carving out the last final beads and pits of aluminium that we do not need right now. And this brings us to the next part.
Right, and next to the design, which is our homework to reduce the mass, and I think that sounds strange because we are paid by selling tonnage, and now we're reducing it, but that's the new century. And then we come to the system level, and there's a new currency in it. So far the currency was U-value, we're all hunting that U-value. It was budget, of course, and what you just mentioned, that's also good for the budget, isn't it? But there's a new one in it, which is the CO2 value, which will be able to feed into the building models that Phil has shown. Like, we have the budget in here, we have the U-value, and by changing the configuration, going from fixed glaze to tilt and turn, from a sliding door to whatever, you see immediately what this value does. You choose a different material. We'll now add glass, different glass types to it. We have heard about AGC, we know about Saint-Gobain, so we'll add these generic glass types, these specific glass types, remove the generic ones, that you have an option, and you can do the design and see immediately what is the effect, what is the carbon footprint of all my elements that I've just designed for that one. For that window I've just shown in the beginning, it will look like that. That one is the one with the low carbon, which we started with, which is the 34% and 240 kilogram of CO2 with a standard glass, so it's not a low carb glass applied here. Bringing that one down reduces the aluminum part by 45%. For the whole system, it goes down by 15%. So there's other bits and pieces we need to tweak. It's about choosing the right system. It's about having the data available to know what you need to change in order to reach the value you're aiming for.
Perfect. And it's me again. And so now we look, okay, how do we use those systems, the materials, the profiles, and we do a combination of how to look at operate to decarb and actually build to decarb. What we think might be a vision of the future, and I think we would have to do it even more and more, and today we're already doing that, is looking more into hybrid systems. Why hybrid system? Because we think using hybrid system means we're combining the best of two worlds. So I'm really considering it as a kind of hybrid system. This is actually what we did with that minimal wall concept also, is a hybrid system of the stiffness of the glass and the stiffness of the construction. We see it for building integrated photovoltaics. We see hybrid systems for green facade. We see hybrid systems for add-on construction on any kind of material that you want. And looking into that a little bit deeper, it's at the end, it's combining the best of the world, and we see those examples in the nature every day. So that is a section of the skin on the left-hand side, and the right side is a section through a tree trunk, which actually works like that. So it's working in a kind of layered concept. So we need to look and understand what is the critical function that we want to have a value creation for, and what is the function layer that we actually need. And we need to combine those in the best possible sense, understanding how they interact, understanding what we need, and how the interfaces works. And that brings us in a modern situation where we not longer only look at the triangle of cost and speed and function. It got much more complex. So sustainability driven is, I think, it's the most important thing. Shortage of labor force, productivity increase, circularity. Those are all things that we need to take into consideration. And this is why we think industrialization. We have been doing that anyway with the unitized facades, big time. Standardization, more standardization, automatization, digitalization is what is needed in the whole construction concept also for the building envelopes. And this means modularization. And again, we see a lot of timber, and you might think, okay, why is Schüco showing pictures with a lot of timber? Because that is exactly that hybrid concept. We talk about a hybrid substructure, a hybrid main structure made from wood, concrete combinations, but put at the outer shell something that is endurable, something that is weatherproof, something that is durable, and at the end you end up with a solid, functioning, easy to maintain and long-lasting aluminium facade. And that brings us to the added value that we need to look at, how to combine those things perfectly. We do have different tolerances. We do have different movements. We do have different humidity behaviors between those two materials. And this is something that we've been working on with our aluminium competence, with the decarbonization competence, in order to bring that competences to the decarbonization of the full buildings by using any kind of material that you want.
We discussed already how important it is to bring down the carbon footprint of the material itself, because that is kind of the foundation for everything. That will only work, and I've shown to really come down to really low values. That requires recycled material. And we can only have we can only achieve that one in high quantity if we recycle what we have. And there is one good thing which is probably happening in the next 10, 15 years, which is the large number of refurbishment projects out there where material is taken out, is replaced by new material. And we have to make sure, as Schüco, but mainly as a community, that we take this material coming out from that area and making it ending up here. It is 100% true that you can recycle aluminum infinite times. It is not that true if you downcycle it towards the automotive industry, for example. They are pulling from the same sources that we use. So we need to make sure we have this closed loop within the construction industry. Something that ended up a wheel will never be an extrusion again. So this is why we'll have to make sure that we bring that back in here.
And before you do that, I think we missed 2 slides. Just go further. Because
okay.
this is again still going back to the layer. Don't forget what he just said. And we just run very quickly through that. Huh? So that is.
I will not repeat it.
Exactly. The photovoltaics integrated. Also, again, it's the same thing that we're already doing in our standard curtain walls, in the opaque areas, but also in the transparent areas. And what we also offer, and I'll just run very quickly through that next slide, please, using it as a rain screen in order to gain as much area with energy generating photovoltaics at the building as you want. And then at the end, I think the next choice then should be the transparent areas, as Phil showed that with Clearview. But before that, we have quite some areas still to cover with photovoltaics. And again here, we saw the activated facade earlier already. Again, that is rounding up that function layer concept. Those are all functions that we can add to the facade or leave out of the facade that have got a contribution to the carbon control, whether it's ventilation, especially in renovation things, whether it is the cradle to cradle as a function or as an attribute, the wood green, I had that, and then the IOF, and that's now bridging to what you wanted to talk about. Sorry about that.
Great. So you probably remember what I've just said with respect to the importance of having this material available. And what we also, and this is one example which we did in 2021. This is one of the office buildings which we have at Schüco in our headquarters. It was a technically outdated facade which was completely removed. It had a lot of aluminum sheets in it. We've been able to collect 28 tons out of it, since it had, it was very easy to basically gain a high quantity and a high amount of aluminum to bring it back into the loop. It was 98.3%, which was a third party certifying it, how much that was. And that led to a completely new facade, which was installed, allowing us to operate the building in the future and the next 50 years on a minimum amount of energy, and it also looked quite nicely. What we did and what we are also doing with existing buildings, with all the servicing we're doing, and I think it was mentioned a couple of times ago that not touching a building and prolonging the lifetime of a building and of the facade is the best we can do. We introduced what we call IOF, the Internet of Facade, which is a tech which leads to a storage, a digital twin in the cloud. It holds basically all service and maintenance data. It holds all spare parts. It holds all the materials, the EPDs, what's the tonnage, what's the kilograms of that window in that corner. It is the position. It tracks everything that has done with it, and it starts at the fabricator. So as soon as the window or the door or the facade leaves the fabrication, it is equipped with such a tag, and it basically holds all of that information. They allow us 2 to 3 clicks in order to save time, so we can have a big workflow within the fabrication in order to create that digital twin. And what we really see, we have been talking about BIM for ages, but that one really is a catalyst. Because it provides that data which allows urban mining in the future, not going into a building which was built 40 years ago and identifying how much copper, how much steel, how much aluminum is in there. You know it because you have this digital twin available. We'll now make it a standard that it's not a tech anymore. We'll make it a standard on our hardware, which we deliver with every hardware which leaves our warehouse, allowing our fabricators to connect the data of the fabrication, of the bill of materials, of everything he wants to connect with it, with that unit. Since it's all cloud-based, we have APIs where we can feed into Madastar, into other platforms which hold the data for the complete building. So our aim is not holding the digital twin for the complete building. Our aim is to make life easy for our fabricators, for the glazing contractors to enter this data, and we make it available to whoever requires it. And that leads us to a future Schüco offer, which we have started in a couple of pilot projects in Germany. This means starting from the renovation with the preferred option. That's what we have seen, because logistics is one of the main part in here, is the material separation with aluminum, glass, and gaskets, and then feeding it in the scrap processing of aluminum to be able to have enough and always enough ULC material for our clients and the new build and the refurbished projects, and on the other side for the glass production. This is where we collaborate ideally with the glass industry. There is no competition in here. This is a win-win for both of us. Key is logistics, because this is where the money is lost or not lost, ideally, and you'll have to have a network wherever the building is in order to collect it, to collect it in 3 different skips, sorting the disassembling, and this means not breaking the glass or perfectly separating the glass from the aluminum and from the gaskets in 3 different skips, and then bringing it back into that value chain.
That's the final slide, and that is kind of a comprehensive overview of our so-called carbon control toolbox. We just touched, we think, the major parts. There's more in it, and we're happy that you start to explore it even deeper. Thank you very much for your attention.
Thank you.
Thank you, Thomas. Thank you, Stefan. If we can keep you here for a minute, because they're setting up the stage for a panel discussion. John, in the meantime, has some questions for you.
I do. I am, I have to say, way out of my depth in this field. And I'm very grateful to Zak for actually having me here, because I have learned so much about carbon. But I wanted to ask a couple of quick questions about the performance chart you have. You very carefully went through and said all the functionality elements, got to be weatherproof, adequate, all those bits and pieces, energy developing. Are you going to go into local energy storage so that all the energy that hits facade is used? Some of it gets transferred. Most of the stuff that gets transferred from a building perspective is waste. So I think the big move forward is storage. What are the potentials there?
You mean the storage within the building?
Within the facade itself, potentially.
Well, we looked into that one in the past, but you can comment first if you'd like to.
Yeah, it's if you want to have storage, you need mass and volume in order to store that. That again is a downside normally on the carbon footprint. So you need to kind of balance that out. So what we rather prefer is an activated system, which is combining building integrated photovoltaics with a proper storage. That is decentralized, that is centralized within the building. Storage of the energy in the facade. It's a concept, could be a concept of the future.
But not yet.
We would rather go that far that we have developed sensors which use the energy of the window going open and closed and use that energy in order to operate itself, because it's much cheaper to store it locally or to store it centrally. And maintenance, everything is much easier.
Okay. I think, I personally think that's a huge future for countries like Australia, where you have massive waste heat. So it's interesting to get that. The second question I had is, you talked about hybrid systems, timber, aluminium composites, but you didn't ever give a carbon content for that in terms of kilos per square metre. How low can you go? 240 to 200? Will you be down below the 200 with the hybrids?
This is why when we talk about a hybrid system that we showed there, then the superstructure, the timber structure is out of our control right now. So the only control that we have is up to the interface, where we match the tolerances, where we match the connections, where we go into big units in order to have the erection process properly provided. But today, that depends totally on the system that is used for the superstructure, whether it's hybrid concrete or whatever.
But presumably your aluminium content is lower just because it's thinner. So the mass...
Exactly, the mass is less.
Yeah.
The timber comes in a negative value.
Yes.
A1 to A3 comes in a negative value.
Wow.
So with such a hybrid structure, without having calculated it, it will probably negative, which is good for the environment.
Absolutely.
So at minimum it's zero, I would say.
Last question. Okay, the last question was on the use of, you've used structural glazed glass as a stiffening element, so big plates. Can you do the same thing with sticky gaskets and captured systems? And will you go that way?
It's even harder to calculate and assess and to get it approved at the end. But that could be at the end. It's a hidden source of stiffness that we actually have, and we see that every day when we test our stick systems. It's like the loads that we can carry are much higher than what we have to assess. But at the end, it's hard to grab and to get hold on.
Sure. So it's more, at the end of the day, it's more a what can you prove rather than does it exist. It's a hidden one that will probably help us as wind loads increase, yes. And we're looking at older buildings to say, are they safe enough? Then it will come into being.
Exactly.
Thank you. I've really enjoyed that. Can I ask everyone to say thank you again? It was wonderful.
Thank you.
I'll take a quick minute before we start the panel. For those who have joined us now, a couple of announcements from the morning. So, those who have just joined us late, next year we move to the old Billings Gate. It's a beautiful venue. It's a larger venue, a clean layout, not confusing like this venue. So we move there. And we've outgrown this venue. We've expanded it to the max, to our limit. I think we've had a great 6 years at this venue, but it's time to grow. The event's growing. A lot of you are coming and supporting the event. We thank you for that, and we are able to afford the old Billings Gate, so we're moving there. Our events in Europe, we're going back to Manchester, going back to Dublin, London, of course. We've replaced Madrid with Lisbon, so we had a great event in Spain this year. Hope to do the same with Portugal next year. We're going back to Stockholm. Brussels in Belgium is new. Paris, we again go back, and we're replacing Germany with Switzerland. So again, trying new places. Want to see what's for us over there. But the whole idea is connecting people together, and I just wanted to highlight this to you. Okay, after lunch, the hall is going to split as usual into 3 tracks. Those who are attending for the first time, this might be new for you. So so on your right at the end is track A. That's track A. In the center over here is track B, and then to your left at the end is track C. So please pick and choose which track you would like to sit, so that later on, if the halls are full, we're going to close the doors. You will not be able to jump in between. So that's track A, this is track B, and that's track C. After the event, we are scheduled to end by 5:45. We've got a 1-hour networking until 6:50, 6:55 at the Harvest Ballroom right at the end. It's open for all. Everyone can attend. So 1-hour post-event networking sponsored by Obex and Signage. After that, we will request all of you to please vacate the hall. At 7 p.m., the hall will be taken over by SIPSI and the Society of Facade Engineering for their gala awards and dinner. Those who have signed up for that event need to go out, re-register, get the badges for the evening event. So 7 o'clock till 7, we've got the post-event networking at the Harvest Ballroom. Then all of you need to exit, and those who have access for the evening event will need to re-enter again. That's it from me. We go to the panel.
So, thank you, Ahmed. Thank you for all this housekeeping and logistics. We're going to have our panel discussion now before lunch. And I'm really delighted that Steve Bosey has kindly agreed to moderate and lead this panel discussion. So I'd like to invite Steve on stage, please. Steve is, I'm sure, well known to most of you. He has been in our business also for a very long time. And he leads the facades team at WSP. And Steve will present the panel and invite them to join one by one. So I'll hand over to Steve now.
Thank you. Hello, everybody. Good morning. Welcome, and it's good to see you again. Many regular faces are here, which is fantastic. I feel quite privileged to be asked to moderate this panel. It's a very important building. It's a very important project, and it's also very significant design team that we've got. So, if I could ask the panelists to come up to the stage, starting with Pat Jost. Jost Mulhazen, apologies if I mispronounced it again, but Jost is a partner and a director at the Renzo Piano studio, who has been in charge of this building and has led the design. So please take a seat, Jost. With a round of applause. And he has ably been supported by Jean Patterson, an associate at the studio. So, Jean, please come and take your stage. And a round of applause for Jean as well, for all the work he's done. Then, having dealt with the architects, who, incidentally, were supported by Adamson Associates here during the delivery. After the architects come the engineers who have to do all the number crunching and work. So to that end, can I ask Michele Sauchelli from WSP to come up and take your place? Last, but by no means least, is after all the design work has been done by these people, somebody has to build it, as you well know. So to that end, can I ask Ovi Mazzareno to come up from MACE? Ovi is an associate director, and he led the delivery of the project together with Foki, the cladding contractors. So welcome, Ovi. Okay, so an amazing panel. I feel very privileged to have these individuals here today, and thank you for being here, which is very appreciated. We called it delivering the vision because obviously it always starts off with the architect having a vision, with the client having an aspiration, and somebody delivers it down the line. So delivering the vision is a theme, and what we're going to do is a little bit different from what's been done before. We're doing a panel discussion, but also supported by a PowerPoint. So please remember the stars of the show are not the slides, but the panels. So please focus on the panel more than the slides, if that can be done. The project, as you know, it's a building right next to Paddington Station. It's a major interchange, not just for the incoming trains from the west of the country, but also it's an underground hub, which has caused a number of considerations and difficulties for the design team over time. The area in itself is due for some redevelopment around us, so this will probably be the first catalyst of some other buildings taking shape around them in years to come, we hope. There is some need for the redevelopment in the area, but it's a very important landmark in the city, and that I think employed the finest architectural minds for some time to try and get the right product for that location. This is a sketch. I believe this was done by Renzo himself. Jost, was yours? Okay, apologies. Apologies. It was yours. Now there was an analogy here: the canyon and the iceberg. And maybe Jost, can you tell us a bit about how that came about, this analogy, and how it drove the design?
Well, it's an interesting day today because we're in November 2023. I first visited the site with Barry also, the developer, in November 2014. So it's 9 years now. So it seems an awful long time, but actually a lot happened. As some will know, the design has taken different routes in the beginning as well. But our first reaction on when we visited the site was the poor public realm. We have this magnificent station by Brunel, but when you come out of the station, it's like a complete anticlimax. It's just a horrible main entrance to the station. So when we looked at the site of the sorting office of the post, the brick building, for us it was immediately clear that the key to this project would be the public realm, the improvements to also with the public transport, because the entrance to the Bakerloo line was just diabolical. So it was just a very, very good reason to do something with that. So that sketch really showed it. It also shows that we didn't look at all in the beginning at doing a tower. It's not that because we did one tower across the river that we said, well, we have to do a second one. That came later on.
Okay, good. So that was the starting of the journey. And as you can appreciate, as we work in the construction industry, a lot of the design is done before planning. And it's planning when the building goes public, if you like, and then you get all the LinkedIn posts about everything else. But as design teams, a lot of this is done privately, if you want to call it that way. So from the iceberg and the canyon and the drive as being the public realm, it went on to something very different. And Josta, how did it go from the canyon to this, to a shard number 2, if you want to call it that? What was the reason for the jump?
Well, I must admit, looking at it like this way, it looks quite surprising. At the time, it didn't feel that surprising at all, but there are two drivers. One was that the investors were from Singapore, and their key business is residential and hotels, so they were not comfortable at all to do office development. So for them, it was really, we want to do residential. And the second one was the dialogue with the planners at the time, with Robert Davis, head of planning. He really felt that he wanted his I would say, his yard. He wanted a tall building in Westminster. So he really allowed and pushed also the developers to go taller. So we went on that in that direction. And our goal was to design a slender and a nice tower. But we always felt in the background that actually an office building in this location makes a lot more sense because of the use, because of a transport hub where you really activate the area you do with offices and not with residential where people stay there only a couple of weeks a year.
Excellent. And there's also two little twins at the bottom. I mean, those, what was the reason? Was that to get the amount of floor space, or was it part of the public realm?
Well, it was still the idea to have mixed use, to have some office, but it also was to create that public realm, to create that. What we did, I mean, the scheme is not different in that sense, is that we moved London Street to the back, so really to create a large public realm, and that was similar in this project as in the current.
So very, 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 very marked change. And then, Jean, I suppose it's one thing to design a tall building, but then you have to justify the tall plate. You have to do the work. So tell us a bit about all these various iterations and how you went through all of these. And
so basically, we call that sushis.
Sushis,
Yes,
okay, fantastic. There you go, sushi.
Very different iterations in size, in height, etc. And this is the way we're working to try to get the right sizing, the right proportion in the site. And so it's quite a long journey.
Process.
Yes, and time to time, even in late stages, we are coming back to sushis just to verify our assumptions.
Excellent, excellent. Okay, so the sushis, brilliant, just before lunch. One of the bigger drivers, I believe, and we can talk about a bit later, was to transpose some of the filigree of the station, the Brunel architecture, into the building, and we'll see some more details later. But again, maybe back to Jost. What was the aspiration there? Did you want to bring the station into the public realm, or what was the reason for that?
First of all, anybody who visits Paddington Station and forgets all the clutter around it cannot be other than be in awe by the station. It's just a fantastic building. And being so close to it, it was obvious there is a dialogue. You have to do something with it. And as you can see, the previous iteration of having a tower, the shape also had something to do with it. But actually, with the new building, you could say, well, what has a cube to do with the station? You would think, well, absolutely nothing. But I think in a way, it's because it's not a literal dialogue, it's more subtle. It comes more down to the facades, which we, of course, will talk on later. Yeah. And I think there is a lot of common in that, and I think we can talk about it later, and I think the image will talk for itself.
We'll move on. We'll come back to the filigree in a second. That's good. I'm conscious of the time, by the way, the 31 minutes, so we'll need to be mindful of that. But anyway, excellent. This is the approach to the station, which, as it was then, as you know, it's very uninviting, it's very tired. The station deserves something better, as you can see. So what really we've proposed, or the architects proposed, is something much more welcoming. So you can see on the left the existing approach, and the right something which goes into the building. And we'll talk about the retail glazing later on as well. But the approach, the public realm, as Jos said, is very much part of the design of the building. This is the finished product. And there's a couple of things that we want to talk about, and we'll come on to it. But the external lift and the balconies are perhaps something that you've not done in the UK before, if I'm not mistaken. An external lift and these sort of in that context. So, what was the? I mean, we'll come on to that. What was the driver for the external lift?
Well, the external lift was a marker of the entrance to the station. And second is that we really want to mark that there is public access on the roof of this building. Again, we feel that buildings which take a prominent place in London need to have public functions, and so the terrace on the top is public, and the panoramic lifts clearly show that make it visible that it's publicly accessible.
Good. And this is the finished product, and again, it's a fantastic elevation. You can see the lift on the.
This one is not a CGI, just to.
And that's the finished product. Okay, you've heard it from the gentleman there. It's not a CGI; it's the real thing. And I think, Jean, glass. We can't talk about this building without talking about the glass. And I do remember the word reflectivity and the word planners being used widely. So, what was the process there?
Well, there are two aspects, I would say. So you can talk about the building without talking about glass, but you can talk about glass without talking about the unitized system, the frame, the external fins, the shading device, and the double skin. It's coming as a whole pack. Concerning
we'll
the glass,
talk about the blinds later, yes.
Yeah, concerning the glass, two aspects: transparency and reflection at the same time. So it can sound a bit contradictory, but it's not. Because London sky, of course, is changing a lot and is beautiful, and we wanted, like on the Charm, to reflect it. And transparency, because it's a big building, and we didn't want it to appear like a big block. Glass can be a surface, totally opaque, and it has to be different. It has to be transparent to make it lighter and vibrant.
Okay, good. Okay. And here, perhaps you see the filigree of the Brunel vernacular, if you like. This is probably the best shot that illustrates that. So, Joost, how do you think that was a successful transposition? Would you have? And by the way, those are not just for decoration. Those are actual mullions. They're not just there for show. So they do serve a purpose. So
structural, yes.
So how successful do you think that has been?
I think this image is quite interesting because it also shows the different DNA of this building compared to the Shard. Shard was about the communication with the sky, but this building also has this communication with the street level. It's closer to the ground than the Shard. And so there was also concern about the glare, reflectivity about the sun. It's a big building, so to introduce this materiality of the mullions and the shading devices really help to soften it and to give it a light presence in the street.
Okay, that I think is a very, very strong image there. Delivering the vision. Now, obviously, that's the architectural part of it, and then this is a largely facade-based event, so we can't not talk about the facade. So maybe if I could just go on to there. It's largely a double-skin facade, and a lot of effort was expended in trying to get the right amount of transparency between the mullions. So again, one for Jean maybe. What were your main aspirations there? I remember you were doing lots of CGIs and you've done lots of work of a moving viewpoint to see what the thickness of the mullions would be at various points. So did you succeed, you believe?
Yeah, that was mainly to reassure the client that the visibility through the facade was still there.
Yeah.
We had no doubt about that on our side, but we needed to reassure the client.
Yeah.
But we introduced the long holes in the external fins to make it look like a kind of lace facade related to the station, of course. And it's a kind of it's a way to give the facade a rhythm. So that is very important.
Okay, good. And then we get on to the technicalities. Now, as I said, it's a double skin. It's a 1.5 module because it's an office building, and the external panes are split in half. So it's a 750 module externally, 1.5 internally. Small cassette, not dissimilar to previous work, but it has its own peculiarities. So maybe one for Michele. What were your main recollections of all this design development? What the ventilation, the framing? I know we did lots of calculations in trying to fine-tune the framing down, as these guys always demand from a facade engineer, which is fine. Tell us a bit more about all of that.
Yeah, well, first of all, it's been a nice journey. Obviously, involved a team of people. Not everyone is here, but since the very beginning. And I always joke with Jean, because we moved into the configuration we see here after a few iterations and design iterations. And one of the driver at the beginning was we want to do a double skin like the Shard, but lighter, thinner mullion, better performing. That was the requirements we got from Jean.
Nice and easy, yes, not difficult.
But I guess there are a few colleagues here, engineers as well, and contractors, so they know the challenges about having a very thin double-skin facade to avoid overheating, even in London, controlling the light coming through, but also delivering a structural performance. Because also another element that we touched base before is that everything you see is there for a reason, and is there structurally. So the mullion that you saw outside is not there just as a fin, so it's not an aesthetic element, but it's actually working structurally to support the frame. The mullion is very, very slender, and the process involved a number of different iterations, which went from typical structural engineering analysis done on a computer to 3D printing of different models and mock-ups to see that every element was working and was also delivering the vision that the architects had.
Good, thank you. It's a ventilated facade, naturally ventilated facade, so obviously there's a lot of engineering has gone into the way the air is taken in at the bottom and evacuated through the side mullion. So we did a lot of work on the gaskets, something which is normally not a big deal, but in this case they became a major design element. So what do you think was the main challenges with that? Or
well, we had many.
List the biggest ones.
Yeah, as always, as we know, what I like of our job is that we always are challenged by the architects and the clients to make it something better.
We don't make your life boring, no.
No, that's it all, and that's what we like, really. And so, one of the elements was also looking at the joints being regular, but being minimal. So the joints here are around 15 mil, and we had to deal with different tolerances, because another element we don't see here is that some of the structure is actually hanged from the top. So we had some movements and tolerances to deal with, by also being able to allow the natural ventilation of the cavity. So we even ended up, modeling the gaskets in the early stages and doing CFD modeling to see how the facade was performing under different conditions. All the gaskets are gray, so they're not black anymore.
Is there a reason for that, Joost?
Yes, there is. Well, I think you have to go on site. Even with a very grey London day in the rain, the building looks very light. And so it's a small detail, but it helps.
No, I understand. Good answer. I don't seem to be able to scroll forward. Can I try the page down? Page down. Okay. All right, so we'll bin this one.
I can say a few things while you say that.
Okay. If you look at the image on the right-hand side, there are we talked about the lift a bit, but the corners are an echo of the shard, albeit the fact that the steelwork here is on the outside, which has generated additional difficulties in terms of thermal breaks. Should work. Yeah, fine. Thanks. Thank you, Anne. So we'll talk about the corners in a second, about the thermal breaks, the penetrations and so on and so forth. But this is an interesting one because, again, if we go back to the design iterations that happened before, this is a very different image on the left. And again, maybe you can ask Jean or Joost, what was the transition between the left to the final product on the right? We've got curved corners, curved glass, which is very different from.
Well, the left was the planning permission, and the other one was a modification to the planning.
Okay, so this was planners
yes.
driven.
Well, we're always very much aware that compared to the scale of the buildings along Pratt Street, it's a massive building. I mean, it's 54 by 54, the footprint. So it is a big building. So we're always very much aware of the scale of this building in relation also to the Hilton Hotel building right next to it and the station itself. So we did feel that by articulating the corners, it would really break down the scale of this building and would help it. So it was, one of those moments you wake up in the morning, you think, maybe we should discuss. And that is also with Renzo discussion. We said, okay, it is too late to do it, but not too late.
Not too late, yes, good. So that was the final product. Good design development. Now I'll probably have to page down again.
There's another reason on that, which also really on this image, is that we also wanted to express the structure, coming back to the dialogue with the Brunel station. It really was very nice to be able to express the structure in the facade.
Because that is a visually very strong element, yes, you're right, you're absolutely right. But in that context, with the steelwork on the outside, that meant the steelwork at some point had to go internally, and you know what that means, cold bridging and all that. So we did quite a lot of work in trying to minimize that effect. And when you can appreciate the tolerance of steelwork versus the tolerance of a curtain walling system are very different. So we had to make sure that the gasketry was sufficient dimensions to accommodate the tolerances in the steelwork. And that was part of the design iterations that we actually during design development. Michele, do you want to add a few words about this?
Well, actually it's quite interesting in this one compared to the shot, because this is actually, although it's behind the structure, it is actually also a double skin.
Yes, of course.
Because this corner is actually facing south. I mean, Paddington has a very funny configuration that it's exactly 45 degrees facing south. So that corner is due south. So to make sure that there is no not too much energy coming in the building, the double skin there would. So that was a big challenge to do that.
And it's also giving you a lighter glass in the corners, whereas a shard, because it's single glaze, is
different color,
darker. Yeah, absolutely. Michele, sorry. One comment on the gaskets, and what was probably the most difficult detail on the building from us, I think.
Probably one of those. We had a few, I must say.
Yeah, okay.
But you know, the beauty, I think, of this building is that when you look at it, it looks very simple, very sleek, very, very detailed. But this is because we really started from the beginning as a team to work. You know, I just see one of my colleagues, Serena Gugliotto, worked with me on this project, for example. Every one of us put as much as possible passion and motivation. We all wanted to do the best we could. So, for example, all these penetrations has been studied before, because one of the challenges we had is that the primary structure that is going outside. So the primary structure is intumescent painted, so we had to allow for enough movement, tolerances, intumescent paint expansion, but also avoid the usual things, you know, thermal bridging and condensation inside.
Okay.
That involved a number of different studies and iterations.
Good. Okay. Excellent. And then, and then we go back to the contractor's solution. Now, you've seen the thermal brakes before, but then this is what Fokke with Mace came up with. So, I mean, Ovi, just bringing you into here, what was your recollection of all of these? How well did it work, do you think?
When I first met the client, he was so concerned about these details. He was convinced that the facade was going to leak through these penetrations, because there's so many hundreds of them and a very critical detail. But I think in the end, credit to Fokke and the design team, we ended up with a simple and robust detail whereby some vulcanized concertina gaskets.
And that's an actual
this
sample,
one here.
Yeah. Okay.
Sealed around the penetrating steel and then glazed within the surrounding facade. And they produced this very simple and robust detail. We tested it to CWST, dynamic test sequence there, and it passed. We never had any issues. And to deal with the cold bridge, we had to insulate the penetrating steel, and we did that by insulating it on the outside, where the insulation is the most effective. But also because we considered introducing thermal brakes, structural thermal brakes within the primary steel, but the loads transferred were too big. So we ended up with this insulation. We see this horizontal insulation, which wraps around the penetrating steel and is clad with a aluminum cover.
So it's very comprehensively designed. Okay. Blinds. Now, I know as a studio, you're very keen on blinds. A lot of other architects simply put up fit-out blinds inside and forget about it. Now, for you, blinds is as much as important as the extrusions themselves. So what was the process in selecting the final product in all of this? One for either of you.
Well, I think the interesting one, this one, is that we actually use Venetian blinds, not the roller blinds, and I think it was a very good, smart move. Again, just the DNA of this building, it seems to go very well. We visited this morning, and when blinds are down or up, it's hardly to notice the difference from outside. But also, they are very comfortable. You really give the tenants the possibility of. It's not just to protect from the sun, but it's also from glare. So they are actually.
You were happy with the product in the end.
Yes.
Yeah, that's good.
And it's always bringing another layer of vibration to the facade.
Yeah.
It's not a solid facade when the roller blinds are down.
There's an additional softness to it. Yeah. Good. Okay. Thermal performance, Michele. Double skin, always challenging to get the U values correct and G values, because it does depend on the transient airflow. And when it's at the mercy of the prevailing weather, it's always a challenge. So, how do we get to these final numbers, and what was the process there?
Yeah, so the process, well, first of all, going a little bit back on the blinds, because I have this still in memory. I had a call with Joost, and it was just before a Christmas break. I still remember that. He was very adamant that we started a blind pattern and perforation and color that would have been able to allow the people to still perceive and have a relationship with the outside even when they were activated. Because obviously one of the concerns that we all had as a team was that when the solar radiation was too high, then these blinds would have worked, so would have been activated. But then what would be the feeling as a person working on a project, on a building, that you see the Hyde Park on the one corner when the blinds are down maybe 3-4 months a year. And so we went through a number of different iterations and studies to literally design the pattern and the perforation and the color of these blinds to be able to meet both these very stringent G-value requirements. So when the blinds are activated, the G-value goes down to 0.08, which is very low, but still leaving the visual perception of the outside from the people living in the building.
Good. And that's the final product. So you look at it; it's a very elegant, simple facade, and you think, oh, it's easy to develop. No, it's not. It's totally the opposite. The simpler it is, I think I'm right in saying, the simpler it is, the more design work goes into it. So the beauty and the simplicity is very telling there. I mentioned earlier about how it's all, the realm is as important as the building itself. So. Jost, what did you have to, what loops did you have to go through to make sure that there's a station entrance there which is integrated with the building, and technically we can talk about the retail glaze in a minute, but how was that achieved?
Well, I think the best way to describe it in 2 words is we wanted to make an inclusive building, not an exclusive building. So what we did, we put the lobby actually on the 2nd floor.
Okay.
It's a very nice lobby, very spacious, and it's more like a lounge. But that means that the ground floor, or the street level, and the level before is really as public. It really opens up with a very generous canopy over it, so even on a rainy day people can enjoy the public space.
Thank you. So it's a public space as much as an individual building. That's the key message here. And then in that context, the retail glazing is different from the double skin at the top. So Jean, you were very keen on simplicity and transparency at the retail because that's what you want, visibility at the lower levels. So tell us a bit about the iterations that you and Michele went through in designing what is a very slim stick system in the end.
So for the retail facade, we choose to stick to the 1.5 meter grid, first of all, to make a difference with the office facades. But this is the same DNA. We still have the perforated fins, but this time internal, not external. And I would say that the main challenge, the biggest challenge on the retail facade was to integrate the louvers related to air intake and
yes, I remember that.
Yes, and it was a big challenge, and you can't see any of them actually because they are all hidden by fascia between the retail facade and the lobby facade.
Yes, so basically those are all louvers.
Exactly,
but
and the louvers are hidden behind this fascia.
The aspiration was that you don't see them as louvers, and I think that's been quite a successful exercise. COVID. Now, so we went from collaborative face-to-face meetings and so forth to become a world of avatars on screen, and it's very easy. Well, no, it's not very easy. It was relatively easy if your job meant you were working on a screen, but for the contractors, it wasn't that easy because you had to be in a certain location, doing a certain function at a certain time in person to physically do that. So, Ovi, how did that impact the delivery of the construction, the design? I do remember, for example, that some of the mock-ups, visual mock-ups were inspected remotely. Yeah. Maybe this is one, again, both for Ovi and you asked, did you feel that worked well, or was it unsatisfactory? How was it?
So around early 2020, we were in a position to submit samples and visual mock-ups to various parties, including planning authority, clients, architects. And we were prevented from doing that because of travel restrictions. Mm-hmm. And we were the first project within MACE to implement real-world camera technology, which allowed for streaming live images online. And we did that for inspection of visual mock-ups, which were at that time in Italy at 4K. Mm. So we had all the parties attending from all over the place, including Germany, France, UK, even Canada. And everybody was able to take part into this review. And it worked very well for us. So much so that we carried on and carried out even quality control inspections when the assembly of the facade was ongoing.
How did the visual mock-up work for
Well,
you?
I have to compliment Focky on they delivered an excellent job, but you have to really keep it in mind during this very challenging period. So delivering this facade during COVID, so it was a major challenge, and we did learn to do mock-up control remotely, and it went better than we expected.
Good.
But again, it comes down to trust. If you trust each other, then you can
yeah.
talk about really issues, and you can move forward.
I have to say, at the beginning, we were not really convinced to review a mock-up remotely, and but Focky and Mace, you made it possible, and it was quite an organization. But it worked.
You felt it worked, yeah. I remember there were very interesting
it doesn't
video calls
a physical review, but it's a big step forward, and it's really helping.
I think, but then there was an element of trust built within the team, so that's another reason why it worked out very well for us.
Okay, good, thank you. I'm conscious there's 10 minutes according to this 9:59, so we need to be mindful of that. We'll look at a few images of the completed product later, but essentially we're now moving on to the delivery, the construction, and maybe one for Ovi to tell us a bit more about what the constraints and the logistics and the problems were. So you can see the station entrance here, which with the old buildings demolished. What were the biggest challenges for you in getting
So the constraints, logistic constraints came because of the entrance, train station entrance, which is right next to the project. The ambulance lane is on the other two sides. And at the time when we were installing the curtain wall and erecting the scenic lift, we were also digging out the entrance to London Underground. So we had to look at these constraints holistically, looking at how to adjust the design, how to develop bespoke methodology, or even resequencing some of the activities, as it was the case with this the retail facade along the west elevation, which was built after the gantry was removed. So we looked at various solutions to minimize the impact of the constraints in logistics.
And it's worth saying that the majority of the facade is a unitized panel 1.5 by floor height, but around the bottom of the building, one of the design features was the glass over sailing down. And I think there was that, did we call it a skirt? Or that was the skirt. So that meant that the panels had to be oversized, if you like.
Yeah, I think we combined it with the skirt of the vision area because of the limited access to the underside. And Focky had to develop a bespoke launching table, which is about 6 meters long, which they used to launch those longer units.
So that was a bespoke trolley made just for the installation of the so-called skirts around the building. So that's quite an investment. And what about the corners? I mean, we talked about them earlier from a design perspective. From an installation, you had to thread these panels in between. So how did that one go?
The complexity of installing the facade around the notches comes from the fact that the primary steel is external to the facade, and there's a lot of penetrations, but also because the facade is very close to the primary steel. So Focky developed a bespoke tilt and turntable able to offer the units to the work face, but we had to do that from within an exclusion zone because the edge protection was removed. So there were additional constraints, health and safety constraints put in place. The smallest unit came to site and as a kit of parts, less than 1 square meter, was just put together around every single penetration on site. And that required additional quality control procedures to be implemented.
Okay, and the lift. I mean, we talked earlier about, Jos described how it's part of the public realm, but building a glass lift like that, it wasn't unitized. I don't believe, Michele. That was all a stick system, wasn't it? Yep. So what were the how did that happen?
So the other constraints we had at the time when we were glazing this the scenic lift, there was ongoing work around the base of the scenic lift, which prevented us from using a mast climber of any access starting from the base. So we had to install the glazing with access from suspended cradles. And I think the most complicated phase of the scenic lift to install was the one facing the office building, because of the additional constraints of the link bridges, which are located at every other floor. So we had to use upsailers to install that glazing.
Good. I'm conscious of the time. Again, this was part of the chassis for the lift.
Yeah, prefabrication. We looked at doing it as much as possible. We brought the balconies as complete elements. We assembled the pulley rooms on the top of scenic lift on a yard outside London with input from 4 subcontractors. We brought to site and lifted in place. And we did the same for the scenic lift. Section of the scenic lift were assembled in the factory, and then they were erected in place on site. And that is one reason for that is because the scenic lift was specified to plus minus 15 millimeters in and out.
So tight tolerances.
The primary steel, yes.
Okay. The canopy, we can't really not talk about the building without a canopy because it's a major design feature, which it oversails the entire perimeter, and as you say, probably stretches into the public realm. What was the? How well did that work, Jost, from aspirational to delivery?
It's a very big statement, so we really had to get it right, and I think Jean did an excellent job on that. It's been quite stubborn about it, to be honest.
Yeah, absolutely.
So it's been a big challenge, but again, I think the team has really picked on that, and I think the result is there more so than we could have hoped for.
Okay. And that's the end of the not a CGI. That's the final product. More on the canopy. Jean, you were very keen on the glass modules, and I remember we did lots of iterations. And again, it's a very tight filigree, and what drove you to that? Was it a transposition? It's a very tight spacing of the framework.
Well, basically, this is a bit the main facade horizontal, and we wanted to keep the same grain. And just for the story, this canopy is collecting all the water and sending it into rainwater pipes concealed into the columns, the structural columns. So it required a huge amount of coordination, and dozens of people have been involved in the design of this component. And it's basically, this is the reference plane above which the cube is floating.
Yeah, absolutely. More of the same again. 3 minutes I have, and we'll try to stick to the time. I'd like to talk a bit about maybe the interiors. I mean, this is the reception, which is on level 2, which is a departure from evident entrance at ground floor.
So here we are on the same level as the canopy. It's like it's floating in a sea of glass, and also the access it's the canopy, and there's also a terrace, so you can actually sit on the canopy. But what's really nice about this that you are still connected with the buildings surrounded by you. You are still part of the city. It's a very generous space, but it's a quiet space. You're not connected to all the people coming from the station. So you have your own private space, but you're still visually connected. So we think it's, well, to be honest, I think it's a successful space.
Absolutely, absolutely. And then main building on the right, there's a little baby brother on the left, which is done as a Pred Street building, PSB, which comprises of an existing, I think it's the pub, isn't it, which has been kept. And you've built an additional extension to that. So, again, was that part of the public realm strategy? What made you keep that building and add a little bit on the side?
Well, obviously, from a developer's point, it was not, but it was really to make the transition from the Pred Street scale to the cube, but also to provide the public realm. So that's why we made it deliberately a smaller building. We didn't fill up the whole Pred Street. We planted a very large tree there, which hopefully becomes like a meeting point. So the materiality of this building had to be different, and we want to introduce the stone to make that transition from the Pred Street scale and materiality to the main building.
And I remember one for Jean and Michael. I remember the stone fins on top of the curtain wall. It did generate a lot of design iterations, and you always wanted a stone very small, and so on and so forth. So what happened in that? How did that? Did you get what you wanted, basically? Did Michael give you what you wanted? I guess it's a simple question. And you can be truthful.
I would say that on our side, it's even better than what we expected.
Oh, good.
Basically.
Well done.
So, and every time we're on site and we see this building, we're a bit surprised because it looks so good.
There's a very strong chain vernacular from the existing building to that right next to each other. I don't want to use the word juxtaposition because all architects use it, but if you get a chance, look at them close together, and it is quite stunning. So the little brother's been a success. And there it is. You can see the existing building on the left and the extension to the right with the stone fins.
Maybe we can say also that this little building is really articulating all the public realm that we created. The public realm has been designed with as much as attention than the building itself. So it's really a big component of the project.
So it's this very, very subtle, very delicate, yes. Okay. And you can see an interesting photo there of the new building, the big brother and little brother there. And what stone did we use for there? Remind me. What was the stone for the fins?
Travertine.
Yeah.
Travertine. Why travertine? Why did you choose travertine as opposed to limestone?
We wanted it, although travertine is definitely not a London stone, but it still had that London feel to it. And of course, it's not Portland stone, but it still has that feel.
And it's matching the sandstone color also.
Yes. Yeah.
So sandstone could not be used on such facade elements, and we had to find another stone for that. And with question of infield or not infield due to maintenance issues, etc. So the travertine addressed all the requirements.
Good, excellent. And I think we've got 55 seconds left. So what I will say is, what I will ask you is, if you were doing this again, if you would start again, are you happy? Well, you're obviously happy, but would you have done something different? And I mean, starting with Joost, what?
Well, I think with the previous speakers, I think the subject is quite obvious. It's the whole story about the carbon footprint.
Yeah.
I think in terms of design process, because that's what is the interesting part, is we're currently working on a project in Tokyo. And what we really established there is what we call a carbon budget and a cost budget, and you do it parallel in a very early stage. And there are always moments where actually the carbon budget and the real budget, they're converging. Using less material means less carbon and quite often less cost. Of course, they also diverse, and then you have to make quite often the difficult decisions. But to bring that on in a very early stage and very consciously, I think is a good way forward. I think we have done a very responsible project here, but I think doing it that way, it would have made some decisions differently. But I think the concept and the need for a special building in this location is still standing. So I think from that perspective, we wouldn't have changed the philosophy of the design.
Good, good. Anybody else would have done things differently? Or is everyone diplomatically silent?
I think from our perspective, I would have liked to look at off-site.
We have already a challenge done
manufacturing the retail facade and the canopies.
Would you have done it differently then?
Just to improve the site activities.
Yeah. Okay, good. Jean, anything closing off for you? Are you happy? If you're happy, you're happy. I mean, this is all this several years of design work is to make you happy. So hopefully you should be saying, no, I'm totally happy with it.
Well, the interesting thing is that we wanted the building to be open, and it's we showed the image of the iceberg, and what is below ground, invisible, is still going on. Is to work with the LUL, and really, if that could have gone faster, quicker, and that that part of the public realm, the retail will be open before this Christmas, would have been great. But it's
fantastic.
Not the case.
Fantastic. Okay.
Maybe I would say that the time life of such a project is so long. So we were talking about 9 years from the very beginning. that of course technology is changing, and you are still late when you complete the building. So somehow this is a bit frustrating, but I guess there are no solutions.
There's never a solution. Okay, excellent. Well, ladies and gentlemen, can I say it's been a privilege to partially worked on this. Michael has done most of the facade work. Ovi's done a lot of jumping up and down to deliver it, but certainly Jost and Jean are responsible for what you see there. And my apologies for crediting the initial sketch to Renzo, whereas it was yours.
Don't worry.
So can I just close off with an applause for me, an applause for the panel. Thank you.
Thank you, everybody, and thank you, Steve, for moderating a really, really fantastic case study there. Brilliant. And by the way, 55 seconds you had overrun. You weren't. And the rest of you, please enjoy lunch and then decide which track you want to be on. Remember, A is over there, B in the middle, C is over there.
Well, good afternoon, everybody, and welcome to session A. I hope you've enjoyed your lunch, and we have a very interesting set of talks this afternoon for you. If you're just coming in, please come in, take a seat. My name's Patrick Ryan. I'm a director of Patrick Ryan Associates, and I'm here today to chair this session, track A. So you are in track A at the moment, just in case you're wondering. So welcome. We have some great speakers lined up for you, and so without any further ado, I'm going to introduce the first one. And our first speaker this afternoon is Douglas Paul, who's an associate partner at Architects RSHP, and he will be speaking on an inclined triple glazed facade from design concept to completion. So please welcome Douglas Paul.
Thank you, Patrick, for the introduction, and thank you for giving us the opportunity to talk. Yes, so today I'll be focusing on the triple glazed facade for a pier extension at Geneva Airport. Often the most challenging sites lead to the most interesting results. I'll start by explaining how the constraints of the site led to a very specific facade design. So the Canton of Geneva was the last to be admitted into the Swiss Federation, and essentially it forms an enclave. The green area, the green overlay is France, and you can see Geneva is a bridging point where the water from Lake Geneva flows into the Rhone River. The airport, you can see, is close to the... Is this pointer working? It is, sorry, bear with me. Yeah, so there's the airport there. It's close both to the lake and to the city centre down there. And it's at essentially at the pinch point between France and the lake. So if we fast forward to the site plan, essentially the footprint of the pier is in blue, the existing terminal in green to your left, and the landside perimeter is in pink. The pier was serving 6 stands which were already in operation. If you'd flown into Geneva prior to the LS being built, you probably arrived at one of 2 satellites out on the apron, and you traveled through a tunnel to the baggage reclaim hall, which is essentially an underground arrival experience. And your main impression of Geneva, initially at least, would be of watch adverts, more than likely. In 2010, Geneva Airport launched an international design competition to select a design consortium to design the pier extension, and this was the reference project. I just want to highlight 2 things about this. First of all, they imagined that there would be in terms of arrival sequence, you'd be entering an underground tunnel that connected into the baggage hall. Another thing is that these large boxes which protrude into the airfield housed the vertical circulation stairs and escalators. I should explain, it might be obvious, but on the right is the airfield, on the left is the land side. And in February 2011, RBIT was the design consortium announced as a winner. That consists of Roger Stark Harbour and Partners, Jacques Bougne Architects based in Geneva, the Angerop engineering group based in Paris, and T Ingénierie, which was a structural and civil engineer based in Geneva. And essentially, one of the key aspects that RBIT won was that we placed the arrival sequence above ground. So the orange zone is the arrival corridor, was previously in the reference scheme, the pink tunnel underground. At this stage, you're probably asking yourself, why are the facades inclined? Well, the answer in terms of the land side is easy. It's simply we're respecting the rights of lights of the existing neighbours on the land side. In terms of the air side, we're maximising the volume. And the other thing that the winning design did was it incorporated the vertical circulation stairs and escalators, separating the two passenger flows internally. So we don't have the boxes sticking out into the facade, thus minimizing the amount of envelope and minimizing carbon. So this also shows the reason for the inclined facade on the air side, which is that we had to respect a minimum offset to the nose cone of the nearest aircraft. And because the service road, which is C, needs to sit below the building, we had very long spans of 20 meters. B is the area that the pushbacks operate in. So RSHP, essentially a rebranding of Roger Stark Harbour and Partners, which previously was Richard Rogers Partnership. And there's a common thread to the aviation projects in that we've tried to systemize the facade design. This is Barajas Airport Terminal 4 in Madrid. Most of you recognize this as Heathrow Terminal 5, and there you can see again the vertical circulation, which is behind the facade line, separating arriving and departing passengers. And just to give another example, this is a terminal building that we built in Lyon, in which the vertical circulation is perpendicular to another inclined facade. So if we just return to Geneva again, essentially the pier is 520 meters long, 20 meters wide. The plan at the bottom of the page is showing the service road with technical cores on the land side. The middle plan is departures in blue, in which you're traveling through the pink area, through passport control, left to right. The top plan is arrivals. We are coming up the valve and traveling from right to left, again going through passport control. In reference to the architecture of Louis Kahn, the pier is a simple diagram of servant cores on the land side serving the extrusion of the pier itself. So the client opted for a traditional procurement route. So the facades were fully detailed by the design team before we went to tender. This is one of the tender drawings. So it was tendered in March 2016. There was no contractor design element in the tender. These drawings were prepared by Arcora, our subconsultant based in Paris, in which we've got a unitized triple glade facade with fixed brise-soleil on the land side to protect against, obviously for solar control. And if we just show the plan details, again, showing the unitized gasket system. used the external steel columns, which are tubes essentially, or a box section, a steel fabricated steel box section for wind loading. So those of you that represent the facade supply chain probably a bit surprised that the client chosen a traditional procurement route when you've obviously got so much input to give in the detailed design of the facade. And right enough, Gartner, who was the selected subcontractor by HRS, the Swiss general contractor, naturally came back with their own proposal, which hadn't been anticipated. On the left is the tender, the unitized, and on the right is Gartner's proposal, essentially a stick system, a bespoke stick system. And one of the reasons given for changing to a stick system was just the improved U values that the profiles gave. And after an intense period of negotiation, the client agreed to proceed with the contractor's proposal. And we worked collaboratively with them to improve and refine. And essentially, you can see on the right that the refined final detail offered much slimmer profiles compared with the original tender proposal. One of the obstacles we had to overcome, or one of the technical challenges, was there's a longitudinal slope along the jetty of 1 in 300. The facade's 10 meters high, the panels are 2.5. Because of manufacturing limitations, the 10 meters was split into 2 panels, and Gartner proposed supporting the upper panel with minimal pegs so that the lower panel could be removed in the case of a breakage. We should say that the 20-meter structural grid also had many challenges, including the structural tolerances and differential movement, and these accumulated up to 100 mils. So Gartner proposed a series of rigid and soft joints to accommodate, well, the soft joints to accommodate the differential movement, and rigid to resist racking. A mock-up was built, and this was an excellent means of choosing between 2 glazing suppliers, 2 different products. And it also proved to be a very worthwhile exercise to take the client through the design development. Facades were extensively performance tested at Gartner's facilities in Gundelfingen in Bavaria. And the facade installation started in 2018. So this is shows the landside facade with the rectangular wind posts, the fixed brise aren't in place yet, and the towers to the back are the service cores I described previously. Because of the limitations, because it was an airfield and there was a radar height restriction, the facade was installed just using cherry pickers and avoiding tower cranes, and it was using cherry pickers and mobile cranes. So each panel is, well, just under 3 tons. And one of the most difficult details in terms of waterproofing to execute was this structural transition from outside to in. This was a key detail in terms of the design intent, that you can read the legibility of the transition. Obviously, there's a certain amount of overcladding that was required, but it runs all the way to here. This was extensively thermal modeled to ensure there wasn't any cold bridging or dew point issues. I think we say we're very pleased with the actual precision achieved. As we're all aware, the challenges of climate change need innovative solutions to complex problems. And a highly insulated envelope, in this case triple glazing, is only one part of a strategy to reduce or reverse the carbon associated with construction. So although it was conceived a decade ago, the jetty is designed to be energy positive in operation. That's to say, it's designed to generate more electricity than it uses. Part of that strategy uses 110 geothermal piles which run underneath the jetty, connected to thermal ceilings. These can both cool and heat the building. And in the services gallery running under the jetty, there's another resource that will further help the energy balance. These are supply and return pipes which take water from Lake Geneva. The Genelac project is being rolled out over various parts of Geneva, and it can save up to 80% of the CO2 associated with cooling buildings. Rather like the geothermal piles, the system uses the thermal stability of the water in Lake Geneva. And by 2050, the Genelac system is projected to save 80,000 tons of CO2 per year for the city. Yeah, if we're serious about tackling the challenges of climate change, it's this level of infrastructure, infrastructure investment that will be required. So just moving on to the last part of my presentation. The pier was handed over in July 2021 and was operational by December 2021. This is a photo taken of the land side showing the fixed brise soleil and the triple glazed facade. This is the airside facade, where the brise soleil weren't required. And just to reiterate some earlier comments, the passenger experience has been optimized for both departing and arriving passenger flows, without one being prioritized over the other. You can see the arrivals corridor runs along the that's the arrivals corridor there, running along the airside facade. And those are the clear views of Geneva the clear views to the Jura Mountains to the north. So the daylight and the views offered help to relieve some of the stress associated with air travel. It's been proven that relaxed passengers actually spend more time and more money in airport retail. And we tried to ensure that the passive wayfinding for the jetty was prioritized, with passengers able to find their departure gates without relying on signage. That brings an end to my presentation. Thank you for attending.
Well, thank you very much, Douglas, and thank you for a fascinating insight into the project. If I can ask you one question, was there a problem with, outward-facing glass onto air facilities has to be radar invisible? Was there any influence on the design from the radar point of view?
No, there are advantages in terms of glare that the inclined facade was 26 degrees to the vertical, but actually there weren't any issues raised in that respect. It was more a height restriction for radar. So it was well received by those operating the airfield, the proposal.
Okay. Well, very good, thank you. Well, thank you very much indeed. Please thank Douglas for a wonderful talk this afternoon. And so we're moving on to our second speaker this afternoon. Our second speaker is Massimo Chies, who is a Director of Cost Management for Facades at AECOM. And Massimo will be speaking about the facade budget at early project stages. So, Massimo, over to you. There he is.
Patrick.
Over to you.
Thank you. Thank you, Patrick. Yeah, as some of you know, I started my career as estimator for a large cladding contractor in Italy. This was in 2005. After a few weeks of training, I was shown the estimating tool of the company, and it was a very complicated tool. I had to prepare my first budget for a facade. And I was struggling. So I turned to my tender manager and I asked for some help. And he said, "Don't worry, Massimo, we'll do this together." And then he added something else. He said, "By the way, we've been told that the facade budget is £650 per square meter." And I started wondering, why 650? Why not 600 or 700? And who decided that rate? Okay, and how did they get to that number? Later on, in 2014, AECOM asked me to join their QS team in London, so I jumped to the other side of the fence, and I could find the answers to my queries, and I would like to share those with you today. So today, we will see the tools we use to establish the budget of our facades. We will see some of the key cost drivers for a facade. And in the end, I will touch very briefly about 3 challenges for our market. So this is the RIBA plan of work. It shows the various stages of a project from stage 0 to stage 7, so from conception to final use. And I would like to talk through the first few stages when we establish the budget, so from stage 0 to stage 4. So we know that there are many stakeholders involved in the design and delivery of a facade. So from the client, of course, the architect, all the consultants, and of course the contractors and the supply chain. The key thing here is that not all the stakeholders are involved in every stage of the project. At stage 0, simplifying a bit, the client takes a decision that he needs a new building. He appoints the architect, he appoints sometimes the project manager and the QS, and there is no design developed at stage 0. At stage 1, we run feasibility studies, and we need to answer this kind of queries. So, is the project big enough? How tall can we go? What is the budget? We get briefed by the client, and we are asked, cost consultants, to imagine an efficient solution for the facade. So we go back to our office, and we start picturing in our mind how the facade can be, and most of the times we think about something like this, very simple, repetitive. Then we meet the architect, and we need to get his ideas. And sometimes, not all the times, but sometimes he might start describing this facade. So, yeah. We have a problem, so we need to align the 2 ideas. Also because all the times clients prefer the facade on the right for the budget of the left. So what can we do? We use the first tool we have in our pockets. Benchmarks, we see what other projects have done to deal with this problem. And AECOM have been involved in hundreds of projects in London and the rest of the UK, so we have all sorts of information on all those projects, the location, the typology of the building, the key stakeholders, areas, sizes, rates, design, everything, okay? So, very easy. We just filter the tool. This is just a screenshot of, the tool is much bigger, yeah, there are many more columns. We just filter a few columns until the architect is happy, so easy. No, it's not easy, because unfortunately, for the cost consultant, Facade is a very bespoke package, probably the most bespoke in a building. But let's say that we are lucky and we find in our past portfolio something that makes the architect happy. We still have some variables to consider. The first is inflation. We've seen the last few years what's happened to materials and labor costs. Then we have currency fluctuations. Most of the cladding contractors operating in the UK, they are actually based outside the UK, so we need to deal with euro versus pound exchange rate. And then we have updates to the building regulations. We know that Part L gets updated every once in a while, and it's very difficult to take track of this in the benchmarks. And then market conditions in general. We know the state of the economy is a key factor in the rate of our facade. Just to give you some reference, to build a medium-rise office building in London, nowadays it costs about £430 per square foot, and the average rate coming out from the benchmark tool for the facade is about £1,700 per square meter. So at the end of stage one, we make an informed decision. There are some, we discuss with the architect and the client, and we commit to a rate, and we kick off to stage two. Stage two is a very volatile stage. There are many more stakeholders involved, facade consultants, sustainability engineers, and I also start bothering many of the people in the room, to update my costs, my rates, and I try to be the link between the client team and the market, the facade industry. So what do I do? First of all, I do my own cost estimate. Thanks to my previous experience in contractors, I developed my own estimating tools, and to put together the cost of the materials, I made one specifically for glass, and then I make my assumptions for fabrication, transport, installation, design, management, the other preliminaries, cost, and of course overhead and profit. In parallel, I talk with the client team and the architects, and I agree a list of potential contractors that could deliver the facade. So, and I run a market testing with the design information I use to develop my own cost assessment. At the end of the market testing, we recap all the numbers, and we issue the cost plan to the client again. It's important to say that we don't have all the information that we will receive in later stages, so we need to make some allowance for contingencies. Stage 3 and stage 4, things vary a lot with the procurement strategy that we decide with the client. Sometimes we can decide to negotiate the facade package with the contractor. Most of the times we run a competitive tender. And ideally we would like to involve cladding contractors as early as possible through a pre-construction services agreement, so that they can help the client team to develop the design and ask cost consultants to provide a more cost certainty to the budget. It's important also that during the PCSA we maintain control of the design before awarding the whole contract value. So we've seen how we get to the facade rate, what is actually driving the cost of our facade. Many things. One key factor is the wall-to-floor ratio. The wall-to-floor ratio measures the efficiency of the building layout. So we want to minimize the facade area and maximize the internal floor space of our buildings. Of course, we want the wall-to-floor ratio to be as low as possible. The wall-to-floor ratio depends on the shape of our floor plate. Ideally, from a wall-to-floor ratio perspective, a circular shape is the most efficient, but of course, it gets more difficult to partition and more expensive to partition a circular space. Squares are more efficient than rectangles, and as soon as we start introducing further corners in our floor plate, the efficiency keeps dropping. Then if we have two floor plates with the same shape and the same story high, the one with the longer perimeter, we have a higher efficiency. The problem with that is that we will have less light far from the facade. Story high, if we have a tall enough building and we manage to squeeze in an extra story by reducing the story high, we gain floor space area for the same facade area. And of course, facade depth. On the right, I have a naturally ventilated double skin with a very deep cavity for maintenance. And on the left, we have a more efficient closed cavity facade. Another cost driver, of course, is materials. They normally account for about 40% of the total value of a facade. I've seen on a couple of projects recently very deep reveals that didn't provide a meaningful shading for the windows. So any reduction in depth of the reveals can generate massive savings. Design complexity, of course, tall and repetitive buildings like the ones on the left are much cheaper than buildings with complex geometries and many different wall types. Also, design is linked to other cost factors like transport and installation. Panel size, there's always the big debate. Is there actually a universal optimal size? We usually say that 1,500 by story high is a good compromise between production, installation cost, and transport as well. We could go wider. We would save money for brackets. We would have less production cost and installation, but we need to make sure that we can vertically distribute and install the panels without the use of the tower crane. Of course, shaped panels are much more expensive than rectangular ones due to the extra cost of materials, assembly, and machining. And another cost driver is joints, and I refer particularly to horizontal joints. This is the base study of a unitized facade. In blue, we have the glazed elements, and in red, the solid ones. Normally, for drainage reasons, the horizontal stack joint is continuous between the panels because we need to install the saddle gasket over the top transom. For architectural reasons, we might want to misalign the stack joint. That can be done, but it comes at a cost, of course, because we might need to install separately the solid panels over the backing unitized panels. Inflation, of course, on the top we have the cost of the raw aluminum for the last few years, and at the bottom we have the Dutch TTF. We've seen the massive impact that the pandemic had on the materials cost and the impact of the war in Ukraine to the energy costs. Other market conditions are the ones that we've seen when we were talking about benchmarks before, so currency fluctuations, import policies, updates to the building regs, and the state of the economy in general. So to conclude the presentation, I would like to talk very quickly about three challenges we have in front of us. The first one is, of course, net zero carbon. We should be familiar by now with the terms of embodied carbon and operational carbon. Up until a few years ago, all the focus was on reducing the operational carbon and reducing the U values of our envelopes. In the last few years, there's been a clear change in the focus, and we need to deal also with the embodied carbon. And this is important for the cladding contractors in the room. Please be aware that clients and design teams, they make choices over the cladding solutions at the very early stages of projects. So you need to be creative and try to improve your systems. Reliability of carbon assessments. Nowadays, embodied carbon calculation is a key deliverable on every tender, and it could be a criteria of choice at tender stage, so it needs to be a reliable assessment. Low carbon materials, we need to make sure that all our projects in the future can make use of recycled materials or low carbon materials, because at the moment they carry an important premium over standard materials. So with a widespread use, it will be better for the environment, of course. It will increase the demand, and it will hopefully reduce the rates. The second challenge is the Building Safety Act. It's a very complex topic, and it would require a separate presentation. But very briefly, just be aware that we will need to be competent and provide proof of competence to work on all our projects, not only the residential ones. And then the Building Safety Act will have also a massive impact on the procurement and the delivery of higher risk buildings. Inflation, again, we've already seen the impact of the war in the Middle East on the energy cost. Materials, they seem to have reduced in cost in the last few months, but unfortunately, labor rates, they keep rising. So just to recap, we've seen a few of the budget tools we use to establish the facade rate, and we've seen some of the key cost drivers for the facade. We cannot control some of these factors, inflation and market conditions, but we can control the other ones. So it's important that all the stakeholders agree a direction for the design at the early stages of the projects, and to make our buildings nice, but also profitable for clients and contractors. Thank you.
Well, thank you very much, Massimo. That's been a fascinating talk. And I have just one question for you.
Yep.
It's an easy one. I can understand if you're creating a database of cost, you've got many projects within AECOM that you can draw from for information. But is there any sharing of information between cost consultants? Do you have any? Are you sharing it amongst yourselves within the industry? Is there a wider sharing?
Well, let's say that when I produce my cost assessments, I try to cover as many facade types as possible on the projects. But sometimes I have to rely on benchmarks. And of course, I talk all the time with many of the people in the room, with cladding contractors, suppliers. It's probably my main task in AECOM to keep this discussion open.
Okay, so you're gathering information from suppliers and from
contractors and suppliers as well. Yes.
Very good. Well, thank you very much. Thank you again, Massimo.
Thank you.
Please give a round of applause. So next we have up a talk from two speakers. We have Ana Araújo, who is a partner at Bureau Happold, and Patrick Campbell, who's a senior partner at Foster & Partners. And they are going to be speaking to us about the Whiteley's renovation in Queensway. Welcome to the stage.
Thank you very much.
So please give a warm round of applause for Ana and Patrick.
Thank you.
Thank you.
Yeah, thank you. Thank you very much. And it's great to be hosted here, so thank you very much for inviting both of us. It's lovely to be here. It's lovely to see so many familiar faces at the event. We are super pleased to be talking about a project that is still live, still going. It's been going for about 10 years, so it's a bit of a labor of love for us and I'm sure for a few others in the event. Today's really to talk about the facade, the heritage fabric, but also how that has had an amazing impact and inspiration on the overall project. We're talking about conservation, adaptation, and the upgrade of the existing facades, which has been a huge technical challenge as well as an architectural challenge, and that's really what we wanted to get into today. A little bit first about the project. Not everyone knows where it is. It is in Queensway, which is a principal road just to the east of Notting Hill, just to the west of Paddington. It's an extraordinary little road that has been kind of lost in plain sight for so many years. It's a 5-minute walk from Paddington. It's a 5-minute walk from a royal palace, but it's kind of lost its mojo, and that's what we're trying to sort of bring back. It was the brainchild of this fantastic man called William Whiteley, who was a northern merchant who came down to London and thought that he would compete with the Selfridges, the Harrods, and all the rest of it. So the story goes that he had £10 in his pocket and he went to this place. He, through a series of mysterious insurance claims on even more mysterious fires, he slowly built up his empire to the extent where he then commissioned Belcher and Yoas, the sort of fine architects of the day, to produce something that was completely out of scale with the neighbouring kind of stucco-fronted Notting Hill squares. And here he wanted to create something that was unthought of in the day, which was retailer's experience. He wanted to create the world's biggest shop. Wow. And he came up with these very flamboyant, very lavish facades, including terraces to take the air. There were places to buy pins and elephants. There were places to see fashion shows. There were all sorts of things. It was a very, very, very elaborate kind of piece of theatre. It's a Grade 2 listed building. It was when we started. It will be when we finish, we hope. And it's made up of some wonderful bits of history, bits of material, some fantastic pieces of sculpture, beautifully made existing windows, existing stonework, a very sort of highly detailed facade that in principle is 4 stories high, 180 meters long in the north-south direction. On the ground and first floor is a Welsh granite, and above that is Portland stone. There are elements of greater ornamentation in the southern cupola and the central clock tower, which we'll talk about. And then there are other elements of really interesting heritage facade. There's a central screen, which we've played around with and relocated to make sure that it's absolutely at the heart of the project moving forward. Also an existing dome, a beautiful thing, and an existing staircase. So a number of kind of key assets that we've put front and center in the project moving forward. It very much lost its soul, its spirit from the high days of William Whiteley. In the 1950s, it started to kind of recede on itself, and the upper floors were converted to office space in a really kind of not particularly sympathetic way. Lots and lots of redevelopment saw the facade being retained in front of some, again, unsympathetic developments to create a very large car park in the middle of London. That's not what cities are all about, what they shouldn't be about. And you can see how it became a very internal and rather dreary place. And it closed before the pandemic, but it certainly wouldn't have survived if it had carried on anyway. So what was the ambition? We had a fantastic, far-sighted client who wanted to see this as the rebirth of Queensway. As I say, it was one of the kind of the last of the park-facing neighborhoods to really kind of fulfill its full potential. So what we wanted to do was to make the facade and the heritage story at the very, very center of the redevelopment. So the idea of 180-meter long, to completely refurbish and restore the facade in a super sensitive way, but obviously lifting the technical performance of all of those elements to the max, thinking about combustibility, thinking about how the supply chain would feed into that. But just to give you a sense of scale, so we've got 180 meters, we've got the 4-story high, and I'm going to try and point to this. Here we go. So 4 stories high, 180 meters in length, an existing cupola to the south, which was then matched with a new, because it was never installed in the first place, at the north, the central dome, and then 3 stories of additional accommodation that was added on top of the heritage facade. When we first started the project, the inside of the building was, as I say, very, very dull, very unloved, to the extent where there was an A board on the pavement saying shopping centre. You know, no one knew that it was there. So what we wanted to do was to think about how we could really cleverly adapt the existing fabric. So we took the central screen, which you can see behind the big W, which we have got rid of finally. That big screen was moved to the northern end of the site and then became the entrance to the new Six Senses Hotel, which is about 110-room sustainable wellness hotel. So that gave a much better sort of setting to the entrance to that hotel, but allowed us to open up the heart of the building to a new pedestrian and public space at the center of the plan. And then this is the new entrance to the hotel. You can see it was once the entrance to the car park, where all sorts of antisocial things went on, and what we wanted to do was to breathe life into that rear street as well. As I say, the facade this isn't a story about the facade and everything new behind. The facade is absolutely at the heart of every design decision we made because it informed the plan form, it informed the grain, the grid of the building, so each inter-column dimension is about 4.5 meters, which is roughly the width of a terrace house in London, just to give you a sense of scale. The windows are 4.5, 6 meters high, so that again told us that that's how the new building had to kind of follow suit. And so to create these wonderful lateral apartments, all with fantastic external space to the rear. And then taking on those wonderful idiosyncratic spaces on the corners or at the tops of the building as well. We wouldn't be here today if it wasn't obviously for the client making that call to buy the building in the first place, but also a huge range of experts in the design team and in the contracting team to really think about how we bring together the 1 million square feet, 100% BIM obviously, but every single room is different because of the way that it has to interface with that heritage facade, and I think that's been an absolute kind of tribute to the kind of attention to detail that we've seen from the entire project team.
Thank you. Thank you, Patrick. So Patrick explained a little bit about the building that was there in the beginning, a bit run down, protected, lots of merit to save as much of the heritage material as possible. So something that we had to define quite in the beginning was what's the strategy for surveys, what unknowns we have at the moment to be able to develop the design and start making the decisions of what this project should be, that we need to start tackling now, and then dividing those surveys almost into stages. What can we do pre-contract to enable the design decisions, what needs to come next. We had this amazing ambition from the client and the architect on what could be achieved of this building, and that's made us have to do very early days a number of surveys that most projects don't have. So just to guide you a little bit through it, I think the first step was a very thorough archive research that Foster's did. We did. Everyone really digged into all sources possible that we could find. And this project was actually quite good in obtaining very relevant information early on. You can see here, for example, let me see if I can point as well. We were able to find a photograph of the day of the opening of the shopping center. So in terms of getting relevant information of what was the original intent, you can immediately see how this is quite valuable. Something that came to our attention immediately was that potentially the white windows that we had seen when we got to site were not the original color. So you start to be the hints of what's there. Also, very good information about the retention that had already happened in the 80s. That from a structural perspective gave us very good information about that facade and probably helping us to focus where we should start opening up and investigating. But also things just as great as this detail from 1908 showing where the embedded steel in the facade was. Not all projects have the benefit of having that, but again, it saved a lot of time and investment in intrusive investigations trying to collate this information. So the archive research in the very beginning was actually very powerful. Obviously, and particularly considering that this was a listed building, but just for its relevance, having informal planning conversations that Foster's led, just really trying to get a sense of what are the elements that really matter, that are really important, that we really need to help protect. It really helps to also guide those design decisions. As part of those conversations, one element that came out was the absolute love that not only us, but the planners as well, had for the heritage windows that were there. The perspective always from a distance of who looks at the building is, it looks about right. And normally 90% of the times when you start to look closer, probably it's not in such a good condition as we expected, or maybe not so much of the original material is there as we expected. So what we discussed with the client, and kudos to the client that was very brave in investing at stage 3 of the design, in a very detailed condition survey that measured, mapped, cataloged all of those windows to help inform those planning conversations and help us understand how much of that original material was there, what type of materials are there, even if we want to replicate. So again, very valuable information. Then obviously the masonry elements of the building, and we're talking not just about mapping up the defects, and this brought very early engagement of contractors that helped with the surveys, Bay in this case, to really help map up all the defects, photograph, because these surveys are always a point in time, and bearing in mind that there was going to be a retention scheme coming along where there was vibration movement happening to that facade. It was very important to catalog what was there before and monitor any alterations. And then obviously start intrusive investigations. We had those clues in the beginning of what might be there in that facade, but we could then open up. In limited locations, the building was still in operation. There was only so much we can do, so we had to be very targeted on the information we were trying to obtain in those early days. But we were able to get a lot of information, not just about condition, location, but start doing some structural assessments of that facade as well. I could go on the list of surveys that were mapped out from the beginning, some that then continued when the contractors were on board. But in these types of projects, we really do need to think laterally. Just thinking, for example, the color of the windows and doing paint analysis through all the layers to try to match what's the role that currently would be best connected with what was the original color of the windows. Just the presence of lead content in the paint that would shift the decisions in terms of doing repairs on site, doing repairs off site. This is all very valuable information that as early as we can have on a project, and in this project we were very lucky to be able to do those early days, really help progress in the right direction. We had to select a few stories. This project could have probably 1,000 stories to tell. It's a huge in scale. We chose Central Dome as one of the stories to tell because probably I'll let Patrick tell a little bit about the intent for it.
Well, if I just jump in for a second, what I think, as Anna was just saying, is that at the heart of this is a fantastic collaboration across the project team, but also with the different stakeholders. In this case with Westminster, but also with the local neighborhood societies, because it's trying to identify what are the most important parts of the heritage story and how faithfully should we look to repurpose them. Obviously, understanding that there are new criteria that we have to kind of work to in terms of health and safety, in terms of combustibility, in terms of thermal performance. And so it's allowed us to kind of be very innovative in terms of how we approach this. In partnership with all of those different players. The Central Dome itself is a beautiful thing. It's a twin-skinned piece. The inner skin was historically polycarbonate, which obviously, for all sorts of fire safety issues, couldn't be retained. But then trying to understand the load-bearing capacity of how we might introduce a new internal skin of glass. So we've been thinking long and hard about how that might be reworked and trying to understand which of the elements of the existing structure we could reuse. And so that's led to a number of different approaches. But at the heart of it is that this needed to remain the focal point of the project. And I think that was the key kind of goal of everyone in the project.
And being lifted to a new position, even in level, new structure supporting it. So just guiding through it, when we started looking at it, we tried to identify what were the main components and how much can we salvage, bearing in mind that this dome would have to be dismantled, taken off site, waiting for the new structure to come in and then be reinstalled. We followed a lot of those processes of surveys that I talked about, but the main elements that we looked at were the main structural steel, the ribs and the purlins, the aluminum framing that was supporting the glazing, and the glass or polycarbonate in the inner dome, and starting to draw what the system was to get records of it. There was a lot done from testing for material identification, measured surveys conducted by the contractor, condition analysis of the components, stress tests and metallurgical analysis to understand the capacity from a structural perspective, and then doing those in-house structural calculations and assessments to see if with the new loads of the project and the new conditions, these materials could be reused. So the outcome of this exercise was that the main structural steel, the ribs and the purlins, could be repaired and reused after being taken off-site, and they had to be very carefully dismantled, catalogued, and so on. The aluminium framing, though, it was in very poor condition and it had insufficient load-bearing capacity, so we couldn't reuse in the new project. And the glass as well, the external glass, the wired glass that was there, single panes, not just was in poor condition and insufficient load capacity, but also from a safety perspective, we wanted to provide something more robust for the new project. So the next step was to help with the selection of a new off-the-shelf patent glazing system that could provide this extra performance that we were looking after. You can see here on the right a photograph of the new system that is now being installed almost complete on site, and just a view of what that dome looks on site, still works in progress, but you can see there in white the structural elements that were able to be reused, and all the rest just replicated and mimicking the original as faithfully as possible. Another story that I would like to tell, because it was so central in all the conversations throughout the years, was the story about the heritage windows. It's part of the identity of the building when you go through Queensway. As I said, when you start looking closely, things don't look as well as they do from the distance. And we did that very detailed condition survey to help inform how much could be kept or not, what materials were there, what sight lines we should be able to respect. But this was the condition. And actually, throughout the years, a lot of the original handles, spanulets, everything had been removed. So there was very little left of those windows. So the exercise we went through is saying what can be salvaged, and how much can be repaired, and how would it look like if it was repaired. And again, we were very lucky to have a client that followed our advice and from early days invested in real scale mock-ups. And again, Patrick gave an indication of the dimension of these windows, 4 meters, 5 meters tall. And it was really putting side by side these options of repairing, putting secondary glazing to give the performance, or finding a solution that could respect the sight lines, could look like the original, and integrate as much of the heritage fabric as possible. You can see here various VMUs that were done through the years, so there was a lot of visits to specialists in repairs of steel windows to see what could be achieved, because we had to make this realistic assessment, what can be achieved by the supply chain. And you can see here what was the final VMU that was assessed by Historic England and Westminster, and with lots of praise, because it really not just meets the sight lines of the original, is a thermally broken steel system with double glazing, but it incorporates the heritage mullions, so this is heritage material that was incorporated. in this image you don't see, but there's a lot of the pieces of the balconies above that were also reused. You'll see in the next photograph. We tried to use as many of the glazing bars that went into the frame. So there's a lot of the original fabric still in those windows. So this is how it looks like today. Going back to that darker color, that was the original intent, and going back to what was the 1908 intention for the building. So a lot of existing fabric, even though it's a system that performs as per current requirements. You can see here a lot of the cast iron, the balconies, the mullions that are part of the 1908 fabric of the building. Final story is just the deconstruction of site storage and reinstatement of the masonry facade features, and that we talk about the entrance screen that Patrick referenced to, the south cupola, the clock tower, the dome, which we knew because of the retention scheme would have to be taken off-site, being dismantled very carefully, and then reinstalled with new detailing and meeting a different type of performance to incorporate in residential and hotel use. So again, early contact with the supply chain to understand what they would need to make this happen was crucial. And I chose some of these photographs because you can see here the very special mason scaffolds that you need to be able to even dismantle some of these features, bearing in mind that there was a retention scheme coming. Being able to advise and understand that actually the retention scheme needs to wait for these scaffolds to go up and down, it has a real impact in terms of program and budget, and really enabling for that is quite important. So there was a lot of detailed survey during the dismantling. Once the scaffold was there, you can see there just a little bit of the work that Pei did in mapping out the different pieces of stone as they were removing layer by layer, using it as a map so that they could rebuild after. Some images of when they were dismantling the central dome as well, the clock tower. The elements being protected and catalogued on site and then taken off-site for storage. They were off-site for years. So even visiting those storage units every now and then just to make sure and give reassurances that all of that material was in good condition. And then the reconstruction, giving new structural elements to support these features, and just rebuilding using all of that information that was catalogued through the years to bring these elements back to life and incorporate them in the new building. I'll pass to you, Patrick, if you want to close off.
I think one last slide. So just to say, we are super close to completion early next year. It's been an absolutely fantastic journey that I've been part of, that we've been part of, that also gives us a great access and a celebration of sort of some of the amazing trade contractors that the industry has in terms of fettlers looking at the bespoke steel windows, or the stonemasons looking at the individual fingers of some of these statues. It's an absolute joy to be part of that process. So, any questions at all?
Thank you.
Thank you very much.
Thank you. Thank you, Anna and Patrick. What a wonderful and fascinating presentation. I had just one question for you. The double dome, do you have any idea why it was constructed originally as a double dome? Do you have any thoughts on how that came to be? It's very unusual.
It's a very good question. When we first started, we asked ourselves many, many times, why did they build that part of the building like that? And sometimes we had answers, and sometimes it was pure speculation. So in terms of the dome, I think there was the piece about trying to access and how that might work. In the original piece, there wasn't an external gantry, there was just an interstitial gantry.
Yes.
So perhaps that was part of the story.
Yeah. Okay, well, it's a fascinating talk. Well, thank you so much. And it's wonderful to see such a fine building restored. And the amount of work that's gone into it is truly amazing. So thank you very much for a wonderful presentation. Please
thank you very much.
Thank our speakers. Well done. Thank you. Thank you. And so up next we have a talk from Rudolf Zelmer, who's coming up onto the stage now. Rudolf is an architect with iRise, and he will be speaking about dynamic liquid crystal glazing to enhance building performance. So Rudolf is making his way up, and he's got some samples as well down here. Rudolf, I'm presuming that we can hand these round, can we?
Yeah.
Okay.
We should have.
All right, Rudolf Zelmer, please welcome Rudolf.
So the presenter is here? Yeah. Yes, hello. My name is Rudolf Zelmer. I'm an architect at iRise Merck, responsible for architecture projects with iRise with switchable glazing. So, what we are building for? As architects, we are mostly building for people, we're building for environment, we're building for human being. So daylight is one of the essential things we want to have in our building. Always, we want to have daylight. Why? When you're going somewhere in a restaurant, where is your seating place you preferred always? It's always near the window. You want to have this daylight. Daylight is beautiful. Daylight gives us some kind of wellness inside. And we love this. Exception, we don't like glare. We don't like too much sun, and we don't like that our building are some kind of overheated. So the heat is a problem, sun glare is a problem. And we mostly don't want to like some kind of shading system that have to be repaired all the years, have to be exchanged, are dirty, are ugly for the architecture on the building, and this is what we can find a solution for with liquid crystal. So, liquid crystal is an integrated solar shading solution for facades with the technology from the company Merck. Merck iRise is in this case the same. So, what is behind who we are? We are Merck, the leading company for liquid crystal technology. And it was founded 1904, so a few years ago. And it was founded, and we are mostly a supplier for Samsung for around 65% of all liquid crystals in display. And this display technology to have a new kind of dynamic windows, we translate it into architecture. And now we have architecture facades with liquid crystal technology on the market since a few years. How does it work? The best explanation is if you see the liquid crystals switching there, the liquid crystals have some molecules, some black molecules with them, and they are switching from some kind of open space to closed space. The liquid crystals, they are absolutely transparent, and the molecules are absolutely black, so very high color trueness, and they can switch dimmable with 256 stages. You don't need all them, but it's dimmable, and you can exactly go with the sun. When there's some small cloudy, it's dimming a little bit, a few percent down or up and down. You can exactly do this in the glass in between two glasses. So on the left, on the right-hand side, here, the pointer, yeah, maybe the other one. So here you see the electronic coating. On the other hand, the electronic coating as well. And you can imagine it's like a compass. The liquid crystals are switching from closed to open in a dimmable state. And these liquid crystals in between these two glasses, this is only around 30% of 1 millimeter. This is the way the liquid crystals are working in two stages. So the next, you can see our standard double glass unit. Mostly it's around in Switzerland we are working with triple glass units, in other areas with double glass units. Outside you have always a cover sheet, a cover glass. It depends on the project. On some projects we need 5, 6, 4, or 10, even 12 millimeters for a cover sheet. Then you have the iris cell, 2 cells with 2 times 4 millimeter glass in between the liquid crystals. So the sun shading systems has to be outside. It's exactly like this here. And then you have a PVB layer for sure. You have the secondary seal, primary seal, spacer, coating, inner pane, middle pane, or the inner pane in a triple glass unit. So this is the technology behind. Yeah, what is right now classical solution for sun shading? The classical solution for sun shading are mechanical shading outside. You always have this shading for sure. It works. You have maintenance, mostly high maintenance when it's a high-rising building, for example, or a very complicated form, and you cannot really enter every stage to maintain this. You block the view. People are inside, sitting in the summer. So we have made this investigation and saw that in summer, for example, people in 30% of the day sitting behind closed blinds. So it blocks the daylight, and it's slow and noisy. So on the next slide, you see what is the advantage on iris on the picture below. The same like shading, but there's no maintenance, absolutely no maintenance. It keeps the view. In a sunny day, you can look outside. Nothing is blocking the view. You have some kind of daylight autonomy, fast and silent, and no peak loads. And you look on the cost. You don't have to look always on the invest only. When you only look on the invest, for sure, it's an expensive solution. But when you're looking on the whole time, for example, 25 or 40 years, it absolutely makes sense when you don't have maintenance. The most costs not only are in investment, a lot of costs are during maintenance the building, clean the building, or replace the sun shading system. That's pretty expensive. So after around between 8 and 10 years, it's much more cheaper to invest a little bit more in a technical dynamic glazing, and it works without noise, without anything. So this is an example on a project we've made in Switzerland, in Vevey, near Geneva, so Geneva again. It's a project with more than nearly 2,000 square meter glass, and for sure, when I'm sitting there, I want to see the mountains all the day, in summer and in winter. And this is what a solution gives you, really a high appreciated sitting there, looking on the mountains, working a little bit, but see the mountains. Yeah, all the time, and not in 30% don't see nothing. I will just go to the slides. Sustainable solution. For sure, when you look on the overall costs on a building, on the overall costs on investment for a building, it's a sustainable solution because building operation is 27%, building construction and so on. So I mentioned this before. When you compare our system, iris, with other glass solutions, you see a double glass has a embedded carbon comparison of around 100 kilogram CO2. Then you have this external blind, and both together you have around 450 kilogram CO2 per square meter. When you look on our solution, even on a double glass solution, here, with our glass, with iris, you have the sun shading inside, you're around 220 kilogram per kilogram CO2 per square meter equivalent. And a triple glass unit on this row is So it's approx 50% lower than normal glass in and classical external shading. Sustainable solution, I will not go to each topic, but you know exactly social, economy, environment. I will also only point out this important topic. Social improves thermal comfort up to 10%. The tenant can have to pay, or the investment can get more money for the rental fees. It improves health and productivity up to 5 years. We have made this a solution for a lot of projects and calculated it exactly. IRAS life cycle. So after production, manufacturing, you see the glass can be absolutely recycled, like similar safety glass. There's nothing else. And you can go with this glass and recycle this again. Yeah, this was the project we have made an opening 2 weeks ago in Switzerland. This is the Google headquarters for in Switzerland, in Zurich. And from Swiss Prime, Urs Baumann, there was a testimony on this. I will not go to each topic, but they were pretty happy to have this glass on site. They don't need anything else than dynamic glass. So SNBC, this is the equivalent like LEED, or in Germany we have DG and B. They had very positive impact on this certification because of our glass and the healthy and well-being inside staying there, and the material resources. You don't need sun shading, you only need this one glass. Yeah, on this topic, 30%, I mentioned already. This means, on this project SMZ, in Müllerstraße, there was a building from the 80s, and the architects really made a lot of effort to recycle every aluminium things, recycle as much as possible, to have a low carbon footprint as much as possible, and there our glass was very helpful for them. This is the situation before, and for sure here after. Really a solution like you wish. Calculating case study, we have made a calculation what kind of mixture in darkness they need, and we helped the customer with this as well. So this is the building from outside. Inside, there was about 3,300 square meter glass, more than 1,000 panels of liquid crystal dynamic glass. And yeah, not only on the facade, we have made a project in Zurich as well for a roof. So to summarize, you have always color neutrality in comparison to other technologies. You have always access to daylight and thermal comfort, and is fast switching and instantly in response like the sun is going. You don't need to be very, that there is cloudy, not cloudy sky. The dynamic glass is exactly going the same way like the cloudy and sunny sky. Yeah, these are the projects, realized projects, some of them summarized here. And what's important right now, and we count this on each big project as well, how many tons CO2 you can save in comparison to your regular glazing you would have. Because you don't have this two kind of sun shading and glass all in one glass. For example, on this SMZ project here, we saved 750 tons CO2 was saved only by choosing the, I would say, the right glass, but the dynamic glass with liquid crystal technology. Yeah, this is a small video from the installation on SMZ. This is the glass package. It was about 68 millimeters with the cover glass, with all the liquid crystal and glass panes inside, a triple glass unit. They were prefabricated in the company Epley, for example, in this construction site. And now the building is ready. Tender is by Google. And you see the glass is not, you don't have any other things beside. You only have this pure architecture with glass and sun shading in one or in few millimeters. Instead of, for example, closed cavity, you need 700, 800, it depends on the system, millimeters. With our glass, you only need 68 millimeters. So it's really a difference in between for a place you can use in another way, not only for facade or whatever. Yes, it's a nice area, and then this, for sure, you need a view you don't want to have in this project or in other projects, really looking on external blinds. Yeah, so I will invite you to see the glass in live. It switches from dark to bright, and it's really dimmable on each stage you need. And exactly this is what the clouds and the sun is doing when it's going down and bright and sunny again. It's exactly like we can do with dynamic glazing. Just try out, and yeah, thank you for your attention.
Well, thank you very much, Rudolf. Thank you for your fascinating talk on liquid crystal. It's an amazing technology, and I know from previous discussions that it can go down to, so the minimum light transmission is going to be about 4%.
Yeah.
If you have it in a double glazed unit, what is your maximum light transmission?
The maximum light transmission in a triple glass unit.
Yes, in a double glazed unit.
Yeah, in a triple glass, for example, you have a maximum light transmission of 45 in the bright state.
Okay.
In the mixture, that's pretty bright.
Yes.
Then we have a dark mixture. The darkest mixture is 34%.
Right.
Switching to 4% or even 3% in some projects we have
all
seen.
the way down to 4%.
Yeah.
So
it's dynamic, and the G value is dynamic as well.
Yes.
We architects have to think a new way of designing a building, because the G value is not a one fix again. The G value is, for example, switching in a triple glass unit between 23 and 7. Dynamic and without steps.
Okay, and it's obviously toughened glass because there's going to be a lot of energy absorbed by the glass itself.
Yeah.
Well, thank you very much indeed for a fascinating presentation. Yeah. Please give a round of applause to Rudolf as he leaves the stage. Thank you.
Thank you.
Okay, and so next we welcome Stephanie Godard, who is the Business Development Manager at Eastman, and Stephanie is going to be talking about a bird protection safety interlayer with SafeFlex FlySafe 3D. And please, welcome Stephanie to the stage. Thank you.
Thank you. Well, thank you, Patrick, and good afternoon, ladies and gentlemen. Let me take you through a subject that we introduced the first time at Zak Manchester last year, and it has been evolving since then. So we'll have a brief introduction to what SafeFlex is and what it brings to the world of facade before going to the main subject, that is the bird-friendly glazing solution. We'll look at what it means in terms of building regulation, including sustainable standard, and also what it means to use SafeFlex FlySafe 3D in glass design before looking at the path forward. So what is SafeFlex? Well, SafeFlex is, for 85 years, the high-performance PVB interlayer that is being used between two panes of glass to keep shattered glass in place. It's been specified in many iconic buildings around the globe by facade engineer and architects for its safety and security feature. but also by glass processors and facade industry that can rely on our expertise and services. Over the last 20 years, continuous innovation has led to add acoustic comfort, solar control, extra UV cut, but also structural performance in order to reduce the glass thicknesses. With our colored interlayer, Vanciva, that we can stack between 2 panes of glass up to 4 layers, we offer more than 17,000 tints, allowing to sign very unique design feature. So now, what about birds and glass? If it works. Oops, sorry. Well, glass is undetectable by birds. Every time there is a reflection of trees, of landscape, or sky in a facade, it's a potential threat for birds. Every time there is open spaces with lights on, or trees behind, this is a potential threat as well for birds. And unfortunately, the number of fatalities are quite impressive and participate in the loss of biodiversity. There are solutions, fortunately, but what should you expect from those solutions? Well, first of all, you should expect that they've been proven, that they've been tested. There is no norms on the market to test the effectiveness of those solutions, but there are scientific protocols by ornithologists to say whether a solution is effective or not. One should also expect, those solutions to have a minimal impact on the human vision, but also to respect the aesthetic of the overall building. And of course, no one in this room would ever specify glass without the best solar and thermal properties, would ever specify a solution that would need to be replaced every so often because it's not durable. And if we can avoid, extra treatment, heat treatment in particular, and thus saving CO2 emission, that is even better. So what are these bird-friendly solutions? We've all seen these bird silhouettes on glasses. You can see them on walls, along the highways. Well, clearly, unfortunately, those silhouettes are not durable. Not only they're not durable, but they're not effective. It's the ornithologists who say that. Then we have silkscreen, acid-etched, UV-treated glass, and they are highly effective solutions. Unfortunately, sometimes to the detriment of light transmission, because the glass coverage is quite high. When it comes to SafeFlex FlySafe 3D, well, like everything we're doing, it's an in-glass solution. It brings also safety and security, so it's a durable solution. And this is a real case scenario there, where you see the reflection of that tree. And this is actually the window of one of my colleagues. And he sees the fatalities of birds going down to 0. So these sequences that are present between the PVB are highly visible obstacles that the birds are safely avoiding. And it's been tested by the American Bird Conservancy and the WUA in Austria. There's only 2 places in the world where you can actually test those solutions. So what we've done, we've mapped all these solutions And we've taken into account the percentage of approaches as tested by the ornithologist on the y-axis, and on the x-axis, we've put the pattern coverage. Well, you see where our SafeFlex FlySafe 3D is laying. So it's in the lower left quadrants, with less than 1% coverage of the glass and less than 10% of approaches considered by the ornithologist as being highly efficient. Well, this mapping is updated on a continuous basis because there's more and more solution being tested. With this slide, I would like to draw your attention, and I mentioned it before, to the fact that both transmission and reflection is important. The WUA in Austria is testing those solutions for both transmission and reflection. That is an important factor. This document here was published in December 2022, so it's a very recent document. There is an even more complete document by Vogelwarte, that's a Swiss organization, that is listed all these solutions and what to do and what not to do. So what in terms of building regulations? Well, our chairman today in this session, when we introduced this subject at Zak Manchester, came to me, to our tabletop, and he said, I'm very interested in birds, personally. I don't know if you remember that, Patrick. And he said, but as a facade engineer, I never had any request for that. Well, fortunately, like sustainability, biodiversity, things are changing in the good direction very quickly. So, in terms of building regulation, in North America, there was already a number of legislation attached to cities most of the time. What we see is more and more of those legislation being adopted. On this side of the ocean, the state of Hesse has also adopted the Nature Conservation Act to prevent the bird to strike onto glass surfaces. When we went to ABS last week, we also learned that such a legislation would be adopted in 2025 in Finland. That is tomorrow, basically. In France, labels such as biodiversity will only be granted because if a bird glazing solution is adopted when needed. Just as a reminder, using SafeFlex FlySafe 3D is eligible to 1 lead point under the pilot credit SSPC 55. So now, what about glass design and SafeFlex FlySafe 3D? Well, I'd like to remind you that because of the low coverage of the glass surface by the sequence, there is no impact on the light transmission and on the solar factor. Also, the glass and the glass supplier can be chosen independently from the bird-friendly solution. That gives some freedom, of course. And moreover, and more important, we carried out a modeling study to map the configuration using the low E coating and the solar coating that would remain effective with the SafeFlex FlySafe 3D. Because of the testing is carried out by the WUA only in a certain period of the year, all the configurations that are available here to you the facade engineer and architect cannot be tested. So we had to find boundaries, where low-E coating and solar coating would be used, with SafeFlex FlySafe 3D without being tested. So we considered the properties, first of all with the low-E coating for double glazing unit and triple glazing unit. For solar coating, we looked at the reflection and the transmission. And we sat with the ornithologist and we established these boundaries. So it also allows, if you have a configuration, to say ahead whether that will work, whether that will actually be effective. So it allows to have no compromise on the thermal and on the solar properties with this SafeFlex FlySafe 3D. The summary of the outcome is this wide range of conventional low-E coating, solar coating that can be used without having to be tested. With that in mind, the first SafeFlex FlySafe 3D that we launched last year was the 9mm sequence. Shiny for the exterior, black on the interior, in order to minimize the disruption to the human vision. And we recently launched the matte silver for the exterior sequence and always black in the interior. We also have smaller sequence, 6mm in diameter, both in shiny and in silver matte, but also for applications such as anti-noise walls or rooftop that are very fashionable these days with a lot of vegetation. We have shiny and shiny on both sides. And we have them on our tabletop if you want to see them live in a laminated glass. I'm not going to go through all the details of this slide, but I would like to point out two things. First of all, like every other interlayer that we are offering, we can go up to 3.2 meter width, allowing, big pieces of glass to be installed. And the surface coverage, for the 6mm sequence is less than 0.5%. And for the 9mm sequence, it's less than 1%. So what about the path forward? So it seems quite clear that we will not go back. And actually, for Patrick's sake, there is a project in the UK at the moment. It's driven by building owners, more and more regulation being in place. And there are continued offer development with the PVB interlayer solutions. So, I would like to end this presentation by our very first project that has been installed in Germany, the Helgers School in Cologne, with very high glasses, 5 meter high. And as a matter of fact, I started my presentation with a view from inside as well. So you could see both from the exterior and the interior. Thank you for your attention.
Thank you, Stephanie. Thank you. Fascinating. And what an amazing statistic that 1 billion birds die annually, 1 billion, from collision with glass. And really, in a world where we're losing species, where we're losing our natural world, literally as we speak, what an important product this could be in the reduction of bird deaths due to impact with glass.
Indeed.
So thank you very much for a fascinating
You're
presentation.
very welcome.
And we look forward to seeing the Helios built. And let's all go and have a look at it, shall we?
Thank you.
Okay.
Thank you very much.
Thank you. Thanks, Stephanie. Please. So lastly, we have a panel discussion. And the discussion will be on 21 Moorfields, building on air. And I'm sure that the team are going to explain what that's all about. So they'll be looking at the design challenges and concept, structural solutions, glazing and envelope at this particular project, along with the construction strategy. Our moderator this afternoon for the panel discussion is Giles Martin, who is a director at Wilkinson Eyre. So Giles, please come up and introduce your team. Please give a round of applause for Giles and say thank you very much.
Well, I'll make a start. Shane will make his presence very well felt as he's 6'7" with size 15 shoes. You'll see him in a minute. Well, when Zak asked us to do this talk, they suggested doing it as a panel discussion. Although we're going to do it, there's actually 4 different perspectives of looking at the same challenge. And we're all members of the design team, and rather than introduce them now, I'll introduce them one at a time. And when we got together to discuss it, we agreed this is the most difficult bloody job we've ever done in our lives, and we've taken the theme of challenges to take you through the project. I'm Giles Martin. I'm a design director for Wilkinson Eyre. I have led the project for 11 years. Wilkinson Eyre do a lot of long-span structures, bridges, stations, arenas, and although this is ostensibly an office building, it is in fact a bridge over a station, so it's very suited to our core skills. Here's a view of the building from the northwest. It's in a ridge of tall buildings between 2 conservation areas, Finsbury Circus and the Barbican, and it's very constrained by how high and where it can build. The diagonal cut is a St. Paul's view, which you'll see later in a minute. Here's the same view just after the Second World War. The station, highlighted in blue, of course, was a cut-and-cover, just subsurface station with canopies, people coming down from Moorgate to the north. This is a view you might recognize if you ever used the station. And they built a oversight development integrally with building the station, which is quite unusual for the 60s. So the columns in the center of the platform and the structure of your head is in fact part of the oversight development. And here it is when we took it on. Well, actually Crossrail knocked a big chunk of it down, but it's a very unflexible building. You used to follow courtyards, a yellow line through courtyards to get to the Barbican to the west. And it's been empty, it stood empty for 15 years, really due to the fact that it wasn't working as it should. That all changed when Crossrail came along. Crossrail, Liverpool Street is also by Wilkinson Eyre. The trains are so long that the Moorgate station, the Moorgate end has its own ticket office. And so suddenly Moorgate had become highly valuable. And it very nearly looked like this, where just a single-story building standing in this highly valuable part of the city, which had been a real waste of some very highly valuable real estate. Crossrail had the idea, or the foresight, to have us look at where we could thread structure through, and Chris will take us through a bit about that, and to allow us to build a taller building over the top. And aren't we glad they did? You can see the same building at the bottom, but that V-shaped column there is supporting 1,000 highly paid bankers. And by allowing access on top of the station, it created a 3-dimensional world where the pedestrianised street at the front, and then public space in the middle, and the building upstairs for the tenant. And by good fortune, this is an area of town where that is a highly relevant action, because the city works, this part of the city works at first floor podium. and the bridges crossing the roads, walkways crossing buildings, and all focused on the Barbican Arts Centre to the west. But the constraints at ground and first are completely blown away by the constraints below ground. There's 3 tube stations and several sidings running straight under the building. This is an image of the urban plan with the roof cut off, and we're looking down at the station. We're only able to put our piles down in the 2 pink areas to the top and bottom of that plan. Everywhere else is constrained by live rail. And if you break the circle line, it costs £1 million a day. So we were very careful. The constraints above ground I've described in a bit, but obviously we took the site and extruded it as high as we could and then cut away to end up form-finding, rights to light to the Barbican, etc. All those models standing on our car park are different forms that actually you can see fill the same envelope. The most restrictive of these is a view of St. Paul's, where we're standing just behind the dome, Sod's Law, and a valley of a cut goes right through our building, so that from Westminster Pier, St. Paul's can still be seen in clear blue sky. And then a tenant came along, and actually all these decisions had led to a very fixed form, but it suited them very well. I mean, big dealer floors along the bottom, the size of football fields, all their public and open space in the middle. A little square to the south separates their wellness centre from the main building, and then stepping forms for all their different workplace environments and client-facing areas give different west-facing roof gardens looking out across the city skyline. And it's just about finished. The public spaces are looking quite extraordinary. They'll be open in January, and you'll be able to go and use them. This unusual square, tripod square, above the main station and below the bank. You saw it from the front. The walkways have this artwork drawing people along it. Bridges, stairs, gardens, and a little square designed by Andy Sturgeon. Well, when we put it all together, we're very lucky we had the very talented Robert Bird group, and you can see each grid line created a truss that was a different design to deal with the constraints of the space overhead and the location of the piles below. I have Chris Papanastasio here, director of Robert Bird Group. Chris has worked with me on 21 Moorfields for half his career, rising to be project director and last man standing. Chris's collaborative and inventive approach to engineering has driven the project forward and enhanced the design. Chris.
Thanks very much, Charles. So today I'm going to do a quick whip through of some of the structural challenges that we had to create a 100,000-ton building on top of a live underground station. So as Giles pointed out earlier, we have significant underground constraints within Moorgate Station. The presence of live running tracks, platforms, existing services, and existing foundations meant that we couldn't really put any foundations in the centre span of the station. This essentially meant that we had back-of-house areas to the north and south where we could negotiate pile locations. These were around 40 to 60 metres apart, or roughly the wingspan of a Boeing 737. The image on screen shows the 15 piles that we're using to support that building and the Crossrail super pier built within Crossrail station. These piles are 1.8 and 2.5 metre diameter. They are 70 metres long, and they're the highest capacity piles asterisked in London, last time I checked. So once we knew how to create the capacity to build this building, we needed to understand how to build it. So going back to 2013, when the project was first looked at as a viability study with Landsec, we have a sketch there of a very simple piling grillage sat on top of Moorgate Station roof and the biggest piling rig in the UK rumbling around on top. Effectively, the scheme looks a little bit different now, but we installed piles directly from the Moorgate Station roof. We put steel sleeves inside the station and spent 3 to 4 days constructing each pile. We needed a 3-day continuous pile test to prove their capacity, and this was all done without anyone really knowing within the station what was going on. Moving on to the superstructure. The superstructure is effectively a 17,000-ton steel frame spanning the width of a full-size football pitch. That's approximately 2.5 times the weight of the Eiffel Tower. As well as above and below ground constraints, we had significant logistical constraints for this site. We had a maximum crane lift of 16 tons, and we had a maximum delivery length of 16 meters due to local roads. This placed significant constraints on the structural solutions that we could adopt for the frame. So in order to transfer that span, 60 meters or so, we needed to look at various transfer systems, and we started off looking at kind of traditional truss systems, low-level truss systems. Due to the scale of the building, these were becoming extremely heavy, and they would have fouled the spaces at the lower levels of the building, really kind of ruining the architecture and not leaving much to coordinate plant and etc. in those spaces. We looked at taller arch systems. Now, these are great materially, but they require a lot of temporary works to build them. You need to support them on something until you've connected the arch, and we had a station with not very much load capacity on the roof. So the structural solution that we adopted harnessed the best of both of those systems. We incorporated permanent temporary launching trusses within the building, and we worked with Giles and the team to locate them and coordinate them. These trusses were lightweight and were only used to build the essential structure required to build up to the top of the arch. Once we were at the top of the arch and we connected the arches, we were able to run, or let the contractor run, with the rest of the steel frame, the concrete, the facade, the MEP fit out. The early stages of the construction were essentially a race to the top of the arch. On the east side of the site, we have another very complex system where we need to cantilever out the building 25 meters over the crossrail box. The initial concepts for this east face truss were flawed in their number of bays and their structural efficiency, but we developed this concept of expressing structural load paths within the architecture. And through coordination with Giles and the team, we added the tripod that Giles mentioned earlier. Now, this tripod not only created the right number of bays to have a symmetrical system, but it also added stability to the structure and celebrated the support that we're gaining from the crossrail station. The final east face truss sits in front of the glazing line and is a celebration of the architecture and engineering that's gone into this building. That celebration continues internally with 25-meter spanning trusses supporting the Finsbury sightline setback. You walk past the tripod as you enter the building, and you walk through the launching trusses as you circulate in the lower levels of the building. You can see how the building was built above the station. And as you rise through the scenic lifts, you start seeing the arches appear on the floor plates, and you start seeing the bracing of the arches in the atrium. We worked and collaborated heavily with Giles and his team, but also with the steel fabricator on these systems. It was a really fantastic experience. And lastly, before I hand to David, we talk about movement. So the east building is essentially a floating building on top of cantilevering piles. It sways around 40 millimeters during a wind event and deflects up to 100 mil in full occupancy. The Moorgate station roof below is relatively rigid, and that supports all of the plant systems and all of the west buildings shown there in blue. All of the fire compartments, the MEP, the facades needed to accommodate these differential movements, particularly challenging for fire compartments. We developed a construction stage model to look at detailed movements pre-construction. We took information from monitoring points on site and fed it back into our construction model so we could feed back to facade contractors tolerances for fit-up. And lastly, the east facade is exposed thermally to the sun's heat and the cold. It expands and contracts up to about 40 millimeters. This was another complexity that David and his team needed to deal with in the facades.
Thank you, Chris. My next speaker is David Perez, Senior Envelope Design Manager at BAM Construction. David led the facade with me while at Wilkinson Air. for 5 years, from concept through procurement to construction. And when he felt it was a stage he thought we could manage without him, he took his dream job as head of facades for BAM. David.
Thank you. I think after having heard the presentations by Giles and Chris, it's probably clear by now that 21 Moorfields is not a standard type of building. It's above a non-standard type of site and definitely has a non-standard type of structure. And I believe that understanding the nature of that structure is probably key to understanding the nature of the facade design and its complexity. So we go back to the color-coded diagram that Chris was talking about before, showing how the building moves in its different parts. I think this diagram probably is also useful to show how the facades in the building can be grouped. So we would have a first and predominant group of facades associated to the main building in red that moves, as Chris mentioned before, in all directions quite a bit. Then we'd have a second group of facades associated to the static structure at the base, the podium in blue. And then in between we'd have an interface facade that is meant to manage the movements of the building above. So I'll first talk about the first group of facades associated to the main building. This is mainly a group of curtain walls, generally in glass, but also in aluminium, with an aspiration for clarity, transparency, and lightness. And basically, they are the core of the main building. And I'll speak about 3 specific facades within this group. First, the east face truss, this east face truss facade, the main facade behind the truss that Giles and Chris had described before. In this facade, the truss and the facade act as one combined element. They dominate the east elevation, and they share a common design and performance. So on the one hand, we have the truss, which is acting as an active solar protection device for the facade, and on the other hand, the facade itself is engaged in all the movements related to deflection and thermal expansion of the external steel elements. One of the biggest challenges of this facade was its installation. So we have 250 mil deep glazed panels, sometimes 5 meters by 3, that had to be introduced in a 300 mil gap, basically 50 mil of wiggle room between the truss and the slabs, and slotted down through that gap from level 11 all the way down to their position, and manipulated from the outside through the openings in the truss. Every structural penetration includes thermal breaks to ameliorate the potential thermal breach. And the external face of the connection is concealed laterally by 2 continuous stainless steel closures with the purpose of visually detaching the truss from the glazing. In a way, the truss appears as it is floating in front of the glass of the facade. This dialogue between facade and structure was adopted as the narrative that drove the design of the facades across the whole building. The second facade in this first group is the crown facade, which is set above the one I just described, set back and inclined both in plan and section. It's actually a combination of 2 facades that have to look like one. This is mainly because the facade spans across 2 very different types of floors. Below we have the executive office spaces, the most exclusive office space in the building. All the CEOs will have wonderful views of the City of London. These floors include a closed cavity facade to improve the efficiency of the floor space. And above these floors, we have double height, massive mechanical plant rooms, single glazing and open to the sky above. So one way we used to kind of achieve that consistency, that visual consistency across the levels, was including an Antilio reflective coating on the outer pane of the glass of both facade types to increase the reflectivity of the glass without completely obscuring the transparency. Through samples and mock-up test units in Gardner's facilities in Germany, we finally reached the kind of fine-tuned balance between transparency and reflection. And this is an image showing the final result on the building, where you can see also how the facade had to deal with two different sort of interfaces. Internally, it had to deal with a 1.5 meter planning grid, and the partitions of those offices could reach any one of those points, whereas externally, the facade had to respond to the 3 meter module of the predominant in the external facade. To do this, we introduced an additional mullion inside the CCF panel. And you can also see in this image the vertical recesses in stainless steel reflecting the internal structure, again, kind of creating that dialogue between structure and facade. And on the right, we can see an image of both facades above each other, forming the dominating east elevation seen from Finsbury Circus. And the third and final facade of this group is the west facade, where the rules of dialogue between facade and structure are somewhat inverted. Instead of having a projecting clear structure to the outside of the building, here the geometry of the diagrid is recessed into the facade with a metallic feature, with darker colors to relate to the palette that you find on the Barbican across the road. And in between east and west, the building's geometry has to accommodate all those constraints that Giles was talking about before. And as a result, we end up with a very complex set of interlocking volumes, inclined facades, faceted roof lights, internal glazed atria, and terracing levels that scale the building down towards Barbican. Second group is the podium cladding, which is considered as a heavy base to the building, anchoring the building to the ground. Here, the materials used are dense and heavy to provide the podium with its density and weight. And we find stones for floors and walls, metal panels and GRC for soffits, metal louvers, and most importantly, a whole set of very large precast panels that cover 3 elevations of the podium. Emerging from the west end of the podium, we find the amenities building, which includes these perforated metal skin that shows a sequence of diagonal folds which relate back to the geometry of the diagrid on the west building, and the west facade of the east building, again giving a hint of that dialogue between facade and structure once again. And the third and final group is what I've nicknamed pivoting facades, mainly because these facades are meant to, among other things, accommodate the movements of the building above, and they do that through their pivoting action. The zigzag layout of the facade and the fins behind stabilize the facade and provide restraint to the lateral loads. The bottom brackets allow a sway of the facade at the top of up to 40 mil in every direction, and the top brackets allow for a vertical movement of 100 millimeters or so. And the image on the left shows just how difficult and what a challenge it was to install these enormous panels in place with what I hear is the only manipulator in the country that can do that. And here's an image of the facade installed in the building, very recent image. And here a more holistic view of an example of one of each of those 3 families that I've just described above each other, working as a system. Oops, that wasn't me.
Oh, sorry, probably me.
Yeah, so yeah, the 3 facades above each other forming a system.
Thank you, David. Can you move the slide on one, please? Our final speaker is Shane Ensel, Project Director for Construction for 21 Moorfields at Landsec. Originally from Brisbane, Shane has worked his way across Asia, building several skyscrapers and arriving in London 29 years ago, and working on the Shard and the Scalpel. He's led 21 Moorfields since we moved into construction, overseeing it from the piles to the completion. When I met Shane 5 years ago, he told me he was a bulldozer and he just kept moving forward until the job is done. How's that going for you, Shane?
Thank you, Giles. It's 22 years I've been here, not 29,
Sorry.
But that's fine. I started on this in 2017. One of the 2 project directors for Landsec who have gone through the whole build cycle on this. This is definitely the most complicated thing I've done anywhere. You've heard about some London projects, but I've done the Olympics and the Commonwealth Games as well, so nothing comes anywhere near this, particularly as a commercial office block. The demolition of the original buildings was pretty simple. It was just a traditional masonry building knocked down. All we had to do was make sure we didn't tip anything down into the station or put too much dust in there. The next picture just beside it just shows you the scale of the piling deck and everything we put on. The biggest challenge to this whole project really was the creating the openings through the retained deck into the station. So this is some photos down below. You'll see there's pipes and wires and cables running everywhere. TfL generally don't know where they start, where they finish, or what they do. Also, we uncovered a lot of other problems. There's multiple train stations in here. Bits of equipment have been placed all over these areas for different train lines without anyone knowing. So when we tried to track and trace everything to take this stuff out of the way, it was an absolute nightmare. TfL is basically a big cumbersome beast that moves at glacial speed. I'm sure some of you in here have dealt with them. It doesn't sit very well with us. We were quite lucky we didn't end up with a very good person at TfL and a very good TfL contractor, Dewald. We managed to get the services cleared 17 minutes before 8 o'clock on the last day, before there was an automatic extension of time for Mace digging the piles. It's been an absolute joy dealing with them, and to this day I'm still trying to close out with them. So, yeah, TfL, there you go. Procurement's always been the main driver for this project. What we decided to do is we thought we'd do something different. We decided we'd go into PCSAs with these 4 main contractors, and we'd take the design through and try and get ourselves to a fixed price lump sum and an agreed program before the piling finished, which is when we were going to go to the market and get ourselves our main builder. The big upside of this is we kept control of the process, and we managed to design, procure, fabricate, and deliver the steel to site 1 week after we agreed the main contract sum. Yeah, so this just shows you how massive it is. That's just one piece. The site itself is very, very constrained. We have built up to the boundary on all sides, maximised out this as much as we could. It became very challenging for McAlpines to actually provide site establishment for the guys on site. We capped out at about 1,000 guys per day. So the accommodation was moved around the building as it progressed and then off-site. So, COVID hit us pretty badly. At the time we were in the middle of doing the steel structure. The guidance that came out, as you're probably all well aware, was social distancing. One person had to do a job on their own. So basically we were bolting up structures. It delayed us for 3 months, and we had no chance to get that back. The other thing at the time was Brexit. We did do a lot of pre-planning on Brexit with the supply chain. To be honest, it didn't really affect us. We had contingency plans for storage of materials in the UK, but we had virtually no real delays on the job from that point of view. So I just want to leave a couple of parting thoughts for people being a property developer, but this building I think will be here for 120 years. It's been absolutely maxed out on the site. I don't know who would ever try and pull it down. And if you did try to pull it down, I don't know who would have the appetite to spend years negotiating with TfL to try and actually do it. And anyone who wants to try, good luck. Thank you.
Thank you.
Thank you very much, team. So thank you very much for your presentations. Giles, that's been fascinating, and it's obviously been a massive and an amazing project. And thank you very much for your presentations, all 4 of you. We are soon going to be taking a break, but could I just first of all thank all of our speakers. So please, another round of applause for all of our speakers this afternoon. And I'd like to just introduce, so we are going to have a break, and the break will be, it's a 30-minute break, so you will have a 30-minute break.
Good afternoon, everybody. My name's Aideen Lee. I am Facade Technical Lead at Multiplex, and I'm delighted to be hosting this track session this afternoon. We do have a really jam-packed session, so I would ask all of our speakers if they could keep to time. The bell will be there to remind you if you are running over, and if you could stay behind at the end for the presentation afterwards, that'd be great. So first up, we have Daniel Lobitz. Daniel's partner at Robert A.M. Stern Architects, and he's going to talk to us about the exceptional One Mayfair project. And the presentation is Embracing Context, Craftsmanship and Efficiency. Daniel, if you'd like to come up.
Thank you, Aideen, and hello, everyone. As Aideen said, I'm Dan Lobitz, partner at Ramsay, Robert A.M. Stern Architects in New York. And today I'm going to talk to you about One Mayfair, which is a new, as Aideen said, a new luxury residential building currently under construction. Very near here, if there were a window in the room, you could probably see it from the window, in the heart of Mayfair. We at Ramsay are based in New York, but we've built top-level residential buildings around the world and have broken price records wherever we work. Among them are 15 Central Park West, 220 Central Park South, 70 Vestry Street, our Four Seasons downtown 30 Park Place, which you can see here in the center, is the tallest multi-family residential building in downtown Manhattan. One Mayfair is our first project in London, and we're very excited to be building something of this magnitude and quality here in this great city. Our building encompasses about 30,000 square meters of space distributed over 9 above-grade levels and 5 below-grade levels. We have 29 very luxurious residential units and significant amenity spaces. And the project is being developed by John Caldwell, who has a vision to create a legacy building that, a legacy building that will make a significant contribution to the architectural heritage of Mayfair. The Caldwell team interviewed over 30 architects for the job and chose Ramsay partly for the financial success of our projects, but especially for our proven track record designing buildings that grow out of their specific context and place. We're working very closely with our wonderful London team, including the outstanding EPR architects, Arab Structural, Arab Facades, Horley Mechanical. The primary contractor is Mace, and EDM is the facade contractor, and many of our colleagues are here today, I'm very happy to say. Our site, as I said, is just a few blocks away from here in a block bounded by South Audley Street, Hill Street, and Waverton Place. And you can see it right there. Our site was occupied for many years by an unappealing 1950s car park, a compromised Georgian house, a hotel, and a filling station. John Caldwell bought the site about 15 years ago with approvals in place for a Foster and Partners designed residential scheme. This scheme did not align with John Caldwell's vision for a building that would tie into and carry forward the great 400-year tradition of classical Mayfair residential architecture. Ramsay was hired in 2011, and we worked for 3 years with Caldwell, the City of Westminster, and our outstanding London team to design and secure approvals for the scheme you see here on the screen. And 10 years later, and after much blood, sweat, and tears, this concept is still the basis for the building that is currently under construction. Our goal from the beginning has been to create a true Mayfair building with a true Mayfair facade. We studied the neighborhood context very closely, and you can see here in this diagram on the left that it's largely a masonry neighborhood, and most buildings are either brick, usually in red or brown tones, or stucco, or stone, usually in warm light tones. We were very interested in tying into this sophisticated palette. On the right, in shades of blue, you can see the numerous historic listed buildings surrounding our site, and we felt a great responsibility to enter into a meaningful architectural conversation with these venerable neighbors. 4 centuries ago, Mayfair was occupied by 7 great estates. As these estates were subsequently subdivided and developed, their classical Georgian expression was carried forward and transformed to accommodate ever denser and taller development, culminating in neo-Georgian apartment houses in the first half of the 20th century. The elements of these larger, classically derived Mayfair buildings are quite consistent, and here on the screen are 3 nice examples. Each has a clearly defined base with an appealing level of detail and craft to create interest at the pedestrian level. Each has a comparatively expansive and repetitive midsection, often punctuated with elegant mid-scale elements like stacked bay windows and balconies to create an intermediate scale when seen from further away. And finally, each has a beautifully sculpted roof or crown with dormers, chimneys, pediments to create a distinctive and memorable silhouette against the sky. And then, of course, Mayfair boasts a wealth of characteristic, classically inspired details to study, to emulate, to adapt. So our next step was to turn what we learned from our study into a compelling architectural concept. This is a perspective and plan of the existing site. You can see the former car park in gray here in elevation, in perspective, and in plan. And you can see the wide, empty, paved area in front of our site. Our design strategy was to create Audley Square, a new public square for Mayfair, and to define it with a formal composition of buildings in the Mayfair tradition. So we started with a square symmetrical pavilion as a central focus for the square. This also is the location of our front door. And then we created a vertical pavilion flanking the left side of the square that mimics the massing of the historic University Women's Club on the right side of the square. Oh, I'm sorry. That's the University Women's Club. That's our flanking wing. These two pavilions together serve as bookends that flank the square. And then finally, we fill in the remaining portion of the site with a hyphen on the left of our central pavilion that matches the listed townhouse on the right side of our central pavilion. So our new building here in yellow on the left works in concert with the historic buildings on the right side of the square to create a formal symmetrical composition defining 3 sides of the space. And then we introduced new planting and streetscape to complement the building and also to create an elegant and inviting Audley Square, a new public space for Mayfair. So with the massing in place, the next step was to design elevations that integrate with and enhance the existing neighborhood to create a building that fits in and at the same time makes its own statement. And careful analysis showed that the adjacent buildings utilized the golden section to devise their proportions, so we did the same for our building. In designing the building, we began with hand-drawn concept sketches, as you can see on the left, and then developed the details digitally, ultimately proceeding to a Revit model and construction documents, and then final professional renderings. And it was very important to us from the beginning to create a building that was highly energy efficient and sustainable. Our design aligns with the London plan's Be Lean, Be Clean, and Be Green hierarchy. We've incorporated passive measures including recessed windows to protect against solar gains and a fabric-first approach to reduce energy demands and carbon emissions levels. We also incorporate greywater and rainwater harvesting, external planting to increase biodiversity, and a managed refuse strategy to ensure proper recycling. In addition, 95% of our construction materials are sourced in the UK, which keeps embodied energy figures to a minimum. My personal favorite, though, are the bat boxes on the roof to control those pesky mosquitoes in a natural way. A gas-combined heat and power system will generate electricity locally whilst generating heat for domestic hot water and tempering fresh air. A reversible and efficient ground source heat pump system will provide space heating and cooling and also heat our multiple swimming pools. In addition to openable windows, dwellings are being fitted with state-of-the-art mechanical ventilation systems with heat recovery. Fresh air will be supplied through beautifully crafted openings in the stonework and be preheated by the stale air being extracted by the system. A south-facing courtyard garden oasis with biodiverse planting is an important part of our strategy that prevents overheating in hot summer months while permitting beneficial solar gains in winter. This lush garden courtyard allows us to create dual-aspect units to provide cross-ventilation in every apartment. And now I'll share some details about the design of our facade. This exploded image by Arab Facades describes the many layers of our facade assembly with stone cladding, a proprietary lateral restraint system, double-glazed timber sash windows, and multiple layers of membrane, insulation, and cementitious board. And here's a detail of our facade facing Hill Street. The main elements are Portland stone cladding laid up the traditional way with a granite water table and operable timber sash windows and a zinc pitched roof. Metalwork details are a combination of bronze, brass, and wrought iron. So first let's take a look at our stone cladding. Here on the left is a cross-section detailing the facade buildup, and then on the right you can see the relationship of the facade in blue to the poured-in-place concrete structure in pink. And most great cities of the world historically have been built using their local stones. Nobody likes to drag those heavy stones too far. In Paris, it's the beautiful golden limestone from the shallow open quarries of Burgundy. In New York, stately gray Indiana limestone sets the tone. Here in London, there are many buildings clad in rich yellow bathstone, but arguably the dignified warm gray limestone from the Isle of Portland has been the building block for buildings of significance in London since Christopher Wren first used it to rebuild St. Paul's Cathedral in the 17th century. The Isle of Portland is located just off the southern coast of England, a few hours from London by car or train. We made a number of visits to the quarries to study the various options and narrow down our selections. The quarries prepared samples and mock-up panels for our review, and we carefully studied the various alternatives. Much attention was given to establishing acceptable ranges of irregularities and inclusions. Portland stone is a sedimentary stone, and depending on depth in the quarry, the stones vary significantly from quite smooth to quite shelly. The stone was to be fabricated at the quarries in a series of old-fashioned metal templates, as you can see here in the center, were developed to achieve our varied profiles. So this diagram shows how our various selections were distributed on one section of the facade. We specified a range of 5 different stones across the building from 2 quarries to achieve subtle variety and also to ensure adequate production of the significant quantities required to meet our schedule and needs. Coursing design is a key issue on any stone building, and our goal throughout is to maintain symmetries and achieve a pleasing composition while also achieving a consistent block size. Effective strategies for turning outside corners can be particularly challenging. One Mayfair incorporates numerous special details, and here you can see a signature column capital from hand sketch to 3D digital drawing to professional rendering. This piece will be carved using computer-driven CNC machinery. Stones are being fabricated from block to slab to individual piece on location at 2 separate quarries, and each section is dry laid before shipping to verify accuracy and harmony of range. And now a few words about our operable timber sash windows and French doors. Overall, One Mayfair has 646 external windows and doors, of which 88 are curved on plan, 6 are curved on plan and elevation, and 385 are box sash windows traditionally hung on cords and weights. So we start the process once again with precedent research and initial hand sketches. Then we move on to physical study models and ultimately a full-scale mock-up, which you can see on the right, to understand scale and openness to views, which of course is very important in a luxurious residential building. And then, of course, technical drawings and coordination with the manufacturer. Our windows are being fabricated by Mumford & Wood, a UK manufacturer based in Tiptree, England. Timber used is a mixture of redwood, red grandis, and sapele mahogany. And this is an example of one of our bay windows. All the windows are double glazed and include laminated panes with acoustic interlayers. The cavities are filled with krypton gas to meet thermal requirements. In order to study and refine the relationships of all of the elements of the facade, we built full-scale mock-ups. In the foreground is the dry lay of a larger section of the facade. The windows are mounted on stainless steel tube noise mitigation brackets and pads. Here on the left, you can see the complete facade assembly, including the stone fresh air vent and ironmongery. The typical window is quite substantial, weighing in at 300 kilos. Our client Stephanie in the middle photo, posing as a nosy neighbor, gives you a sense of the scale. On the right is a photo of our outstanding team. And now a quick look at additional details. Our typical railings at balconies and roof terraces are black iron with bronze and brass handrails and accents. That's my cross-section sketch of a decorative bronze rosette on the left. A signature element of our exterior lighting is a family of custom bronze and brass LED lanterns with mouse-blown glazing. That's a prototype on the right. Our sidewalks throughout are lined with wrought iron light well rails with integral lanterns, a feature typical of the neighborhood. And now for some construction progress. As I said, One Mayfair has 5 below-grade levels, and it's being built with a top-down, bottom-up construction. The poured concrete above-grade structure seen here in the center of these photos from a few months ago has just been topped out. And in these more recent photos, you can see one of the 2 structural cores rising and also the lower levels being filled in. The Portland stone for the balconies and bays is fastened onto precast panels off-site and then lifted into place and mounted and then grouted on-site. And here's progress on some special windows, a bay opening out to a roof terrace, a double-height lobby, and French doors with an arched transom. And here are typical windows being installed in Zone 1. You can also see stud work and the innermost layer of eye candy. These professional renderings were created by V1 and should give you a good idea of the final building. Here's the twilight view of Waverton Street with a welcoming glow in the private motor court entrance. Here along Hill Street are entrances to maisonette townhouses, which extend the wonderful single-family texture from the surrounding neighborhood. I encourage you all to take a walk over there and look at the progress. It's just a few blocks to the north. And finally, this is the new Audley Square and our new #1 Mayfair with our front door right in the center. Maisonette townhouses flank on both sides. So thank you for joining me today to learn about 1 Mayfair. I've really enjoyed sharing our project with you. Thank you.
Thank you, Dan. I think that really shows, obviously, the challenges around sustainability that you've been dealing with throughout the project, while also maintaining the historic aspect of the build. And I think it's really credible that the 95% of building materials were UK sourced for that facade. So that's an incredible story. And thank you for your presentation today.
Thank you.
Thank you. Next up, we have Ben Isaac, Tony Cinnamon and Daniel Lemieux, I'm hoping I'm saying that correctly, from Weiss, Yanni and Elsner Associates. What we're looking at in this presentation is the challenges around change of use, office to resi, which really ties in with obviously our main topics today around reuse of structures. Please.
Thank you. Thank you and welcome. And it's certainly a pleasure to be here. It's a privilege for us to present here. This is our first time here in London at Zak. We did present in Washington, D.C., which is where I'm based, and Ahmed was kind enough to ask us to come and present on the same topic here, so it's a pleasure to be here. I'm joined by Tony Cinnamon. He's in our Chicago office. We're actually based outside of Chicago. And Ben Isaacs, who's in our London office over in Aldersgate. So we're going to talk about a couple of case studies. Ben has the unique challenge of talking about one of our office to resi case studies in East Croydon. It's a bit of a what-if scenario. It's an office refurb, but it's also a property that really, really lends itself well to office to resi. So it's a good opportunity for us to talk about built assets and when they make the most sense for this kind of conversion. So real quick, we'll take a quick step back into the U.S. Most of our major cities are facing a housing crisis like you are here in the UK and in London in particular. We have a lot of open office space in the U.S. in our major cities. We had a great presentation on Paddington earlier, just before lunch, and there was some discussion about Paddington as a transportation hub to attract office to resi, or at least residential conversion, or just new build residential. What our federal government has done and the Biden administration is start to free up through our Department of Transportation funding for this kind of conversion. So the idea is we look at transportation hubs in the US, and that's where we want to push some of the funding and try and encourage some of this. So this is federal top-down support for this kind of conversion in addition to the tax incentives and the things that we see in most of our major cities. One point on that last slide also, we obviously have an election coming up, so anything goes really in terms of where that's going to go with the Biden administration. So here in the UK, you're a bit ahead of us. About a decade ago, we had an opportunity here, or at least the development community was presented with an opportunity to relax some of the affordable housing rights by relaxing the PDR requirements. And if you had an Article 4 direction in the boroughs, there was an opportunity there to push back. And again, Ben will talk a little bit about the project in East Croydon. East Croydon does not have an Article 4 direction, but is encouraging office to resi conversion. So the market opportunity, as you would expect, the developers were quite intrigued by this. This is something that Savills put together. The key here is, regardless of the cultural challenges that we have with our housing crisis, it has to make sense to a developer, right? The numbers have to add up. So depending on where you are in the UK, depending on where you are in the US, when you look at lease rates for this kind of conversion, it has to make sense to them. In London, most of these markets, it would be a challenge, right? So this is something, obviously, in East Croydon. East Croydon is an area that is ripe for this kind of conversion. But the numbers may not work, and we'll talk a little bit more about that. So questions will be asked, right? And most of you are aware of this. Now that we're 10 years on into this process, we had developers that, by some opinions anyway, that they took advantage of this a little bit, right? So we have We have office to resi conversion with no increase in affordable housing. A lot of concern there, a lot of outcry. So we're in the US, we're looking at this. We want to learn from some of the lessons that you've experienced here in the UK and see if we can apply them in the US. So how do we find the sweet spot? So this is something Gensler put together. This is a bit of a scorecard, if you will, and when it makes the most sense. We're going to focus on the envelope, and what we want to talk about with some of the case studies is the percentage that you see here. So our experience in the US and our early experience here in the UK is that 10% figure for the envelope and the facades is more like 20 to 25%. And that can be a deal breaker. And I see some head nodding, so some agreement here. So I think that's an ambitious figure. It's not really been our experience. And as again, and through the case studies, you'll see that really, really can be a deal breaker in what we're trying to do. So we're trying to solve very important cultural challenges, housing crises. We're trying to respond to COVID and what's happened to our office space, downsizing, and at the same time, try to make this attractive and make it make sense for a developer. So pivoting to East Croydon, and I'll hand it off to Ben, but just very quickly, most of you are familiar with this area. The building stock is quite ripe for this kind of conversion. There's a pretty significant transportation hub there. Our case study is just a block from the rail station there. So a good opportunity. As I mentioned before, this is a bit of a what-if scenario. So I will hand it off to Mr. Isaacs.
Thank you, Dan. So yes, I'll talk about this case study at a very high level, but I'll let my colleague Tony go into a little bit more of a deeper dive on a Chicago project that we have. But yeah, this project is in East Croydon. For those that don't know, it's just over 10 miles south of central London. It's on the transport corridor, so it gives numerous transport links into central London. You can see there's a snapshot of the building here. Arguably already looks like a residential building. We've got window walls set back between expressed reinforced concrete columns, which were originally clad in mosaic tiles and now being overclad with an aluminium cladding panel. There's a car park there as well, and it's literally 2 minutes walk to the train station in East Croydon, so it's very well located. On plan itself, again, it looks like a residential building. It's got 2 wings, 2 vertical circulation cores, multiple egress, narrow serving corridors which allow for building access on either side, and an existing window wall system which can be relatively easily replaced or upgraded at a cost that's fairly efficient, we think. What else? So other design considerations. I think when we think about transforming and reusing existing buildings, it's important that we don't just look at doing early stage conceptual analysis. Although that's a great way of feeding into the direction of the project, there's nothing better than getting up close, doing an early site inspection to visually understand, look at areas of distress, connection details between the facade and the primary structure itself. This way we can take samples of the facade, we can take samples of the primary structure. And this is a little example in the middle. Office to resi conversion inevitably begs the question, can we add more stories? Of course, utilizing the reduced live loads from an office to residential conversion, there's often capacity to add additional floor levels, which is something developers are very excited about. So what did we do? And as Dan mentioned earlier, our client actually engaged us to look at an office upgrade, but very much the analysis is similar for an office to resi conversion. So in this case, we looked at energy efficiency and with an eye toward net zero challenges, the new London plan, BREEAM attainment. We analysed a number of conceptual build-ups looking at the existing facade system, replacing certain elements like glazing panels, looking at a replacement window wall, curtain wall, and stick system. Looking at not only the acoustics, the thermal, the structure, but also the cost efficiency. And as Dan rightly mentioned, that idea that 20 to 25% of a total refurbishment cost could come in the replacement of panels. This is just a simple snapshot of a thermal analysis for the window wall option. And that's very much kind of a very quick, high-level view of the East Croydon project. This is a nice segue into the next slide, which Dan will touch upon on EPC requirements.
Yeah, and so we heard, if you were here this morning, a fair amount of conversation about the EPC challenge. This is something that's front and center for our clients here in London, of course. The big concern with our developer and clients and our co-investor or investor clients is obviously the EPC time bomb, whether or not they will end up with stranded assets in the marketplace unless they move quickly. So you have the challenge of the regulations are changing at the same time they're trying to decide what to do with their various built assets. And this is a significant concern, and the numbers speak for themselves. Let's pivot to Chicago.
Thanks. So the thing that I work out of base in Chicago, and recently we actually started as Dan said, we're lagging behind, but started a process in this office. And especially in Chicago, the city has been looking at this pretty hard. And not so much from the housing standpoint, but of course, during COVID, everyone was working at home. Office space is, there's lots of vacant office space right now. What do we do with that vacant office space? So the city of Chicago actually started a program here where they were offering tax incentives and tax incentive financing to developers who were willing to take on these types of projects. And so you can see in the map here, the buildings marked in red are actually buildings that are slated for this right now. The one we're going to talk about today is here. It's right in the middle of what we call the Loop in Chicago. It's right in downtown Chicago. And we're currently in design development right now. We are the facade consultants. We're working for the design architect. So everything I'm going to talk about here today is still in flux, right? Everything's on the table here today. But the interesting part about this building, or the building that's on the site, is that it's actually composed of 3 different buildings built at different times. And so you can see on the site plan here, there's what we call known as the address. It's 115 South LaSalle. So this is at the corner of Monroe and LaSalle Street in Chicago, if you're familiar with that. It's a high-rise curtain wall building. The middle building, or what we call the center building in red there, is a much older building. It's built in 1911, a much more historic, it's on the register of historic landmarks. And then you have what we call the east building. Now, the reason I've got these 2 highlighted in red here is that these are the 2 out of the 3 buildings that are being currently developed for this office to residential conversion. All 3 buildings currently are attached, and you can get from one building to the other within the interior. What they're doing right now is taking that building that's on the left, that 115, and basically what they call decoupling it from the other 2 buildings. That one is going to stay an office building, and it's basically going to be on its own. The 2 buildings next to it then are going to be converted. So here's a view of all 3 of them in the row. The center building, like you see there, is historic masonry. You've got marble columns built in 1911. The east building, which we're going to talk a lot about, and it's part of the conversion, is from 1958, designed by Skidmore, Owings and Merrill. And then the west building as well, or the 115 building, was at SOM also. So they started looking at a preliminary program here. And certainly daylighting is a big issue. And originally it was going to be residential, kind of on the top half. And as you can see, office, they were still going to maintain office space on the bottom half. That's already changed. It's now going to still stay residential on those top about 10 or 11 floors. The bottom now is slated to be hotel. Now, as it stands right now, those 2 are still going to take place independently and probably at different times. So there's certainly going to be challenges once they get into construction with that. But as they
even just entered into the project, the scope started changing. So there's some very specific challenges with this project. First of all, as I said, the center building is a historic landmark. It's a landmark building, which means Landmarks doesn't really want you to touch it, right? So it's got replacement windows in it already, but they're single pane, they're thermally inefficient. So you have to replace those with, with a modern or a contemporary window, thermally broken with insulated glass units that, has a historic feel to it. I'll use the term, that's the easy part, right? I mean, that's not a challenge. However, the east building, which you can see here more on the corner, is not a landmarked building. However, the Landmarks Commission, because it's adjacent to a landmark building and basically part of it, they really consider that sort of to be landmarked, which presents a whole other set of challenges we'll see. So on that particular building, on that east building, it's a curtain wall building, monolithic glazing, thermally, not very good. We'll use that term lightly. And so obviously, if you're going to convert this to residential, you're going to have to do something about that existing system. Now, unfortunately, with the aesthetics and the Landmarks Commission, you're not going to really be able to change anything with the system. So originally they thought, well, hey, we'll just replace the curtain wall. Well, first of all, financially that wasn't going to work, and then Landmarks said, not a chance. So looking at ways to thermally upgrade that. Also structurally, like, hey, if you try to introduce, say, an insulated glass unit into this somehow, structurally, can it take the additional load? What does it look like now, from 58 to now? And getting a look at those anchors and trying to figure out if that's going to work. And then, of course, there's also the light and vent considerations. The code in Chicago says, and as it does most everywhere, you have to if it's residential, you have to provide fresh air somehow. The project team basically approached the city and said, could we do that just using MEP, HVAC, using the mechanical system? And they said, no, you've got to have operable windows in there somehow. So now, not only do we have the challenge of, upgrading this thermally, now we have to introduce operable windows into this curtain wall without changing how it looks. So you can see there's a lot of different considerations to take into account on this. So like we talked about, on the center building, it's pretty straightforward. Not touching the masonry, not touching the facade really, just some maintenance repairs probably, but replacing the windows. And that's, we can, like we said, we can replace that with a window that'll match historic profiles. It's thermally broken, has an insulated glass unit. So that's, like I said, kind of the easy part. And here's, just some examples of that type of window we've used on other projects, and kind of a section of that where you can have an operable window that looks like it's a simulated double hung and has that offset, but it can actually be an awning or a casement, something like that. The bigger challenge, like we said, is at the east building, at the curtain wall. So this is a couple of views, closer views of this. It's kind of, it's very simple. It's sort of Miesian in that it has kind of the, not quite the I-beam mullions, but something similar to that, but they are, they project out. And luckily, we've been fortunate enough to have the original drawings for the building. So we've been able to search through those, and the nice part about it is, like, the drawings back then are almost shop drawing level, and these are the original SOM drawings. So we've been using these, at least for now, as a basis of design. We've started poking into the existing system a little bit, pulling things apart to see what we can do. But of course, one of the first things we said was we've got to upgrade the glass here, right? And we've got to figure out, is there a way to sort of thermally break this? What can we do with this? So one of the things we were looking at closely is, this is the typical cross section of one of those mullions. And so up close, that's really sort of the existing glazing detail. It's pretty simple. You have an interior glazing stop that goes basically around the perimeter of the glass. It's glazed with, just glazed with a sealant, and then is captured by that profile on the outside. One of the interesting things about this, and I don't know if you could tell from that, is all of this is stainless steel, which, as we'll see in a minute, thermally is a bit of a benefit because it's less conductive than if this were all steel or aluminum, something like that. So, but anyway, so we started looking at what are some ways we could introduce an insulated glass unit into this, right? So, but keeping that outer, basically keeping the aesthetics. So we looked at, certainly we can fabricate a new interior glazing stop. We can put in an insulating glass unit. Again, sort of, pretty easy, at least, in theory, right? It looks good on paper. And it's the system is really kind of the same at the jambs and the head. So really it's kind of it's an easy detail to sort of project around to the rest of this. So that in and of itself would be pretty simple. So we did some very preliminary therm modeling on this and found something fairly interesting. On the left is the existing system. And like I said, a lot of this is stainless steel. So they haven't really had any problems with condensation. And as you can see, thermally, it's not bad. So the middle one is where we took our IG unit with our new stop. We introduced a thermal break there, and as you can see, it really doesn't make that much of a difference for the system. Now, we're not talking about operational carbon, things like that. Of course, that would be, that's going to be impacted for sure. But the system itself really doesn't get impacted by putting in the insulated glass unit. And then we even, went so far on the right as to, well, what if we just took out the thermal break and put in an aluminum glazing stop on the inside? Still didn't really change it that much. So it was kind of an interesting exercise, really, in the existing materials that you have, and knowing, kind of what to expect with that. So then, like we talked about, we've got that added complexity of trying to introduce some kind of operable window in here. And so we talked about, I think we've sort of settled on, an awning window is probably the easiest. And then we went through various iterations. The one on the left is just, hey, what if you just took, say a off-the-shelf curtain wall system and put it in? What would it look like? Well, it's terrible, right? It doesn't match the aesthetics. It doesn't work. So we said, okay, we're going to have to start looking at a zero sight line vent. We're going to have to probably look at some kind of a custom cap to this that might mimic what you've got on the outside. That's what you see in the middle there. But you can see there that, even if you sort of put that into the system, now you're extended much further back into the space than you were. So we've got to look at, can we thin that up? Can we shed some of that load into the existing mullion? One of the things to look at. One of the things we've kind of been working on then is the one on the right, where we're trying to take that awning window now and really kind of tuck it behind that existing sort of fin there, or that existing profile on the outside. That seems to be sort of for lack of a better term, sort of the leader in the clubhouse right now. Trying to at least work with that. Now, the rub to this is that the code in Chicago is supposedly going to be changing next year. And if this is permitted under next year's code, we won't have to have operable windows in here. They're going to allow this to strictly be provided by the MEP systems. So you didn't hear it from me, but I think the developer is looking to kind of, maybe push this off as long as they can in order to satisfy that. And so this is the kind of thing, we've been looking at least for those residential areas. The hotel areas, not unnecessary to have an operable window. Now, for me personally, the fun part about this, and I call this a proximity alert, this is the view out my office window. So I can see the project right out my window. So it's kind of fun when I'm talking, if I'm having a discussion with the design architect who's across town, I don't really remember what that looks like. I'll just stand up and go, oh yeah, it looks like that, or no, it doesn't. Now, here's sort of the postscript to all of this. Like I said up front, the city had promised a certain amount of money to these developers. Well, we elected a new mayor in the spring. That mayor now is considering taking that money to pay off the budget shortfall for the city rather than promising it to the developers. So adding another layer of complexity onto this. And of course, as you can imagine, the developers have said, without this money, we can't do this. It's not viable. It's barely viable in the first place, but without this money, we just can't do it. So a lot of these may get kicked down the road a little bit. This hasn't been fully decided yet, but it looks like that's the way it's leaning. So a lot of complexities and a lot of things that go into this, not only as we've seen with the facade, but just with the politics, which I'm sure everybody knows here. So we'll wrap up with just sort of a lessons learned slide here. Just like we said, the road's paved with good intentions, but whether it's federal, whether it's local, like it is in Chicago, there can be some challenges for that. And sort of finding that viability sweet spot there can be very difficult. As I said, those are five flagged projects in Chicago. There's a whole lot of other buildings there, but the viability is, as we said, the margin there is kind of razor thin. And just being able to recognize what's embodied in that asset. Is it what's attractive about it, the location, the floor plate, it all works into that viability. And you have to have somebody that has has creativity and courage to move forward. City of Chicago, I give them kudos for trying it, and hopefully we can see it through there. But as we've seen, there's various challenges for it. So Dan, I don't know if you have anything else to add to that.
Yeah, and Tony, thanks. Obviously, with all the technical challenges, it's a bit of a political football, right? I like the idea with the code to slow walk it
right.
a little bit, but no, it certainly challenges across the map for this kind of conversion. So the lesson we want to leave you with, a couple of things, and you heard from Ben and Tony about the technical challenges. We heard this morning about the need for an independent, very comprehensive analysis of the enclosure. That's absolutely critical. We hope you've seen that here. It's easy for a developer to get drawn into the idea that it's 10% of the overall refurbishment cost. They might be looking at some very optimistic energy models, that kind of thing, but it really requires getting your hands on the skin of the building, really understanding the as-built construction, which Ben talked about, and the modeling you need to do to really understand what your options are. So, and again, it very likely could be a deal breaker. So that's how we would like to leave you today. We certainly appreciate the opportunity. Thank you again.
Thanks to Ben, Daniel, and Isaac. That was a really interesting discussion on that, about the change of use. Obviously, in the London market, we're dealing a lot with the upgrade of office spaces at the moment, probably not tackling the change of reuse from office to resi and the challenges that can present. So really interesting discussion there. Next, we have Olga Gomez-Fernandez. Olga's director at Squire & Partners, and she's going to be talking us through her presentation, Architectural Identity. Olga?
Thank you, and hello, everyone. Today, I'm not going to have a very technical presentation, I'm afraid. I'm not show you any facade discovery, but I'm going to talk about a little reflection about how our society has been designing building for years. And this has meant that we have an interesting architectural identity across different towns. Unique context, unique architecture. In the past, buildings used to adapt to its location. Not only that, they used to protect themselves from the environment and respond to any social and cultural demands. This is why two different locations, on the left, this is Lake Bled, Slovenia. On the right, this is a fort in Abu Dhabi. And they are so different. In recent years, materials and the methods of transport has made available to all of us any material that we want. Not only that, technology has advanced quite fast, and we have technology at our hand for anybody. This has led us to an international style, and sometimes it's even difficult to pinpoint where these towers could be located in the world, because we have a globalization effect. So if we have to find an identity, and I've come across as an architect in many new developments where I need to design, and they say to me, we want this to be exactly Abu Dhabi. We want this exactly from Spain. And how do you find identity? We could go back and just add passive solutions. Forget about air conditioning and any technology and just be back with our fathers and trying to make it work. We can also forget about proportions, because in reality, before we have all the structural advance, the windows have to be as wide as we can build them. So basically, the lintel will be as the technology we had at that time. Also, we reduce almost all the ornamentation, and sometimes the ornamentation is not located in the right places, or we use references that are not for that particular country. So it's quite difficult to differentiate where we are. These are some examples of very distinctive villages, and I think it's always easy to find unique identity in small-scale developments. So in here on the left, we have a village in Morocco, Ibn Hadou, all made out of clay. On the right, very close to where I'm from, my country is Spain, south of Spain, near Marbella, Casares. They both have an Arabic heritage, and they're quite different. Why one is white and the other one is not? White, very interesting, we used to paint the houses just to repel the heat. But it's not only because of that, it's also a symbol of hygiene. When we have the plagues and there were a lot of deaths, they will paint the house white to make sure that that house was completely clean. And this has remained over centuries, and all our cities are painted in white. How beautiful. Another two examples, two stone cities. I love stone. On the left, San Gimignano. On the right, this village of Palangan in Iran. They're so different in form, and I chose this because on the left, the towers, defying gravity, is where all the people used to say, the powerful the family, the taller my tower. On the right-hand side, everyone is equal, and it's very friendly because actually your courtyard space is on top of your neighbor's roof. So it's fantastic. So same material, different parts of the world, so different. And here we are in the UK. I have to write this. Probably is like my favorite towns in the Cotswolds. But what makes them special and unique? Actually, the limestone. Fantastic porous material, great insulator because of the porosity. And it also brings you an amazing identity. So we summarize all of the things that we need to think about. What brings identity to architecture? I think it is climate. I think it's the surrounding landscape, the materiality that we have available, the scale, the culture, and the social particularities of each place. Now, I'm going to talk you two different regions since I started this presentation. One is in Europe, the other one in the Middle East. This one actually was my first project in the UK when I came here 20 years ago. And I came here to design British architecture, but then they told me your first project is going to be in Kranj, Slovenia, in the mountains. The brief was to create a new residential development, 400 homes, next to this little village in the mountains. It was quite tough, saying, what kind of architecture? I was in this competition against 8 Slovenians. We were the only international architects, but they really liked it because we were really respectful. We wanted to replicate, not exactly a replica, but be respectful and understand why those buildings, they look that way. We like the idea of having an interpretation of the organic roofs, and we also look at points of reference, as you do as a foreigner and you go into a new country. We like the kosolci, that is this little unit where you dry the hay. And the best thing about it is that they have these amazing balconies in timber where they do social gatherings. So on the right, you can see this was our first space study, trying to do a contemporary interpretation, incorporating timber in the facade and having a stone base just to protect it from humidity and having like a barrier. But what happens when you design something in a city and there's so many architectural styles and there's so many areas? When we went to Zagreb, they asked us to do a design code for a master plan for a new development. So we wanted to be Croatian. What does it mean to be Croatian? And we understood that we had to go out there look at all of the examples of architecture, and obviously it's not only the villages, you have the central part of Zagreb, and then on the right-hand side, the new developments. I mean, they have also their take, because different regions. But if we have to choose one, we started obviously looking what it makes it very particular from this country. And we like this structure, you know, the roof, the ceremonial entrance, the base of the buildings. We have that across in many cities because they have to deal with humidity, and as well the windows. And looking deep into this thing, we realized that the windows and the roofs, actually, they're not only from Zagreb, Croatia, they're actually in Europe, you have them in many places. But what makes the windows different? And this is fascinating. We have three types of window. You have the windows where you have a threshold in Spain where we put the shutters in the outside to prevent the glass to overheat. You have in the northern where people put the shutters in the inside in order not to let the heat out. And then you also have other windows where they have no shutters at all, but it's all about decoration. So in reality, we were not going to find too much out there. So I'm just going to go now and show you another part of the world. Oh, sorry. The Middle East. Here are some shutters that actually we did in one project that I'm going to describe right now, when we were working with many architects, and very lucky to do Musharraf Heart of Doha. I was part of the design of 5 buildings, 6 actually, up there, all quite different. And what we really like, enjoying and working together, these numerous architects, all trying to be prima donnas, trying to have the best building, the best design. We actually were managed by Allies and Morrison with a fantastic master plan where they gave us the 7 steps of architecture. And in these 7 steps, not only they gave us guidelines for each of the buildings, the best thing is that we all have to have the same material. By only making that decision to have a local material and different types of architecture, what it meant is that it automatically rooted the building to its place. But what is the challenge? In Doha, when you look at the references, we have to look inspirations from very low-scale developments. So if in this one, for example, you have to design a 5 to 6 story building referred like a house, how could you make that? Quite challenging when you have to do a render facade of 6 stories with movement joints where everything has to be seamless and in a very tight budget as well. But the idea is to convey, you know, the materiality and the feeling of being in this part of the region. I think it was very successful. In here you have 4 or 5 buildings between Mac Aslan, Squires, and all of us. And what I really like about this is that we all follow the 7 steps about certain rules that respect the traditional architecture, but in a contemporary way. And it's not only about the spaces between the buildings, but also how it relates to the old and the new. On the right-hand side, you can see in there, you know, this is an existing building and how they rise above the towers. Finally, this is a view from the Souk Waqif, that is the center in Doha, looking to one of our buildings. This is the hotel, the first hotel that we designed. And then from the top of the hotel, looking back into Doha, that I really enjoy. But you can see by the choice of materiality, it's almost like it feels like it could be there. Following that, we were commissioned as part of a competition process to define the architectural identity of Abu Dhabi. We worked with the government for over a period of 2 years, trying to have a design code that will inspire architects, developers, and anyone in the construction industry, that it won't be very prescriptive, but it will allow flexibility and creativity. The problem in Abu Dhabi is that, as you can see in the bottom part, all of the buildings, the arrival of air conditioning, they have large mirror glass windows. The styles are all over the place. Some people were copying the same building. You do have the same building in the same street. You say, well, I don't know what I'm going to do. I'm just going to copy that one. And it happened like that. So they found themselves, should we go back? Should we refer to what was our original architecture? So we produced this little page, just to say in the bottom, that is a tree. You take inspiration from the past into the future. You never replicate the past. You never put the tree upside down, but you're trying to get those branches that it will lead you to the new language of our contemporary architecture. And as I mentioned before, there's not only architecture in the villages or in the very, very vernacular architecture. There are great examples about brutalist architecture and other buildings from the 60s and the 70s. But these interesting buildings, they all respond to a climate, to a location, and I think they feel very much Abu Dhabi. We came to them, provided a series of books and guidelines for the planning department, and we defined, similar to Eliza Morrison, instead of 7 steps, the 6 design principles of Abu Dhabi. There is about rhythm, the interface of buildings on the street, how we respond to climate, the chosen material, extremely important, the simplicity of forms, and the appropriate cultural references. We thought if you apply all of these design principles or get inspiration from them, you will have an Abu Dhabi building. Since then, we informed with a series of diagrams and just trying to get a bit more technical that I'm not going to do, but I'm going to show you that there are some rules. I think you have to have certain amount of recess. You have to respond. So bringing those passive solutions into your facades and try to forget about technology for a second, saying that that facade is going to perform as it should be when there was no technology, it will provide a bit of identity. Finally, some of all the diagrams that we've done, and most of it was about materiality and simplicity. Materiality, there could be anything. It's not so prescriptive, but it's a series of materials that will all be in line with Abu Dhabi, with the climate. We did a little exercise in trying to use the same rules for a Abu Dhabi shopfront, Harbiya Marina. And each of them is a different architect trying to do different things to see if they will all come in line. A bit repetitive, we're still working on there, but I think it's really good to say that this shows you a style. Hopefully you can feel that this is Abu Dhabi. Thank you very much, and I'm going to leave you with this image that for me is one of my biggest contextual architecture. This is a colleague, a Spaniard, Manrique in Lanzarote, and I love his contextual architecture because it's all exciting about the volcanic rock. And you can see in here that it's not about trying to get the context out, but perhaps we need to bring the context in. Thank you very much.
Thank you, Olga. That was a really insightful presentation regarding architectural identity. And I think one of the, my favorite point in your presentation was the analogy of the tree and actually rooting the material to place, because you're not talking about creating a pastiche, about mimicking what was done in the past, but actually just creating concepts that can allow creativity while respecting local materials and response to climate. So thank you. So next up we have Boston Valley. Boston Valley Terracotta. I think there was a change of name, so I'll invite you up to introduce.
Thank you. Got it. Hi, everybody. If you look in your programs, I am not John Krause. So unfortunately, John couldn't make it. So my name is Laura Rogowski. I am the president and CEO of Boston Valley currently. So I appreciate your patience in not looking at John for the next 15 minutes. In this time period, what I really want to do is talk about materials and why materials matter, specifically talking about terracotta and giving you some examples of how it's been used for different reasons and different purposes here in the London geography, and then just spend and wrap up a few minutes talking about sustainability and why that's important and how terracotta as a material is actually extremely sustainable and probably one of the few materials that you can take off a building, crush, reform, recolor, and put it back up again. So there truly is a circular economy possibility here with terracotta. So for those of you that may or may not have designed with terracotta before, I think what's important to realize is that it really is about a quarter of the weight of natural stone, but yet it can be used to mimic natural stone in its glazes and its finishes. It's important to note that the through color actually doesn't change with exposure to UV, so you'll have a consistent look throughout the life of the building. And as I'll talk about a little bit at the end, there is research, and we believe that terracotta may actually play a big role in future buildings as a conduit for potentially evaporative cooling and thermal heating. There are, as you can see, there's many ways to use terracotta, many ways, reasons that designers use to choose to work with it. And one of it reasons is that you can have great variety in the material, form, and finish. I think throughout history, all of us have seen that terracotta can be formed in innumerable ways with different patterns, textures, and glazes to give it the appearance of other materials like tile or stone. In our particular company, we actually use 4 different ways or methods for forming these materials, and we have over 30 years of research and experience in matching glazes. So with that, let's talk about a couple of jobs. One of them is 60 Curzon, which is here in the Mayfair area. It's a high-end residential development that is currently under construction. You can see the team, PLP was the architects on it. And this building is actually included and located on the site of a 1930s building that once housed the famous restaurant Mirabelle, for those of you that may know some history of London. What was really important is that the local craftsmanship of the geography or the neighborhood was represented there. So actually, most of the facade of this building was carefully made with Portland stone. I believe we talked about Portland stone in the first presentation today. It is sort of it is a bespoke material, and a lot of bronze was used in this building. But let's talk specifically about the terracotta. I want to talk a little bit about the process. Well, we were fortunate in this particular project to work with Studio Christine Jenton. If you don't know her, she's here in the room. And she worked with PLP to really deliver a specific glaze and a specific look, which you can see in this green color. So once that was developed and approved and we won the bid, then essentially we went to work trying to create that particular glaze. And you can see here what's interesting, at least to me it is that you see the pieces to the far right. That's actually from the project. But the ones on the far left are actually from a building in the United States that we were working on mimicking that original stone. So you can see how little changes make it different, but yet there is a similarity, both historical reference, but yet coming in a more modern form. Once we have identified a glaze, we always do a factory mock-up and get glaze approval. And you'll notice just with these pictures, when you use terracotta with the glaze, you can see how the corner pieces look very different than some of the flat pieces. And this is why I think it's really important to do these mock-ups, because what it does is it allows you to inspect for consistency and alignment before it actually goes on site. You can see we also do a dry fit to make sure that everything's going to come together and to make it as easy as possible once it gets on site. On site, there was a mock-up process here. Because the other thing about using terracotta, as with other materials often, is that when you look at it vertically, it can be very different than looking at it horizontally. And it may or may not convey in the way you want and get different lights. So once it's mocked up on site, construction can begin. You can see the structure behind it that it's going to be hung on. See, we'll whip through those. Beautiful, right? Christine did a great job. So I think what's most prominent about this particular building is you notice how everything melds well together. The glaze goes well with the bronze as well as the Portland stone. And when you looked at it in the neighborhood, and I encourage you to look at any of these 4 buildings while you're here, you'll see it really does complement the Georgian townhouses that surround it, but it doesn't overpower the street. And it does give a great smooth transition when it comes to the scale of that particular building to the ones around it. What you're looking at right now is actually a second building that I want to talk about. It's 48 Carey Street, and it's in the residential area of London called Holborn. It's a 10-story building. It has 22 apartments, and it was also designed by PLP. And what was interesting is that PLP really focused and took the challenge of designing a very slick new building which features would blend in well, again, in a surrounding historical neighborhood. Unlike creating something very colorful and unique, what PLP wanted was us to come up with a softer, a little more monochromatic gray hue to match the stonework that was already there and in the surrounding community. You can see it here. The architects really were focused on this identity of this idea of architectural identity. Thank you, Olga. As well as mixing the 2 types of both stone and terracotta. So you can see this is what we came up with in the end. But there are different forms that it's important to see how the glazes react on each of those forms. In this particular project, we did use 2 different methods of creating these pieces. We used both extrusion and our ram presses to manufacture them. But you can see that no 2 are exactly alike. And that's one of the unique things when it comes to terracotta, is that the idea of flaw or uniqueness should be embraced. It's not going to be a flat monochromatic type appearance. So this custom glaze actually, when put together, it blended in very, very well. But what is unique is not everybody wants that. Sometimes our terracotta is used for different reasons. In this particular building, which is Moxon Street, what you'll see is that this architect wanted some natural look, but it was a very long building. It actually takes up a city block. And the architect wanted to use the idea of color or color change to give some variety, so you're not just looking down at one color all the way down the street. And so this is what they did. We actually created 4 different glazes for this particular project, and it helped differentiate. Now, you just saw this picture, right? It looks white. Whoops. Hold on, let me go back. There we go. See the picture on your right? Those are the colors we used. And you don't, I think it's interesting because the white doesn't necessarily stand out to you, does it? But again, when you put it in that particular setting, it looks different. In this particular project that we produced just under 10,000 units in 3 different methods of all different sizes. So if you look at this, just to give you some context, this is about 450 width by 250 by 600 metric. So that's a pretty good sized piece. And that's why we use different methods to produce each of them. This is one example of some things have to be hand pressed. So if you think about hand pressing, I remember my first time in the plant, I walked in and there were literally people throwing clay into molds and pushing it down manually. And so that method still happens. It happens every day in our plant in Buffalo, New York. But we do have the ability to do beautiful things like this, as well as more of those standard type pieces too. The other thing that's fairly unique is that when you think about installation, and everybody does, right? The cost of installation and how does terracotta work with that? And right here, what happens is we actually don't always drill the holes for installation. Those are done on site. What that allows it allows the contractor the flexibility to be able to ensure that the holes are exactly in the right places, make minor adjustments so everything is flush. They don't have to go back and either adjust holes, do other drilling, and it really does help speed up the actual installation of the job. You can see this is another example of how you can see some of those stones, how they're anchored into the wall there to fasten back to the substructure. So let's talk about this particular job. You can see how the terracotta blends really well with all the metals and the cast metal balustrades here. There we go. See, all the same building, 4 glazed colors, yet they all look very different. All right, so let's talk about the circular economy and about sustainability and biodiversity. Well, I did talk to you about first that it can be, think about the idea that in the future, if you designed a building today and used terracotta, that in 20 years, when someone decides they don't like it, or they don't like the color, or they want to make a change, they have the option of being able to take all those panels off, have them crushed, and then recreated into whatever the new look is. So in theory, there is very little waste, if any. One of the things we are very dedicated to, and that is finding new ways and doing research with architects and academics and facade engineers to really determine what is the future of terracotta in facades. So for the last 9 years, we've worked and held this, what we call the Architectural Ceramic Assemblies Workshop, also known as ACAW. And it's sponsored by Boston Valley, the Carnegie Mellon University, and the University of Buffalo School of Architecture and Planning. And it brings sort of all the players together in one place to actually propose and actually do a project and to try some things to see what will work and what we need to do for the future. So I want to show you a couple of ideas and projects that came of this last ACAW just about a month and a half ago. Several of the teams really wanted to focus on climate change and sustainability. If you look at here, this is a group from Seldorf Architects, and what they really wanted to do is they wanted to reduce the weight of the panels. So you can see by making them concave, actually, their motivation or inspiration was sine waves. So they wanted that undulating type of look. But you can see by cutting out the center and actually having that separate design, it allowed it to be almost 60% lighter than a traditional panel. The other interesting thing is they did use red iron oxide. Red iron oxide comes from coal mining. And it essentially is found when, as a byproduct of old coal mining, it was dumped into streams. And it's found at the bottom of streams now. So we're trying to find other ways to take sort of nasty stuff that's in the environment and making it useful again. So this is a red iron oxide color. So now you see it mocked up on the inside, and that's when sunlight hits it. Again, there is a variety and a beauty to that particular offering. And let me wrap up by talking about a project that was done by Eric Perry and his team. And you can see it here. They were trying to do fishmongers right here in the city and trying to find ways for lichen and for ivy to be able to grow and create a living wall. That you can see this is what it's supposed to look like. So you see exactly how the living wall comes alive with both ivy, lichen, etc. And one thing that the result of that I just want to leave you with is that 10 square feet of moss put on one of these buildings absorbs as much CO2 as a tree. So there's a lot of opportunity when it comes to facades to impact the environment. Thank you.
Thank you, Laura. Some really interesting work going on in R&D at Boston Valley, and really encouraging to see the innovation that you're really working on there. So thank you for that. Next, we have Simon Ince. Simon is product specialist at UL Solutions. Simon is going to be talking to us about striking a balance between safe and sustainable facade systems. Simon.
Okay, just like our last speaker, I'm a substitute, but I'm not first choice, I'm second choice. So you can tell what kind of performance you're going to get today. The guy that was supposed to do it was based in Chicago, and he phoned me up last night and said, these are the recommendations, mate. This is about 8 o'clock at night, so I was really thrilled about that. I'll give you a bit of context about me because it's quite important. I come from a risk management background, so actually looking at buildings, risk assessing them, fire risk assessing them, and seeing what kind of mess the external wall systems are. So I was technical officer for the Fire Sector Federation for about 12 months, and in that time I wrote a guide for fire risk assessors to look at external wall systems. Part of the regulations in the UK is to have a fire risk assessment, and the external wall systems weren't always included in that. They are now. That's our test lab at Telford. I'll talk to you a bit more about that later. So it's quite important to give you a bit of context about who UL Solutions are. Does anyone know who UL Solutions are? That's the normal reaction we get, so I'll explain who we are. We're a testing, inspection and certification body. We've been around for 129 years, so next year is our 130th birthday. We cover loads of different things, so appliances, batteries, chemicals, healthcare, pharmaceuticals, we cover everything. Wherever there's a kind of consumer protection required, we're in there. But at our core is buildings. That's where we started from. That's where we kind of our core values and processes all come round from building construction. Our first testing standard for fire doors is 120 years old. It was written 120 years ago. So we've been in this business a long time. We've got 15,000 employees. We're in 40 different countries. So we're a large organization, and yet only one person's heard of us. So. And as I said, we do have specialist testing facilities in the UK at Telford. So we do look at external wall systems and glazing systems as well. We've got a booth just outside, so if you want to know more about testing facade systems, then please do go and speak to the people out there. So this one we're going to look at is slightly different than what's advertised, but I kind of wrote this myself. I don't like taking other people's presentations, so I kind of changed it slightly. There's lots of technical papers and presentations and conferences. I'm going to one that's in Slovenia at the end of this month about sustainability. So it is a hot topic at the moment. Sustainability in facade systems. There's lots of different elements to this. There's things like PV cells, green walls, increasing thermal efficiency, those kind of things. So there's lots of detail. And what I've done is try to simplify it as much as I can. I used to be a school teacher, and I'm used to making it as simple as possible, to be honest. You'll see how simple it is in a minute. So when we talk about sustainability, what's the definition of it? There's lots of different definitions you can use. The construction industry use one, but I like this one. This is a World Health Organization. The reason I like this, it brings it back to human beings. It brings it back to the people that actually live in these buildings and occupy these buildings. So, social and personal health in the future. So without sacrificing our environmental, social, and personal health in the future. Simplify that again, and we're talking about green. So that kind of buzzword, green, because they focus on limited impact development on the environment. And that green word gets abused quite a bit, to be honest. Green and sustainability are interchangeable. They're kind of used in the same thing. But has anyone heard this term, greenwashing? Has anyone heard that term? It's actually on the radar of the European Commission. I'll talk about that in a second. So what I thought I'd do is demonstrate this. Greenwashing is essentially the headline, 100% recycled, powder-coated steel cladding. So it's 100% recycled. Fantastic. That's sustainable, surely. Well, although this is made up, this actually could happen because I've checked out all the facilities in all these different countries. So we're collecting scrap steel in the UK. That gets shipped on a boat all the way to northern India to get processed in a coke-burning smelter with electricity for driving the plant that's driven by a coal-fired power plant. Okay, so then it gets put back on a ship and it gets taken to northern Turkey, where it gets fabricated into the panels for the actual cladding system. It doesn't get coloured there though, it gets put on a truck or a couple of trucks, and it's driven all the way to Poland to get the powder coating on. And then from there, it's driven on a truck to the west coast of Europe. It's gone on a ferry across to the UK, driven across the entire of the UK, back onto another ferry, and it's gone to Dublin, and it's installed in a project there. So, although it is 100% recycled, how green is that product? It isn't. You know, it's got a massive carbon footprint, thousands of miles long. So, back to our kind of definition of sustainability. And I like the bit about at the bottom, improved health outcomes and decreased stress. What's that got to do with sustainability, you might say? Well, these are some headlines from The Guardian. This is after the Grenfell tragedy in the UK. And people have been left in the UK with houses that are just worth nothing. Flats, apartments are worth zero. And they can't even sell them because the cladding systems aren't on there. So imagine the stress if you want to move out of your house, you want to sell it, move somewhere else. You might, need a house, a bigger house or something like that, and you can't actually move because no one will mortgage those properties. And on the right-hand side, mental torture. These people have been stuck with this cladding on the outside of their building for 6 years now, some of them. And it's, it isn't good for their health, so it's not sustainable. And another example of lack of sustainability is this. This is not cladding, it's timber resin, so timber frame. So sustainable material, you can regrow it, it's wood, it's better than concrete. But there was a fire here in Cheshire in 2019, I think it was. This was a retirement home, so people who were downsizing, they got all the possessions inside their house, and there was a fire on the roof, and the whole thing went, 150 people lost. So having a building that will burn to the ground is not sustainable because you've got to rebuild it, you've got to rehome all those people. And they lost everything in that fire. So I told you it's simple. What I've done is kind of used the balancing metaphor, if you like, to try and look at this. So these are our claims: durability, longevity, recyclable, sustainable energy used in production. So all these kind of buzzwords we've got on the left-hand side, that obviously unbalances the seesaw. So that's a kind of on our left-hand side. So how do we balance that out on the right-hand side? This is our green, sustainable claims. But how do we balance that out? So the first thing we use is substantiating. So what are those claims? How have they been measured? What metrics are we using to measure those claims? It uses 60% more recycled material than our competitors. But who's done the research on that? How do you know your competitors don't? So these kind of marketing claims, essentially, need to be substantiated. You need to measure those properly. The second part is communicating those. What do you put on the packaging? So what information do you put on those? And then the third part is verifying that. Is it actually accurate? So the use of third-party certification bodies to go in and check that those claims are actually real. Now, as I said before, the European Union have got wind of this, and they've started a green claims directive. So that should be in place in 2026, and that will come into force. And essentially, those three pillars, those three things that balance it, will be included in that directive. So, balances sustainability and fire safety. Here we have our balance again. Do they even up? So on our left, we've got our credentials, sustainability credentials that have been verified and confirmed. And on the right-hand side, we've got functional fire safety. The functional requirements. How do we keep the people in that building safe? And often, they're life safety only. And therefore, life safety is the minimum requirement you have to make sure that building is safe for the occupants. So there's not a lot of redundancy in there. So if you do have a fire, the likelihood is, like I showed you at Beachmere, if you have a fire, you could actually lose the whole place. As long as everyone gets out, you still could lose all the place. So, but I would argue, and we would argue strongly, that actually safety of human beings outweighs sustainable credentials. So there isn't a balancing act to have, because you have to have something that is safe to go on a building. So, for example, if you come up with, if you can harvest all the plastic that's in the oceans, that's great. And if you use it to skin thermal insulated panel that goes on the outside of the building, fantastic. That's great for humanity. That's great for the oceans, etc. But it still needs testing. If you use wood byproducts, timber byproducts, the ends cut off lumber to make shingles, or if you use tires to make shingles that goes on the outside of the building, that's great, but it still needs testing. If you use sheep's wool, or you get recycled clothing and you cut it up cotton to make insulation, it's great, but it still needs testing. So actually it does outweigh it. There isn't a balance to be made there. So let's look at testing and how testing supports conformity assessment. So testing is a standard, well, first of all, why testing is useful. It should be independent test labs. So it's not tied into a manufacturer, they're independent test labs. So what they do is they give you a measure of the performance of that. Standardized and calibrated test equipment, your competent test operatives, so the UCAS accreditation, they come in and check the laboratories, make sure that they're doing it properly. Make sure the records are kept accurately and reporting is accurate. So what was actually tested? What's the makeup of that product that was tested? But testing is a standalone thing, really. You can send in, as a manufacturer, you can send in your products to be tested, and you can just manufacture them for the test, to pass a test. Test labs take what you've got, and you tell them what you've supplied, and then they will test it. So there is a better solution to that, and it's conformity assessment. So conformity assessment is a demonstration that what is being supplied actually meets the requirements. And that means this, that third-party certification is assurance of conformity. How do we get that? Well, because this is what we do. Selection of products for testing off the production line. So you can't just manufacture them and send them in to be tested. We take them off the production line, so they're standardized. So that's what you produce week in, week out. Then it's tested, and then the audit of the factory. So how do you make sure that your product as tested this week is the same as next week, next month, next year? So we make sure we go back on a regular basis and we check your controls to make sure it is the same. I better speed up. Third-party certification is used for lots of different things. And all these kind of products that we test and certificate, a lot of time the stakeholders are involved. So the trade associations, the manufacturers, the end users, so the main contractors, specialist contractors, are all involved in putting together the checks and balances for third-party certification. What we're really talking about is the life cycle of buildings. So you've got to design it, and third-party certification helps designers because they know that that is safe. That product has been tested, it's got a test result, it's been factory audited, it is what's going on in the building, what was tested. It helps in the building process because the builders then can look at the design and what was tested and make sure it matches in the building. And then occupancy. So if I have to replace anything within there, I can use my third-party certification and say, right, well, this is what it was. This is who manufactured it, this is what it does, and therefore I can replace it quite easily. And then end of life as well, you understand what you've got in your building. I'll move on. So that's called the golden thread of information. Anyone heard that term before? Golden thread of information, really important to go through. So third-party certification helps mandated information transfer. So you can use third-party certification. In the UK, it's Regulation 38. It will be different in different other countries. And it's there so you can actually help the end user to understand what they've got in their building. I'll speed up. So, balancing innovation. Innovation is something that human beings have done all their life. It's got to be there. We've got to change and make things better. Use different materials. But does that outweigh fire safety? And it does. Because all these things, thermally efficient, low carbon materials, photovoltaic, green walls, it's going at such a pace that we can't keep up. So how do we make the balance on this one? And the balance is made this way, by regulations. We've got to improve our regulations. They're not keeping up pace. It takes a while to change regulations. It takes a long, long time. Test methods, are they suitable? Are they covering what we need to cover in real life situations? Or are we just shoehorning it into different tests? And then also certification schemes. So having those schemes in place that actually check what needs to be checked for safety are really important. And then insurability and fire safety. Like it or not, I think this phrase is that if you can't get it insured, you're probably not going to build it. So if you cannot get it insured, you're probably not going to build it. And insurance companies are very wise. They don't take risks. And I've kind of used a final phrase on this, taken from the Hunger Games, and I've changed it. And this is the insurance motto is, may the odds be ever in our favour, because they're certainly not in yours. So I know that was very brief, and I've got about 8 seconds left, but thank you very much.
Thanks, Simon. A really important message there around testing and certification as we're on this speedy journey, as you've said, towards more sustainable solutions. We are coming to the last part of our track session today, which is the panel discussion. So I'd like to invite Hugh McGivery from Eckersley O'Callaghan to introduce all of the panelists. And can I remind all of the speakers from this session if they could remain behind at the end for the memento presentation. Thank you.
Can you hear me? Perfect. Good afternoon. Thank you for choosing track B. When Zak asked me to pick a project for a panel discussion today, this one jumped immediately to mind for a couple of reasons. It's an extraordinarily complicated and challenging project, and timing-wise, it's due to PC in the next month, touch wood. So it's a really good time for our team to be reflecting on the lessons learned and being able to share those now. So without further ado, I did want to just quickly do some acknowledgements for everybody who's not on stage. We could have spoken all afternoon about this project. These logos are just some of the other companies involved purely in the facades, and that's not without going into the Arabs and the AKTs and everyone who involved in the scheme generally. Particular shout out to Stanton Williams, the Morrison Company, and DSDHA, and to Thorpe and Lindner, the trade contractors who are a huge part of this. So I wanted to introduce our distinguished panel. We've got Lynn Summerfield, who's project director at British Land, so the client. And Lynn was responsible for leading the design team and instilling a really great culture of collaboration in the team. And we've got Peter Mayhew, architect from AHMM. So AHMM were the master plan architects alongside the other three. And AHMM had the building design for three of the larger buildings. We've got my colleague Rocco Baselli from Eckersley O'Callaghan, facade engineer, who looked after a lot of the scheme, including all the refurbishment aspects and the Blossom Yard building. And then we've got Sophie Baker from Skanska, who's a senior construction manager who was responsible for the delivery. So without further ado, I'll pass it on to Lynn, who will introduce the project.
Okay. Right. Okay. Right. Hi, everyone. So I'm just gonna set the scene really and give a bit of an overview on the project. It's quite complicated, so it just gives a bit of context to what the rest of the team are going to talk about, and then touch on what's important to us as a developer. So the project is a mini campus. It consists of 6 different plots. And within each of those plots, there are 2 buildings, a new and an existing. So we say 6 plots, 12 buildings. 340,000 square foot of commercial office space with retail on the ground floor. But we've got 87 different floor plates across that development. So a lot of work and different spaces to work on. So as a result, we've got 11 sectional completions. So quite a challenge. The project's been in work in progress for British Land for a long time. We acquired the site back in 2013, which coincidentally is the same year my daughter was born. And since then, we went through quite a difficult planning consent period, which then enabled us to start on site at the beginning of 2019. We did a lot of archaeology, over a year and a half of that, before Skanska finally started on site at the beginning of 2021. And we're looking to get the fit out and done and the buildings occupied mid next year, which is just in time for my daughter to start secondary school. So good timing. There are a lot of stakeholders on any project, but on this project it's particularly important. We've got engineers, architects, contractors, the sort of normal things, but also when we were looking at facades, the stakeholders involved, the people around the project, the local community who were really involved with what we were doing, and all our third-party stakeholders. And part of the reason for that is all the constraints. There's no constraint at Norton Folgate that's unusual, but it's quite unusual to have all of them together. We're in a conservation area, which is the pink part on the screen. We've got a scheduled ancient monument under part of the site. We've got listed cobbled streets running through the development, locally listed buildings, and then we've got the usual things of the main line running into Liverpool Street on one side of us, a red route on another, tiny, very narrow streets. And then the thing which is a really odd thing to have in central London is local residents sitting and living right alongside us in listed buildings in those blue blobs on the diagram. And probably the biggest constraint for us is the thing that's the most valuable, which is all the retained elements. So this image shows the development as a whole when we took over, and all the things in blue were either retained buildings or retained facades, some dating back to the 1800s. And when Skanska started, this is just before they started, but you can see from this image, there were still a lot of structures on the site, which meant we never had a flat site. That's something that Sophie will touch on when she talks about logistics. And then I call them our beautiful constraint, the retained structures, because they're like what makes the building special and what will attract tenants for us. But just to give a sort of insight from what that was like when Skanska started, I've got 3 images from across the site. This is the rear of the Water Poet. It's a pub that lots of people know, sitting on Folgate Street. And from the main road, it looks normal, but behind that facade, we had all these structures. This is a couple of warehouses retained in full, 1887, and then the facade at the front of 1927. And lastly, a retained facade on Commercial Street. This is probably one of my favourite photos from that period on the project. So what success looks like for British Land? Well, we set the challenge to the team. They're going to talk through that. That obviously, for us, it's really important that we have a safe site, that people's well-being and their welfare is top priority. But also, when looking at the facades, we needed to make sure we maximised our net lettable area, that we delivered as quickly as we could so we could get tenants in, paying rent as quickly as possible, and then underlying all of it, making sure that we were achieving a quality product that people wanted to move into. And I'll hand over to Pete.
Which button? The middle one? Okay. Hi, afternoon, everyone. So, talking about all the design on this project would be very difficult. There were 4 architects, 6 or 12 buildings, as Lynn has said. So I'm going to focus on the largest footplate building on the site, which is what we call Plot S1, now known as Blossom Yard, which is the stepping brick building in the centre of this image. So it has a long facade. It's at the gateway to the city, so it's quite an important site. It fronts onto Foster's Principal Place, which is also very prominent. And one of our goals was to deal with the arrival into the city, the exit from the city, and the transitioning of scale from city, locally listed buildings, to these new buildings that we were designing. So what we've done as a design approach in terms of massing is to take this big lump and split it into 3 bays on the front. So we're treating it as a giant warehouse in a way. We're then looking at what the appearance is on the street. So we've looked to then push the massing back. So we've stepped it to mitigate the impact of the street, which forms some terraces, opportunities for floor plates, etc. And then if I flick, so this is one of the views from looking down Shoreditch High Street, and you can see that stepping elevation and the city in the background. So that's our kind of transition into it. We looked in terms of materiality, we thought about brick, and I'll talk a little bit more about that in a second, but that's the main material, which is a really warm material, instantly provides some character, but also deals very nicely with the context that we had, which was a myriad of types. And this is a view looking up from the Liverpool Street end of Shoreditch High Street. Again, you can see the stepping there, and one of the other buildings in the master plan is just in the front there, the one by Morris and Company. So in terms of a little bit more detail on the facade, so as I said, brick was the primary material. You can see we've taken a typical bay here. This is from the planning drawings. We've essentially turned it into a giant warehouse. We've got piers within which we have infills. Those infills are formed of horizontal spandrels that have texture. We've got large full-height windows to get plenty of natural light into the space, and then a glazed side panel to it. let me flick on a minute. This is a detailed study of one of those typical bays. So the brick was selected to be complementary to the surroundings. We have a textured horizontal brick spandrel, which is formed of a sawtooth brick, alternating courses, and that picks up on the heritage of the area from the warehouses that we retain to the back of the site. We have very strong express sills and head trims, which again provide some visual interest, this large window that I mentioned. And then as a feature panel, which at one time we were thinking of using to screen natural ventilation, we have a terracotta profile panel, again picking up on that sawtooth idea. But it's quite a strong idea. This is a bay that then repeats across the facade. There's obviously a lot of, well, I don't know, I say obviously, there's a lot of articulation within the facade in terms of depth. So all these are on differing planes, with the piers and the head being the key plane that takes it through. Thinking about facade, when we were dealing with that, we weren't actually thinking about how we were necessarily going to do it in terms of prefabrication or not. So when prefabrication came onto the agenda, some of the issues that we were keen to think about or of concern to us were how we panelise this thing and where the joints come and how we deal with those joints. So that, oh, hang on, can I go back one? Yes. So this is sort of an extract from Thorpe's, one of Thorpe's drawings, showing their idea of panelisation. And this is us taking it to understand where we can position those joints and how we can deal with them in terms of size, location. Essentially, we don't like panelised buildings. We want to lose those joints. Corners were a particular interest. Those long views I showed up and down the street show how prominent the building is. Those are the ways you see it most often. So we were really keen to understand how the joint worked on the corner of those buildings. Then internally, we had a set zone for our facade. And we know these panels have to be hung with brackets. So there was a slight concern to us about how those might appear inside. We've got totally exposed surfaces, no ceilings to hide anything. That's an extract from the subcontractor drawing. And then finally, one of the other major concerns, which Lynn sort of touched on, we've got all these retained buildings and how we then detail and accommodate and adapt the precast system, the DFMA, to deal with those conditions. So those were our sort of key design concerns, which I think we then worked through with EOC. So I will pass over to Rocco.
Thank you, Pete.
No worries.
Hello, thank you, everyone. So now I'm gonna kind of explain how the process went for when Squire got involved, and we kind of been asked to redesign the building as prefabrication. So we kind of got involved for a stage 4 redesign, where basically we kind of finished as the building was proposed as Endley brick solution on an SFS with also terracotta rain screen, as per Peter said. And these were kind of the baseline detail we kind of were basing all our study above. And the first thing we kind of decided to investigate was how much we kind of extend this prefabrication feasibility study. And we kind of took the elevations from HMM and kind of investigated where this was applicable and where it was not. So all the areas in orange was where what we thought it was actually not ready to be prefabricated, especially for interfaces with the ground floor or with the plant room and the roof, or especially in the Blossom Yard elevation, where there was an elevation setting out that was not really allowing the joint to be really hidden and around the warehouse's existing building. In the end, actually, I think Blossom Yard was designed to be prefabricated, and we kind of studied where to hide the joints that were more visible than anywhere else. So during the prefabrication, we investigated 4 options, and the first one was brick and terracotta face precast. Then 2 optional with the UHPC, one with the brick only as a facing material and the terracotta as a rain screen to the curtain walling, or another option where the terracotta was actually part of the facing. And as a final solution, the unit ties with brick and terracotta face GRC as rain screens. And with these 4 drawings, we were trying to investigate where the weather line, the thermal line, the VCL line were kind of located compared to the different solutions, and how this was impacting the facade zoning or the slab edge location, trying to advise the other consultants on all the modification that this would have cost. And After that, we kind of compared those 4 options based on keeping the thermal performances of the facade as a fixed point, because it was already been modeled. And we investigated different parameters, which included the NIA impact. That was really one of the main points for the client. Architectural implication, both internally and externally, about materiality, joints locations, bracket locations, how the impact on the primary structure was, and then all other performances such as acoustic, weather tightness, and the logistical, like how many panels can you install compared to the different options, and as well upfront embodied carbon and the service life. And then the first thing that we noticed that the precast option, even though was looking very nice, generally speaking, it was kind of a big NIA impact, which was not really an option for the client, since the option of prefabrication was already an additional cost. But as well, since this was coming really late, we already having the pile on the ground, so the structure was not really able to take the additional weight coming from this option. The unitized option was excluded for architectural reason and embodied carbon primarily, because materiality change internally, the joint really visible externally, and open joint. Therefore, the kind of focus was in the UHPC. And the option where the terracotta was kind of a rain screen was creating more issues logistically and for installation. So we kind of opted in the end for both brick and terracotta as facing material to the HPC. And this is just how explaining a bit the sequencing on how we kind of decided with Thorpe as well to produce and install the panels. So the panels are coming as donut panels with the brick and terracotta face to the UHPC substrate and a bit of lost formwork insulation to kind of fill the gaps between the ribs. Then the curtain walling, stick curtain walling with the glazing has been as well as installed offsite in the factory. And then the panels were transferred, finished on-site, and installed via hanging brackets from the primary structure slab, and the additional insulation being installed internally, plus the internal lining. These are kind of some images just to show that the prefabrication was kind of straightforward, but then with a lot of heritage and existing warehouse buildings, we kind of have to deal with a lot of interfaces that were more difficult than just a movement joint between precast panels. And this one is one good example, because the image on the left-hand side is the vertical movement joint between the right precast panel and the existing masonry brick warehouse. And the other one is basically 3 layers, the new UHPC panel, the end-lay brick that is actually new, plus the existing masonry at the bottom. Another good example is in one of the warehouses, we had to kind of top some existing masonry piers with a precast beam to kind of replicate enclosing the facade that was actually supporting on a secondary steel that is actually as well supporting the existing elements. And finally, the most difficult part was restraining the panels that were actually interfacing with the slab of the existing building, where we actually couldn't really transfer any load or any force at all. So in one instance, we actually have an internal core or double height elevation where no slab was there. So we actually had to install a secondary steel hanging from the top that was actually supporting the precast panels. And to explain how we actually deliver it to Sophie.
Hi, everybody. So we've heard so far from Peter and Rocco about the aesthetic and the technical challenges and considerations that we had going forward. And it's only right at this point in time that we touch on our trade contractor Thorpe Precast, who delivered this for us on site. So early on, Thorpe were involved in these discussions. They came with a very open and honest attitude, and that confidence enabled us to go forward with the decision to go for a precast solution. So through the next few slides, we'll look at program, health and safety, logistics, and the quality of the construction as well. So fundamentally, going for a precast solution gave us a scaffold-free and fast option. This precast solution offered us a 40,000 person-hour reduction on site, which is huge. And a lot of that would have been working at height, working off scaffold, high-risk activities. And the reasons for that reduction is because Thorpe operate an extremely light team. 2 teams of maybe 4 or 5 people installing panels, comparing that to potentially 40 bricklayers that would have to do the hand-set brickwork. That also then reduced our risk or potential risk of being exposed to labour shortages as well, which I'm sure all of you are feeling as well. As mentioned, this is precast, so we were working in an off-site manufacture up at Thorpe, which is in Stoke-on-Trent. Really nice environment for the guys producing those panels to work inside in a controlled environment, and that also offered us a good quality product as well. So next, just to touch on how Thorpe deliver things on site. So it's just-in-time delivery. As you've probably seen for the earlier slides, we had no space on site to even store these panels, even if we had wanted to. Just-in-time delivery, lots of crane time, which made us susceptible to wind and the environment as well. And just to touch on, though obviously precast goes on with the crane, we do have a team post-install of those panels in the cradles, sealing those panels together. So there's a picture here of some of the abseilers working off one of the more challenging elevations where we couldn't use a cradle for the different constraints. And finally, the biggest benefit for us going down the precast solution was the program and the program saving. So comparing it to a hand-laid brick solution, we saved 16 weeks on the program. And there's just a quick time-lapse video to show you main S1 plot going up over a 3-month cycle. So it starts going in on the bottom right, and you can see it flying up extremely quick, even in those challenging winter months where you are affected a lot by the weather as well. We also, touching on it, had the window installation off-site at Thorpe as well. So another saving on the program, and also logistically of not having that window installation happening on site, and another high-risk activity that could be done in a more controlled environment. Next, looking at quality, as mentioned, factory conditions, perfect for even inspecting it. It meant HMM and EOC could come up to the factory and see those panels before they even arrived to site and critique things. With Thorpe's open attitude as well, any changes that did need to happen were discussed, and it was implemented very quickly and with ease. Again, with the window installation off-site, we could critique those items, so it meant a lot less snagging when we finally did install those panels on site. Just to touch on, this is a CGI here, and I'm just going to compare it to some of the items Peter discussed earlier. So the corner joints, this is a real-time photo. You can barely pick up where those corner joints are. If you know, you probably know, but hopefully not many of you can pick up where those joints are. The brackets, which were a concern initially, but with the exposed surfaces, again, you don't really read them as much, and they kind of fit in with the overall industrial look of the space as well. And Rocco's point in our interaction with the heritage frontage. So on the far right of this image is the precast panels, and we've got a small shadow gap there using the same brickwork as the precast, but is infilled by hand set. So some items we transitioned with a small shadow gap, and it kind of highlights those warehouses as well, reading from the kind of uniformity of the precast going into that the warehouse's facade as well is a good comparison. In some instances, like Rocco's shed, we could butt up directly to those panels with a small gap. And as Lynn mentioned at the start, we had 6 different plots across the whole site. We had to take a judgment on where precast would or wouldn't work in those elements. And the whole idea of the project is to have a different rhythm and feel across the whole project, and hence why we didn't go for a precast across the whole project, but there are elements of it, and that gives it a different flavour, a different feel, which is really good. So fundamentally, just to summarise on the construction side of things, we saved 16 weeks on the programme in comparison to going to hand-set brick. That equates to kind of 40,000 person hours reduction on site. Maximised the NIA by going for those really slender ultra-high performance concrete panels, and produce a high quality product due to those factory conditions that they were being produced in. And that's it. So thank you very much.
Thanks. That was fantastic. Thank you. we haven't got time for too many questions, but I thought I'd just pose one question to the whole team and get the different perspectives from the different parties. So, with the 2020 benefit of hindsight, we went through this whole journey, some of us for 10 years, some of us for 5 or 6 years. Would you do it again? And if you were going to do it again, what would you do differently? There's many lessons to be learned here, but maybe we can come back from Sophie back along the order. But,
So I'll start with that question. So as mentioned, we did an analysis of where we should or shouldn't be going for a precast solution. And for me, on site, there were potentially some elements that could have benefited from going from a handset than precast, namely the one that kind of Rocco mentioned with that topping, capping beam element that interfaced with the existing. That was extremely challenging for us and was towards the end of the project. So there were elements where we could have picked up on had we had maybe the site team reviewing some of those earlier elevations that were scoped out to Thorpe. But again, definitely do it again. It was a lot easier, really easy to manage, a smaller team on site, and ensure their health and safety and reducing the amount of hours people were working at height, including myself, looking at the stuff as well. So, yeah.
Great, thank you.
Yeah, I think we would have done it again. I think the prefabrication was the way forward. It's always been like a really kind of easy setting out and really easy to panelize project. So definitely would do it again. Maybe sooner, the better, as we noticed on site that a lot of interfaces were not the major topic that we investigated initially. So a lot of interfaces, we had to come on site and see how to solve it because we didn't thought in 5 weeks initially how to solve it, but definitely do it again. And also considering the UHPC solution in the end was the one selected. Normally when we do for prefabrication, we do unitize or precast rather than UHPC because UHPC really is much more expensive and really limit the kind of battle of the tender because it really limits the trades that can actually bid for it. So we normally go for precast, and this was actually our biggest and first UHPC project. So it actually was a challenge and an opportunity for us to investigate the new material. So do it again for sure.
Yes, so as everyone said, it came in quite late in the day, but I think our design was robust enough to deal with the challenges of panelisation in terms of hiding joints and so forth. I think as a process, I really enjoyed it actually coming quite late because it made us all work really hard collaboratively and work in a more flexible, fluid manner, which actually was really pleasurable to do. And Skanska pushed this. They were really keen to do a precast, prefabricated facade from the outset. And we said, yeah, we're really interested in this. So I would definitely do it again. I think if we could have done it slightly earlier, it would have had benefits in terms of some of the fine-tuning of coordination and so on, which was quite challenging. And yeah, bits of MEP coordination with the facade. So I think we could have, the sooner you know, the better you can design to accommodate and deal with it. But yeah, definitely do it again. Very happy with the outcome. And the quality was exceptional. Really good.
Good. Lynn, the client's perspective.
I feel like I shouldn't say yes because everyone else has suggested. And probably on a similar line. So yeah, definitely do it again. I joined the project in 2017. The first thing I said is this is a prefabricated project. So you could just see it. We could never get the numbers to work. And part of the reason we couldn't get the numbers to work is because we were looking at precast options rather than UHPC. So I think at the point where Skanska joined and started talking to us about that, it enabled us to do that. And although I would have wanted to do it earlier, maybe we wouldn't have gone that route if we had done it earlier. So, which is a bit of hindsight. But I do think we would never have got where we got to with it in the time we did if we hadn't all had a team that we'd got really strong core values on the project. We selected Skanska because they fitted into that. And we worked with Thorpe in a really open way, and they joined that team in with the right attitude. And we even went up there to make sure they wanted to work with us. It wasn't just did we want to work with them, did they want to work with us? And I think because we set it up that way, it made it more successful. So I think any of these things, when you do them, it's about getting the team working together in the right way to make it more successful.
Yeah, no, thank you. I don't know if we've got time for any more or if we're running behind. We can keep going. 2 minutes? Okay, well, along the similar lines, I think, like we said, it was a 10-year project, and there was a lot of potential, I guess, design fatigue in the team after 8 years. and a lot of decisions have been made along the way. So I guess a question to Sophie, did you need to change people's opinions? Was there much of a battle you had to have about the prefabrication, getting it on board in the first place?
I think for a lot of our team, it's maybe the first time they'd been exposed to precast in that scale as well. So once we get rolling and delivering it on site, then people are on board, obviously. But initially, that changed to what was potentially normal for people. We had to do quite a bit of engagement with our health and safety teams with these huge panels that were coming into site, people working on lanyards on the edge of the facade, as you saw in some of the pictures, but which was a change to the norm. But getting them on board, then witnessing some of those early panels going in, making sure they're happy with the method, and maybe even tweaking it with Thorpe if we thought the need was there, before then going into that big scale of rolling out all the panels in quite quick succession was key, I think, early on.
Yeah, I think, well, certainly from talking for Rocco, I suppose, EOC's perspective, it was very much preaching to the choir in terms of adopting the panelized approach. Yeah, I don't know if anyone else, do you feel any resistance to it, or is it?
I think we were particularly concerned about making sure that the architects came on the journey with us, because making sure that you couldn't tell it was prefabricated was really important to us. So I think that was probably our biggest challenge. And also, we'd got a lot of local community members who were really invested in the project, so making sure we didn't then deliver something that wasn't going to work was also really important.
Yeah. Brilliant. Well, thank you very much. I guess that's the bell. Appreciate everyone who's come to Track B to listen. Thank you.
Thank you.
Thank you.
Thanks you to the panel. For everybody else, it's tea and coffee break. So short break before we get into the last session of the day. Thank you.
Lovely to see so many familiar faces. I'm going to crack on. I'm also going to be very strict on timing. Ahmed, I'm assuming we've started 15 minutes after the original schedule. So I'd firstly like to introduce Peter Fisher. Peter is at Bennett Associates and pioneers sustainable projects. Peter studied architecture and environmental design, a great two things to do together, and has taught and lectured extensively on architecture and sustainability. He is currently involved in several zero-carbon projects using timber and reuse, and is currently working on Timber Square in Southwark. Peter is going to present Facades and Upfront Carbon, Is Curtain Walling Dead? So all of you in the aluminium industry out there, be aware. Thanks, Peter.
Thank you, everybody. A bit like I might be walking into a hornet's nest. And the one thing I'm not going to do is answer that question. Is curtain walling dead? I don't know, is the honest answer. But this is the, musings or reflections on where we are, and quite a bit about where we've come from. I think one of the most interesting things in architecture is actually architectural history, so that we understand where we've come from, and we learn a lot of lessons from that. And at the moment, there's lots of things. We're just having a conversation about circularity, and this applies to so many things where we talk about net zero carbon and circularity as though they're new things, and they're not. Not being circular, not being zero carbon, those are the new things. And so a lot of the lessons for us actually lie in the past. And so at a facades conference, I'm going to start with the Great Pyramid at Giza. It's estimated that the carbon to build this is the equivalent of a small office building in London today. And all of that carbon was biocarbon, not fossil carbon. And yet it was the tallest building in the world for about 4,000 years. And if we look throughout almost all of history, we're just in a blip, the carbon blip at the moment, all the way through history. The pyramids, the Romans, medieval cathedrals, along the bottom, time. We were zero carbon, net zero carbon. There's no fossil fuels being used. And it's only really when we get to the rebuilding of London after the Great Fire, the early Georgian period, where we started transporting coal from Newcastle down to London, because it was much easier to do that, to make bricks just outside London, than it was to transport stone, because we could use water. And that is the beginning of the carbon age that we're in. And we need to rapidly decarbonize. I don't think anybody in this room would disagree with that. The simple question is, how do we do it? And many of us don't know. It's a conundrum, it's difficult. Part of it is about looking backwards. And you will probably often hear the built environment is 40% of carbon emissions. The construction industry portion of that is 11, 12% of all carbon emissions, more than double aviation. Now, there are lessons in buildings like this. Presuming, I'd be interested if anybody does know what this building is. I think it's probably the most significant building of the 20th century. It's called the Millen Building. It's in San Antonio, Texas. It was built in 1928. And it's the first building in history for human habitation that had air conditioning. Air conditioning had come out of the meatpacking industry, particularly in Chicago. And this was the first building that applied air conditioning to it. And it's interesting for many reasons. It's interesting for what it unleashed. It's also interesting for how it itself was. And at this point, air conditioning was merely augmenting the environment of the building. The building isn't totally dependent on it. It's got small windows, it's got opening windows, it's got thermal mass, it's got lots of brickwork on the outside. If the air conditioning in this in 1928 broke down, the building would still be habitable because it was broadly like all the other buildings being built in Texas at that time. It was habitable. It wouldn't be quite as comfortable. But it unleashed loads of change. And then we move forward. Well, actually, we don't. The first image here is 1928. Just for clarity, I've done this before, and some people think I'm having a go at Mies. I will say the only fridge magnet on my very crowded fridge at home that I bought is a quote by Mies. I love Mies's work. And I would have been as wrapped up in this in the 50s as everybody else. But we start on the left with the Friedrichstrasse competition in 1928. This was a competition that Mies did. It's one of the most iconic images of modernism. Had that been built in pre-Second World War Europe, it would have been uninhabitable. We had the cladding technology, we had the structural technology, we had the lifting technology, but in comparatively poor, comparatively technologically backward pre-war Europe, we didn't have environmental systems that were beginning to emerge in America. So that competition, I got quite a lot of myself there. That competition could not have been built. And yet we wind forward to 1958 in New York, and Mies can then build the Seagram building. And that remains, in my view, one of the most beautiful modernist buildings built. But increasingly, the building was separated from its environmental systems. In effect, architecture was liberated from the need to temper its environment. And that allowed architecture to completely ignore its environment. And then you get forward, I happen to have put in Michael Gray's Portland, Oregon building. You get postmodernism. The architecture is literally becoming paint on the outside. It is wafer thin. Architecture has lost all its meaning, its tectonics, any relationship to its climate. And that has unleashed something hideous all over the world. And now we have often completely rootless buildings. They're the same all over the world. They look the same. It doesn't matter whether they're in a desert, whether they're in the Arctic. They're beginning to look very, very similar. Cities look very, very similar. And that tells us not anything about a solution, but it does tell us what the problem is. And we cannot have internationalized solutions. We can have internationalized technologies, but I think many of the solutions lie much, much closer to home. And if we begin looking back, I think there are incredibly profound lessons to be learned from vernacular architecture. And very often, vernacular architecture is responding both to local climates and also to resource availability. And that is telling us a huge amount about how we can lead more environmentally benign lives. And whether it's extremely arid, extremely hot climates with massive diurnal swings where we're losing local mud, or it's very, very humid tropical climates. And we could go on and on and on. We could just do an entire encyclopedia on vernacular architecture, the materials they're using and the climates that they're responding to. And that gives us many, many clues in many respects. And then I was just going to come on to this image. Now, the graphic on the left-hand side is a series of curves done by a physicist called Nick Baker in Cambridge in I think it's the late 80s, early 90s. And he was trying to develop some curves that were about glazing ratios. And I was a student of Nick Baker's. And I was very excited by this idea that, dependent on what you were doing, where in the world you were, which way you were facing, that buildings would be modified and tempered really by climate and their response to climate. And this was taking into account everything: heat loss, heat gain, loading, heat loadings, daylighting, etc. And we did quite a lot of parametric studies of this. And the slightly disappointing result, in my view as an architect, coming out of that was it was almost always the same answer, irrespective of where you were, what you were doing inside the building, and which way you were facing. And that answer was somewhere usually between 30 and 50%. And hey presto, that is a Georgian terrace house. They're almost always about 35 to 40% glazing ratios. So in a sense, we know what the answer is. That is probably where we should be going, not aesthetically, but that's probably where we should be going. That's probably always where we should have been. But we have a problem about a culture of how we build and how we conceive buildings that probably prevents us doing that, certainly in temperate climates. And then today, as we move into a world that is much more understanding, certainly of its impact, if not what it can do about it, playing that with new buildings, playing off operational and embodied carbon becomes very, very interesting. And these curves are altering quite a lot. What this is showing across the bottom is ongoing operational carbon emissions from a fairly typical British office building. And it's declining slightly due to grid decarbonisation. The dotted line is then the cumulative carbon emissions from that building. And what you see is that the upfront carbon and the embodied carbon, or the upfront carbon, never, ever meet. And all of the pink carbon on that side is emitted before you even occupy the building. So people will be familiar with that as a notion, but I think the differential between them is absolutely vast. And that's probably where curtain walling and the facade systems that we use have the biggest issue. Now, what we do know is things are changing. They're changing fairly quickly, and I think we've got to move very, very quickly. And one thing that's going to help us, I think, a great deal is the net zero carbon building standard that's been worked on at the moment. That's going to give us clear science-based targets for both operational and upfront carbon. And I think that will probably become a standard. At the moment, there are many, I often talk about net zero carbons in the plural. That's probably going to give us a singular definition across at least 13 different sectors. And when we start to look at the impact of facades, it's generally, we think, somewhere between 11 and 15% in most cases. And I would say in the last 5 years or so, we have made enormous strides on superstructure, less so on substructure, but on superstructure, the move to biogenic construction. So that portion is slimming down considerably. I'd say we're halving it at least. The facades generally haven't moved. And there are mutterings, but the facades have more or less remained the same. Bar one or two slight changes of emphasis or nuances in recycled materials. But it's probably about the same, but proportionally, it's getting much more significant as we make greater inroads into what are the much, much bigger proportion. So we've been trying for a while to get to what will our target be? What do we need for the surface area of facade as a target? And if we work through the Letty targets at 350 kilograms of CO2 per meter squared GIA, and through general facade areas, floor-to-wall ratios, we get to a target of somewhere like 150, probably closer to 100. Now, as many people in the room will know, 100 kilograms of CO2 per meter squared is basically a double-glazed unit with nothing else. So that's the challenge that we have. And so what we've been doing is working through a series of parametric studies. The intention is not that anybody can read this, rather that what this is doing, we've realized that the substrate is actually way more important than the cladding itself. Across the top is a cladding type, down the side are substrates, and curtain walling, of course, is all of those. And you will notice these are loosely based on as-built projects of our own, or projects that are in the office. And there is nothing in the curtain walling world that comes anywhere close. These are all 300. The best we're getting is 250. The only one that comes anywhere close is on the right at the extreme left-hand side, which is the
my left-hand side, your right-hand side, which is beginning to look at timber unitized systems. And I think we're really not there with that. Frighteningly, if you were religious about the carbon on this, probably the best outcome is hand-laid brickwork on an SFS backing. And that is certainly not where the future of the industry is probably headed, or probably should head. But if you were religious about carbon and nothing else, that's probably where you would go. So I said these are some sketches of a recent project where we're working through different substrates mostly, and it was the brickwork that comes out best. That, incidentally, is not what we're doing because of the way in which it is built. But as said, I think we're making significant improvements on structural carbon. We're making much less progress at the moment on the facades. And they said, we do know that there are curtain walling systems becoming available. There are timber ones that are, well, they're sort of getting there. But every time that those come on stream, we're not doing very much in that world, despite trying. And we think the carbon improvements are probably about 25%, but that still doesn't get us close to that 150 target that we need. And we think that there are some fire compliance issues around those. And again, this is embryonic at the moment. I still don't have available data that I trust right now around systems such as this, neither on cost nor carbon. But they're definitely headed in the right direction, I think. But whether or not this is actually the answer, I don't really know. I think it might be making the problem slightly less bad, but it is probably not the answer. Now, I'm coming into probably the last three slides at the moment. The reason for putting up this is an office building that we're working on at the moment. It is a mass timber structure. It's a 9-story building. We're at stage 3. It's got planning. About 40% of our workload as an office now involves structural timber in some way. And I think if you go back only 5 or 6 years, if you'd said that we would have mass timber commercial office buildings, I think that would have sounded slightly deluded. And it simply wouldn't have seemed real. Yet we're at a point where about 40% of our workload is exactly that. So the penultimate slide, is stuff that we're actually looking at the moment. And some of this probably seems completely unreal at the moment, or naive, and I think some of it probably is. But I think we've got to keep our eyes on what those might be. And we are looking at rammed earth on the outside of buildings up in Edinburgh. We are beginning to look not just on a private house, but increasingly on a 6-story office building at using modularized straw. And that, if you begin to think of it as a SIPS panel with a different insulation, becomes psychologically slightly easier to handle. And the final one is a couple of buildings that we're looking at now, which are using structural stone with cross-laminate timber structure inside and nothing else. And once we do that, that is very low carbon. That gives us a bit more to play with when we get to the glazing. And so the final thought, really, I said, not answering my own question posed at the beginning of this, but these are a couple of buildings. Wessex Water, which is over 20 years old now, where we reopened a quarry. We were able to use local stone on that one and elements of curtain walling. And then a project in the city, which it's not actually structural stone, but this is something that we're looking at the moment, replacing the concrete backing to this and holding up the building with it. And I think that may be one of the answers going forwards, but I'd be very interested in other people's views. Yeah, I think the answer to my own question that posed at the beginning is probably just 3 dots and a question mark. I still don't know where this is going, but I hope that was of some provocation, but not too much. Thank you very much.
Peter, thank you very much. I think there's a lot of food for thought there. Maybe it's more of a matter of we need to rethink curtain walling and how it's used and the other materials we use with it. So a great discussion. Peter will hopefully be available a little bit afterwards if the curtain wallers would like to discuss it further with him. Sorry, just one reminder to all the speakers. I have been asked if after, at the end of this session, if you can all remain behind just to receive something from the organisers. So I just wanted to put that in. Our next talk, I'm very glad to say, is Glass, A Circular Journey. And that's being presented by Brodie, Isaac, from McLaren. Brodie is head of sustainability at McLaren Construction. He specialises in decarbonation of site activities and the delivery of net zero carbon buildings in construction. Brodie has won the Sustainability Champion of the Year and Sustainability Strategy of the Year awards at the Shift Sustainability Awards. We also have Claire Tribe. Hello, Claire. Claire started her career as a quantity surveyor and has spent the last half of her career in a pre-construction role, focusing on design and procurement of major projects in London. Claire has developed technical expertise in procurement of facades. Claire is very interested in sustainability. She was shortlisted for Best Woman Contractor at the Women in Construction and Engineering Awards and awarded a Group Chairman's Award for Building Sustainable Communities, Community Legacy. Welcome both of you. Thank you. Do you want to come up and You've got 20 minutes.
So I'll just introduce McLaren first of all. So we're a £1 billion company, principal contractor. We're working on Portland House, Landsec, one of their big ones, IKEA on Oxford Street, and Excel, just to give you a few. But we have a problem, not just McLaren, but the construction industry, and that is that 1% of all building waste goes back into a building. I'll just let you think about what that actually means. So all the material that we're putting into the building, 99% of that has come from virgin sources. And what we're trying to get at is to a circular economy. And you can see that the linear aspect is where waste will come straight out of a building and then back straight either into some other types of form. Recycling is great, but it eventually ends up either in landfill or in some other low source recycled terms. But the circular economy is where we want to get to. I'm obviously telling everyone to suck eggs here, but using it again and again and again, where we have a finite planet, that's where we need to get to, because that 1% isn't going to cut it. The London plan is really trying to get at this. With the circular economy statement, we've got it comes up forward with 20% recycled content is what the challenge is. It doesn't stipulate whether that should be recycled or reused. The recycled element is really helpful when we're purchasing material, but if we're thinking about the material that's coming out of buildings and that 1% that we need to get back, there's a real challenge there. So a lot of you probably know what this is. Marks and Spencer's in Oxford Street. A lot of this in the news at the moment. The first time that the government has quoted net zero carbon 2050 targets. Apparently, it's not in line with them targets. And that's because of the embodied carbon, which we heard about earlier, and the reuse aspects of it. This is pinnacle. It's the first time it's ever happened that sustainability legislation is stopping a building being developed. Think about the reuse aspect and how that's going to have a knock-on effect. Claire.
Okay, so today we're here to talk about, which you have probably heard about quite a lot this morning, that zero waste hierarchy in terms of the reuse down to the disposal. And when we first started this journey, there was a lot of feedback from the industry. Yes, we recycle. Yes, it gets recycled. When you probe that into it, the actual material was either being downcycled, repurposed, or disposed. On the next few slides, I will give a few examples. So I think the only example currently that exists for successful reuse, I know there are some projects in construction at the moment, is British Land's Triton Square, which is on the right-hand side, which has reused all of the glazed and aluminium units into the new build. Then we have the recycling, which is effectively the only contribution to low-carbon glass, which is end-of-life material taken off dismantled or demolished buildings. And then probably the most common themes at the moment of where the glass goes is either downcycled into glass bottles or repurposed into road coverings, also into items like mineral wool, etc., on new buildings. So where are we now? So I'll pause on the picture on the next slide in a second, but effectively where we are is the pre-consumer waste from the production closed environments that are quite hygienic, going back to the processing is really working, and that has been working for many years in terms of waste cut-offs on the pre-consumer lines when the units are being manufactured. What isn't working very well is once we've built the buildings and they've been in use and they've reached the end of their life, is getting that post-consumer material back through the value chain, back into the production lines, into new construction materials. So I'll just pause on this slide because I think this picture here shows exactly the reason why it's difficult and why it's a challenge in terms of the whole logistics piece that we'll come on to. Here you can see a picture taken at Ali Trade. At the front here are the windows from Chalcott's estate, which are effectively the post-consumer material. In the rear, you can see the pre-consumer material. So you can really see the difference in the demolition material that we're taking off the buildings and why it is difficult to get this material back into the new products. Then in terms of why we got on this journey, this is probably a bit of a historic slide that David will update everyone on later. In terms of Saint-Gobain's figures, I think this started 2 years ago at Zak, and that's how we entered into this process with Saint-Gobain to help them increase their post-consumer cullet, which is currently was at the time running at less than 1%, but we'll get an update on that later this afternoon.
So we've gone through really the problem, bit of like the methodology, and we're trying to get to that circular aspect away from the linear, but then what's actually being done? And this is what we're here to talk about. One of the projects that we're working on, Chalcott's estate, London Borough of Camden, 4 23-storey tower blocks with over 3,500 residents in situ. So they're there, they're not moving it, they're not coming out. What are coming out is the windows and that aluminium facade. And you can see some of the numbers there that we're talking about. This is post-Grenfell. You know, the cladding had to come off, putting it back on. There's a lot of reuse items here that we're trying to promote. But we had a problem. London, so we were powering with Saint-Gobain and Powerday and Ali Trade for the aluminium, but we're talking primarily about the glass with Saint-Gobain. The logistics. London, the red one is Saint-Gobain. How do we get it up there? And also, how do we process it? These are the main barriers when we're talking about circularity. And that 1% is how do we get it out, process it, back to the manufacturer. This is just a nice little diagram of the linear economy would be the waste bit coming out the bottom, the circular going back to the manufacturer, and up Saint-Gobain, Powerday, Ali Trade were helping us in there.
Okay, so then just a bit about the process that we undertook at Chalcott's. So effectively, we purchased one of the Merlin lasers, which you can see on the screen there, relatively cost-effective to purchase, and we effectively went round and audited the circa 3,500 windows. Obviously, at the time when the project commenced, the monolithic glass was the primary focus for recycling, and fortunately, both panes of glass in most of the highest percentage of the building were monolithic, so they were suitable for recycling. So from that audit, we established that the glass could be recycled. Oh, back. So then the next part was dismantling the units. So as Brodie has said, we went through a number of journey that's here. It took us about 18 months to get this process sorted. Originally, we were looking at sending the glass back on stillages in one piece. In the end, we partnered with Powerday to put a processing factory in their North London facility to be able to process this glass. So effectively, we take the glass out on stillages, and we now are loading those onto timber pallets that then are effectively stored in skips. So on here you can see we have segregated the waste. So on the left-hand side is the Powerday skip, which the glass is put into, and then on the right-hand side is the aluminium frames that then go to Ali Trade in a separate skip. So we segregate the waste at site level. Then, in terms of the processing, this is the machine, which is a Saint-Gobain processing machine that is at Powerday's facility. That glass is taken in the skips to Powerday's facility. They then process that glass into what we could see cullet on the left-hand side into bags. Then I know we're primarily here talking about glass today, but I think it's important to know what happens to the aluminium. That is effectively goes to the Ali Trade facility in Birmingham, and then that goes through a shredding process. And it's worth noting that every part of that waste is actually recycled in some form, and then that is sent back to remelt to hydro. Then the glass from Powerday's facility is bagged into the tonnage bags and picked up on return deliveries from St. Gobain. So when they deliver the sheet glass down to the processors on the return journeys, they pick up those bags on specially adapted fleet vehicles that take that material back up to St. Gobain's facility in Eggborough and goes back onto the float line to post-consumer material into the new glass production.
So that's really important, the process. This just doesn't happen overnight. This is something that needs to be worked at, and working with supply chain partners, a lot of technical knowledge, the likes of Powerday, and like how the material needs to get there and what state it comes in is really important. So just to give, we estimated on how much carbon we were going to be saving. Just for those out there who would like to know, 1 ton of cullet equals around 700 kg of carbon savings, and that's across its life cycle. The project is going to be aiming to recycle 90 tons of glass, which equates to 63 tons of carbon, which could power and heat 24 homes for an entire year. Where we're currently at 10 tons of CO2, 10 tons of glass with around 8 tons of carbon being saved. So there's still a long way to go on this process. But it hasn't been plain sailing. All the process that we went through there seemed quite straightforward, but we've learned a lot of lessons along the way. First of all, the one on the left here, this was the first delivery that came to Powerday. There was broken glass all in the bottom of it. That had a shovel, and then it was put into the bag, which is what you can see here. It's safe to say that St. Gobain were not very happy when that arrived, because you cannot put dirt into their glass manufacturing process. Also, we started to get, it was smashed, you can see that, and then it started to get better and better throughout time when we were having to go through it. Again, it was being kind of discarded not very well. Lots of other bits of trash were in there. You can see some like tape or something like that at the bottom. But through a lot of work with the people who were operating it, the waste contractors who were dealing with it, we managed to get it to that top right picture. And finally, where we managed to get it at optimum levels, this took a few goes to get it like this. We put it on the wooden stillages. So we had a forklift being able to take that in and out of the back. And we also tied it as well, so it wasn't going everywhere and breaking during the transport. Now, we've got a process that works, that I think is relatively simple to follow. But what's next? So this is really a unique selling point that McLaren is bringing to the market. It's worth saying that this is now available for everyone, and we're going to talk about contact details if you're finding this interesting about how to get involved. But yes, Spring Gardens, we've just managed to confirm that we've won this project. There is some film glass on there, but we've been able to highlight that this is something that we're going to be able to do on the project. It's helping us with work winning, and every client that we're talking to, like the landowners, the developers, who are refurbing their projects want to know about this. There are still challenges, though, for the industry. Film glass and laminated glass are still throwing up a lot of issues, but David's going to be coming on from St. Gobain later. I can see him flexing his muscles at the back there, about how we're going to challenge this as an industry. But this is my most important slide, and the bit that gets me excited. The scalability of this. What we've done, yes, is innovative, but at a relatively cheap cost, we've been able to open up reuse in one way to the London market. So everyone in the room who's either dealing with a retrofit project, is getting glass or a facade taking off, this is something that you can do now, albeit within London. But there are individuals who we'll talk to. I'll show you their contact details later about who you can talk to get something set like this up outside of London. So just a bit of a summary then from everything that we've spoken about. Early engagement in this is absolutely key. because where we're going in and talking to clients and the demolition contractor has either already been signed up or the contract's been agreed, reuse, whether we're talking about glass, steel, aluminium, plasterboard, it's usually just being ripped out, thrown into a skip. It might be segregated, but this does take planning. And if you're going for the cheapest option, reuse is not the route to go, then that's just a fact. But we obviously realize as an industry, we need to get better at that. Collaboration, we've already highlighted Saint-Gobain, Power Day, Alutrade, but there's loads of reuse schemes out there. And it's not just to do with glass. There's a lot of other building elements that we need to be looking at as well. I've touched on the scalability bit and how that we all need to be able to we can all get involved. The journey is certainly not over. Let's really challenge that 1%. We need to get better. We're a finite planet. 1% of waste coming out of a building from refurbishment isn't going to cut it. And that's where the industry investment and involvement gets. Everyone in the room can in some way push this agenda so we can challenge that 1%. So this is the bit that if you wanted to get involved in this, these are the people. I'd say take a photo now if it is something that you think you can get involved in. Anthony Davitt from Power Day and Richard from Saint-Gobain. David, I left you out because you're coming up next. Thank you very much.
Thank you.
Thank you, Claire and Brodie. That was fascinating. And I really do think that you've shown that it can be done. It'd be really interesting, actually, to get from you an idea on how much it added to maybe the demolition programme. Would be fascinating. Maybe some people can ask you afterwards. But I think it's fantastic. So often in construction, we'll say it's too hard to do. But no, you guys have shown it can be done. Anyway. This works very well because, as they said, the lovely David Entwistle, I may say this, I have known David for well over 20 years, is going to talk to us about sustainable glass solutions for building envelopes. David is head of major projects at Saint-Gobain and has been involved with the London facade community for many, many years. Not only at Saint-Gobain, but also working for specialist facade contractors on complex facades. I changed your bio to say you have recently completed the MSc in facade engineering. David is passionate about sustainability and improving recovery of end-of-life glass back into building glass. So David, please do come up. And you've got 15 minutes.
That's impossible. 2 years I've stood on a stage at this event and talked about recovering end-of-life glass. I was about to say, people say I go on like a crack record, but it kind of ruined the joke because the record wasn't on the screen. But anyway, let's try and move on. So, life is about choices. Anybody recognise where this is from? So 1999, a film came out called The Matrix. It was a film about people in dodgy overcoats with sunglasses on, fighting against people in dodgy suits with sunglasses. They weren't real people. And what they were actually trying to do is they were actually trying to defeat artificial reality created by machines that was controlling people. Does that sound like AI to you? Maybe. And so we have this scene where Keanu Reeves, who plays Neo, meets Morpheus, played by Lawrence Fishburne. And he holds out 2 pills to him. And he says, are you going to choose? And these are the words he uses. I can't do accents. But this is what Lawrence says. This is what Morpheus says. He says, you can take the blue pill. The story ends. You wake up in bed and believe whatever you want to believe. You can take the red pill and you stay in Wonderland, whatever that means. And I will show you how deep the rabbit hole goes. So what am I saying through this? That's a very good question. There's a few people sitting there going, where the hell is this guy going? So it could be that I'm giving you a choice. And I might say, you might learn something today that means you might have to react. Or you might learn something today and dismiss it and go back to acting as normal. And what do people say? They say, stupidity is doing the same thing and expecting different results. So what has got to change here? I might also be saying, well, maybe I'll give you a choice today. You can have a choice between a nice corporate video, waterfalls, blue sky, green fields, or I can actually talk to you about the real challenges of getting commercial glass on buildings in London. Maybe we should have buzzers on the desk. You can choose which you'd like to see. It can be the nice corporate stuff on their seat, or would you like to hear the real stories? Well, I'm going to assume everybody here wants to take a red pill and hear about the real stories. Yeah? Is that a fair assumption? You can give me a bit of feedback if you like, it's okay. So, some of the challenges we face, and again, talking about reality, talking about what's actually happening. I'll just give you an example of a few challenges. It's fantastic today that a number of companies within our industry, within the glass industry, are producing a low carbon glass. And obviously, more EPDs are coming out as time goes on, which is great, which is really important. And on the one hand, it's fabulous. What it's doing is it's proving the actual benefit, the immediate carbon benefit of using cullet in glass process in terms of its carbon reduction. So that's the positive. What's the negative? Well, the negative is the average recycled content, end of life in new glass, whether it's low carbon glass, whether it's stone glass, is less than 1%. So, hold on a minute, we're being sold this slight dream, low carbon glass, but what you're actually telling me is the end of life content is minimal, to say the least. And the answer is yes. That's what's happening. So what's happening is we're all fighting over pre-consumer, which is the stuff you buy from the glass processes. We're all fighting over pre-consumer glass to make a product that we're calling low carbon. Now, I don't want to throw the baby out with the bathwater because it's important because we're proving a principle of the immediate carbon reduction of a high recycled content. But where we get the glass from, well, you might struggle on some. Find the truth. But the fact is, that is where it's at. Can't hear me at the back. It's funny, nobody's ever accused me of having a quiet voice in my entire life. But anyway, there's a first time for everything. All right. And the last thing I want to say, before I move on, because time is ticking down on me very fast, the last thing I want to say is that, you can get... One thing I've been talking a lot to people about is that we cannot disconnect low carbon from circularity. And it sounds a weird thing to say, but it is possible to make low carbon products by using renewable energy, but they're not recyclable. And for me, a key part of our strategy going forward has to make sure that we connect circularity with low carbon, because if they get disconnected, we make ourselves feel better, but we're still digging loads of stuff out the ground and using up valuable resources. So it's really important that we tie the two things together. Anyway, let's move on. So we're going to talk about a study from 57 interviews, in-person interviews for 1 hour, and we're talking about interviews with clients, we're talking about meetings with developers, architects, main contractors, facade consultants, demolition contractors, waste management companies. So we've done our research. I want to talk to you about how that affects how we look at scopes and what that means to us. Scope 3 is a real game changer in our industry. And then we got embodied emissions in there as well. And then the last thing is just what does that mean in terms of a strategy for recovering end-of-life glass? And what are we doing about it? And the fact is, we are doing stuff about it, and we will hopefully tell you more about it. We're now working. All right. So the first thing is I want to talk about the results from the study that we did. So, I just finished MSc qualification. I graduate end of November, which is fabulous. And one of the things I did for my dissertation was interview these different groups that you can see up there for an hour, talking about what they would do about end-of-life glass, why wasn't it working, what could we do. And you can see 14 clients. And just to give you an idea of the people we talked to, and these were all director-level people, we talked to people like, I can't even find my list now, British Land, Argent, Land Securities, Great Portland Estates, on and on and on. All those sorts of people were the people that we actually talked to.
about this subject and trying to get their opinion. So what I'm going to try and do is I'm going to try and actually distill down the responses they gave into 5 questions, and we're going to run through each one of them in time. So the first question we said was, what happens to end-of-life glass? Now, across the whole range, most of them identified that probably the demolition contractor did something with it. But when we kind of dug a bit deeper, said, well, do you know actually what happens to your glass? End-of-life glass of commercial buildings in London. 50% of the responders were honest enough to say, we don't really know. Now remember, less than 1% of end-of-life glass finds its way back into new building glass. So where the hell is it going? 50% of the responders didn't know. Is that shocking? Is that surprising? Don't know. And then basically the rest of the people just came up with various answers about being crushed, segregated, etc., going to landfill. 50% of facade engineers thought end-of-life glass was going to landfill. Not really in London. And then 50% of client developers thought their end-of-life glass was being segregated on site, but they couldn't actually prove that it was, which was kind of interesting discussion, perception versus reality discussion. All right. There we go. So why is glass not recycled? So virtually everybody used this phrase, and it's a really interesting phrase. They said, there's no reverse supply chain. Now, when you said to people, well, what do you mean? They just said, we don't know who to go to. They couldn't really express what it really meant. They said, we don't know who to go to. We don't know what to do. Who's going to deal with it? And then obviously time and logistics were part of the issue. For the facade consultants, technical issues became quite prevalent in terms of, well, what do you do about contaminants, and everything else. But this point of the lack of a reverse supply chain has become very much a theme of how do we actually move forward in this area. So for the client group, and the client group are very key to unlock this whole situation, 93% of all their responses revolved around lack of a reverse supply chain and time and cost. And you kind of would expect it, but it's good to actually realize that those are the key issues for the clients. And so what does that tell us? Well, we'll come back to that in a minute. What's driving current practice? Well, we know that within London, and it's been talked about already, the planning requirements, the circular economy requirements, pre-demolition audits that make assessments of carbon. People are doing stuff about the concrete, people are doing stuff about the steel, and as you start to go down the list, glass, aluminium start to appear in terms of the big embodied carbon things. And again, it was really interesting, the first guy that spoke when we came in, embodied carbon. I cannot tell you how many times during the interviews I had to say to the person I was interviewing, you have not mentioned operational carbon. Why not? Why have you only said embodied carbon? And the fact is, I think more and more people are realizing that the embodied carbon, and I think the point was made earlier, the embodied carbon is being spent today. The operational carbon is being spent over the lifetime of the building. So if we're to do anything about trying to limit the effects of climate change, it's what we're doing with the carbon that we have today is becoming more and more important. And obviously, operational carbon is improving because of renewables and energy efficiency and everything else. And the last thing, green building labels, LEED BREEAM, everybody wants them, everybody likes the tick in the box, but generally seen as being a little bit ineffective in terms of actually affecting circular economy thinking. And those things I know are changing, but are definitely part of the slight challenge there. So when we said, well, what would change current practice? Not surprisingly, a lack of a reverse supply chain was seen as a barrier. So if we have a reverse supply chain, then maybe that can work, providing it can work in with a time cost scenario. And that is a big deal. And we've talked about, well, we've heard stuff about Chalcots, and we'll cover that in a little bit as well. So, and then we see the client group who are squeezed by the issues of planning, the issues of circular economy and planning. They're squeezed by the ESG requirements of their investors, and they're also squeezed by the ESG requirements of their tenants. So they're sitting in this kind of perfect storm and realizing that they have to do something to address it. And this is where we come in there as well. And then I think probably the last question we said, well, who should be driving this change? And I think everybody would recognize that if change is to be far-reaching, it needs to be driven by government, okay? It needs to be driven by government. Now, whether that will happen and when it will happen is anybody's guess, but because the client group in London are sitting within this environment of being squeezed from all sides, they are very responsive to this change. So they're not waiting for government to do it, they're pushing it on. And what was really fascinating about every interview with a client, they all referred to these other factors, and this comes in this 22% at the bottom. And they talked about, we have a responsibility. We feel a moral pressure. We feel a societal pressure. We feel we have to do something. We have to do something now. We can't carry on doing the same as we're doing and expect different results. And so those comments came through from the clients. And one of the other really interesting things came through was, this is what the clients said. They said, within our businesses, we have a younger generation that is coming through, and they are not happy with the depth and the speed of change. We are being pushed by a younger generation who are saying, we are inheriting this world from you, and it's going to have to be better than it is. And so there's this inbuilt pressure that's coming through these organizations. And again, the final thing they said was, it's going to take bravery, it's going to take courage, it's going to take leadership to make this change and happen. So where do we go from there? Well, I've got a minute and a half, so I'm going to have to go. 4 minutes. Oh. Fabulous. All right. So as I already said, nobody's talking about embodied carbon. I can get it done in 4 minutes. And the Ellen MacArthur Foundation said that we have to reduce the embodied carbon in making things by nearly 50% in order to mitigate the effects of climate change. You see a quote in the bottom right-hand corner. I don't think it was from the CBRE, but it's in one of their reports. Without action on embodied carbon, the UK's net zero goal is not achievable. The penny is dropping on embodied carbon in materials. It's the carbon currency that we are spending today, and we are stuck with it once we've spent it. So we have to do something about it, and urgently. All right, Scope 3 emissions, real game changer. Why is Scope 3 emissions a real game changer? Well, for I don't know how many years, we have understood our Scope 1 and Scope 2 emissions. And obviously, the emissions are in the Greenhouse Gas Protocol, 2001, whatever it is. They're defined in there, and you've got these scopes. And so we understand our Scope 1 and 2 because they're from our direct activity and from the energy use that we have. Scope 1 and 2, we've understood that for ages. And so we've always said to people, 1 ton of cullet gives you a reduction of 300 kgs of CO2, roughly. But all of a sudden, we're going, okay, well, we've got to be net zero by whatever date, pick a date, 2040, 2050. We've got to be net zero across all scopes, and that includes Scope 3. So what's Scope 3? It's what happens in the supply chain above and below us. So basically, we inherit in our carbon footprint the carbon impact of our supply chain. Okay? Their carbon impact becomes our carbon impact. So what's happened is people are starting to get on with this now. So we've started to see these things happen where there are strategic agreements going because people realize they have to align their businesses with companies that can help them achieve their overall carbon objectives, including Scope 3. So I was in Foster & Partners about a week ago, and I said, you will not be choosing your glass in 5 years' time based on appearance. You'll be basing it on what are the Scope 3 emissions. Oh, sorry, Foster & Partners. Anyway, I'm nearly finished. 4 seconds left. I mean, it's great. We're in a vibrant industry where people are continuing to pioneer. We are, and AGC are, other people are as well, which is fabulous. So we brought a low-carbon glass to the market about 1.5 years ago with an EPD. We've done trials with hydrogen in Germany. We've done various things with other people as well. And we've done a zero-carbon glass where we used 100% cullet, renewable energy. Can you buy it today? No, but we trialed it, okay, to prove the point. We're also now producing low-carbon glass in India. So you can't just talk this talk. You've got to make sure you walk it, even in places where the culture is throw everything away. So it's really important you carry on. Right, I'm nearly at the end. So strategy, finally. How many seconds have I got left? 10 seconds. All right. So 3 years ago, I made this little chart on the left-hand side, which was a little bit naive, a little bit idealistic, that we kind of take this glass off the building, we carefully deconstruct the facade, we wrap it in cotton wool, we take it somewhere else, and da-da-da-da-da-da. And then we hit Chalcots, and they were going like, no, can't afford it. And so we went through this whole process from October 2021. We went through this whole process of refining the costs to make it work. And it had to fit in with time and cost. And we went through a whole process, and we brought the cost down by 80% from where we started with this idealistic approach. Now, I'm not saying the idealistic approach is not a bad idea, but it is not scalable. It is not going to work on the scale of project we got. Right, I'm nearly there. So what are we doing today? And I'm just going to give you a tiny peep under the hood of what we're doing. We are on site right now on 6 projects in London, commercial jobs, where we're recovering end-of-life glass. Interestingly enough, Citibank, was anybody there for Yasmin's presentation on Citibank? I went to her afterwards and I said, you don't know this, we have taken 40 tons out of glass out of the inside of your building 2 weeks ago. 40 tons. And that's one of those 6 projects up there. So we're doing another job called One Exchange Square. I shouldn't even give you the names, it's top secret information. Anyway, top secret information, and we've got another 24 waiting in the wings to go. So what do? We go to site, we basically give some advice to how we're going to take the glass off the building. And then we work with the existing supply chain, and we then create a joint methodology for taking the glass off the building. The demolition contractors is one part of that supply chain. The demolition contractors then include us in their bid for taking the glass off the building. And hey presto, they win the job, and hey presto, we get the glass, and we return it back to building glass. Sounds simple, it's not. But we're doing it. And I'd like to say thank you very much, and I am done.
David, thank you so much. And again, I'd just like to say, yes, it can be done. I think it's fantastic. You know, we weren't talking about this stuff 3 years ago. So, you know, the last 2 presentations have shown there is a way forward. We've all got to just try harder. Anyway, the next presentation is on the arbour at Bankside Yards. I'd like to welcome Daniel Moore, who's a partner at PLP Architecture. So Daniel has an advanced understanding of facade technology and has developed facades for Francis Creek Building and 4 Cannon Street. And he's currently involved in the extensive development of Bankside Yards on South Bank and the Kaleidoscope project, which is a new commercial building above Farringdon East Crossrail. I'd also like to invite Lee Easton. Lee's Principal and Co-Office Director at Thornton Tomasetti Facade Engineering. He has a wide experience globally of different building types and expertise in curtain walling systems and detailed knowledge of facade materials. Lee is also focused on developing the next generation of facade engineers, which I'm very glad to hear about. Fantastic. Well, thank you, gentlemen.
It's our pleasure to talk about arbour today. We're going to talk about the facades of arbour. Before we do so, I'm just going to give you an overview of Bankside Yards, which is the development that it sits within. Arbour is in the middle there, which is the first building which has been completed. It's a 20-storey office building. It was completed at the end of last year. This is the first major mixed-use fossil fuel-free development in the UK, which is carbon neutral in operation. It's able to be that due to being 100% electric. It utilises a 5th generation energy network, which allows for energy sharing benefits to maximise the efficiencies. So Bankside Yard sits on the south bank of the River Thames along a stretch which is rich in cultural history and cultural institutions. And we wanted to kind of participate in that as well. As such, there is a cultural institution proposed below the central plaza within the main square, and also some cultural space within the arches as well. So there is Bankside Yards as a master plan is composed of 8 new buildings, 6 new public spaces arranged around these refurbished arches. There's a mix of different uses. There's the 2 office buildings to the south you see there, and then there's residential buildings, there's hotel use, there's retail, cultural, and also leisure. And those uses together create this really rich and vibrant and diverse environment, where those uses mutually benefit each other. So Bankside Yards itself, well, that sits on the south west corner of the site. It hovers over the top of a new plaza, Invicta Plaza, but also the railway viaduct as well. As I said, it's a 20-storey speculative office building. To facilitate hovering over the top of the viaduct, we incline the soffit at the base, and correspondingly, we did the same to the top for the dynamism. And that creates these quite special spaces. At the top, there's this double height space which sponsors a mezzanine floor. And then at the base of the building, there's this terraced space between level 2 and 3, which is really good for co-working and other spaces. Other uses, sorry. So those spaces together with other spaces and facilities together create really good and exciting facilities and space that people want to work in. Create spaces that provide joy rather than somewhere that you simply turn up to go to work. So in terms of the performance of the building, it's a very efficient building. As I said earlier, it's carbon neutral in operation. It's very biodiverse as well due to a huge green roof on the top of the building. But significantly, it's also got a closed cavity facade. So most of you will be aware that a closed cavity facade employs a double glazed skin on the inside and then a pressurized cavity with a laminated glass outer skin. And the blinds within that pressurized cavity provide any kind of like solar shading that you need, which means that the glass can be very, very clear, so it doesn't have a high-performance coating on it. Now, typically you can get up to about 75% light transmission with a closed cavity facade. In our case, we had Lawan glass, as opposed to with a performance glass, you're probably looking at around about 50%. So there's a big improvement in terms of natural light, which is going to lower your requirement for artificial light, but also really improves the visual amenity aspect of it. So a little bit about our approach to the design of the envelope. We saw this as this object suspended above the viaduct, but we saw it also as a crafted object, something which could be almost handmade by artisans, which is led by the planning authorities, that they wanted buildings more like the new extension to the Tate Modern, which is nearby, something handcrafted. And we like the idea of doing something in glass. So our first design that we ran with the facades was actually slumped glass, so curved slumped glass sections on a 3-meter grid, where you get a curved section where it's heated in a mold and slumps, and then a section of flat glass as well. So the idea was to provide these vertical ribs, which works with the verticality of the residential tower next door. We went as far as testing the visual effects of looking through curved glass to check whether or not it was going to be producing warped views. We used some very sophisticated software that actually gives the exact glazing characteristics, and we identified that there wasn't so much of a problem. But alas, the client wasn't 100% convinced, and so they wanted us to go back to something which was a little less curved, less warped, and just flat. So to enable us to maintain that kind of like crafted and tactile appearance, we started looking instead at 3-meter panels, which we would tilt in both the vertical and horizontal axis, so that you get this kind of fish scale effect. That only really worked, this fish scale effect, when you did a 3-meter module. But but the client and agents were quite keen to actually have some areas of the facades which was a 1.5 meter module, so that modular offices would have a little bit more flexibility for setting out. So we ended up having only on the west and on the southwest elevations the overlapping facade, and then transitioning to flat facades on the north and on the east. And you can see the way that we transitioned so that it wasn't such an abrupt change between the two. So these are images of the finished project. You can see the kind of the agitation, which is quite nice and rich on the facades. And you can also see around the corner how it transitions to being flat from being tactile. You can also see the way that we've kind of like gouged out these kind of balconies and roof terraces and plant spaces out of this object. Now, CCF facades, they're typically fairly flat and regular. There's a couple of examples here. Whereas I spoke to you earlier, I mentioned earlier that we were inclining these panels, which ordinarily would create these tapered profiles on the mullions and the transoms, which, as I'm sure you all know, is not such an easy thing to do, to extrude something which is tapered. But we worked together with TT and with Scheldebau to come up with ways in which we could actually get the geometry to work with sheets, and I think Lee's going to talk a little bit more about that. That was the initial idea, and then that ended up morphing into something which is a little bit more sophisticated. This is what was finally delivered, where you have extrusions, you then have these cut sheets, cut extrusions, cut to the taper of the cheek, and then it's finished with a closing piece. Yeah.
I might swap places with you and make this a bit easier. And if I knew I was going to be after David Entwistle, I would have worn a louder shirt. So, thinking about the way that CCF works, and this is not new, but with any facade development and design, it's always about compromises. It's understanding all the inputs that are going into it and what's important, and coming up with a design that is the best match. And 2017, we weren't necessarily talking about embodied carbon. It was very much more about operational carbon. And so we used the idea of this to start investigating what was the right process and what was the right activation of this CCF based on the other inputs, which is including, you know, how much glass is on this building, the size and width of these profiles and panels. And so we ended up doing parametric studies like we always tend to do, and we started thinking about context as well. Now, this is actually from the visual mock-up from Bankside Yard, so we didn't have this at the time, but this is the thought of a transparent glass that has a high G value, which is what was going to match what was wanted for the project. We wanted something that was highly transparent. Compared to another project that PLP and TT did together some time ago, which is Nova, quite typical high-performance glazing, which is a very low G value, but also very low light transmission. And then something a little bit different, the Brunel building at Paddington, Arab Design and TT did some work during the construction phase. We understood what typical office facade glass looked like, and we wanted to do something a bit better. So we ran some of that analysis and come up with a thought of how to make the blinds work, which, considering Steve Bosey was talking about the Paddington Square with the blinds on that, it's a very similar process that we went through. And what we came to was this comparison between a typical office glazing and what we could produce for Bankside Yards, which is a G value which is much higher, a light transmission which was much higher once the blinds were open, but then when the blinds were closed, it was also much higher performing than what the solar coated glazing could do. And through a 3D study, we found that we could get the radiance to less than 100 watts per square metre on the facade, on the inside of the facade, at all times during the year. But in fact, that was about 90% of the time less than 75. So we could reduce the amount of solar radiation into the building to 1/10 of what the outside of the facade was seeing. That went a long way to getting the operational carbon working. Back to that original design of the slumped glass, and this was a very rough sketch by me, actually at another conference in 2017. And what do you do when you have a complex curved facade? I called Francis Ellington, and we went through it with Cruiser at the time. One of the things about looking at a 3-metre wide module here was having half of it remain flat while one half of it went slumped, and it was very complicated. There was a lot of concern that we could get the visual quality acceptable for the curved glass, but actually we deteriorated the flat glass. So there was also thoughts about how do you make that transom work that has to match the omega shape. There's a lot of work went into that. We also looked at concepts of stiffening up the frame itself, because we knew that the glass curved would be the most structurally defining aspect of that module. So we thought of all sorts of silly ways, including a glass fin in the middle of the CCF panel. We didn't design that. We didn't get any very far with that. But then we went to that change to the more planar approach of the glass, flat glass. And again, we had that thought about the glass is now more simple. It's a more easy thing to produce. So how was the module going to work? And we looked at that concept of modularity, about maintaining the least number of profiles to then actually be able to adapt it. Here it's even an earlier stage where we were looking at multiple profiles, a much more clunky carrier frame system, which Schelderbau redesigned into something much more elegant and easy for replacement. But we kept on going through that approach, thinking about how do the longer faces work, the longer profiles, things like where do you put the restraint sockets for the BMU system? And in fact, the trick is it's on the underside. We went underneath. So completely hidden. And one of the other major aspects of this new fish scale design were the cantilevering glass fins on 2 corners of the buildings, the ones that transition from the fish scale around the corner and then go back to the flat. On those corners, we have cantilevering glass. So back to this as a visual mock-up, but in fact, Schelderbau produced something very similar in size, actually a bit bigger down the longer face, to do as a performance mock-up. We wanted to test the corner. It was very important to get into this, all the different aspects of the glass, and make sure that we were going to be safe. And here's a closer view of that cantilever glass. So one of the things we did, it's quite difficult to do impact modelling, and we went through various adaptations of this, of equivalent static forces, dynamic forces. How do you model the deformation of the impact? And we realised that it was good for a guide, but it was never going to be good for the final result. So the only way to do it, as we said before, was to test it. This is another angle. This is actually from on top of the train line itself, which is a place you'll never get to. And forgive the straightness of the panels, Schelderbau hadn't finalised their snagging at that point. It looks much better than that. We did the tests, and I got to give shouts out to Schelderbau, because one of the things they do with their visual mock-ups and their performance mock-ups is they'll do a full report prior to doing the attendance or the test. And one of the things at the end of the report is a list of non-conformances where they haven't been able to produce something to the level that they think they should, or what was on the drawings. And this was also at a time through COVID when we couldn't be physically in attendance. We're sort of fortunate that Schelderbau had their own testing facility. We had time to have it in place. They set up numerous cameras. We had lots of meetings during the days, but we also had the third-party independent authority on site. So we had a lot of coverage. We had a lot of good communication, and it worked. But one of the things in their non-conformities were the day prior to doing that report and sending it for this, getting ready for the test, they reversed a forklift into the corner of the mock-up and broke a fin, and sort of had to put their hand up and say sorry. And my response was, yes, great. Now I get a chance to impact a broken fin and understand what that does. Now, we were a bit concerned about impacting the point of the fracture, so we had to do it elsewhere. But this is not the actual broken fin, but the sort of impact testing that was carried out on a fin that was broken for both serviceability and safety, and we found that there was no further deterioration of the performance. Now we're in a position that we're very confident that this is a good system, even if the worst should happen, because I didn't say, this external glass is laminated annealed low iron glass, so it almost looks like it disappears when you're inside the building. But fracturing a annealed laminated glass, what we were able to prove is it was maintained, it was kept in position, it would not form a danger of falling, and yeah, it was fortuitous, we had time, it was a really good thing to do. So we're going to finish on a few other images of the building and just come up with a few anecdotes from the time, because the process is so long. It was 6-7 years, and I'm sure longer for PLP. One of the things that we didn't talk about was the amount of effort that went into the blinds, which included the amount of perforation, the twin colouring, so it's different colours inside out. You do, when the blinds are down, there is a very good visual aspect of what's outside the building. All this was very important. But what we did find, no matter how well they were produced, and in a hermetically sealed facility at Scheldebouw's factory, there was always dirt, debris, detritus that was in the bottom of the panel, and a lot of it was coming from the blind. And we found that even after the number of uses, more would come off. But, and I can spy Rob Peebles in the corner over here, had a very good idea that we put a shuffle glazing system into the profiles. So to clean that out, it's actually taking away the glazing beads and lifting glass an inch, cleaning all that out, putting it back in place. So for maintenance, it is a remarkably good system. Just looking at the fish scales themselves, and what we found from inside is this external glass is invisible. Once it was clean, it was almost, you could not perceive it. You're standing inside what actually looks like a very thematic feel, because these 3-metre wide windows and these big picture frames that stick out, and then it looks like there's nothing. It was a really nice result.
If you've got the time, do you want to tell the anecdote about the swaying blinds?
Swaying blinds. We noticed on a couple of occasions that blinds seem to be moving within the cavity. Now, they're sealed, they're pressurised, they don't have any stays because they don't need them, they don't really need them. And after observations over 12 months, lots of work by Scheldebouw, lots of visits on site, we determined that it was due to the motorised action of changing from open to closed would impart, usually from closed to open, would impart a force on the blind, and they would start to oscillate. And they oscillated to stop at a different period, depending on location, but it wasn't to do with it wasn't environmental, it wasn't sunlight, it wasn't wind, and what we'd actually determined was it was the tolerance of the setting of the blind. The more horizontal it was, the less, and aerodynamics is not my field, but it didn't dampen as much. As soon as it was turned by 5 degrees, they dampened much more quickly. So we're going through a process of now still investigating what is the best setting for these blinds, so that when they turn from closed to open, they don't sit there and oscillate for an extended period of time. It's one of these things where, and I find this in facades all the time, you always discover something new. Every single project, there's always something new. And so we take this information now and it will impart on the next one. But yeah, it was an unknown when we first looked at this.
We're running over now, guys.
So
I think we kind of done.
Just go through the
Just
last
some pretty pictures.
Yes. And that is it. Thank you.
Thank you very much.
Fascinating to share that journey. Really interesting project. Our next speaker is going to talk to us about what to look for from a vertical wall membrane as part of a facade system. And I'm going to ask Allan Hurdle, please, to join us. Allan has worked for many years in the building services industry. And following the Grenfell Tower fire, Allan has been focusing on A2 wall membranes and is a technical consultant for Stamizol UK, a Serge Ferrari Group company. He is a strong advocate of independent testing of fire products, coupled with competence of installers. Thank you, Allan.
Okay, thanks for attending, everybody. As we said, what I'm looking at today is actually at the vertical wall membrane, but what I want to do is go into a little bit of a different spin on this to look at all the technical requirements, not just for a membrane in terms of its A2 properties, but for other requirements that the building owner may need in terms of waterproofness, UV control, breathability, etc., etc. And we'll look at all those standards that we effectively go through. So as I said, my name's Allan, and I do some of these CPDs with both REBA, SIPSI, BISA itself, CABE, and I work with BSI as well to try and bring around new PAS arrangements that are occurring outside in the industry. What we're going to be looking at, as I said, is the A2S1DO membranes for outer-wall systems and why we need water, W1 water protection, the tightness. Now you're seeing there in some of the slides I'm saying waterproof, as one of my colleagues pointed out, we actually should be saying in terms of the facade industry, W1 as water tightness. So I'll just get that one out of the way as we move on. Here we go. So not all facade systems actually will require a membrane. But if it is selected, we should consider the performance of the membrane and what we are actually trying to achieve to get for it. Because what we'll be looking at is the sorts of tests that can occur, particularly between an A1 and an A2 when it comes to waterproofness. And what we'll also be looking at is driving rain tests, as well as the W1 and W2 tests that convert it. If that fails, it goes into a W3. So we'll look at all the various tests that are occurring. I have a video of a smoke test with a driving rain test, with a breathability test that you can look at, and then some other slides that we can look at in terms of what happens when it's looked at W1 and W2. So we'll eventually go through and look at all the various ISO and BS standards that a membrane has to adhere to, because it is not just about being A2. After obviously Grenfell, the big drive was about the cladding and ensuring that is A2, but a facade system is actually expected to be an A2 requirement. So effectively, given that there is now Class A2 membranes available, the approval document B Part 4 states that membranes are exempt from being part of the A2 system. You can fit a Class B S3 membrane. And the reason for that is because at that time when the documents were completed, there wasn't an A2 membrane available. Most manufacturers now will produce an A2S1DO. So I'm trying to work hard at trying to get people like Dewald, Dame Judy Hackett and the others to actually think about changing what is required in a facade system. As I said, not every facade system wants a membrane. But if you do require it, then you should now consider the A2 membrane as being a requirement with W1 waterproofness. Now, what we're saying is effectively that smoke can lead to hospitalisation. So over 50% of hospitalisation generally comes from smoke. And a lot of people don't actually know you can only use 3 breaths of toxic smoke to render a person unconscious. That's all it needs, toxic smoke of that amount. So anything we can do to reduce the amount of fire and smoke and hot droplets from a building has got to be of benefit. Because we know we're talking about the outer facade system. Now, membrane is a generic term, and people have said to me, oh, well, what about it? Can I use it as a damp course membrane? Can I use it as a roof membrane? What we are looking here is at the vertical wall membrane, because the manufacturing process for the roof membrane damp course is entirely different, and it's a different application that we're getting. So what we're trying to do is get a product that effectively will give better visibility, because if there is a fire on the outside of the building, we don't want any smoke to be pulled through any of the windows, the ventilation systems into the building. So anything we can do to reduce the amount of fire and smoke has got to be a benefit. The other thing to remember, in England, we consider A1 as being a non-combustible product. We consider A2 to be limited combustible. So a lot of people are now turning around saying, actually, we ought to be turned around saying our product is class A2 S1DO. Because effectively, if you go to Scotland and the rest of Europe, they actually think A1 and A2 are non-combustible. But in England, we consider A2 as being of limited combustibility. Now, what I'm showing here, this slide effectively shows what can happen to the insulation when no breathability or no W1 membrane was fitted. Now, the cladding was fitted over W2 membranes, and because of the high humidity, the actual thermal blocks could not dry out. So what ended up happening, when they actually took away the cladding and identified underneath the membrane that was there, that actually water had penetrated through with moisture, and then mould started building up. So eventually they had to take the whole thing down. Now, this not happens on all buildings, but it just shows you what can occur if you don't get the correct membrane that you're looking for, the application, the location, etc. it goes through. So that just to show you what can happen if you haven't got the wrong. If you have a class W3 or a W2, potentially I always recommend try and go for a W1 waterproof membrane. Now, a breather membrane effectively is there to assist in avoiding condensation and removing any moisture that could have been left in the building. Because when you're fitting up the thermal block, and you might have the membrane on top, it could be exposed for up to 6 months. We was talking this morning and saying there's a project and that it was 2 years. So what you're trying to do is ensure that you don't get any sort of water penetrating, but you can draw moisture out. Now, when they talk about the moisture and avoiding condensation, it's similar, a membrane that says it's breathable, to the human skin. Because you can get driving rain on your skin, but it doesn't penetrate through. But you get hot, you sweat the moisture out. So it's the same sort of principle where you're not letting water in, but you actually want to let any sort of residue moisture that's in the building to let it out. Now, effectively, if it's an open facade system, you could actually want the membrane to have at least 5,000 hours of protection, of UV protection, because you don't want the sunlight to start breaking down the membrane before it's been carried out. If it's a closed membrane, it could be 336 hours. So it's all about what the architect is designing and what he wants to do with the actual building and what he wants to get from his membrane. Now, another aspect that you should be thinking about, because we talk about, as I said, the actual fire protection of an A2 S1DO, But there are other aspects, like I mentioned, the W1 waterproofness, the breathability that can be coming out. And effectively, what we should say, we actually don't want any fire shrinkage. Because again, one of the companies has said to me, well, what about fire shrinkage? If there is a fire, is it going to pull away from the actual building and therefore lose its fire protection? So you should be asking the question, have you done any sort of fire test to ensure there's no fire and no shrinkage that come through? So there's a lot of scenarios that eventually you can look for from a membrane. You want it to be fireproof as much as possible, limited smoke, no hot droplets. You want it to have UV, high UV protection. You want it to be breathable. And there's other issues as well that fold becomes an issue, because when it's on site with a site engineer, when he's bending it, he ends up being in a situation he doesn't want to actually have all these issues as an installer. So we're just going to do a quick review now, hopefully, on the fire and smoke test that is carried out. And if this works, we'll see it now. And this was for a fire test comparing Class E and Class B membranes and Class A2 for a fire test in the amount of smoke, followed by, which we'll be looking at, a water test, a driving rain test, then a breathability test. And it's really to give you an understanding of the sort of tests that are carried out. Now I'm going to move the video on actually because of time limitations that I've been told about. So we'll move on to the next scenario that occurs in terms of the water test and the breathability. But we can come back to that, and a copy of this video is available on the Stamasol's stand if you want to have a look at it in detail. Now, the thing is, we've got to remember effectively that all manufacturers are required to perform age testing with 336 hours of UV exposure before they move into a water test when they're looking at W1 to W2 membranes. So an age test should carry on, because you think about it, what you want is if it's up there before you fit the cladding behind it, you could have the sun on it and a breakdown on the UV rays. So a manufacturer will be effectively looking to say, right, I'll do a UV test, then I'll actually end up doing a water test. Now, a water test that you're looking for W1 actually has a dye water passed from underneath, passes through onto a paper gauze material. And as soon as it goes through after that, this was done on why I mentioned about A1 not having the waterproofness like an A2. But as it passed through, you can already see that the actual membrane is starting to take dyed water come through on product Y and then into product X as it comes through. Now, effectively, what you've ended up seeing there is that after the 1 hour test, it was actually only the Stamasol Safe 1A2 W1 that passed the water test for an A1 process. So what you've ended up happening effectively is that it was the two other units that were the A1 failed the water test for A1. But what that means is it can then process on to a W2 test. So you've got the A1 test that moves in to a W2 test as well. So a W2 test, what you're doing is pouring water upon the membrane itself, and then what you're considering there is to see the amount of water that can penetrate through the membrane to the bottom tray. There's a glass filter underneath that you'll be able to see how much water comes through. So after 3 hours, effectively, what's ended up happening, you can actually see the water penetrating one of the products with only a little bit of drip coming through on the other product, which was the A1. So what you'll end up happening, because of that scenario, you're now in a position that both the A2 passed, one of the W1 passed the W2 test, but one failed. Now, a product that fails the W2 test will automatically be given a W3 status. Okay? So it fails a 1, fails a 2, it will automatically get a W3 water status that comes through. Now, we've talked about the tests for W1 and W2, and the other tests that have been asked for is things like fold tests. Now, here is a fold test. Now, it's had 120 passes passed over with a heavy-duty roller to see how much creasing, or if there was a fraying of the membrane, which will affect what's going on by the installer on site. Here we can see a pull test, and what's happening there, pressure is applied and pulled up on the membrane to see how much pressure can be applied to it before it pulls apart and fray, because they are important factors in terms of what goes on site. Now, I'm going to rush through these now because of the time constraints, but there are a number of EN and ISO standards that are membrane. There's a copy of this again on the Stamisol if you want to see all the various standards that come through. So you've got all those standards about flame retardancy. You've got all these coming through when it comes through for tensile strength to EN standards. And you've got all these standards when it comes to UV, etc. As I said, there's a copy of this available on site. Now, I'll leave now on terms of this message from Dame Judith Hackett. Dame Judith Hackett, she was at the Construction Leaders Summit in October. And the key points is up there what she's taken away from that. The new Safety Act, the new Health and Safety Act, which comes into effect in April 24. There will be changes, she said, to approval document to improve and continue. Competence compliance with independent testing is going to be the driving force that comes through. So they're going to be paramount to what's going to be coming through in the future. So that's it. Thank you. I believe I weren't too far over time, and I won't get too much of the rest of it.
Good afternoon. We're here to talk about, is unitised curtain walling dead for new build high-rise residential? Which is an interesting question. And we're going to discuss this in the context of a new high-rise residential project, Plot 103 at Greenwich Peninsula. With me to discuss how the facade selection, why we've gone for the system we have. I'd like to introduce my guests. I've got Tom Calloway, Head of Construction from Night Dragon, which is the developer behind the Greenwich Peninsula project, which I understand is Europe's largest development project. I've got Richie Biniage. Yeah, right. Okay, good. Who's Associate Director, and Mace signed a framework agreement with Night Dragon to deliver the whole project. I've got Chris Wilkinson, Managing Director of Joe Cowan Architects, who is the delivery architect for plots 1 and 2. I've got Richard Till, Chief Commercial Officer of KGC, a Lithuanian facade company, who I believe you're currently doing a project in Liverpool.
We're testing the Liverpool system next week, and we're on site with a project in Hammersmith at the moment.
Okay.
Accommodation.
Okay, and last but not least, my colleague Manuel Dos Anjos, Senior Facade Engineer at FMDC. So what we're going to be talking about is how what facade system we've come up with, what were the main drivers, and the particular design criteria which has driven this is a very, very low U value. So I'd like to ask Tom to give some words about the Greenwich Peninsula development and what are kind of the drivers for the project, maybe what's built and what's coming up.
Yeah, no, absolutely. Greenwich Peninsula is a large master plan all around the O2 arena. So it has a lot of both conditions in the ground, with the Jubilee line and the Blackwall Tunnel. You've got the O2 with the noise breakout from there. And then also it's quite a windy place, the peninsula, so it has to respond to all these environmental factors. In terms of the master plan, it's a 17,000 home master plan, so predominantly residential. However, there is some culture and some commercial workspace there. To date, about 2,500 homes have been delivered, so there's a significant journey to go on the 17,000 total. Plot 103 that we're discussing today is a plot that looks over the Canary Wharf Way, a very high-rise building. And I think the panel is going to talk about it, but really for Night Dragon, it had to be a very high-quality architecture, but given the cost of living and inflation and construction, the budget was extremely tight, combined with the challenges we just spoke about of the O2 noise in the tunnel. And it was how we could overcome all of these factors and avoid, active cooling to still have an affordable product that was really important to Night Dragon.
Okay. I'd like to ask Richie about, we were talking about a 30-story tower. We know that plot 1 is 20 stories, which is being delivered in brick-face precast concrete with punch windows. And I'd like to ask Richie just to describe Mace's view about what's suitable facade systems for 30-story towers and what you see as your drivers.
Is that better? Yeah. For us, there's a few factors we need to consider, and it's the optimum factor. So we look at carbon, we look at quality, and we look at logistics.
Yeah.
For precast to go up 30 stories, it's not heard of, but there is an optimum, I think, where we can go to height of precast. We also need to look at logistics of precast, and it's very hook dependent. We're in quite a windy area there on Greenwich Peninsula. And the logistics of getting 12-ton panels and actually installing them, the optimum solution for us is usually unitized, because we can there's less deliveries coming to sites. We don't need external access, and if we're using a built-up wall, we tend to have much more deliveries to site. So again, the carbon content of that goes up, and it's the workmanship piece. So we know at Mace that off-site prefabricated solutions reduce our defects by about 30%. They also reduce the carbon by about 20%. And in terms of safety, what we don't want to be doing is building very, very tall scaffold and built-up walls off-site. In terms of program, if we're putting mast climbers up, there's big leave-out zones for the ties. So for us, unitized is normally the preferred optimal way to go.
Yeah. Manuel, maybe you could describe, we now know that unitized curtain wall was kind of the way that the team wanted to go, and we know that we had a very low U value. Could you probably describe what we looked at and how we developed our design?
Yeah. I'm going to sound like a broken record, but the most important thing is start with the architects and big picture thinking with them. Fortunately, we started working as stage 2, and we managed to sort of highlighted the key items to put us in the right path to meet the low U values. So one of the first things that we talk about is minimizing framing, right? So rather than having a glass panel in the middle of the panel, right? You just put it to the side and you eliminate one intermediate frame. So it's that, it's that type of thinking. Then we also looked at glazing ratios. So I don't think nowadays we can have resi buildings with glazing ratio upwards 50%. So that was a very important discussion and crucial at the time. Then we also had to think about penalizations, right? Because we want panels as wide as possible to have a bigger area to sort of spread out the timber bridges. But there are hoist constraints. We don't want to use tower cranes to install the panels. So that's one crucial thing to look at.
And what panel sizes did we investigate?
So ideally, typical unit size is what, 1.5, right? Yeah. Ideally, you want to double that to 3,
Yeah.
But of course, that doesn't fit in the hoist.
Yeah.
So we ended up with something about 2.1,
Yeah.
which, given the external features that we have, well, you cannot see it here, sort of you could easily fit it in. So that's the place, the good compromise that we get to. And then lastly, the location of the vent. So that's a very important one if you want to meet low U-value targets, because usually architects want the vent in the opaque area, and that's your best performing area. So you rather take the hit on the glass area, which is, the lowest area of your panel. So once you set all those 4 parameters in the beginning right, and of course I said in the beginning because all of those things that I talked about has an impact on the architecture, not only externally but also internally in terms of layouts, then you can then start thinking about more detailed kind of nitty-gritty details of the facade. But like big picture thinking, high level, that has to be set out from the beginning.
And what U-value did we achieve in our calculations and design?
So we managed to get it to 0.65 after a couple of iterations, different architecture, panelization. So we managed to get to 0.65.
Okay.
That was at the end of stage 2.
Okay. Richard, maybe you can say about how KGC became involved in the project?
Yeah, hi. So we were asked by Mace to have a look at the scheme. Thankfully, many of you probably know, I have a very long-term colleague, Alan Anthony. Unfortunately, he's not here today, but he's testing in IFT, but we've worked together. Next year will be 30 years. So he is really the core of the knowledge, and his team in Basel, the core of the knowledge, and we joined KGC 2.5 years ago. But what that team really brings is what I've seen in the market is that if you went back a few years ago, U-values were relatively easy to achieve, and architects could design whatever they want. Our system designers could design whatever they want, and the engineers basically made the thermal performance, which was the key driver, made that work. Now, with the latest iterations and the latest changes, we are quite clearly entering a new era in our industry. I think the headroom, if I call it like that, on U-value compliance is going away. We have to have highly engineered systems to get. So here, for example, we have a unitized curtain wall which has balcony penetrations, MVHR connections, opening vents, sliding doors, all the things which leak watts and which make U-value compliance very difficult. We are optimizing that system by using a bespoke system, so we can move thermal breaks backwards and forwards, in and out. We can fully optimize that system and each detail that we're using to get those U-values down to get a compliant system. Now, what we're doing in doing that is we have our building physicists and our system designers are working literally, whereas before it was probably the system designer went off and drew, and then the building physics guys said, we're okay. Whereas now, the engineers now, this is where I think it's the new era. The engineers, specifically building physics people, are now leading the design, and they're telling the designers, yeah, you need to change this. You have to change the size of that vision glass. It's real fine-tuning, which is taking us from the old U-values we were looking at in residential of 0.7, 0.75, down to 0.6, 0.65. And here, I think we've got one building down to 0.6, including all the balcony penetrations and everything else, and the other one's at the moment 0.63, but we're fine-tuning the last bit. So you can see where the industry's going, and I think now that new era is not just going to be about U-values, it's going to be about embodied carbon, and we now need to start not just doing value engineering on a money basis, we're doing on a cost basis, we're doing effectively the equivalent of value engineering on a thermal basis, and we're going to start doing it on an embodied carbon basis. So whereas before you just had one list with costs and the client went, I'll take that, I'll take that, I'll take that. Now we're going to have this debate of, well, if I take that, the embodied carbon's this, the U value is this, and that will generate a whole new sort of process in what we're doing, and that will come earlier in the process, maybe into late stage 2, early stage 3, whereas before, we were getting the knock on the door at stage 3, stage 4. So I think that's what's fundamentally changing, and I think that doesn't just change for us doing what we do, it will change for architects and yourselves and the M&E consultants at your level as well.
Yeah, I'd like to bring Chris into the discussion and ask about your approach to deliver the performance. I mean, I think it's fair to say that that Joe Cowan didn't do the planning design, but you've taken it over. And I understand the building was approved by a committee yesterday
Last
evening.
night, yeah. Which is always a relief. So we're working with Pilbrow Partners, who are the concept architects for this, and we stepped in at the later stages at point of working with the delivery teams, and with that comes a lot of pressure because you have to uphold the design and the intent of another designer first and foremost. Which always means that you have to hold that very preciously. You don't feel the same liberty to modify in the same way as if one were the original curator of that. I think one of the key challenges really on a scheme like this and on any residential unitized scheme is understanding the pace at which you can design it. They're highly complex buildings, they're fraught with challenges, and obviously we have clients who have very strict criteria for mix, and the brief that comes with that can often lead to decisions that ultimately filter through to the facade systems, and that'll be through placement and positioning of windows, as Manuel mentioned, about vents, etc., and really about trying to look how you can optimize the quality and the performance of it whilst upholding a design standard that's been set, is a key challenge there. And I think that one of the primary aspects we looked at was how to reduce the quantum of framing across the scheme, and that comes very carefully in consideration with how your apartments are working. Another key challenge as well that was touched upon is positioning of balconies as well. You have much more freedom and flexibility as an architect if you have a slab penetration balcony connection. It gives you that ability to fine-tune the positioning of it. You don't have to co-align it with mullions, and you can set them as you wish depending on the door opening and relative to Part M conditions with nib edges against the doors, etc., etc. So there's a lot of fine-tuning that comes with it that have quite fundamental impacts on the performance and the value of the U-value performance ultimately of the building. And so I think that was the absolute key criteria for a lot of this, was about ensuring the performance whilst upholding the design. So the two in hand came together.
Okay. I'd like to kind of drill down into the detail. How are we actually delivering 0.6 U value? Is it the curtain wall alone? Is there an internal wall? Where is the vapor control line? All the usual dew point issues. I mean, that's open. Who wants to answer that one?
Can I go, Richard?
No,
you can start.
Okay. I mean, look, you have to take advantage of everything you have in the system. So if there is dry lining, put some insulation in there. As long as you do the dew point issues and check all of that to make sure you're not creating a long-term problem. Very similar as we saw about membranes and things like that. So we do all of those checks. That's important, I think. But the reality is, how to get to where we get to now is really we are looking at new products. So I don't really want to go into it in this environment because it's that technical advantage at the moment. It won't last forever, but we're looking at new products. We are playing with the system literally to the tune of millimeters to optimize each detail, to get those thermal contours running through very smoothly, coming from opening vents, through mullions, through element joints, into insulated panels, around brackets. We even engaged in this process with the balcony suppliers, thanks to Mace. They helped us, and we had meetings with them, so we got their details and we coordinated their details to put those into our thermal models, so we know exactly, we're not guessing a value and saying there's an arbitrary value for a bracket. We've modeled the bracket and we know the heat loss through that bracket. We've done that for every detail, so we end up with a thermal report on this job, probably more than 100 pages, I guess, isn't it?
Yep.
Good reading if you like it, yeah. But it shows the level we're going to as a business now and as an industry.
And who are you providing the dry wall behind your curtain wall?
No. What we're doing is in our report we state the performance, the insulation depth, the lambda value of the insulation, and we also give other factors. We're not putting foil-faced insulation in. Foil-faced plasterboard in, so we're not trying to put vapor barriers to the inside specifically, but we do give performance requirements for that in order to balance the system to make it work, to make sure we don't have condensation issues.
Okay.
Can I add something?
Yeah, of course, Karen. Yeah.
So, apart from everything Richard just said, we also looked at chamfering, framings, integrating the profile of the sliding door to the transom stack joint. So we looked at all of these little detailed things, and this was before your involvement with stage 2. So how do we deliver low U values? You need to go all the way down to the detail on stage 2, which is supposed to be a concept design.
Yeah.
So that's, and then when KGC came on board on stage 3, we then sort of had more certainty that the things that we wanted to propose and the things we wanted to do, the facade subcontractor got buy-in and can say, okay, yeah, I would like to do that. That sounds like a good idea. No, I don't want to do that. Why don't we do this? And it's that type of collaboration.
Yeah. We haven't mentioned embodied carbon so far. I understand there's a target. And I believe the target was about 146 GIA, which with the form factor relates to about 292.
Yes.
I understand that we are about 302 without a safety factor, A1 to A5.
Yes.
I believe, Richard, you submitted the embodied carbon report a few weeks ago.
Did I?
Yeah, you did.
Yeah, thank you.
I think we've returned its status C. Sorry,
B with comments, please.
Yeah.
Showing your true colours there, Simon.
Yeah. I mean, do we see some progress in that? I mean, a lot of the figures were based on the CWCT kind of guideline figures. Where do we think we're heading?
I mean, obviously, we've prepared and we've coordinated a whole embodied carbon calculation system with it, and we've synchronized, for a nice way of putting it, maybe that with yourselves.
Yeah.
You helped us a lot in the early days of formulating that. So, but what we're ending up in a situation is where we are reacting to the architecture. If there's a mullion there, we can't make that mullion disappear. If there's a metal panel with a shape on it, we can't make that panel disappear. So I think at the moment we're in a scenario where, as I said earlier, we're probably entering into a new era where embodied carbon is going to start informing the design as to what we do. And that will get really interesting because if I look at some of the other projects we've looked at, no disrespect, gents, but we looked at a project in Manchester and we did quite a bit of work on it. And we started with an embodied carbon. We had 272. And we just said, okay, what can we do? We went away and we optimized all the profiles, optimized the design without changing the fenestration. We were straight away down to 234. And then we've got all these other products we can bring into play, like the Circal, and there's glass options and things like that. So I think as time goes on in this business, maybe for the next we find that this building is kind of locked in where it is at the moment for 103. But in your next buildings, I'm sure you're going to be asking us, right, do more. And that's when I think we'll end up doing a lot more coordination with yourselves and the rest of the team to say, right, this is where we're going to go with the embodied carbon.
Yeah, I mean, I think we're entering a period of carbon-led design.
Yes,
and
I think so.
And what's the architecture going to be?
Yes.
And I mean, where do you see like the U values going on unitized curtain wall? How low is low?
Well, this is the question, isn't it? Ultimately, I think on unitized curtain wall, we're now. I asked Allan Anthony once again. I every now and then over the years, I've said, "Oh, you haven't been very innovative recently. Come up with something new." And he gets slightly a bit annoyed with me, and then he runs away and he does some amazing stuff. Absolutely blows my mind. So I asked him. I said, "Look, in the years to come, what can you do?" And I said, "We're probably at some point in the next 2 to 5 years going to need curtain walls with 0.4." It took him 2 weeks to develop a system with triple glazing, so nothing out of the ordinary, but just fully optimized. Now, when that will inform the design, it will inform mullion centers. It will that had, just to be clear, that actually had 46% vision. So it wasn't as though we made a very small window and a lot of panels. We ticked a box. But it shows what we can do. It shows where we can go. And ultimately, we won't end up with 0.4 curtain wall because we're going to have balcony penetrations and VHR opening windows. But we will have to maybe look at how the amount of them we incorporate into a facade to make it work. And this is where this interaction between building physics people, embodied carbon. In our company, the same people do the embodied carbon and do all of our building physics. So that's like a one discipline working with the designers. But eventually, all of those things are going to come together, and we're going to end up with facades, I would guess, 0.45, 0.5. But I think it will also plateau because of overheating.
Yeah, exactly.
So maybe you should comment better on that if you don't mind.
Yeah, when you said about 0.4, I was like, overheating, maybe.
Yeah, exactly.
Well, that ties to glazing ratios as well and all that type of stuff. The good thing about, all the things that I talked about previously, the principles about high-level thinking, is that it also helps for embodied carbon. So, less framing, less aluminum, lower glazing ratios, less glass. So, glass being a super high carbon-intensive material.
Yeah.
So to our fortune, it sort of blends in a way those two things and helps us. But yeah.
I'm just wondering if this is going to have a effect on the procurement. I mean, Richard and I were talking before about PCSAs and possibly saying that was, probably too late. We need earlier involvement. I mean, Richard, do you want to add something like that? I mean, is a PCSA too late? I mean, do we?
I would probably suggest it is. I think the involvement at stage 2 in the collaboration and talking with the building physics people, the specialist subcontractors, the facade consultants, and the client, and actually thinking about what is it we're looking for at the end of this process. Are we looking for the most cost-effective tower building that we're building? Is it the one that we can build the quickest? Or actually is it the lowest embodied carbon, the most cost-effective, with the best architecture that is fit for purpose? So the earlier we have those collaborative discussions, I think the better the results that we get at the end. The PCSAs, in my opinion, are probably a little bit too late. They're just optimizing what's already there without an opportunity to develop that further.
I mean, certainly we're seeing clients come to us, and sometimes before even main contractors are actively involved, they're coming to us and saying, look, I've got this scheme, and they're literally giving us their planning drawings. Yeah, this is the planning submission we've made.
Too late then. Too late.
Yeah, but they give a very early, let's rephrase that, a very early stage package, and they're saying, give us a price, a cost plan, give us a set of proposals, and we will literally do a set of system details, mostly a U-value assessment, an embodied carbon assessment, and an acoustic assessment often. And if you have those 4 key characteristics, and then a price, obviously, because that's the point they really want to know. And if we have those characteristics, and we tend to write like a small, it's not a specification, it's a technical proposals document, maybe 30 pages, which describe, with price powder coating, we've used triple glaze units with this G value. All the key parameters are in that document. And when you bring those things together, which is what we did here to yourselves, that gives them, the client team, confidence to say, this isn't just the Wild West. The facade contractor can't just run off and do whatever. They've got a set of parameters from us, and they say, yeah, that works, or sometimes come back and say, yes, but can you do this? But we very quickly reach an agreement at often a stage 2 as a route forward. And in that stage, then we're working with yourselves and saying, okay, this detail, can we do like this? Can we move that? Or can we move that balcony over, weren't we? We were playing with all of those things.
Yeah, absolutely. I think that point, just to go back one step that the point you're making about some of the work that you're doing to get U values down to, say, 0.4, for example, really highlights for me that issue about what stage involvement happens. And for me, the earlier the better. Now, that's sort of a bit of a double-edged sword as an architect, because you end up hamstringed by being controlled ultimately by the delivery end of it, when you still need that freedom up front to be able to design and curate things, particularly with regards to impact upon the urban realm aspects to it, enabling buildings, etc., etc. And you need that freedom to be able to be responsive. But I do think it's changing so much that we need to find that balance point between finding incredibly good systems that are really well controlled and using those as a design tool before you lose that opportunity. And I think particularly with the level of detail that's required of planning applications, the amount of reporting, CGIs, etc., Bay models, details, 1 to 20s, 1 to 10s sometimes, that control and fix so much of it. It's very hard to unwind some of that. So I think that early involvement is really, really critical.
Okay. We've got to wrap up now, so I'd like to ask Tom, the client, to maybe just say a few words about the process so far. Are you happy with the way it's going? Are we?
We're doing a terrible
you're happy.
Is it going the way you want?
No, I think it's been a really good process, a very collaborative process, and I think we definitely wouldn't be where we are today. Fantastic that we got planning, but we wouldn't have had a scheme that we could submit that we knew would be buildable without this very early involvement. And I think that it's been invaluable having both the subcontractor and the main contractor sitting by us early on. I think where we need to get to is it does all still feel very bespoke. So we've kind of got, say, 6,000 more homes to build in this area. A hell of a lot of work went into getting this 900 unit scheme. But if you multiply that work by every single building left, there's a huge amount of time and money potentially. So I think that toolkit approach that Chris was referring to, and with this team, that's really where we need to get to. We can't do this level of engineering on every single one of our projects. The viability is so stretched already that I think it's been a great process, and I can't speak highly of this team, but it feels to me that the next step of this process is the standardization part, the toolkit part, the faster route to market part, and we need to know very early on, will the building need cooling, for instance? That's kind of £3 million swing. So we can't wait till that gets further down the process. So I think it's really a case of super positive, but a long way to go before we can just have some real confidence and agility in the design process at this very technical level.
I think it's also like a learning curve thing, because for us, it's probably the first time we're delivering a resi with the new part L. And then that part of the part, meeting the U value as well, it's a challenge. And it was a key question to figure out. I mean, once we sort of answer that, then we can then...
Okay, thank you very much.
Thanks, Tom.
I'd like to thank Tom, Chris, Richard, Richie, and well, that was fantastic. Thank you.
Welcome back, everybody. If I can ask you to please take your seats. We have one more presentation from Allan Gibson from Cure. Is going to talk to us about high-performance product management. Is that right? Sorry, no, you're not. No. You're talking to us about laminated glass with ultraviolet control.
Yes.
Thank you.
Thank you very much. Okay. Thank you all very much. Now, I know that I'm between now and the last panel for today. I want to thank the organisers for a fantastic day yet again. Zak in London. For those of you that don't know me, and I'm sure that there are a few that don't, I've been involved in the supply and specification of materials for construction for nearly 20 odd years now. But now I work for the Advanced Interlayer Solutions division of Carrari. And this presentation has been brought to you by Carrari and underlines their commitment towards serving the ever-changing demands of the glass and glazing industry. Now, a lot of you know that I can talk, so I have my notes here, so I'll try and keep it as punctual as possible. Now, the purpose of this presentation is to help us to understand the effects, or the negative effects, the positives and the negatives of ultraviolet light, and which is imperative for today's life. It can be controlled to give benefits, or it can be controlled where and when required. Carrari is a company that's committed to designing interlayers for laminated glass, and we have many 7 production sites throughout the world, employing 900 employees, and 7 manufacturing sites, research and development facilities, and sales locations throughout the globe, which gives a very local service to our project stakeholders and customers. So, radiation from the sun. The presentation will look at the electromagnetic spectrum, helping you to understand the importance and the effect and the benefits and disadvantages of ultraviolet light, particularly how laminated safety glass can help control the flow of UV, and why this is important for occupants of modern day buildings, or to protect those important valuable artifacts. Discovered in the 1800s by a German physicist, the ultraviolet region of the spectrum helped us to understand the sun radiation. And the actual part that we're looking at is very, very small. It's between 100 to 400 nanometers. And it comprises of 3 particular types of ultraviolet light or UVA, UVB, and UVC. Now, only 95% of UVA actually gets to the Earth. It is able to penetrate the ozone layer. UVB, only 5%. Now, UVC does not get through our ozone layer. So wherever you see UVC being used for bacterial control in hospitals or whatever, it will always be manufactured by artificial means. So just very quickly, very pretty pictures, not very many words, but the UVA radiation is the most common. As I say, 95% of the UV will actually penetrate this Earth, and it sheds a similar, so we can't see ultraviolet light, but a lot of the birds and insects can actually see into the UV spectrum, and they can see into the UVA, and I'll explain a little bit about that later. UVB, which is only 5%, you remember from the graph before, actually is the one that's most beneficial to us because it helps us to produce vitamin D within our bodies, and also helps with photosynthesis with plants, increasing crop yield, and so on and so forth. And this is very important, and then the UVC that I mentioned earlier. Now, we are very familiar with the understanding of the UV degradation, or the effect that ultraviolet light has on the materials that we use in architecture. And of course we need to understand the fragility or the discoloration of some of the impacts that it can have on some of the materials that we use. But with the use of chemicals and additives, we can actually help inhibit the risks of UV degradation in some of the modern materials that we use in architecture. Now, you're all familiar with, or maybe if you're not, but just quickly, a couple of slides, which you've probably seen in many of the workshops I deliver. But these are the three common glass breakage patterns, with annealed glass, which are very sharp and dangerous, fully tempered glass, which is very fine particulate of glass when broken, and then you have finally laminated glass, which is what we're all about, and it just maintains the sharp, or the pieces of glass in situ, bonded to the interlayer. And this is accomplished by putting two plies of glass sandwiched together with an interlayer, and that interlayer could be PVB, it could be century glass, or it could be EVA, polyurethane, polycarbonate, and so on and so forth. So all these products that we produce are able to provide laminated glass that provides decorative opportunity or acoustic qualities and acoustic benefits to acoustic attenuation, structural or security qualities to business, and it's quite often used in automotive, especially with the glass roofs that you're seeing now, and of course sustainability. But the area that I want to focus on is the specialized. So this is where we're able to look at materials that are able to control the flow of UV light in or out of the building. And this is available through three products that we produce. Natural UV will allow certain radiation from the sun in UVA and UVB spectrum, and this could be really important for botanical gardens, zoological gardens, and so on. And actually, we need to be looking at this as an opportunity for construction and architectural, certainly in office space, and I'll explain why a little bit later with the human-centric design. And then we have Extra Protect, and this is where it totally blocks out the UVA and UVB from entering through the glass panel. So the question is, well, when would you decide that you do want UVA or UVB, or you don't want UVA and UVB? Well, if we look at things like museums, libraries, where you have very important artifacts. We did a very big project in Egypt, the museum there, where you don't want UV degradation to affect the valuable artifacts within the building. Then an Extra Protect, or a UV Extra Protect interlayer will help to stop those damaging rays from entering the building and cause the degradation. On the other hand, you may have the need to look at the biophilia and support the plant growth within the building. And we're seeing so much more refurbishments of heritage buildings like the one that we see here. In fact, we're working on a current project in Edinburgh at the moment where you have an existing frame, you have existing glass, you're removing the glass panels, you're replacing and refurbishing the metal structure, and you want to reduce the glass or the weight of the glass on that existing structure. And by utilizing central glass with this coupling effect with the natural UV penetration, it will improve the production of, or the photosynthesis of the plants, healthier plant environment, and of course you're getting much reduced, in fact in this particular project we were able to reduce the glass content and weight by 30%, which is embodied carbon. And you know, when you're looking at natural UV, there are so many other qualities that it gives to us. So I showed the slide where you're looking at 95% of UVA, 5% of UVB, but actually, as humans, we need UVB. We need it. It's very, very crucial for the production of vitamin D. But one thing that we also have within a lot of buildings is sick building syndrome. We have disorders like SAD, or SAD, where people aren't getting the full light spectrum. Isn't it bizarre how when you're in the Mediterranean, you're walking along the streets, you've got beautiful blue skies, and all the colours seem so bright and vivid, and people are walking around with smiles on their faces, just like London. But you know, it's a different world because you've got the full light transference from the sun, actually, you know, taking advantage of all the things around us. So there are many benefits to ultraviolet light in a controlled manner, and in particular, if we look at the spectrum of sight for humans, for insects and birds. Actually, insects and birds can see into the UV spectrum. And when we look at these two images of flowers, it gives a different appearance. It helps them with the pollination. It helps them to be able to, helps animals to see their assailants or enemies. You know, when they're in the Sahara Desert and Sahara Desert, where did that come from? You know, in South Africa and in the plains and so on. So there's many benefits to UV, but we need to be looking at it from a holistic point of view. So let's look at some of the humocentric design and some of the studies that went before to help explain this in a little bit more detail. Now, I do want to thank Benjamin Beer. I was very grateful to host the SFE event in Dubai. And Benjamin also was able to complement the event with some slides. And it's really, it put a bigger picture on what I was used to, where we've done design work, where we've done some work with Arsene University in plant structure and how UV affects plant structure and how we can improve the design and structures of some of the very, very large greenhouses that are built in the Middle East, for instance, where they have a concentration of population, very minimal space to grow. How can they increase the yield of their fruit? And also by using centroglass ultraviolet natural UV, it would also they were able to use bees to help pollinate these more effectively, because the bees use ultraviolet light to navigate and to find the pollen, which, you know, is amazing. But anyway, going back to the study, so this was done in the States, and it's really quite shocking, really, to see that the areas that have high light levels don't subscribe as much of the antidepressants and some of the anxiety tablets and medication as those areas with the low light levels. And this is quite evident when you think that as humans, we've really become an indoor species. We spend so much time indoors, fed by artificial lights, very little natural light coming through the buildings, through the glass. So much glass being used in our buildings now is blocking out a lot of the natural light that we need as humans to be able to prosper and feel happy and not be subjected to SAD and so on and so forth. And actually, the human body is designed to use light to help regulate hormone production, which can make us feel happy or make us feel sad, or it can affect our sleep patterns and so on and so forth, as you can see from the slides there. And it's worse than that. As time goes by, we're using more coatings on our glass, which is blocking out even more of the solar gain, because we're trying to make our buildings more cost efficient with thermal response and so on. But actually, it has a detrimental effect also. So it's really important that we start looking at the ultraviolet penetration within our glass buildings, especially where we're looking at buildings now, and we're looking at wellness and well-being, and we're introducing a lot more plants within our buildings, like the Atlantean HQ in Sydney, where biophilia is really part of that design. We need to be looking at how can we allow more ultraviolet light, controlled ultraviolet light, into those working areas to increase our productivity, to make us feel well, and not have to rely too heavily on artificial light. And of course, it reduces the embodied carbon, or the cost of running a building with artificial light. So, James. See this image, it shows up everywhere, but this is a great example of how glass can let in so much light into an area. And fortunately it's not an office space. It's not so much regulated by artificial light, but museums, shop windows, all things. So this is the project that I showed you in Edinburgh, where you've got 6,000 square meters of area, 5,720 glass panels, all being replaced with Century Glass natural UV. And even with heritage blocking the UV that can have degradation causes on a beautiful a building that was built in the 1500s, and has had many, many uses. So I hope this has sort of provoked a little bit of thought, something a little bit different, but I thank you very much for your time.
Thank you very much, Allan. That was certainly very thought-provoking. Thank you. We're going to move on to our last, our last part of today, which is the panel discussion. But before we do that, I think there is a prize draw. Some of you may have put your cards in a prize draw at Obex's stand. Obex has a prize to give. And Dan, who's on the panel with us in a little bit, will draw the winner right now. So what are they winning, Dan? It's a golf set.
Set of golf clubs, yep.
Set of golf clubs will be drawn now.
So, this is a set of Callaway golf clubs.
Yeah.
It's not just the ordinary golf clubs. And yeah, the winner will be measured up so that the golf clubs are specific to that person.
And if the person's not in the room, we'll draw again.
Yeah, if the person's not in the room, the winner's not in the room.
We'll keep drawing until somebody says yes.
Until somebody says, hi, it's me.
But you have to prove you are that person you claim to.
So get creative. So are we ready to go?
Go for it, dig deep.
Let's have a shuffle. Right. Ready, Josh? Marco from GL and SS, I suppose that's glass. Marco? Are you here?
No. Not here.
Oh, how unfortunate. Right, let's go again. Nicola Gould from Harris Associates.
Nicola? No, we go again.
Oh, dear. We're not doing very well, are we? Anybody got any suggestions? Somebody who's here. Can you say that one?
Yes, Ugis writers. Are you here, Ugis? You are. You must be here.
Oh, look, there he is.
Come on.
We hope you play golf.
Do you play golf? He doesn't play golf. You can put him on eBay.
Well, they'll be on eBay next week. Good, thank you.
Thank you.
Thank you.
Okay. You can stay here now. You can stay.
Can I? Oh, thanks.
So I'd like to invite our panel for the last discussion, please. Dan Norman is already here. Dan is the lead specification manager at OBEX. Bram van der Waal from APT Architects. Please, Bram, join us. Neville Grunwald from Waits Construction. Zara Edwards from ACOM. And Ausra Vankivichuta from Staticus. Thank you. Anyway. So we're going to try and keep this short and sweet. And we are going to do what they did in the morning, which is to use a combination of slides as well as talking to our panelists, just to help bring the subject to a little bit more visualization for you, what we're trying to cover here. If I could have the slides, please. Yeah. Here we go. So we're covering 2 or 3 different topics that the panel wanted to cover and we think will be interesting for you. And we will invite you to please ask questions after each person has given a short introduction and got cross-examined by the panel. So as I introduce the panel, here they are. You see them again. And we're going to start with a few words from Bram on a project that he's working on currently. So Bram.
Right. So can you hear me okay? Yeah? So when we got together to talk about topics for this discussion, one of the things that was raised was whether or not unitized facades are still relevant and viable for a high-rise residential building. So I thought it's a good chance to use our True Trafalgar Way project here as an example. This project is located near Billingsgate Market. It consists of a 28-story residential tower on the right-hand side of on that side of your screen, and a 36 and 46-story student accommodation tower. They are linked by what we call the Sky Bridge, where all the amenity facilities are located. All of this sits on top of a 4-story podium of commercial and retail. There we go. That's a view of the student entrance at podium level with its GRC facade there and the office accommodation on the levels above. Lower levels are all stick system, and level 2 above is a unitized facade system. The building is designed as a passive house, and to meet the stringent performance requirements there, we've set the glass to be above desk height, and so that we can achieve a glass ratio of about 30% on the typical floors. We've also worked very hard with our facade consultants, FMDC, and passive house consultant, Hendrickson Studio, to minimize any heat losses through facade elements and frames. And we got also, as part of the project, 2-story sky gardens running up the tower, which offer urban greening enhancement, but also visual amenity. We are on site, and we've recently inspected the visual mock-up. Performance mock-up is due next month, so fingers crossed. And hopefully, if all goes well, we got a fantastic project here with which delivers exemplar sustainability credentials.
And you're able to meet all the Part L and all the thermal requirements for SAP calculations with the unitized facade?
Yes.
And do you take into consideration any internal dry lining in the thermal performance?
There is a separate dry lining element, which we also put some insulation in.
So that's part of the calculation?
Yeah.
Okay. Great. Does anybody on the panel have any questions for Bram? I know earlier in the day there was in one of the parallel sessions some discussion about unitized construction being, if you like, obsolete as far as high-rise residential is concerned. And I think Bram's demonstrating to us that it is not obsolete, that you can achieve all the current legislations and meet the targets and you're hitting passive house standard with it.
We've achieved passive house design stage compliance,
Yeah.
so that's been signed off, and then obviously final certification will only be done once the building is built. But yeah, we've got passive house tests and all that sort of stuff lined up to get us there.
Yeah, it's a great exemplar project. Any questions from the panel? Otherwise, I throw it to the audience.
At what point did you decide to put a dry lining on the inside? Was that quite early on, or was that always known to be the case for a passive house?
It wasn't necessarily something that was passive house driven. It was as a finish. We actually had quite a debate on how it was going to work. We couldn't just fix the dry lining directly to the cladding because of penetrations to the facade. So we had top hat solutions and so on, and at the moment we've got a sort of separate standalone dry lining system behind the facade. But it's to do one to create the finish to the room, but also to enhance the performance. And it was early on, but the method of how we got there changed throughout the process.
Yeah, I think it's a fair question because we've had also several projects where people have wanted to use unitized construction but have got this really stringent U-value requirements of aggregate 0.6 or thereabouts, which is really hard target to achieve. And the only way we could see to achieve it is to take into consideration the additional benefit of having the drywall, because in most cases people are putting that into the building, just ignoring it normally in the thermal calculations. So we're absorbing it, and I have a couple of slides to show on that in a little bit.
I guess the question from me would be, how do you manage the potential for overheating? The number of meetings I've been in over the last 6 years while I've worked for Waits, and we've got building physicians, and they're saying, oh yes, but it's only so many % of the building that overheats. That might be 100% of somebody's accommodation. So how did you manage that?
We've had back and forth with MEP consultants, passive house consultant, analyzing that. We've got mechanical ventilation throughout the building as well, which will mitigate that anyway, and that helps as well because we minimize again connections to the facade. But interestingly, we had discussions on G values, and actually from passive house point of view, they actually want more solar gain so the cooling load can go down. So there is a balance there. It's an ongoing, continuous checking.
Is there a mixed mode ventilation as well?
Yeah, there's the opportunity to open purge vent panels and all that sort of stuff as well as part of building regs, so yeah.
Great. Are there any questions on this topic from the audience? Please don't be shy. There is a microphone that will be brought to you if you have a question. I don't see any hands. Fine. We'll move on. I think, Neville, your slides. Neville's going to talk to us a little bit about the new Building Safety Act, which is something that we're all preparing to receive.
If I never had to talk about this again, I'd be a very happy man.
So tell us a little bit about it, please.
So really, the thing I wanted to talk about today was, and it kind of feeds into to what we were just saying about overheating, right? We've got to start thinking about meeting the functional requirements of building regulations. And I don't just mean making sure that we've boxed off part B and we've boxed off part F, and when we're pushing on one part of the building, we need to make sure that we're pulling on another. So, for example, when we're talking about a U value of 0.6, we might get into a situation where somebody's talking about overperformance. Great, right, fantastic. Yay, we've overperformed. The problem is now we have got an overheating issue that we can't actually easily get rid of. And in the past that was fine, but now it's not. So one of the things that's going to be coming along, or has come along as of the 1st of October, are these 3 gateways under the Building Safety Act. And I think it's going to change the way that we approach design on buildings, and it's certainly going to change our engagement with supply chain and especially subcontractors, which will probably cheer many up in the hall. So the intention is Gateway 1 will be the initial deposit of plans, including a fire safety document explaining how we're going to make sure that the building's kept safe, where the fire brigade are, where the water is, and so forth. And then we're going to go through to Gateway 2. So once Gateway 1 is signed off on a high-risk building, a high-rise building like the one you've been designing, it will get thrown over to the contractor. And we have got to get, in our opinion, all our designs up to probably REBA stage 4B, right? Pretty much for anything to do with structure and fire, which will include the facade, because pretty much everything that you do on a facade either has a structural integrity part or it has a fire integrity part. And we've got to get that design done with, in my opinion, the assistance of our subcontractors and the supply chain. And at Gateway 2, we're going to hand over a package of information to the regulator, who's going to oversee the building control approval for these high-risk buildings. And we're going to have to stand down for 12 weeks. At the end of that 12 weeks, we've got to be damn sure that we're ready to go, because clients are going to be paying for us standing still for 12 weeks. 3 months, that's a big lump. And then we're off to the races. We've got to get to stage Gateway 3, which is final completion of the building. And if we try and change any design between Gateway 2 and the end of Gateway 3, there's an opportunity for us to have to go back and notify the regulator of those changes, particularly if we're talking about changing the fire reaction for a product. If we've got and Dan and I have spoken about this earlier, let's say we've changed a membrane from a Class B to a Class A, then that's a notifiable issue to the building safety regulator, but we can continue. If we change from an A to a B, that's a major change. We have to stand still, wait 6 weeks for approval, and then we can press on again. And then hopefully we get to a stage where we've actually met building completion and we've got 8 weeks, then we hand over our documents, to the building regulator, and we have to wait 8 weeks for them to approve the building for occupation. So effectively we're adding 20 weeks to the build regardless.
Yeah.
Okay? And the only way we're going to make sure that actually happens smoothly and easily, bearing in mind that the regulator is going to be trying to learn about the regs just like we are, because these are all new and most of their staff are new and getting trained, is by working more closely with people, making sure that we are more aligned with the architect and the facade consultants and the supply chain. We can't be going to Ausra and going, well, here's something that we cooked up. We've got it through Gateway 2, now can you build it? She's looking at it going, well, this doesn't work. Or Dan's saying, well, actually the products that we've got don't actually meet what you've drawn. So there's going to have to be a much more collegiate way forward. So changing material choices after Gateway 2 is going to be a nightmare. So we're going to have the notifiable changes and the major changes, as I mentioned. And the notifiable changes aren't an issue, but the major changes are. Even changing a wall tie in a brickwork wall is a major change. If we change from one to another, we've got to stop and go for approval for that. So it's going to be quite a change to the way we work. And I think it's probably going to cheer you up that our commercial teams are going to have to do all their buying gains before Gateway 2. So during design, we agree what we're going to do. We're going to have to agree a way forward. We've got the figures nailed down, and there's no VE. Value engineering is, those are the two words that strike at the heart of every building safety regulator. They all panic when you mention those two words. VE really shouldn't be a change. It should be, well, we've got product A and product B. The only difference is that one comes from, I don't know, Ford, and that one comes from Vauxhall. Let's stay away from names in the facade world. And in that case, it's dead simple. That car does this, that car does exactly the same, it's just from a different manufacturer. Brilliant. But we don't do that. We say, we want a Rolls Royce, we're going to buy a Mini. Because that's what we think we've got the budget for. That will all have to go away. So that should mean greater certainty for supply chain.
I think you have one more slide now.
Oh, of course we can. I forgot I'd done a third. So at the moment, we're in a weird situation where we've got some transition rules that are applying, and you're probably seeing some of this. So if there's been initial notice submitted or full plan deposited with the planning authority before the 1st of October, and works are sufficiently progressed by the 6th of April next year, and we've given notice, and we've got a building control officer that's actually registered with the regulator by the 6th of April, we don't need to go through the gateways that are coming up. We can dodge it. Now, what does sufficiently progressed mean? It means we've actually put some concrete in the floor. We put raft foundations, pad foundations, or piling down. So you might find that there are a few of your projects at the moment in a busting rush, trying to get concrete in the ground before the 6th of April, so they can avoid the gateways. And I guess most people would go, well, why would we do that? Surely we're trying to build safer buildings? Because that's what the Act's about. It's not about building safely, right? It's about leaving safe buildings. So if that's the case, why would we do it? Well, primarily because the building safety regulator is going to be finding their feet, and we might have more delays. Clients are just worried about what it's going to do to their program.
So what you're saying is the Building Safety Act is now in effect?
Yes.
And unless you've started on site by the 24th of April... 6th of April, 24, you're going to have to go through the gateways?
Correct.
Okay.
On higher risk buildings.
Okay. And does that mean there will be specialists who guide the design team on what to do and how to submit, or is this easily done?
The problem is everybody's trying to work out what to do, right? I was talking to a member of the Building Advisory Committee, which is one of the committees that advise the regulator. And the Building Advisory Committee are talking about how we build, what we build, how we build systems. And they turned around to me and said, there's not going to be a specialist, there's not going to be an expert, there's not going to be a fountain of all knowledge to do with the Building Safety Act for probably 5 years, because we're all going to be learning on the hoof. And that's primarily what people are trying to avoid. And the problem is there are no experts out there that could say, this is definitely the way through. I'm a deep subject expert, X the unknown quantity, spurted drip under pressure, for the weights group on the Building Safety Act. And even as I'm reading it, you can interpret things 2 and 3 different ways. We won't know till we try it. So looking for an expert that's got the perfect solution for all this is going to be a struggle.
Any further questions to Neville on this topic? Not from the panel, from the floor. Anybody has a question? Yes, please. If you can pass the microphone, please.
You can repeat. The microphone will take a while. Very simple question. This sounds like a nightmare.
Exactly.
Fees a fortune, and it will send a whole bunch of people broke unless you have an opportunity to claim variations. I'm seriously concerned about it.
Are we talking about from a subcontract
let me just repeat the question.
Purely designer.
Sorry.
Can you repeat the question, please, John?
It actually sounds like this is going to cost designers a whole lot more, take a lot more time, and there is a latency in that you'll be going back and resubmitting regularly through the process for a long period of time. And I also reckon it's going to take you 5 years to understand what this really means. It actually sounds like a massive cost at a design level, putting aside what it might mean to the people that make things.
Okay, so from a design perspective, I think the clients are going to have to strap themselves in for more upfront costs, and I think we're all going to have to be more honest about what PCSAs cost. Because at the moment, we might stick in, as a main contractor, we might stick in a less significant fee because we're going to get it back in the build, so it's fine, right? The problem's going to be that we won't actually have cost certainty on schemes, I think, until we've got to Gateway 2, and at that point we'll know whether it's a goer or not. So there's going to be some challenges, you're dead right. The other thing that's important about the Building Safety Act is the principal designer, which is a duty much like you would have under CDM regulations. Well, the principal designer has responsibility for ensuring that all designs, when coordinated, will meet the functional requirements of building regulations. Now, half of the architects I'm speaking to are going, yeah, that's fine. We've got a team that's switched on, know what they're doing, right? And we've got half of them going, actually, do you know what? We're not comfortable with that. In either event, I can imagine that there are going to be more architects saying, actually, do you know, for the fees we've got, we can't do that. So there's going to be a change of balance. So there are going to be challenges, and we're going to have to be probably cognizant of that and more fair with each other, more equitable. And again, it comes back to working more collaboratively. I think if we try work in silos, it'll just all fall apart.
Can I just ask, Nev, in this whole process of Gateway then, well, does that mean that main contractors will get involved in the design and the scheme earlier? Because typically, main contractors haven't been involved until REBA stage late 4, 5?
It depends on the contractor. I think some of the tier ones, we get involved stage 2, maybe stage 3. Some of the stage 3s we see are really a developed 2 rather than a full 3. But I think for higher risk, high-rise buildings, we're going to have to be involved. Because we're going to have to work really hard as facade people to never ever have a appointment with somebody wearing a curly wig, right? That's my terror. We've got, across the Waits Group, we've probably got 600 live projects at any one time, of varying sizes, from our property services that might be changing an external door to the battery factory that we're building in Sunderland that's $500 million, right? And everything in between. So for me and my team to be able to monitor each and every one is an impossibility. So we have to set the tone, make sure that we're doing the right things in the right order, we've got the right procedures in place. But we've got to make sure that everybody on the team understands that. And when we're saying, hang on, we don't think that works, you don't take that personally. You go back and go, oh, right, okay, Nev's trying to avoid me and him ever being in the box.
Yeah, absolutely. And the other thing I was going to ask you about is costing. So how's the costing side of it going to work? Because the costing is going to have to be done earlier in this process, isn't it? If we're going to avoid this VE that we all hate and are scared of, and for good reason, are we going to see more cost consultants involved, or what?
Genuinely, I guess we're going to have to work closer with the cost consultants. However, here I can actually praise Ausra and her team. So we had a project that's ongoing at Oxford University where we got into PCSA, and our initial thought was, actually, we don't want to develop a design on our own. We want to bring Staticus in early, which we did, and we agreed a capped figure that we would hone down, right? We said, look, let's go as far as we can with the cost consultant. We're not going to scare them. They've got a top-line figure that we can hit without them all fainting. And the cost consultants worked closely with us on that. And we then honed that down. I don't mean we hacked mountains off it. We just honed it so that Ausra was happy that she was making money on the job, and we were happy that we were getting good value. And I think, from my perspective, that's the model that we should be following. And I would suggest that that's how Waits are going to progress. We'll see an awful lot more PCSAs where we say, right, okay, what do we think is a reasonable cost plan? And we're going to have to stand firm against some cost consultants. They're going to go, well, we haven't got that in. Well, if you haven't got it in, let's not start doing the design. Otherwise, we go back to your point, which is, ultimately, you'll have paid for a design you can't build. And we never want to be looking at a really pretty picture that you guys have developed and thought through and really put your heart and soul into just for it all to evaporate because the money's not there.
Yeah. Yeah, and we're all going to have to work a lot closer together, aren't we? There's going to have to be a lot more collaboration. And certainly from our perspective as a manufacturer, we're going to have to be a lot more transparent. Mm-hmm. And in terms of testing and in terms of costing as well. So that we don't have this issue where something lands on the table, this great idea that everybody, is bought into, suddenly has blown the budget out of the water, because that's where we see a lot of the issues coming into the industry.
So maybe I could get you to hand the clicker to Dan, because he can elaborate on that. He's got a few slides that he can elaborate on that.
Thank you. It does lead very well into what we're working at OBEX, and there's a certain amount of it which is reputational risk. That is a big question. But what we are really focused on, what we're thinking about a lot, is who owns the wall. So what are we talking about in terms of product? We're talking about the inner leaf of the external wall. So 2 sheets of plasterboard, you've got your VCL, SFS and insulation, sheathing board, and then a breather membrane on the outside. So that's what we call the through wall at OBEX. And we're very much concentrated on certain components in here. So probably 3 components here. So VCL, sheathing board, and breather membrane. But it does constitute the whole wall. You can't split those out. So they are integral to the inner leaf. And what we see is up to 4 separate trades are working on that part of the wall, the inner leaf, with possibly 7 different suppliers. So all of those trades, all of those contractors have the opportunity to put their product forward, and they all have an opportunity to buy the product or source the product from wherever they like. Well, that's a tech sub from all those different contractors, which Dewald and his team, or whoever, has got to trawl through and make sure it's all working and it's all tested and it's all compatible and so on, and then of course compliant. So there's a lot going on in that external wall. We, as a manufacturer, looked at it and we thought, well, hang on, can we make this simple? And what we're trying to do and what we have done is brought together a set of products which are tested, fire tested, that we can put on the table and say, look, this is a tested through wall system in our terms, and it all leads on to the gateways and making it easy and hopefully more straightforward and more efficient to get pricing and to get products approved and so on. Whereas fire has been a massive focus in the industry, so fire classification. And I get that, because everybody's risk averse, but we very rarely these days get any questions about performance. So a Class B membrane, we get calls about that all the time. We want a Class B membrane. To do what? And the next question is normally, or the response to that is normally an EPDM. Well, let's just be absolutely clear on this. EPDM is ethylene polymer diene monomer. It's a type of rubber, okay? So we're talking about an actual material, or we're talking about a chemical composition, but it's become a description. It's become a description for an interface sealing membrane. So what we've done is we've said we're calling EPDM or EPDM alternatives, if they're fire classified or not, we're calling them interface sealing membranes to try and get rid of this confusion around EPDMs and so on. EPDM is Class E. It's combustible, it burns, it drips, it smokes. So it is not a great product. We're talking about, in terms of fire, if we're talking about a product, we're talking about the functional requirement of the regs, which is what Neville was rightly spoken about. It says that the walls of a building shall adequately resist the spread of fire, or a building shall adequately resist the spread of fire across the walls. So we need to be very mindful of products that spread fire. Even if our external wall, including the facade, is A1 or A2, that's great. But if we've got a component in there that is going to spread fire, really and honestly, that's going against the regulations. We need to be very, very careful. We might be able to excuse it, we might be able to justify it, but at the end of the day, we've got to be very, very mindful that anybody looking at this from a legal perspective, if there's an issue, will go back to the functional requirement of the regs. The other one is performance. So this is starting to creep in terms of issues with water tightness. Everybody will admit and acknowledges that the biggest problem or the most legacy comes from water leaks. And somebody said to me earlier, well, all buildings leak. So it is a huge problem. When we're talking about fire-classified membranes, they are different materials to EPDM. So they're made from different materials to products that we're used to, like EPDM. So we have to test them to a specific product standard, which is EN 13984. EN 13984 requires 24 hours of testing at 2 kPa. What we're saying is that they're trying to force water through that membrane at 2 kilopascals of pressure, and it has to resist that water for 24 hours. And you either get a pass or a fail. So if you're specifying or looking at membranes to do the job of an EPDM, so an interface sealing membrane, make sure it conforms with EN 13984 and you have an independent UCAS accredited test to prove that it passes. Otherwise, there is a likelihood it will leak. What we've got, the problem we've got is the industry tends to be leaning towards W1 as an accepted or acceptable level of water tightness. W1 falls under EN 13859, and that is a breather membrane standard or product standard. So just really want to raise awareness about this because there have been some issues with this. The products have leaked that don't conform to the right testing levels. And as I say, the big problem is that we are so focused on fire, we don't even look at performance. If you're writing performance specs and it's for an interface sealing membrane, okay, put Class B in there, that's fine, but for goodness sake, please do not put Class B EPDM, because there's no such thing. It's Class E. And put in that it must conform with EN 13984, otherwise your contractor has got nowhere to go in terms of confirming that the product he's looking for or choosing is compliant and performs, fit for purpose. I think that's it for me, really.
Thank you, Dan. I'm going to maybe leave the questions till the end, let you speak next, Ozra, please.
Yeah, we have 8 minutes left. So how bored are you all? It's the only question I got from the audience before this panel discussion, keep it short, because we want to go and have some drinks. So I will try to be, including Steven, actually. So I'll try to be short, and we are not the product creators or the specificators or the architects, as we are Staticus, we are the facade contractors, so we put all the pieces together, and probably really the ones taking responsibility of how it all matches together, right? As we discussed yesterday, and how we see all these changes in recently, and tomorrow will be even more. And we human beings, we hate changes. It's uncomfortable, and then we live with it, and we have to change again. So is it a challenge and opportunity for us? And we've been discussing it at Staticus as well. And in a short term, I think we see it a little bit as a challenge because we need to learn a lot of things. But in the long term, we see it as a big opportunity. And I will not repeat myself. I made a lot of smart notes, but Neville is much more smarter than me, so I will not just repeat it. So where the biggest opportunities we see in a long run is that transparency of the documentation, actually what you just mentioned, right? Like be aware of what is specified and how it's specified. And not everybody wants or reads everything. So is there a space for improvement in terms of the digital tools to use it, right? Can we use unified model with the specification and track it to have the traceability from very early stage to the even the maintenance service and etc. So I think this transparency, we shall not be afraid, but enforce it and aim for it. So that's what we are working and Neville, you using our 4D tools, right? So you see all our failures and not failures in there. In a long term, we also see the really quality of works, and I'm not sure in the audience who would raise the hand and say, yeah, we deliver bad quality product or service, right? How many of us are here? So no, so how we are going to check it and how to prove it, and I think it's really good. And for me as an entrepreneur, I'm not a technician, by the way, entrepreneur, this is the most important, and I'm happy that this is introduced, this quality gates, and some steps we have to perform at our company because it will reduce our warranty costs. And there is no, all the buildings are leaking, right? So all the companies have some costs on it. So I really hope that it will help also for us to earn more money, you know, that we are not a not profit-based organization. So use it then as an opportunity versus complaining or crying. Less of the VEs, which is amazing, you know, we all hate it and we have the allergy for it. And we yesterday shortly discussed, right, will it really limit the VE options? I really, really hope yes, if we all work together and you know, and be brutally honest about it. Waste, yes, we talk about the waste of materials. What about wasting hours in, you know, creating about these VE options? Everyone is specified. We have to meet architects' visions, specification, compliance, and then at the end of the day, we have to meet the costs. Go back all the half a year, put into the trash can, and, you know, work on instead of what you said, Rolls-Royce, get Mazda or whatever. It's also waste, right? And we all have feelings, and people get sad that they work for half a year and nobody is using. So why do we do that? It's we have to think about it. Sustainability, when we are early involved, we can do the design right. And we discussed, today was discussed, and we discussed yesterday, the less is more, and that's about the sustainability, right? We have to optimize our solutions. We have to use less of the aluminum, what the Schüco promised yesterday, right? It's changing even business model. So how we can, in early stage, contribute to cutting the CO2 emissions per square meter, and that can be and shall be high on our agenda in the early stage where we can still have an impact by selecting the suppliers, materials, right, you know, having the right documents in place in one model or somewhere and have the traceability about it. Not just like plant free trees and say we are super green. Yeah, and you know, all of it, how to say, gonna create the value and also will force people to study more. And I remember, and I always repeat this, Neville gave us a lecture at Styricus about this, or how it's gonna affect us, facade contractors. I learned that it will be even more responsibilities and I can go to jail, not even, even more people. So now I'm kind of thinking, okay, we earn all of us between 3–7% of the profitabilities, right, which is low, is not sexy, high risks, and you can even go to jail without money. So that's what we do in this business. But you know, you learn, you get better, so use it, as I said, as an opportunity. And I think also for people in our companies and my competitors here, we are solid companies here, right? So we can send our installation people to our production people, designers, to constant trainings to understand the importance of these changes and the importance of to the building, to the final result, to get better. On the other hand, I see also a little bit of risk. We already have lack of engineers in the industry, so when they know that it's a personal responsibility to go to the jail, maybe we will have even bigger problem with the lack of the engineers. It's a question mark. But at the end of the day, make it all short, because you know better than me the implications. So the collaboration is a must. And moving alone, we will not make a difference and we will not reach the good projects.
Well said. Thank you very much. Thank you. Again, I'm going to skip questions simply because we're running out of time. If you can just click to the next, keep it Zara, and just click the next slide. I just wanted to talk briefly about the subject that Bram covered at the beginning, which is how we are dealing with the new revisions to the Part L, where the tightening of the thermal performance is constantly driving us towards lower and lower U value. And Neville made the point as well, sometimes we're ending up with overheating as an issue. But the current regulation is driving us towards a passive house standard of an aggregate U value of around 0.6, and that's what we get asked to meet in our specifications. And that's a very careful balance with the architecture to make sure that you can achieve that, because a fully glass building probably doesn't have a lot of chance to achieve that. So the ratio of glass to opaque has to be controlled, and then how we handle the opaque. If you can go to the next slide, please. So what we're finding is that you need a significant build-up, and sometimes we're having to, if you like, increase the depth of the system, even though that goes against a lot of what we said about embodied carbon and so on, but you have to increase the depth of the system to hit a particular U value, and even then you're having to mobilize the internal drywall, which is always there in residential construction, but quite often isn't taken into the calculation. So with these type of build-ups, we've got the triple glass, we've got a highly insulated unitized system, we've got a lot of insulation in the system and an additional layer of insulation behind the system. If you go to the next slide, please, we're taking our calculations for a typical glazed module and a typical opaque module, and we're hitting these sort of numbers. And these are pretty much kind of the state of the art where we can be right now with the technology we have. And that gives us the aggregate of the 0.6. We're able to hit that. So that's the message I wanted to deliver from this. And it's to reinforce also the message that Bram gave, that this is probably the state of the art of where we are now in terms of passive house and thermal performance in residential buildings with unitized construction. So if anybody has a question for me, please save it until Zara has wrapped up.
Yeah, I can see Ahmed is getting touchy there, so quick this one up. So I'm a facade consultant, so I'm doing all the wrapping up and trying to distill all the information is what we try and do. And I think we need to do it even more now that we have to understand all the ticket items to get the building compliant to such a point where Waits or the contractor is happy to take it on from us. And I was interested to know really from your perspective whether there'd be some projects you'd be avoiding now. If you received a package, a tender pack, and you look at it and you go, it's gone all this way and they haven't even contacted us. I'm going to give it a wide berth.
I guess it'll come down to the size of the risk in the development of the facade. What we've got to start thinking about is, actually, can we get the right products with the right subcontract design to work? Because ultimately, we go back to what Ausra said about collaboration, and Dan's made the same point. We need to make sure that we've actually got the sum of the parts makes the whole, and that actually works. If we look at a design and we go, well, there's absolutely no way to make that hit the target, then we might withdraw and go, that's probably not for us.
Yeah, because we've got to start thinking about this. We've got the 6th of April where we need our concrete slab down. That means that all the projects that we're working on now, the high-rise, high-risk buildings, are going to be put under your nose, and you've got to be thinking about it now, whether you want to take on these projects.
I guess the other thing you could ask yourself, though, is, although we can come up with the design, and you could come up with the design, I could come up with the design, many in the room could, the problem is they'll all be slightly individual. So we might come up with a design, and we go to Ausra and go, what about that? And she'll go, I can't do that. That's not our house style. So I guess we're back to collaboration, and it's the only way we're going to make it through.
Yeah. So sorry to interrupt you guys. We do need to wrap up quickly, but I think what you're demonstrating to us is that this point that John made, that this is going to add, right now, until we clarify how we deal with it, it's going to add a whole layer of bureaucracy. And I think we're going to need collaboration. That part is clear. I don't know if you have an additional message you want to add, Zara, before you finish, or before we collect.
Try and think of all my points. I think we're at the mercy of the client, really, if we start from the beginning, and on the opportunities we can for collaboration. But our as a consultant, I think we need to really push our clients and educate them that there is this risk. There is an elephant there that's coming quickly into the room. And if we don't get the right team involved at the beginning, then the challenges that we're facing are going to be, we're not going to be able to solve them. They're going to come back with a high cost, high risk, and 5 years' time is too long a time to learn from this. We need to start now and collaborate more and be honest. Intellectual property, that's another challenge. Just transparency is going to be the way forward here.
Thank you so much, and thank you everybody. It's really great to have all your contribution, and thank you for listening to us. We are desperately out of time, and I want to wrap up quickly. Please stay where you are, panel. I want to thank Ahmed and the team from Zak again for a fantastic event.
Thank you.
We seem to keep pulling it out of Ahmed. I don't know how we're doing it, but let's keep doing it.
Thank you.
So thank you, everybody, and thank you, Ahmed and the team.
Thank you. Quick 1 minute. So thank you to all the event partners for supporting this event. Again, without their support, this event wouldn't have been possible. A round of applause to Stephen Tanno, our one half of the event host. And John Perry from Sydney, Australia, all the way for stepping in. Thank you, gentlemen. We've recorded this event. We'll share the YouTube recording a week from now. And that's it from us until we meet next time, 6 November 2024 at the Old Billings Gate. The bar is now open. We'll take some photos and join you there. Till 7 o'clock, we'll have the bar, 6:57. And then we will turn around this hall by then inside. And those who have registered for the dinner event, please re-register outside, collect your badges, and enter the dinner event again.